Hey everyone and welcome to my channel. My name is Shubham and I welcome you to the one-shot video on Docker. Docker is considered as one of the most important tools in DevOps today. It acts as the foundation for you to get along with Kubernetes. In this video, we are going to start from absolute basics and we are going to cover all the advanced topics. Here we are not going to just learn the theory, here we are not going to just focus on the commands, but here we are going to do the practical hands-on, which will give you the idea how does containerization work, right? And at the end of this video, you will also be working on projects that will give you the complete idea how does containerization work, how to implement Docker concepts into the actual projects, right? By the end of this video, you will be very much proficient in Docker by writing the Docker files, by writing the compose file, and here you will not only just learn how to create Docker file, you will also implement how does the concepts applies to the actual project, right? Now, since the length of this video is 12 hours plus, I would request you to watch the video in parts, take notes, and also make sure you are taking the breaks and practice alongside with me. Because Docker is not just learning commands and learning a tool, it is a tool that you have to do the hands-on along with it, right? So practice alongside with me, do the hands-on, make the project, break the project, and that will give you the clarity on Docker. So by the end of this video, you will get all the code repository, the GitHub repository, the slides, the PPT, the decks, everything, the resource material alongside the cheat sheet will be provided to you, right? All you need to do is just sit on the desk, grab your notes and get started with Docker. So yeah, without further ado, let's get started with Docker.
As the cloud server of the local device. Now, what this definition wants to say? So, if I put this into a simpler terms, it is just like making your code available to the user is what we call software deployment. But why do we even need software deployment? So, you as a developer, you write the code so that the customer can use your application, the business can earn money, and the user will use the feature that you developed. But how do we do it? We need a way to present that thing to the user, and that's where software deployment comes into the picture. It is used to move the code from developer's laptop to the user to a server so that the user can use it. It should be safe. It should be repetitively done because every time you write a code, you introduce a new feature and that thing should be available to the user. And if the user is using it, so you have to make sure that it is bug free. That's the reason we are making sure that the deployment has been done repetitively, and it should be done without breaking the existing features. And that's the reason we need software deployment, and that is the entire process of software deployment, right? Now, what will happen if there is no proper deployment done? So the app will only work in the developer's machine because there are no specific set of rules that are being followed. Different servers will behave differently. Why? Because of the configuration. In development server, everything will work fine, but if it moves to QA or in prod, it will behave differently, right? This is happening. Why? Because there are environmental changes, and that's the issue. The server behaves differently. The bugs will appear randomly if these are not in sync. The rollback will become painful, and the release team will say, God save us. And the team will fight instead of fixing the issues, right? So this will happen without proper software deployment. Now, let us discuss about two more things, that is traditional deployment and modern deployment, right? So let us first discuss traditional software deployment. Now, what is traditional software deployment? Okay, so traditional deployment means manual work, server by server setup, human dependent issues, meaning people do everything by their own hand. Like if that person resigns or if that person is on leave, then you will have to wait for the next day. So every step is manual, and that's the pain point why people switched from traditional deployment to modern deployment. Now, if you want to understand a traditional deployment, let me take you to a very vague example, which will help you to understand how does a traditional deployment was becoming painful for the people, so that they moved from traditional deployment setup to modern deployment. Now, let us first take this example, then I will give you a analogy so that it will be easier for you to understand and visualize what was the issue. So, in traditional deployment, the developer writes the code, it sends the code to the ops team. The ops team log into the server. They install the required software manually. I repeat, they install the required softwares manually, they copy the file manually, they start the application manually, and then they praise nothing breaks. Each step here is dependent on human, and they have to remember the things. The best thing that they can do in this setup is to document everything. But again, everything will be done manually, right? Now, let us take an example which will help us to understand what was the pain point in traditional deployment. Now, imagine that you are cooking a food, right? So it is defined into three steps. You cook the food, you prepare it, and then you deliver it. So cooking the food is just like building your application, and packing the food is just like preparing it, and then you are delivering the food, meaning it is been deployed. Now, no matter how tasty you created the food, how much hard effort you put into cooking, if it didn't reach to the user, it fails. Just like that, if the deployment is not done correctly, it didn't reach the user, and then it makes no sense for the development. That was the main pain point of traditional deployment. Now, what was the legitimate issues with traditional deployment? So it created issues like it was working on my machine. So like I mentioned earlier, like everything works fine on the dev environment. But when it moves to a new environment, it used to create issue. Why? Because everything was done manually. The code was copied manually, it was installed manually, and everything was done manually. That's the reason we were facing the traditional statement issue, that was it works on the machine. There were environment mismatch, there was longer deployment time, and every time when we were doing the deployment we had a fear, and this was the issue that was creating the nightmare for the release team. And the deployment they used to feel like god help us, and that was the issue, that was the pain point with the traditional deployment. And then comes the lifesaver, which we call as modern software deployment, right? So what actually is modern deployment? So modern deployment means automation, repeatable steps, same environment everywhere, fast and safe releases. So instead of human remembering the things, machine follow the instructions. Now, let us take an example to understand this. I believe every one of us has ordered something from Amazon or maybe from Flipkart, right? So every time whenever you receive a package, right, you can see a box is of same type. They follow the same labeling. They follow the same instruction. And that's the reason they have very high delivery amount. And that is the reason they receive multiple orders in a time, because they follow the same pattern. And that is something modern deployment does, right? I hope this example made sense. So, how does modern deployment works? The developer writes the code goes to a central place that is called Git, and then automated system builds it. I repeat again, automated system builds it, automated system tests it, automated system deploys it, and then the application is live. So no guessing, no manual copying, and no panicking. And the user can actually use it. Now, what are the focus area of modern deployment? So here, 4 points are there. First, consistency. Same setup is there everywhere. Automation. Machine do the boring job for us. Instead of we doing the manual task, automation takes place. Third is speed. Faster releases. And fourth, reliability, meaning fewer failures. So this is where tools like Docker come into the picture and save our life. Now, let us see a difference between tradition and modern system so that we will get a clarity why we switched from traditional deployment to modern deployment. So in traditional deployment, everything used to be manual, but in modern deployment, everything is automated. Traditional deployment used to be slow because human worked on it. But modern deployment is very much fast because machine works on it. It is working in an automated manner. In traditional deployment, there were chances of error, but in modern deployment, the errors are predictable. Traditional deployment used to be stressful because it used to take a very long time. But in modern deployment, we just relax and let the machine do it work. Traditional deployment used to work and behave different on different environment, but in modern deployment, it works the same everywhere. That was the difference between both of them. Now, if we take a real example, let's say a company gives an updates 5 times a day. what will happen when we go with traditional deployment? It will become very much impossible for us. It will become too risky and it will become too slow because everything is done here manually. But when it comes to deployment, it will be just one click, it will be automated, and if something goes wrong, rollback will be done within a minute, right? And that's how company like startups survive and scale. Now, you might have a confusion, or you might be having some myths regarding deployment. So these are the top three myths that I was having while I started with my journey. So what deployment is? Deployment means uploading files only? No, it includes your environment changes, your configuration, and running the app. Second, only big companies need deployment tools, or like if I am a single person developing the application, do I need deployment? Yes, even a single person, a single projects need a clean deployment. Third, modern deployment is only for DevOps engineer. No, every developer will benefit from it because when it comes to deployment, every team is involved in it. But if we follow modern approach, it will only involve few resources and the remaining resources can work on the productivity. So let us do a recap. So what software deployment is? Software deployment is like taking your app and making it available to the user. What was traditional deployment? Traditional deployment was everything that we used to do manually. It was very manual, and second, it was risky. We came across with new term that is modern deployment, which is an automated manner, and this is where Docker comes into the picture. Now, most production issues happen during deployment time, and that is something that we learned in this specific video. And who is the lifesaver for us here? It's Docker, who is existing to save this issue, to save the pain point of deployment. So yeah, that was all in this video where we learned about what actually software deployment is. We saw a difference between traditional system and modern deployment. Right. In the next video, we are going to discuss about containerization. And yeah, that was all in this video. And I will see you in the next one. Thank you very much and keep learning.
Have you ever faced this? Your laptop becomes slow, your RAM is full, your fan starts to make noise, and your CPU is stressed up. And when you check at the backend, you will see only 2 to 3 applications are running at the backend. But why does this happen? You are going to understand this why by learning the difference between virtual machine and container. And believe me, this is one of the most important DevOps concept you will come across, right? So yeah, let's get started by learning the difference between virtual machine and container. Okay, so before even we do a deep dive directly in container versus virtual machine, let us first understand where does the concept of virtual machine and container came from, right? Because know why there was a need of virtual when even we had a legacy server, right? So in order to demonstrate that, let us first understand architecture of server, then we'll compare it with virtual machine, and the same will be compared with the container, right? So let me draw server first. Here, thing that we would be talking will be for the server. Now consider this box a server. Okay. Now, whenever I am talking about server, I am talking about hardware. So search hardware. Okay. Let me put this in center. And what used to be there inside that hardware? There used to be an operating system that helped us. That helped the developer community to write the code to deploy the. So one more block which represent the operating system, and let me mark it as green. Okay, and here goes our application into the legacy server. Now it can be any application. Okay, for being, let's just assume that application, like it can be a Gmail server, it can be a database. So let's take the example of database, right? And here we are talking about legacy server. Now, what used to happen over here is there used to be a server, there used to be a single operating system within that server, and we used to run the application. But if there is a need, if there is a need for a website, then what we used to do earlier, we used to get more server that used to do the job. Okay. Now there used to be a separate server for database, separate server for a website, right? So if I just rename, so basically it is to like this. Okay. So the server used to be like dedicated for database, dedicated server for website, which resulted the company into loss of resources. Why? Because database doesn't occupy that much of space, and it is not even consuming that much of resources, meaning the remaining space is left out and we are not even utilizing it, right? So this costed a lot of money to the company, and that is how we came up with the concept of virtual machine. Now, what is the difference between legacy server and virtual machine? So let me just mark the difference over here. So I'll create it side by side so that you can visualize it and you can complete picture how and what was the difference between legacy server, between virtual machine and containers. So I'll just rename it to virtual machine. And here, what we have, we used to have the same hardware or the server, but above that, to have some hypervisor. So that hypervisor can be anything. Okay, let me just reduce the size of this one, and I'll just mark this as tuple. And okay, and we need one more player over here, and this will act as our hypervisor. I'll explain you what actually hypervisor is, okay, in a very layman term so that you can understand and visualize how does things happen. Now, if you are someone who has used VMware, right? So that hypervisor is equals to VMware. Now, before even we understand this diagram, let us first understand how does VMware work. You install VMware for Windows, and then you add one ISO file, you allocate resources into your VM, and then you are installing the Linux or any flavor that you want, and then you are using it, right? The same thing is happening here. So in machine, you need a hardware. It is again one hypervisor. It can be anything. Here, hypervisor is equals to VMware. VMware will need a dedicated operating system for the application. So here, after the hypervisor is there is one more layer that we on top of the OS level, and that is the operating system. Now, that you are installing Linux into your VMware. So here you install the Linux. You dedicate 16 GB of RAM that is dedicated to this application. Okay, let's rename this to app 1, application 1. And here we'll rename this to database. Okay, now imagine that in a single server you want to run your application and database. So what we did, we came up with a new solution which was helping us to reduce the cost. That was the return of investment for us. That was the ROI for what we did. We actually created a virtual machine. Within virtual machine, we created environment for the application and the DB, and a single was solving all the purpose. But again, there was again the issue of the resources. We were not even sure that database was actually using that because we were directly occupying those resources. We were hard coding it, right? Because remember, while installation, where you are dedicatedly mentioning that 8 GB of RAM should be dedicated to this VM, right? So that is something we were doing. So that was the issue. And again, the major drawback was the application time used to take a lot of time, right? And that was the demerit of virtual machine. And that is how we came up with the concept of control. So let's copy this entire block and tell you the evolution of the container from virtual machine. I leave this side by side so that it is easier for you to visualize. Okay. Now here we'll mark this as container. Okay. But here, what used to happen? We will have one operating system. And on top of that system, we will have something called an engine. And now let me just reduce. Now, if I explain you this one, so it would be very much easier for you to visualize and understand. See, here we were giving it isolation, and in container 2 we are giving them isolation, right? But here we are reducing the boot up time, because here in VM it used to take a lot more time to system. Comes to container, the boot up time is very much easy. It is reduced. And secondly, how the things are working. We have an operating system. On top of it, we have an engine. Now, this is something that is helping us to do this thing, right? It is helping us to do the isolation, which is helping us to install multiple application into a single server. Okay, we have this engine, is Docker engine, right? So, if application one needs some resource from the operating system, it will directly go to the engine and ask for the resources, and the resources will be used. If application 3 needs resources, it will be shared. Basically, the best part of using container is we are using shared resources, and that's the reason, that's the point we are moving to container. Again, there are some merits and demerits between virtual machine and container, but the purpose of this diagram is to just to show you the difference and evolution from legacy server to virtual machine and from virtual machine to container. Okay. Now, if you want to understand it with an analogy, I will like to give you one example. Now, now imagine that this virtual machine, okay, as a house. Now, within that house, you have multiple houses. Now, each house will have its own bathroom, own electricity, own kitchen, right? But when it comes to container, imagine this as Zomato, okay? Zomato or Swiggy, any delivery partner. Now, what will happen over this? Here, it won't be bothering about having a kitchen, because that waste of resource. It will only focus on the things that it is created. Like, for everything there is a purpose. For that application there must be some purpose. It will only focus for that purpose, right? So it will only focus on the delivery and the packaging. When we are talking in terms of Swiggy and Zomato, they'll only focus on delivering and packaging. The rest will be taken care by the restaurant. The same thing is happening over here. The engine is taking care of everything. They are only worried, they are only focusing on the service they are created for. So that's the basic difference between legacy server, virtual machine, and container. I hope this diagram gave you a good explanation and a visual representation. What's the difference between legacy server, virtual machine, and now let us go to the main topic and let us do a deep dive on virtual machine and container. But first, we are going to understand what actually is virtual. Okay. Now, let us definition. What is a virtual machine? A virtual machine is a software-based isolated computer that on physical hardware emulating a complete system with its own OS, CPU, memory, storage, allowing multiple processes to run in a single machine. Okay. Now, if you see this diagram, makes sense. Now, if we go with a virtual machine is a software isolated computer that runs on physical. Here we are talking about server emulating complete system with its own OS, own CPU, own memory. So here we are own operating system, and here it is taking care with own CPU, own memory, and everything separated for it. So that's the definition of what. If I wrap it up in a line, a virtual machine is just like computer inside your computer. If you want to imagine this, imagine VMware. So you install VirtualBox or VMware into your Windows, and then you install Linux into it, right? So it's just like virtual machine. It's just like into your computer. Now, why were machines created? Now you already have a clarity why it was created. So that is first understand. So what was the earlier problem? There used to be one server. There used to be one application, and there used to be huge waste of resources because the resources were not even utilized. So that's the reason virtual machine came into the picture. So they solved the issue by running multiple on one server. They gave better hardware utilization, and they gave strong isolation because operating system 1 was completely isolated with operating system 2. Okay, operating system 1 taking care of application 1, and operating system 2 was taking the execution of databases. So complete isolation.
So VM were a big improvement over the legacy. Okay. Now again, this solution was also coming with problems. Now what were those problems? So virtual machine heavy, they were very slow to used to take minutes to boot up the machine. It consumed lot of RAM and disk, and they were expensive to sell. The reason why virtual machines were difficult, and that's the reason container came into the picture and saved the and changed the complete picture of virtualization. So let's go with the definition of container. Container is a lightweight, portable, related software package building an application with its code, run libraries, and config, allowing it to run consistent anywhere by adding the host operating system kernel, making it faster and more efficient than VM, and enabling microservice and replicate deployment. If you want to put it into a single statement, a container is just like a with package, but it does not carry operating system. Okay. Now, if you want to visualize it, let us compare it side by side with the diagram that we have created. Now, what it says, a container is a lightweight, portable, isolated software package. So here we are talking about this app 1, app 2, app 3, and app 4. Okay. It is completely isolated and it is using the same operating system which is shared over the world in the form of images. What are those images? We are just going to cover it up in the future videos, but for now just imagine that images are those artifacts that you share it with the world so that they can use your application, right? It's easier at that, right? Second, it is saying it can run consistently anywhere, sharing the host operating system kernel. So here we are sharing the operating system. Now here, if you take the example of this server, we are sharing the underlying operating system, and every resources is being utilized by taking consideration of this operating system. App 1 is the same of OS. App 2 is also referring the same. App 3 and app both are referring same operating system. That's the power of container. Okay. Now, how does container works? So container share the host operating system. We just saw it. And due to that, since we are not isolating the resources operating system, it uses less memory, it starts in second, and it's easy to create and destroy. Now, what is the difference between virtual machine and container? That is something that we are going to learn today. But before even we proceed with, I want to answer you with the first question that was the agenda of this video. Your laptop was running slow, your fan was making noise, your RAM was full, and CPU was making noises. So this was the reason it didn't had those resources. When you take virtual into consideration, it was complete allocating the resources, and there was nothing left to the main operating system to source for. That reason, your fan was making noise, your RAM was full, and your CPU was behaving abruptly, right? So let us do the difference between virtual machine and containers. So virtual machine, there is a full operating system inside each VM, but in containers, at the same host operating system. Virtual machines are heavy in terms of size. When it comes to container, those are lightweight. Virtual machine have a problem. They starts very slow, but to container, they are very fast because they share the same host operating. They don't need to worry about the operating system. Virtual machine provides strong isolation, and that is very of virtual machine. But in containers, it is efficient. It can be manageable. Now, virtual machine uses hypervisor such as VMware. It comes to containers, it uses container engine like Docker. So containers are faster, cheaper, and simpler. And that's the reason we shifted from legacy server to VM and from VM to container. Now, how do we believe? So if you don't believe into theory, just believe of the metrics. So these metrics are something that we actually calculated and wrote it down here. So let's imagine that you're starting an application on a VM. It will take more to 3 minutes. Okay. But again, it depends upon the computer that you're running and installing the VM to. But usually it takes 2 to 3 minutes. But when it comes to container, it spin up within some seconds. So if your app crashes, VM is very slow in virtual machine starts very slow, but when it comes to restart into container, it is instant. And that is why modern application love container. But if there are so many drawbacks with VM, is it still useful? Yes, it is actually useful. So real world company, I'm sharing you the uses of the companies that they use the legacy server for. We usually used for legacy databases system, and whenever we need strong isolation for virtual machine, but we use containers for modern web application, microservices, CI/CD pipelines, and fast scaling application. So the answer is straightforward. Do company use VM? So yes, company use both a combination of VM and container. They don't use and stick to one, right? Let us summarize whatever we learned so far. Virtual machine is equals to heavy operating system. Okay, it used to take a lot of time to clean up, and even if the application crash, it used to take more than minutes. When it came to container, it used to spin up instantly. When we compare container with virtual machine, containers are lightweight. They share the underlying operating system, and containers start faster. And containers usually use less resources, and that's the reason Docker made container popular. I hope you learned a lot in this video. You got the idea what is the difference between virtual machine and container. You got to understand architecture diagram of legacy server, virtual machine, and container. So yeah, that was all, and I will the next one. When you start a virtual machine, you wait, and you wait again. But when you start a container, boom, within a second, your application is up. But why does this happen? Are containers doing some magic, or VM are too slow? Let us understand in this video why VM are slower and why container faster than VM. Right? So let's get started. Okay, so let's get started and discuss why containers are faster than VM. Now see, when we are talking about the speed, okay, there are three core principles that affects the speed of virtual machine and container. That is what needs to be started, how much data is loaded, and third is how many layers are involved. Okay, now let us first understand why virtual machine are slower. Okay, then here when we are dealing with virtual machine, it deals with hardware. So the hardware wakes up the virtual machine resource, then VM loads its own operating system, the OS will initialize the system services, then the OS will load the driver, and finally the application start. It is just like you are starting an entire computer. Okay, even though when you're dealing with virtual machine that is inside a computer, you are starting an entire computer. So it is just like a computer within a computer. Now let us take an example and understand why does virtual machines are slow. Now imagine that you want to prepare a cup of tea, but in order to prepare that cup of tea, you will have to buy a land, you will have to build a house, you will have to install plumbing, you have to set electricity, you have to set up the kitchen, and then finally you will be able to make tea for yourself. So that is a virtual machine, right? Now let us move forward and understand why VM needs so much time and power. Now, see, this will clear why virtual machines are slower than the containers. See, here when we are dealing with virtual machine, we are dealing with the full operating system. So, when you start an application using a virtual machine, you will have to start the full operating system. Then it deals with separate kernel. There will be separate services, separate kernels, and there will be separate background process for your application. And that will result in high RAM usage, high disk usage. It will do the slow startup for us, and there will be more CPU consumption. So even if your app is tiny, the OS is huge, and that's the reason VM is slower than container. Now we have been talking about virtual machine. Now let us see why containers are faster. Now when you're dealing with container, the host is already running, okay, and the container will use the host operating system, whereas in virtual machine the application was relying on different thus dedicated operating system. Right here the app and the required file are loaded instead of the entire operating system, so that time is saved, and that's the reason the app start immediately. So no extra OS and no extra boot process. Now again, let us understand this with one more example. Now here you already rent a house, you already have a kitchen. So all you have to worry about is cooking the food, put it into the tiffin box and deliver it. Now here, the kitchen is the host operating system, the tiffin is the container, and the food is your application. So I hope this made you understand why containers are faster than virtual machine. Now here, with the numbers, we'll understand why containers are faster. So when it comes to startup time, virtual machine takes 1 to 5 minutes, whereas when it comes to container, it takes 1 to 5 seconds. Now when it comes to memory usage and disk usage, the usage is in GBs when it comes to virtual machine, but when you switch to containers, it switches to MB, and that's the reason the scaling in virtual machine is slower, but when it comes to container, it is very much faster, right? Now the big reason, the number one reason why containers are faster, it's because they share the same host operating system, they share the kernel, and they share the system resources that are already present. So this single design makes the container faster than than the virtual machine. So we talked about the speed. Now, what about the isolation? Because in virtual machine, we were given with complete isolation because they were having their own, they were given with this dedicated operating system. But here in container, they share the same operating system. Are we compromising with the isolation and this security? Then the answer is definitely no. Isolation is also possible in Docker, in container, and that can be used using the namespaces. It can be limited using the Cgroups that we are going to see in the coming video. Okay, so think of it like each container thinks as it is alone, but the OS control everything safely. So again, no extra operating system, no extra heavy boot process. Now, we came so far. Now we just let us understand why this company loves the container. It's because, let us say, it helps us in auto scaling during the traffic spikes. Let's say if you want to spin up a new container, it will be very much faster when it comes to a container. But let us say if you're running the same application in virtual machine, you will have to wait some more time. It will consume more time, more resources, and that's the reason the time is very precious when it comes to production. Here, since the container response time is faster, the faster deployment will be initiated. There will be quicker rollbacks if something goes wrong, and there will be less cloud cost. When it comes to virtual machine, it will take more cost, and there will be faster CI/CD pipelines. And that's the reason why companies love containers over VM. Okay, now let us move forward. Now, we understood about the concept why VMs are slower and why containers are faster. Second, we learned about containers start fast because they share the running operating system or the host operating system. And then containers share the same OS kernel. So that's the reason, since the layers in containers are less, that's the reason we're getting more speed. So here, speed is equals to scalability plus reliability. So yeah, that was all. In this video, we learned why virtual machines are slower and why containers are faster. So yeah, that was all. And I will see you in the next one. Thank you very much.
Let me start with a scene that you might be aware of or you might have came across with. So the developer team says that it works on my laptop. QA says it is broken in testing. And the production team says, why did the site crash? Same code, same feature, and the same day. But why different result? So today we are going to talk about one of the silent killer in software, that is environment issues. And believe me, environment is one of the most important topic when it comes to Docker. So yeah, let's start with the discussion on environments. So let's get started with it. Alright, so let us discuss about dev, QA and prod environments. So in software, we usually have three environments. So let us understand what is the purpose of each of the environment and what is the relationship between them. Okay, so let us first understand what is the purpose of dev environment. So dev environment, it is a place where a developer writes their code and this is their personal workspace. Okay, now QA, so it's the environment that is used for testing by the QA team, the quality assurance team. This is where the tester check whether the application works fine or not, and they try to break it on purpose, because if something breaks in the earlier phase, okay, it can be mitigated. Then what is the next step? Once the issue is identified, it is logged, it is shared with the developers, they fix it, that thing is again tested, and then it is moved to production environment. But what actually is production environment? So this is the real world.
where the application deals with real interaction, real people. This is the place where real money is being present and the real pressure arises. So all three environment exist for a reason. So let us take a real life analogy and understand the purpose of dev, QA, and prod. Now, think that you are opening a restaurant where dev is your home kitchen, QA is your nearby friends, okay, who will taste the application before even it is served to the customer. And prod, it is the actual restaurant with customer, with live people who will taste your food. So you must taste your food before you are serving it to the customer. So that is the main reason why this environment occurs. But the main question is why even these issues occur. See, most of the issues are not due to code. Most of the bugs occurs due to environment issues and environment mismatch. Now, the main question is what is an environment? So let us understand. So environment is everything that is around your code, and that can be anything. It can be your operating system, software version, libraries, configuration file, environment variables, and hardware limits. So your code doesn't run alone. It depends upon its surrounding. Okay. So now let us start with the dev environment. Okay. And what are the issues that can come with dev environments? So in dev, so let us understand what are the issues that can come with dev environments. Okay. So in dev, let's say there are multiple people who are working in development of this application. So one developer uses Windows, another uses Mac, and the third one uses Linux. So due to this thing, the operating system changes, and due to that reason, they uses different version of the application. So they someone uses different version of Node, another uses different version of Python, another uses different version of Java. So the code works for one developer in one machine, but the same code, when it is shared with another person, it will differ because due to library mismatch. Now, you might ask me one question. Okay, if I'm using Python 3.10 and the another person is using Python 3.12, why it will not work? Now, see, when we are dealing with code, we are dealing with multiple libraries. So there might be a reason, there might be a possibility that the library that is working fine on 3.10 might fail in 3.12, and that can be one of the reason that it is failing. And second is the operating system change. Okay, due to that reason, it is working on system A but not work, it's not working on system number B, right? So that can be one of the reason, and that's the reason it fails in another machine. And that is how we came with the traditional statement that it works on my machine but it doesn't works on the another person's machine. Okay, let us understand this with another analogy. Let us understand that we have two cooks and we have the same recipe. So one person uses gas stove and another uses an induction. The taste will vary, and that's the reason issue in dev environment occurs, because they are using different flavors of operating system, and that is the reason the environment mismatch happens. Now let us move forward and understand what are the issues that come in QA environment. Okay, so QA server have different configuration. They have different database version. Like they have missing environment variables and they have limited permissions. So you can say that QA are the people who will have limited permission as that of the users, the actual users, so that they can actually test. So here we came across with a statement that it worked in dev, but it failed in QA environment. So QA environment is similar, but not same as dev. They have limited permission, but that word similar is dangerous because they are acting as a regular user who is interacting with the application in the live prod environment. They have some more additional permission to check, to break the application so that it doesn't break on production. That's the reason that QA is said to be the god of testing. Once the QA approves, then only the application moves into the production. Okay. Now, let us move with the next and the most important environment, that is the production environment. So, the production environment, the scariest place. So, production environment is the place where traffic is high, a real user exists, and one bug is equals to reputation loss. Okay. So, even if you can see, even if there is a delay in a live match, many people will discard that particular platform, right? So That's the issue. QA environment exists. QA people focuses more on testing so that those bugs have not been encountered by real people, the real users, right? So what can be the problems in production? So production has scale, production has load, production has security rules. So a code that worked for 10 user may fail for 10,000 users. I repeat, a code that worked for 10 users may fail for 10,000 users. Okay. So let us understand with a classical nightmare that everything passed in dev and QA, but it failed in prod. This is every software team's nightmare. Now, why does this happen? Okay, so let's connect the dot. Okay, so development environment is not equals to QA environment, and QA environment is not equals to prod. They have different operating system, they have different version, and they have different set of configuration. So different environment will serve as different behavior, which means your code is absolutely innocent most of the time. It is the issue with the environment itself, and that's the reason why we are learning environment variable in this specific video. That's the motto why we are discussing environment in the very first place. See, I don't want it to jump directly into Docker. We would have started with the installation, we would have started with containers and everything, but the base remains the same, and here we are covering the basics. Okay, now what is the traditional way of handling the environment variables, which is the bad way, which is not even recommended by software industry. So how things used to be earlier, let us discuss the same. So earlier the team used to manually set up the server, they used to install the software by hand, and they used to follow the written SOPs. And due to that, there used to be one problem. If that SOP has some missing step, it has been followed in multiple environments, and that's the reason we have version mismatch and human errors. Every environment slowly became unique, slow breaks, beautiful but dangerous. Okay. Now, imagine this, that your dev has Node version 18, QA has Node version 16, and production has Node version 17. Your code uses a feature from version 18, that is from dev version 18, but where it will work, it will only work on development environment, and that's an issue. That's an environment issue, not a coding mistake. So if environments are different, the results will be different. I repeat again, if the environments are different, the results will be different. Okay. So if environments are different, so what can happen over here? Most of the deployment failure will happen, most of the production bugs will be present, and the DevOps team will stress a lot because here the environment mismatch is present. Now, how does modern team fix this problem? Okay, so this is one of the beautiful thing that modern development, modern software development techniques has offered. So they offered same environment everywhere. So it's not similar, it's not close, it's the same exactly as it is. But how? Okay, let's first understand. The modern team aim for not similar, not close, exactly the same environment. But how? They are packaging the application, they package its dependency, and they run it same way as they used to run in dev, in prod, and the same way is run in the production environment. So this is where container enters into the story. Okay. Now let us move forward and understand where Docker fits over here. So Docker allows us to define the environment once, reuse it everywhere, and remove that traditional statement that it works on a machine. And for now, just remember why it exists. We are going to do a deeper dive on what is the meaning of environment variables and how does it work. So let us summarize what we have learned so far. We learned about dev, QA, and prod. Dev, it's the developer area where they do the development. QA, it's the environment where the QA do the testing. They break it on purpose so that the issues are not arised on prod. And prod is the actual place where the real user interact. Each environment has different configuration, different settings, and due to environment variable mismatch, it causes bugs. So in traditional setup, there was an increase in risk of environment mismatch, and that's the issue that has been solved by the containers Docker to aim to standardize this environment, right? So that was all, and I hope you understand what is the purpose of each one of the environments, what is the meaning of environment variable mismatch. Okay, in the next video, we are going to learn about containers, and we are going to actually start with the journey with Docker. So yeah, that was all in this video, and I will see you in the next one. So till then, keep learning. Let me ask you something very honestly. Why does your application works fine on your local, breaks on QA environment, and crashes at production? Yesterday we blamed environment variables, but today we are going to talk about the hero who solves this issue. One simple idea, one powerful concept. Yes, today we are going to talk about containers. So yeah, let's get started and understand what actually a container is and what value does it add into a software development channel. All right, so let's get started with container. And believe me, in this video, you will definitely have a clarity what actually a container is, because we are going to cover each and everything for you to get started with container. Okay, so what actually a container is. Now, we won't use any jargons. We are going to understand it in a very basic manner. Okay, so what actually a container is? A container is nothing. It is just like a box, and that box contains your application, the dependency, and nothing else. Everything that you require to run an application is clubbed inside a container, and then you're good to go. And if you carry that box anywhere, your application will work the same way. Nothing less, nothing more. That itself is a container. Okay. Now, if you want to understand the container, so think of it as shipping. You might have you might have seen a ship, right? So inside that ship you have multiple container that we are doing the shipment for, right? So inside that container the goods are packed, they are protected, they are standardized. Now for us the end user, it doesn't matter like which ship it is coming from, which truck it is coming from, and which country it is coming from. All we are interested is to know what is there inside that container, what value does it add, right? So the container fits everywhere. Okay, that's why container are changed for global shipping, and software containers does the same thing. Okay, now what is inside that container? Okay, inside that container you have your application code, you have the required libraries, dependency, and runtime like Node, Python, Java. So a container does not include a full operating system, and that's what makes it different from virtual machine. Because in virtual machine you need a dedicated operating system, but when it comes to container, the resources are being shared, right? Okay. Now imagine this just like you are sending food to someone. So you send the cooked item, the spices used, and the instructions. Okay. You don't share the gas stove, the kitchen. And that's exactly what a container does. Everything is written in an instruction manner that is being followed. And that's the reason those environment issues are being mitigated. Okay. Now let us move forward and understand why containers are needed and what was the actual problem. Okay. First of all, we are going to see what is the problem that we were facing and what solution that container are brought into it. So before containers, the page faced the standard issue that it works on my machine. And there were different software version, there were dependency conflicts, and there were deployment fear. Why? Because the version were mismatching, and that was the actual issue that we were facing this issue. Every environment was slightly different from each other. The dev used to be on different version, QA used to be on different version, prod used to be on different version. And again, the people who are utilizing those environment used to deploy the application based on different version, whatever was installed in the local. That was the issue that people were facing, encountering earlier. And there were lots of manual configuration that to be done earlier, and things used to be unreliable. So that's where a container came into the picture. Containers were created to freeze the environment. So it was just like same app, same setup, and same ripples everywhere. Now let us see what is the solution that container solved. So it solved the issue number one, the most important, that is environment mismatch. Second is it will solve the issue of dependency. Third, it will solve the issue of dependency inconsistency. And fourth, scaling issues will be eliminated. So if a container works in a machine, it will work everywhere. Now, how does a container work? So it's just like you are defining your application. It's just like cooking a recipe, right? So you know a recipe and then you can cook the food, right? So you are defining what you need for that application to run. Then you package the app, and then once the packaging is done, then you run the container into any of the system with the container engine, just like Docker, and then the app is running. Once the app is up and running, you can share that image with everyone, and then it can be further turned into a container. So a container is not equals to VM. It is a process, but with boundaries. Okay. Now,
containers versus normal application. So how the life used to look like when without container, and what value did it added with containers. Okay, so without container, we used to install node manually. There were incorrect version and merging conflicts. We used to install the libraries manually, and we were just hoping that nothing breaks. And this was the life before containers. But when container came into the picture, everything is predefined. There is zero setup which is required. You just have to run the image and the container is formed, and that is how the container is created. Next video, we are going to see how does a container is created, right? We are going to see the actual life cycle of the container. But here we get a clarity what issues does container solve. That's why we are proceeding step by step. Okay. Now in real world use case, where we can use the containers, we can use the containers in web apps, backend API, microservices, CI/CD pipeline, cloud deployment. So we can say every modern companies use containers or utilize container in some of the other forms. Okay. You might have any confusion with containers, like is container is equals to Docker? No, Docker is a tool and their container is a concept that we just cleared today. So are containers unsafe since it is utilizing the single operating system? So no, containers are isolated and can be controlled. That we are also going to see how it can be controlled. Next, are containers only used for big companies? No, even a single smaller project can be, you can utilize the power of containers. And I'm going to show you how you can do the same. Okay, we are going to create a basic Python application and then you can containerize it. So what we learned so far? We learned that container is formed with the instruction, and that instruction contains the data for application and its dependency. And once a container is up and running, it will show the same characteristics, same behavior across all the environments. So since it doesn't rely on operating system, that's what we have written in the third point. It is lightweight and fast. Why? Because it doesn't carry the operating system. It will take all the dependent file from the base OS. There. The main thing that container solved is the environment issue that we discussed in the previous video and we understood in this video. Right? So yeah, that was all in this video where we discuss about containers. In the next video, we are going to see the life cycle, what are the process through which the container has to go. So yeah, that was all, and I will see you in the next one. Thank you very much. So in the previous video, we learned about container and we also discussed what value did container added into the software development journey. Right? But let us take a step back and consider a scenario that you containerize your application, you run it, everything looks fine, but suddenly your container stops. Then what can be the issues? Like you might wonder, okay, did I do anything wrong? Or why did Docker fail? Or is there something wrong with my application? So relax, there is no issue with your application. It's just like you're not aware of the lifecycle of the container. In this video, we are going to discuss the same. We are going to understand what is the lifecycle of the container. Just like we human, we take birth, we do our work, and then we expire. Containers just follow a life cycle. So let's discuss the life cycle of the container. Okay, so let us discuss about the life cycle of container. Today we are going to discuss the multiple stages that are involved in the life cycle of container. Okay, we are also going to see what does happen when we run Docker run command, Docker start command, Docker stop command. Okay, so now let us first discuss what do I mean when I say the life cycle of container. See, before even we move to the theory, let us take a very basic analogy. Just like the human, we follow one life cycle. We take birth, we work, we take rest, and finally we expire. Okay. Likewise, there is a life cycle that the container has to follow. So when I say I'm talking about the life cycle of a container, it is the different stages that the container is going through. Okay. So from the moment it is created until it is finally removed, that is something that I'm talking about, that we will be discussing about. Okay. So that is something we say life cycle of a container. Now, there are multiple stages that are involved in a container life cycle. Now, why it is super important to understand the life cycle of container? See, without the knowledge of container life cycle, you won't be aware what is happening behind the hood. So whenever the container will stop, you will feel very much scary. Logs will not make any sense to you, and debugging will be very much painful, and the most important, production issues will feel very random. So that's the reason it is very important to understand the life cycle of container, because once you understand it, then Docker will become predictable and you will be very much confident with it. Okay, so let us first discuss the life cycle of container, and these are the stages that the container has to go through. So there are 5 stages that the container goes through. The initial stage is the container is created, then the container is executed, then further it is paused, and then it is stopped, and finally it is removed. So these are the stages which are involved in container lifecycle. Now let us discuss each one of them in detail so that it will make sense to you. Now, what do I mean when I say a container is created? Okay, so when a container is created, Docker prepares the container, the file system is ready, the configuration is set, and the application is started. Okay, so it is just like your food is cooked, packed, but not yet delivered. Okay, now many beginners think that created means running. No, it is wrong. When I say a container is created, means everything is ready to start but not yet started. Okay, so let us move to the next stage, that is running stage. Now what happens when a container is running? Okay, so this is one of the active part in the lifecycle of container, because here your application is running, your GPU and memory is being used, and the container is doing the real work. Okay, the container lives as long as the main process is living. So a running container is just like a person who is actively working. Once the person stops working, the job is end. Okay, same happens with the container. Okay, now what does happen when I say a container is paused? A container is paused, meaning a container still exists, the application is paused, and no CPU is used. It is just like watching a movie in Netflix. You pause the movie, it will get froze into that specific time frame, and then you can resume it once you need it. Same thing happens with the pause state. Okay, it will just pause the application. The application will be frozen, but no CPU will be utilized. Okay, so it is very much important for us to understand the pause stage. It is optional, but it is important. What does happen when a container is? It means that the container exists, it is not yet removed, the application is in frozen state, but the CPU is not yet utilized. Okay, now let us discuss one of the important stage in container lifecycle, that is stopped. Now, what do I mean when I say a container is stopped? Now there can be multiple reasons, and out of those, these are the top 4 reasons that you can predict. The first reason can be the application finished, second, the application crashed, third, error occurred, or you stopped it manually. Okay, so is stopping of a container an abnormal behavior? See, stopping of a container is totally a normal behavior. It means that your application is no longer in use. Okay, so should the container should always be running? No, the container will stop once its job is done. Okay, so that is all the meaning about the stopped containers. Now what do I mean when I say a container is removed? So when a container is removed, the container is deleted completely, file system is gone, and the history is gone, but the only thing that remains is the image, which means image still exists and you can recreate the container. Okay, it's just like throwing the box into the dustbin, food is eaten and box is gone, but with the help of image you can again recreate the container, but the only difference would be the data won't be there that was there earlier. Okay, so let me show you the full life cycle that we discussed so far. So the container is created, okay, then the container is started, the application runs, application finishes or it crashed, and then the container stops, and then the container is removed. So this is a healthy normal life cycle of a container. Now let us discuss what does happen when we run the commands and what does happens behind the hood. Okay, so I know we are yet to start with the commands, okay, but I just wanted to show you that what happens when we run these commands. Okay, now it will make sense when you run docker run command. Okay, so what happens when you run docker run command? So the container is created and it is started. Okay, second is what does happen when you run the docker start command? Your stopped container starts working. Third is what does happen when you run the command docker stop? Your container which is running, it stops. Okay, now like next is what does happen when you run docker rn? It will remove your container. So here, after learning the life cycle of container, docker commands feels easy and the life becomes easy, right? So let us move forward and take the recap that we have learned so far. Okay, in this video we learned about the life cycle of container. It starts from creating till the termination. So the container is created, it is running, it is stopped, and it is removed. Next is the container lives in within its main process. Stopping of container is absolutely normal and removing is permanent. But again, we can recreate a container with the same image that the container was created with earlier. Right. So yeah, that was all. I hope you understood the life cycle of container. And that was all for this video. And I will see you in the next one. Thank you very much. All right, so we already are aware that the container shares the same kernel, they share the same operating system. Then why doesn't one container can see other containers file? And why doesn't one container can see other containers processes, right? And also one important question, why doesn't a container occupy all the CPU memory and crash the system? There must be something, right? And it is a good and valid question. So today we are going to understand isolation by understanding two concepts, that is namespaces and cgroups. Now most of us think that since container shares the same operating system, they must be unsafe, right? So logically thinking that might be correct, but in reality things are different. Containers feels isolated because Linux has set boundaries for them, and these boundaries are defined by namespaces and cgroups, right? And these boundaries are not Docker inventions; these are the Linux features, right? So you might be hearing a term from me, that isolation, from the starting of this video. What do I mean by isolation? So let us take an example. During quarantine, the patients were quarantined in a room. So it is just like they feel alone even though they are surrounded with people. The same concept applies in isolation in container, right? So let us understand isolation by understanding the two important concept, that is namespaces and cgroups. So let's start with namespace first. Okay, so what is a namespace? A namespace is something that defines what a container can see. They can see files, they can see processes, they can see network, and they can see users. Okay, now in order to understand namespace, let us take an example. Now let us think that we are working on a big MNC company. There are multiple teams that are working on different projects, right? Now let us take two teams, team A and team B. Team A can see only their desk. Okay. Team B can only see their own desk. Right. Even though they are on the same building, they work on the same floor, they share the same washroom, they share the same building, and they share the same electricity. Okay. That is something is namespace. Now, what does namespace separate? They separate processes, files, network, and users. So when we say a namespace separate processes, so each container can only see its own process. Okay. Now namespace separate files. So each container can see their own file system. Okay. Now see, we took an example that team A and B are working, but team A can only see their own desk. They cannot see the desk of team B. That is something a namespace does. So namespace separate, they separate the container network also. So each container has its own IP. Okay. And users. So permissions are separated for each user for that container. So that is why one container feel like a mini machine even though it is not. So that's the power of namespace. Okay. Now why namespaces are important? So in order to understand this, let us take an example and understand what will happen where namespaces are not there. So if namespaces doesn't exist, then one container can see other containers file. Okay. They can kill other apps of other container, and one bug can literally destroy everything. So namespace answer only one thing, that who can see what. Okay. Now, since we have a clarity on namespaces, let us move to the next topic, that is cgroups. So cgroups helps us in defining who can use how much. So cgroup stands for control groups, and cgroup decides how much resources a container can use, and those resources can be CPU, disk, and memory. Okay. Let us take an example. You are going out with your friends. There are four friends. You ordered a pizza from Domino's. Okay. And there are four slices. So a single guy can eat complete pizza, but if you are going with a group, there are rules defined that only one person can take a single slice, right? And those rules are defined in C groups. Control group defines that rule, and that's the reason it we can understand how much resources can be utilized. So a C group can limit how much CPU a container can use, how much memory it can take, and how much disk speed it can consume. So even if container misbehave and app has memory leak, your system is safe, right? Now, why C groups are important? So see, without C groups, one container can crash the whole server. Memory leaks get exhausted and CPU spike happens. So C groups answers how much can you use. So namespace in combination with C groups provide complete isolation and it's a perfect balance for the container. Now, let us understand the differences between namespaces and C group. So, namespaces helps us in isolation and it focuses on what you can see, whereas C groups helps us in limiting those things for answering the questions how much you can use. So, both are required for safe containers and for providing the complete isolation, right? So, where does Docker fits in this? Now, Shubham, in the starting itself, you told that it is something is not a feature provided by Docker. It is something a Linux feature, right? So Docker that does not create namespaces. It does not create C groups. Linux has them. So Docker simply uses namespaces to isolate the containers. It uses C groups to limit the containers and makes it all easy for us. So without Docker doing this manually is painful. Now let us take example. You have two container. Container one with one CPU and 500 MB RAM, and container two with one CPU with 300 MB RAM. So that can be achieved with the help of namespaces and C group. I hope this example made sense and helped you to understand what does namespaces and C groups does in isolation world. Now, what can be the real world use cases? So let us understand why does company trust the containers? Because they run hundreds of containers over one server. One can hijack the resources. So isolation is provided here without heavy VMs, and that is possible because of namespaces and CPU. And here the performance is predictable because we are limiting the resources, right? So that is why the cloud native tools like Docker, Kubernetes are possible to scale, right? So let us take a recap. And before even the recap, let us understand what are the confusing points when it comes to isolation. So Docker magically isolates things? No, right? Linux does it using the two concepts that we learned today, that is namespaces and see-through. Second is containers are insecure. Now, after this video, you will have the answer because isolation is something that is making them safe. So isolation plus limits makes them safe. So isolation with namespace and limits with C groups. So I must learn kernel programming for isolation? No, definitely. It is something that Docker take care for us, right? So that is something a common confusion can arise in the beginners when they start with isolation when it comes to namespaces and C group. So let us wind up everything that we have learned so far. So what we learned? We learned about containers share the same OS, they share the same kernel. Namespaces control the visibility, whereas C groups control the resource usage. Together, they create the isolation, and Docker uses this Linux feature for providing isolation to the containers. I hope this video made sense and helped you to understand the isolation, and you got to know what actually namespaces is and what C groups are, right? So yeah, that was all, and I will see you in the next one. So till then, keep learning. Thank you very much. So let me ask you one question. If containers already existed in Linux, then why do even we need Docker? Why we even keep saying learn Docker, use Docker, Docker is mandatory for DevOps? Is Docker just a tool or is it something revolutionary that it is doing, right? In this video, we are going to understand what actually Docker is and we are going to understand how did it gain popularity into the industry. So let's understand what is Docker. All right, so let us understand what actually Docker is, right? So if someone asks you what actually Docker is, so instead of replying Docker is a containerization tool, reply them with Docker is a tool that makes it easy to create, run and manage containers. It does not invent containers. Linux already has that capability. Now, what makes Docker containers, Docker stand out is Docker simply makes container easy, portable, standardized, and developer friendly. If you want to imagine what actually Docker is and what it does, imagine that whenever you wanted to share goods earlier, your items used to get packaged into boxes, and those used to be of different sizes and used to ship it using the ship, right?
Now, after the standardization which got applied into the shipping industry, we have common boxes of same sizes, and now goods are delivered inside it, right? So that is exactly same what actually Docker does. Now we know what actually Docker is. Okay, let's understand why do we even need Docker. Okay, in order to understand this, we need to understand how like used to be without Docker. So before Docker existed, developers struggled with the environment issues. Installing dependencies manually was very painful. VM based deployments were very heavy because it used to consume a lot more resources. And scaling was slow. And there used to be a traditional statement, it works on my machine, but it doesn't work into the environment. So these were the issues that we were facing earlier without Docker. But container existed that time too, but they were very hard to configure. It were very complex to manage and they were not user friendly. So we needed a dedicated expert who can help us with this thing. But when Docker came, things literally changed. Now, what actually Docker do? Okay, so Docker allows you to define your application setup. It helps you in packaging your application and dependency. It helps you in creating container images. It helps you in running those images anywhere, and it helps you managing your containers easily. So if it works in your machine, it will work anywhere. So everything becomes repeatable. There is no manual setup and there are no manual surprises. If you want to understand what actually Docker does, think of it like you are preparing Maggie. If you are someone who knows how to prepare Maggie, then definitely you know how to use Docker, right? So what we used to do when we want to prepare Maggie, right? We just open the packet, okay, put it into the gas stove, add some water, put the Maggie, and the Maggie is ready. We are following those instructions, right? Likewise, the same thing we are doing with Docker. I'll explain you in the next slide. Okay, so how Docker works. Okay, so when you use Docker, you write Docker file. So it's the recipe that I was talking about. Docker builds an image, the package, and image runs as a container. Okay, so image when executed, it turns out into a container, and from a single image, you can create multiple containers, right? So everything becomes repeatable. There is no manual setup and there is no manual surprises. Okay, now here we are defining what steps are required for that application to run. Once those setup of instructions are ready, then we are just executing it. And that's the power of Docker. Now, important concept. Docker has three important concepts. First is Docker engine, that is the core service running in the background. Second, Docker image, that is the blueprint of your application. The instruction that you write into a Docker file, it turns out into be an image, and that image when executed turns out to be a container. So Docker container is the running instance of the image, right? So don't worry, we are going to cover these things in detail later, but just right now as a concept, just remember it. Now, coming up to the important question, why Docker became so popular into the industry? So because it solved 5 major problems, that's the reason it became popular. First, it helped in doing faster deployments. Container starts in second, whereas when it comes to VM, it took minutes to start the VM, and then the application were executed. Second, it is portable. If it is running in your laptop, it will run on dev, QA, and on any environment. Third, cost efficiency. Container use less memory, fewer resources, and this allows more application to run on the same server. Fourth, microservice friendly. So Docker makes running multiple small services easy, and that's the reason it is microservice friendly. And five, and the most important, it helps us in solving DevOps and CI/CD integration issues because Docker fits perfectly into Jenkins, GitHub Actions, and Kubernetes and other cloud native application. Okay. Now, is Docker replacing virtual machines? And this is a question coming from real world. The answer is straight away no, because VMs are still useful for legacy application. Because VMs are used for strong isolation, they run on different OS style. And third, infrastructure enterprise still needs virtual machines, right? But Docker often runs on top of VM and they are inside the cloud server. So they work together, they are not enemies. Okay, now let us take the recap, whatever we learned so far. Docker makes easier to use the container, even though it existed in Linux. It is a tool that helps us in managing the containers. There is no additional expertise need to manage containers, right? It solves the environment issues, it standardizes the deployments, it enables fast and portable apps. It became popular because it simplified the complexity. So yeah, that was all in this video where we learned about Docker, right? And how it gained popularity into the industry. So yeah, that was all, and I will see you in the next one.
All right, welcome back. So before even we move forward, I just wanted to show you something. Okay. So I know we are yet to start with the hands-on, so bear with me for that. But I want you to understand all the fundamentals so that your base is strong, so that we can move forward, right? So what will happen when I run Docker run Nginx? Okay. Now what it did, it is showing me unable to find Nginx latest locally. All right. And now what it is going to do? Okay, it is pulling the images from a library. But before even we move forward, I just wanted to understand where did it pull the image from and how did it know where to pull the image from, right? In order to get the answer for this question, we need to have a clarity of Docker architecture. And in this video, we are going to understand the same. So let's understand how does Docker architecture looks like, so that we can have the answer when we run these commands, what happens internally. So let's get started and understand Docker architecture. Okay, so let us understand Docker architecture, right? So when we are talking about Docker architecture, it's not like a big diagram that we would be talking about, right? So we will be talking about only few things. Like when we are talking about Docker architecture, we are talking about how Docker is structured internally, what components are involved, and how they talk to each other. It is just like ordering food from any of the food delivery app. You open the application, you place the order, and the food is delivered to you. But what happens behind the scenes? Your order is placed to the restaurant, the order is displayed into the kitchen, the chef prepares the food is packed, handed over to the delivery guy, and then the delivery guy brings that food into your home, and then you enjoy your food, right? So that is something happens behind the deck. That is something you're going to talk about in Docker architecture. It's just like finding answers of few things, like how Docker is structured internally, what components are involved, and how they talk to each other. So in the starting of this video, when I run Docker run Nginx, even though the image was not present in my local system, how did it know where to pull the image from? That answer we are going to get it from here, right? Okay. So when we are talking about Docker architecture, we need to understand the components of Docker. So the Docker component has, there are three important components. First is Docker client, second is Docker daemon, and third is Docker registry. Docker client is the commander. It's the place where we are actually passing the command from. Docker daemon is the actual brain, the worker who performs the work. And Docker registry is the storehouse where the images are stored, right? So we are going to understand each one of them in detail so that we have a clarity how does Docker architecture works and how does it looks like. So let's cover the first component, that is Docker client. It is the place where we interact with. So whenever we write Docker run, Docker build, or Docker pull, you are using the Docker client. It sends the request to the background service. Okay, what is the background service? So here we are going to talk about the second component, and that component is Docker daemon. So daemon is something that runs in background, right? Docker, the process of Docker that runs in the background. So this runs in the background and does the heavy work. So it's the brain that is actually doing the work. So it performs the below operation. That is, it builds the image, it creates the container, it starts the container, it stops the container, it pushes the images, and many more. So Docker daemon is the brain and muscle of Docker. All right. Now let's talk about the third component, that is Docker registry. Now we send the request, the work has been done, but where do we store it? So here comes in the picture, that is Docker registry. So Docker registry is a place where Docker images are stored, and one of the most popular registry that we have in open source, that is Docker. Like you may have heard about Google Artifact Registry, you may have heard about ECR, right? So these are also the registry that are currently there in the market, but one which is very popular is Docker Hub. Now, when you run Docker run Nginx, what will happen? So Docker will check, do I have Nginx image locally? So that is something that we saw in the starting of the video, right? And that was the purpose to bring it in the front. So it checked whether do I have that image locally? If not, it downloaded it from the registry. Now I think you have the answer. Where did it pull the image from? It pulled the image from the Docker registry, right? Since it will first check the image whether it exists in local. If not, it will get it from the registry. So that is how it worked in the starting. Now let us bring all the things that we have learned so far and understand how these things work together. Step 1. When you run Docker run Nginx, the Docker client will send a request to Docker daemon. Now, Docker daemon does the heavy works for us. Docker daemon will check whether the image is present in the local system. If not, it will go to Docker Hub and get the image. Okay. And once the image is downloaded, the daemon will run the image and convert it into the container. And finally, the container is running, and then we are able to view the application. So everything happens within a second, and we are not even aware of how many things are running at the backend. So let us visualize whatever I said so far. So here, see, when we run Docker run Nginx, it will first check into the local file whether that image exists or not. If it exists, then it will turn into a container and the application is up and running. But if it doesn't exist in local, then it will send the request to Docker daemon. Docker daemon will say, oh, the image is not present. So it will go to Docker Hub. It will pull the image. It will turn it into a container and the application is live. So that's the actual process that are running at the backend. And I hope you understand the architecture of Docker. Now you might have a confusion between Docker image and container. Let me make it very much simpler. Okay. So image is the blueprint through which the container is created, right? Just like we have functions in programming. Likewise, we have images in Docker, right? So when you execute your image, it turns out into a container. So image is static, whereas container is live. So whenever someone asks you what is the difference between image and container, you can just say image is a blueprint through which the container is created, or in layman term, image is something that is static, and when you execute that image, it turns out to be a container, right? I hope that makes sense. Okay, now let's move forward and understand what is Docker engine. Now, sometimes you might have heard about the term Docker engine, but what does it include? It includes Docker daemon, which we just saw. It includes REST API, and it includes command line interface, right? So these are the terminologies that we have learned so far. Now let us see a real world example where a Docker architecture fits in. Okay, so let's say you are working in a company, and the developer writes the Docker file and they run Docker build command. Now what happens? Though the client will send the build request, the daemon will build the image will be stored locally, and once the work is completed, then you will store those images into the Docker Hub registry, and once the image is ready, then you can execute it, and then you turn it out into a container, and that is how the world will experience the application that you have created. But then later, once the dev work is completed, later the DevOps people will come. They will implement this artifact into the CI/CD pipeline, where the image will be pushed to the registry. Okay, the production server will pull it, the container will run, and that's the Docker architecture in action, right? So I hope this example made sense. Now let us take a quick recap and understand whatever we learned so far. First is Docker client. It is the place where we interact. Second is Docker daemon. It's the actual brain who does the real work. Okay. Third is Docker registry. It is a place where we store images, just like GitHub, where we store our code. We have Docker registry. It's just the place where we store the images. Now, what is an image? Image is a blueprint. And what is a container? It is the running instance of the images. So whenever an image is executed, it turns out a container. So it works basically client will to the daemon will pull the image from registry if it is not present in local, and the container is created. Now once a container is created, the end world will be able to experience your application that you have developed, right? So yeah, that was all, and I believe you got to know about the architecture of Docker, right? So yeah, that was all, and I will see you in the next one. Thank you very much, and keep learning.
Okay, so till now we have learned a lot about Docker, and before even we proceeding with the installation, there's still one question that we need answer for. Right? We learned about container, we learned about the architecture of Docker, we saw what containers are, what is namespace and Cgroups, but still there is one question. where Docker fits into DevOps and cloud. In this video, we are going to see top 7 use cases of Docker, and also we are going to see where Docker fits into DevOps and cloud, right? Now see, Docker brings three important things, that is portability, consistency, and speed. Now let's understand what are the use cases that Docker brings us into a plate so that it would be easier and it will give us a good clarity why we are learning this tool in the very first place. All right, so let us see the use case number 1. So the first problem that Docker solved was the environment issue. So the developer used to say it works on the machine, but the same code when it was deployed on QA server, it was failing. So the QA used to say it is failing on QA environment. And in the production used to say it fails and the production is done, right? So there was a issue that we were facing from dev to QA to prod. That issue is resolved with Docker. Now what Docker does, the developer will write the Docker file, image will be created, same image will be deployed in dev server, on QA server, and the same will be deployed on prod. So there will be single image, and since we are deploying the single image, same image, it will be showing the same behavior in all the environment. So that was one of the issue that Docker solved. Now let us take a real life analogy. Let us say we are working on a startup, there are 20 developers that are working on it. So without Docker, the life will be, there will be different node version, there will be different Python version, right? And there will be manual configuration in each and every time, right? And this will be very much hectic for the auction too, right? But when Docker comes into the picture, there will be only one thing that we need to take care of. That will be, we just have to focus on writing the Docker file. Once that Docker file is ready, it will be a single image. The same image will be used in dev. It will be deployed on QA. The QA will test it. If there are any bugs, it will be resolved in dev. Again, a new image will be provided. They will test it. When I say they, it will be QA. The QA will test it. Once everything is approved, the same image will deploy in the production, right? So same image and zero confusion. So that is one of the things that Docker cleared. So that was use case number 1. Now let us see use case number 2. All right, so use case number 2 is CI/CD. So this is the place where Docker actually shines. So what actually CI/CD? CI/CD means automatically build, automatically test, and automatically deploy. So what usually happens over here is the developer writes the code. The code is actually pushed to the central repository. Once it is pushed to the central repository using CI, it creates an artifact for us, and that artifact is Docker image. That image is then pushed to the artifact repository, and then it is deployed to the server. So the same image is used in dev environment, same image is used in the testing environment, and the same is used in prod, right? So the effort here is minimized using CI/CD, and that is the actual power of CI/CD. When combined with Docker, it literally reduces manual things, right? Now, how would be the scene of DevOps without Docker? So it will be like we are using the code, but there will be different environment version, there will be different configuration that we need to take care of. That thing is eliminated using Docker, right? And this is where Docker actually shines. So the same testing version is equals to same version that is deployed into the prod. Third use case is microservice architecture. Modern application is not a big huge application. They are split into smaller services. There will be small service for front end, there will be another service for payment gateway, there will be another service for core, another service for notification. So each of the things are separated by a smaller microservices, and Docker does supports the same. So let's say how does Docker help over here? So each microservice, there will be a different container for each service, there will be independent dependencies for each services, and let's say if there is a need for scalability, so each service can be scaled independently. Now let us take an example, and let's say we are using a payment service, right? And during sales, it requires more consumption of the resources. So you can just scale up and scale down based on the use cases. And that's the power that Docker brings us into the place when it comes to scalability. So here Docker helps us in performing scalability, and that's the reason it is cost efficient. So use case number 4, that is cloud deployment. So Docker is heavily used in cloud-based environments, that is AWS, Azure, and GCP. So instead of deploying the raw code, the companies deploy the Docker images. Now, why do cloud environments love Docker? It's just because they have a resemblance. So the servers are temporary, they can be scaled up and down, and they need fast startup. Now, when it comes to container boots up in second, they use fewer resources and are easy to replicate. So that's the reason it is a perfect match for cloud-based environment in cloud-based deployment. Use case number 5, that is application packaging and distribution. Now consider a scenario where you are developing an application. So without Docker, the life will be very much painful. Now you will write the code, you must install all the dependencies manually, the version config will happen and the setup will be painful. But with Docker, the installation will be very much easier. The user will just create the container and the application is working fine for us. So it is just like downloading an application instead of installing 10 libraries individually. So this is one of the best thing that Docker brings us, so that it introduces manual effort reduction. So use case number 6, a personal favorite one because it helps in standardization of environment. So let's say it is a big company and there is a new person who joins the company. So without Docker, the life of a new joiner will be like install everything manually. There will be version conflicts. He will solve the issues and then things will get started, right? So here he will be wasting a lot more of time. But with Docker, he will just have to prune the repository, run one single command, and he is on pace with the team. So the standardization is been done using Docker. So the final use case, that is testing multiple versions of the application. Now let's say you want to test an application that requires Node 16, maybe Node 18 or Node 20. How will be the life of a tester will look like without Docker? He will have to install and uninstall the Node application multiple times. This will create environment mismatch and the environment will be messed up. But with Docker, he will just have to run the container and he can actually test that application. So no need to worry about the version conflicts, just focused on testing. So this is how it helps the testers to get along with the test. Now, where Docker fits into the DevOps workflow. So let's connect everything into a single place. So the code is written, it is pushed into Git, then it is moved into CI tool. The Docker image is created, it is pushed into the artifact repository, and finally it is moved into the production environment. So Docker acts as a packaging system, the delivery box, and the deployment unit. So it sits in the middle of DevOps. So that was all in this video where we saw the use cases of Docker. We understood where Docker fits into the DevOps workflow and into the cloud workflow. Why cloud environments love Docker because of speed and multiple flexibility that Docker offers, right? In this video, we saw the use cases and where it lies into DevOps domain. In the next video, we start with the installation and with the actual journey of Docker. So yeah, that was all for this video and I will see you in the next one. Thank you very much and keep running.
All right, welcome back. So finally, it is the time for the installation. In this video, I'm going to tell you how you can install Docker into Linux-based system. Also, I'm going to tell you how you can do the same for Mac and Windows-based system. Right. So for Linux, we are making use of Amazon EC2 instance. So it would be pretty much easier for us for doing the practical. And once we are done with the hands-on, we can just stop the instance and then we can restart it whenever we want to practice. Right. So let's get started with it. So before even we move forward, just wanted to let you know that whatever things and the commands we are going to execute, it's been documented in this repository where you can follow each and every instruction. So basically, whatever command we are running, if you want to know what actually it does, everything is documented in this repository and where this data is coming from. So it is coming from the official documentation of Docker Hub. So basically all you have to do is search for Docker installation on Ubuntu. I'll suggest to go with the official documentation, but since we are installing the fresh package, so you can refer my MD file, okay, but it is suggested to go with the official documentation, right? So here you will find the documentation for installation of Docker into Ubuntu based system and whatever things are required. Basically what this command does is basically it will remove the conflicting packages, right? So if you want to know more about the command, what actually it does, everything is documented in a sequential manner into the MD file. So either ways you can refer both the documentation, right? So let's get started. So the first thing that we have to do is we need to first launch an EC2 instance. So I'll go to Amazon and I'll just click on EC2 and I'll just launch an instance. Let me name it as Docker pack, and I'll select the Ubuntu as the base OS. Okay, and I'll scroll down. The instance type would be t3.micro, and here you may select any key pair. And if you don't have, just click on create new key pair and your key pair will be downloaded. Okay, so I already have one, so I'll just select this one, Ubuntu-local, and no need to enable any of the security groups. Will whenever there is a need, we'll enable it on the fly, right? So keep everything as is and just click on launch instance. Now within some time your instance will be up and running, and then we will be starting with the installation of Docker. Now here we won't be running the commands as a sudo user because we want to follow the official practices whatever we do into the live environment. So we are going to allow all the permissions, all the root permission into the user, so that we won't be utilizing the sudo commands, right? So let me go to the instance and let me just launch it. So I'll just click on connect. Either ways, you can try to connect with two method. If you want to launch a new console into the web browser, you can just use EC2 instance connect. For me, I want to use SSH client connect. So I'll just copy the command and I'll go to my terminal. I'll just paste the command. So basically we are trying to do the SSH, and once the SSH is success, we are inside our VM, right? So yeah, we are inside our Ubuntu machine. All right, now let's follow the documentation which is given in the GitHub MD file. So the first thing would be we need to remove the conflicting packages. So I'll just copy this command and I'll just paste it. Now, whatever I'll again repeat, whatever commands we are executing here, it's coming from the official documentation. So no need to worry which version are we downloading. We are downloading the latest package of Docker itself. So let me scroll down, and here we will be downloading the official GPG key from Docker itself. And thirdly, let's go down, and here we are going to add the Docker into the apt repository, okay, which is the package manager in Ubuntu based system. And let me know if you face any issue during the installation. Just paste that error message into the comment so that I can help you with the installation. If something goes wrong, let me know. I'll just help you out with that. All right. So it will add into the apt repository. And finally, this is the final command that will install Docker into our system. So basically, it is not just installing Docker. It is installing Docker CLI, container IO. It is installing Docker BuildX plugin. Also, it is installing the Compose plugin. So there are multiple things that it is installing. So let it install. And after that, we are enabling and starting Docker. So by default, it is up and running, but just to double verify and put a double check, we are running this command. Okay, so it's done. And now let us enable the service. All right, so it says services enable. And then the final thing is we are adding. Okay, so now see, after the installation is completed, and to manage the Docker as a non-root user, okay, we will add your user into the group of Docker so that you can run the Docker command without sudo. Okay, so let me run this command, sudo usermod -ag Docker user. Okay, so the current user is Ubuntu, so it will be added into the Docker group. Now, what will happen if I run Docker -fn version? Okay, it is showing a Docker version correctly, but if I run Docker run hello world, okay, it is saying permission denied, but you might be wondering, we already gave the permission and we added the user into the group of Docker. Why it is not running? Because whenever you do any configuration changes, Linux system needs a reboot. So let us reboot the machine. I'll go to the machine itself and we'll click on the ID and I'll just reboot the machine. So let me just reboot the machine. It will take some time and then we will be able to execute that command. Okay, now let's wait for some time. And meantime, let me show you how you can perform the installation for Mac-based system and Windows too. So all you have to do is open a new tab and search Docker install Mac. And if you're a Windows user, just search for Docker install Windows. Okay, just go into this first link, and here, based on your system type, whether it is Apple Silicon or Intel chip, just click here and it will start downloading the package. Okay, Now it is pretty much simpler. Just you have to download it and just double click, accept all the permissions, and then you are installed. You have installed Docker into your system. Now, how would you run it into the local? That is also something that I'm going to show you in this video. So don't worry, everything will be covered. Now, I think the machine will get restart, and let me just do SSH once again. All right, the machine is restarted, and let me run a Docker run command once again. So Docker run hello world. Okay. So here you can see it is actually running. So what it did actually, it tried to find the hello world latest image locally. It was not present. So it tried to connect to the artifact and search for that image. It found that image, it pulled it, and then it executed that image, right? So that was something that happened over here. Don't worry if it didn't make any sense right now. We are going to cover containers and everything into the coming video. This video has a dedicated focus on installation. So that thing is done, right? So installation on EC2 instance is done. Now let's start with the installation on Mac-based system, right? Let me just exit it. And before we close this session for Linux, let me just terminate this instance or stop this instance. So let's stop this instance for now. And whenever we want to practice, we are going to use the same instance, right? So let's consider that you have installed the package into your Mac-based system. And if you are a Windows user, now let's consider that you have installed your exe file. Now, once everything is done, let me just open the package. So I'll just search for Docker. Okay. And all you have to do is just click on it and it will just boot up the system. All right. So it will take some time. And once the engine is up and running, you can see Docker is installed. Now let me just open my terminal. Let me clear it. And here, let me run the same command which we executed into the EC2 instance. So I'll just run Docker run hello world. So when you are dealing with Mac-based system or Windows-based system, all you have to do is just uh, start the application Docker desktop, and then you will be good to go. It will again find the image locally. And since it was not present, it will try to connect to Docker Hub. It will pull the image and it will execute it. So the answer will be the same. The process will be the same. Okay. The only thing that is different over here is earlier we were using EC2 instance, but here we are using Docker desktop. Now, what is the difference between Docker desktop and Docker CLI? That is also we are going to see in the coming video. But for now, it was about the installation. I hope you learned how you can install Docker into your Mac-based system, into EC2 instance, and into Windows-based system. If you face any issue into the installation, just post your error messages into the comments and let me know so that I can help you with the installation. Now, once everything is done, we'll proceed with the next step, right? And I would suggest to follow the documentation which are given into the Docker website, and also you can follow the MD file which is given into my GitHub repository, right? So yeah, that was all, and I will see you in the next one. Thank you very much and keep learning. All right, welcome back. In the previous video, we saw how we can install Docker into Linux-based system. Then we saw how you can install it into Mac and Windows, right? But there must be one question. If we have Docker desktop, we are getting a graphical overview why we should consider Docker CLI in the very first place. In this video, we are going to see the pros and cons of both the Docker desktop and Docker CLI, and why we should consider Docker CLI instead of Docker desktop, and in which scenario we should use Docker desktop. So that is the agenda of this video. So before even we move forward, let us first understand each one of them independently. Then what is actually Docker CLI? So here CLI stands for command line interface. So it's just like you are typing the command, you type Docker run nginx, Docker ps, Docker images, you just type the command and Docker will execute for it, right? So we even saw what actually Docker engine does, right? So here you are just typing the command and everything is done at the backend. So no buttons, no graphic, just command. So a black screen is there. You are just typing the commands and the work is done for you. Okay. Now, if you want to see a visual representation of what's happening at the backend, we have something called Docker Desktop, the application that we just installed, right? So Docker Desktop is a graphical application, GUI, that includes Docker engine plus a visual dashboard. Okay. So it gives you start stop container buttons. But when you do the same with CLI, you just have to type the command, right? Docker stop followed by image and container. Okay. So this would be the command that you would be using for stopping the containers. And then it will give you a view so that you can list the container. It will give you logs. So everything will be present in a visualized manner. But when it comes to CLI, you have to just put some hard effort and you have to type the commands manually. So that's the reason. That's the basic difference between Docker Desktop and Docker CLI. I can show you how does desktop looks like. So remember in the previous video, I showed you how you can install Docker Desktop. So this is how it looks like. Here you can see all the running containers. Here you can see all the images which are present over here, right? You can even see the builds. You can even see the volumes. Everything is present in a visualized manner, right? But in Docker CLI, you have to write the commands to even see the containers which are running right now, right? So basically, that's the difference between Docker CLI and Docker Desktop. Now, since they both resemble, they are on the same technology, they use the same engine, right? It's not like Docker Desktop is a different technology. No, it's the same thing, but the only thing that is doing an add-on is it is giving you a visual representation. So Docker Desktop does not replace CLI. So inside Docker Desktop, you will have a CLI itself, right? So inside Docker Desktop, Docker engine is running, CLI is available, GUI option is optional, and basically it's just like Docker Desktop is combination of GUI plus CLI which works together. So even when you are using Docker Desktop, you are still using terminal commands. So at the backend, these are the commands which are using. Okay. Now you might be wondering, where is the terminal in Docker GUI? So here at the bottom, you can see if I click over here, you can find the terminal, and from here I can run the commands. So Docker images, and here you can see it is working as it is supposed to be, right? But if I want to see it into visualized manner, so I'll just go over images, and whatever result is printed over here, I can actually see it. So it is very much easier for me to navigate into Docker Desktop, right? And if I want to run this image, right, so I'll just click on here and it will execute that image, and then it will form converted and we get converted into a container, right? So that's the basic use of Docker Desktop, right? So this is the basic reason. When you're starting with Docker and you find it difficult, then you can switch to Docker Desktop, right? So why Docker Desktop exists? So originally Docker was invented for Linux based system. It worked fine on Linux based system, but for Windows and Mac it needed virtualization setup. So Docker Desktop made it easy by automatically setting up the environment, managing virtualization. Okay. And it gave a visual representation, a visual interface for the people who find Docker difficult to understand, right? So when to use Docker CLI and when to use Docker Desktop. So CLI is used in uh, Linux based system. It is used in production, and in many companies, Docker CLI is being used. Okay, so you can consider Docker CLI when you are using when you are trying to do SSH into cloud-based environments, and you want to create CI/CD pipelines, and you want to automate bits. And when to consider Docker Desktop. So if you are new to Docker, you want a visual understanding how does things work, you are debugging things locally, and you prefer seeing logs visually instead of writing the command, and you are using Mac based system or Windows based system, at that time you can consider Docker Desktop. But mostly if you ask me which one is preferable, so I will 100% suggest you to go with a Docker CLI, because that is something that is used in company, that is something which is used into the production. So let us see a direct comparison of Docker CLI and Docker Desktop. The main thing of difference over Docker CLI and Docker Desktop is the size of the exe, right? Docker CLI is lightweight and Docker Desktop contains the exe file contains the size is big, right? So Docker CLI is terminal based, whereas Docker Desktop is GUI plus CLI. That's the reason the size of the application is big. So, but in terms of installation, it is easier to do the setup for Mac based and Windows based environment. Whereas when it comes to Docker CLI, you have to fire multiple commands, which we did in the previous video. So Docker CLI is used in production. It is required for automation, and it is something that is used in industry. But when it comes to Docker Desktop, it gives you a visual dashboard. It is beginner friendly, and there are a few external tools included into it. Right? Now, whatever we learned so far, let us just do a quick recap. We learned about Docker CLI. Docker CLI is a command-based environment that helps us to interact with Docker engine, right? Docker desktop is Docker GUI plus Docker engine. So whatever we do by running the command, it gives us a visual representation. And we learned that in production, Docker CLI is used. And when to consider Docker desktop. So when you are new to Docker and you want to view things visually, you can prefer Docker desktop, right? So yeah, that was all. In this video, we saw a difference between Docker desktop and Docker CLI. I hope you understand the basic difference between it and when to use the application, right? So like in the initial videos, I will tell you how you can use Docker desktop, but we will stick on to Docker CLI because that is something that is used in the industry, right? So yeah, that was all, and I will see you in the next one. So till then, keep learning. Thank you very much. All right, welcome back. So in today's video, we are going to run our first container. In the previous video, you have gone through the installation and I'm pretty much sure that you are done with the installation. If you face any issue, just let me know the errors that you are facing. Let me help you by creating one more video in the installation process. But if you have followed the documentation, if you have gone through the MD file, which I shared already, then there are 99% chances that the installation is success. Even though if you face any issue, just let me know. All right. So what is the agenda of today's video? Today, we are going to run our first container. But during the installation, we ran one command, docker run hello world. At that time, I told you that we are going to cover that in later video. And this is the actual video where I'm going to tell you what happens when you run that specific command. Along with that, we are going to explore a few more commands about Docker, and that will give you the clarity why actually we should consider Docker in the very first place, right? So let's get started. So as you can see, my instance is already up and running, and let me just take SSH so that I can directly take access. I'm using EC2 instance. Feel free to use Docker desktop. Okay. At the end of the video, I will show you graphically how you can perform the same actions that we did using CLI into Docker desktop, right? No worries. But the main point of view would be the CLI itself, right? So right now you can see I am into my Ubuntu machine. And what would be the first thing that you do once you are done with the installation of any package, any software? So the first thing would be you will check the version, and second would be you will check whether that service is active or not. So in Docker, how do you check the version? So for that, we have a command called docker -- version. So this will tell me the current package that it installed in my system. And as you can see, the current package installed in my system is 29.2.1. Okay. Now, how would I check whether this service is up and running? So for that, we have a command called systemctl status docker, and that will tell me the current state of Docker. Now, what are the different states of Docker? It can be active, it can be dead, right? It can be restarting. So let us check what is the current state of Docker. Systemctl status docker. And here you can see the current state is active and it is up and running. All right. Now, what if I want to stop this service? Okay. How would I do it? So let me just clear the screen. The command remains the same. The only thing that changes over here is instead of status, you have to replace it with stop. How to do it? So systemctl stop and followed by the service name. Here, the service name is docker.service, or you can directly write as docker. So here it is asking us for password. Now, if you remember, while we were installing and we configured our user, right? We added our user into Docker group, right? And that's the reason it is asking for authentication. So let me just add the user password. And the user authentication is completed. Now what happened? Docker.service will get stopped and it will get triggered. Okay. And the status will get reflected. How do we check the status? Again, we will run the same command, systemctl status docker. If you want to start the service, the command will change to systemctl start docker. See how easy it is. All you have to do is to change the placeholders, right? So let me just check the current state. So let me run systemctl status docker. And here you can see the current active state is inactive and it is dead since the timestamp which is given. And it's 29 seconds ago, right? Now, what if I want to restart this service or start this service? So again, I will just write systemctl restart docker or start docker, right? So I will just type the command systemctl start docker to start the service, right? Let me just clear the screen. systemctl start docker.service, or you can even write docker. Okay, it is again asking for the password because it will perform the action based on Ubuntu user, right? Here it is saying authentication complete, and then the service we get active. Okay, let me just run the command systemctl status docker, and here you can see the service is active, up and running, ready to serve its purpose. Right. So that was all about how you can check the current state of Docker, how you can verify the version, right? I hope that is very much clear. This is very much basics that you should know when it comes to Docker, right? And even any package in Linux, if you want to just check the version, just add hyphen version or -v. It will tell you the current version, right? And when it comes to checking the status, just write systemctl followed by the service name. It will tell you the current state, right? Let me just clear the screen now, and let us proceed by creating the first container of this series, right? So what would be the first command that we run when we are into any programming language? It's hello world, obviously, right? So in case of Docker, we are going to perform the same. So here we are going to create our first hello world container. How to do it? It is pretty much simple, basics, no need to worry about anything. So all I have to do is just write Docker run hello world. Now, the question is, Shubham, how do you know hello world image is there? Second, how do you know what will be the output, right? Where this information is coming from, how it will work? I will answer each and everything. For now, just notice the behavior. So let me just fire the command. Now here you can see hello from Docker is printed. Now how and why it got printed? Because you remember earlier in the previous video, we just installed the system. We ran this command earlier, and earlier it was showing us the command that it was trying to find the image in local. Then you said it is trying to find it into Docker Hub. Okay, printed the console, right? But right now, when you executed the same command, it printed instantly. How did this happen? So basically, what happened is whenever you run any command in Docker, okay, so it will first check whether that image, okay, image exists in local. If it doesn't exist, then it goes to step 2. It checks it into Docker Hub. Now, once the image is present into Docker Hub, it will pull the image into local, okay, and then it will turn it into a container. And once the container is created, you will be able to see this beautiful output, right? So these are the backstage steps that are running when you run the command docker run. Okay. Now you might be wondering, okay, you said that it will search the image in local, right? So how do I list all the images which are present in my local, right? So there should be some way, correct? So for that, you just have to run the command docker images. Pretty simple, straightforward. Okay. Now here, just note what are the things that are displaying on the screen. Let me explain you each and everything into very much basics. Okay. So the first thing is image, and here it is saying hello world :latest. All right. If you remember correctly, I just executed the command docker run hello world, but I didn't specify the tag. Okay. So whatever comes after this colon is considered as tag. Okay. Here it is saying that it took the latest tag. What is the meaning of that? So basically, when you are running any command in Docker and you are not specifying the tag, okay, it will take the latest version. Now, what do I mean by tag? So let's consider a scenario where you are going into a shopping shop and you're visiting a Levi's showroom, right? And you're purchasing a jeans. So how do you identify the jeans, right? Basically, there is a branding done by the brand itself, right? When you see that Levi's logo in that jeans or into that cloth, you identify that, yes, this is the trusted brand and this is the one that I'm looking for, correct? So that is how you identify it, correct? So same way it goes with the tag itself here. Basically, whatever image we are targeting to, it is a version with some specific version 1, version 2, version 3. And if no version is mentioned, then it will take the latest version. So that's the basic rule. Okay. Now, moving forward, here you can see there is something called an ID. So whenever you are dealing with any Docker image or with any container, it will have a dedicated ID for that image and for that container. Okay. Now, why ID is used? Basically, ID is used for the identification. For example, your Aadhaar card, your PAN card have a unique number. Likewise, you have ID in Docker and image and container, so that it will be helpful for us to identify the images and container. Okay. So basically, instead, when you want to run the command Docker run followed by you mentioned the image, you can just mention the ID. It will give the same output, right? So that's the basic use case of ID. Next is disk usage. So how much space it is consuming. Now, since we are into Docker, we are not into a virtual machine. It is consuming very less space. That is 25.9 KB, which is very less. We compared to the system when we were using virtual machine and when we were using legacy based system, correct? And then the content size, it is 9.52 KB. Okay. And that's it. Okay. Now, if you remember, I told you image, when it gets executed, it converts into a container. So image here serves as a blueprint or prototype through which a container is created. Correct? So if someone asks you what is the difference between image and container, so you can just tell them, okay, image is a prototype through which the container is created. Image still is considered as Docker image, but when that image is executed, it turns out to be a container. All right. I hope that makes sense. Till now, we have gone through the theory of Docker images and container. And right now, it will be making sense for you because everything is being in front of you so that you can just make sure what things are currently going on. Now, here you mentioned, okay, I can list the Docker images. Now, how do I list the running containers? So for that, we have to run the command docker ps. Now, Docker PS will tell you all the running container. But again, Shubham, you said it will tell you all the running container. And I already fired the command Docker run hello world. Now, why it is not listed over here? Is there any problem with the container or is Docker behaving unnecessarily bad? Basically, it's not the issue of Docker and it's not even the problem of Docker image and container. It's the behavior. So once the process is completed, the container gets terminated automatically. How do I validate it? So basically for that, just run docker ps-a. And here you can see all the commands that were executed within that container. So here, as I mentioned earlier, each container will have a container ID, and from which image it is created? It is created from hello world image. And what was the first command that got executed? So it was /hello, right? It was created 5 minutes ago. It got exited with 5 minutes ago. Okay. And there is a name, recursion, drisk call. Okay. So Docker itself gives the container name by default if we are not specifying it. If we want to specify the container name, all we have to do is just add the hyphen name parameter and it will update the name. But for now, that is not the agenda. The main agenda is to just focus how the container are working, how it is behaving, right? I hope that made sense. So basically, this was a service. Now, once the service is done with its work, it gets exited. Here you can see it is showing the exited status. Okay. If it was still running as a background service, so it would have been active and running, right? So that are multiple status that the container go. What status in container in Docker? That is something that we will see in depth in the coming video. But for now, just understand that whenever a container is done with its job, it gets exited because there is no need for it to run, right? So yeah, once the purpose is solved, it will just go and dead. Okay, let me just clear the screen. That was about the life cycle of container and images we just saw. Now, let us see, I want to run an Nginx web server, right? So how do I do it? The first thing is, how do I know whether it is present in my local or not? I will run Docker images. Okay. Now here you can see there are only two images which are present. Hello world. Okay. So there is only one image which is present, that is hello world :latest. Now if I want to pull the image Nginx, how do I do it? So the first thing that I will be doing is I will check Docker Hub. What is Docker Hub? So for code, we store the code in GitHub. Likewise, a place where we store all the images, we have a place called Docker Hub. Okay. So it's of the same thing. Like in GitHub, you store your code. In Docker Hub, you store your images. So I will search that image into Docker Hub. So I'll go to a web browser and here I'll just search for the image name. So here I'll just search Nginx, and that should be an official Docker image. And if I click over here, you can see Nginx image is present over here, right? So what I'll do, I'll just write Docker pull Nginx, and note that I'm not putting any tag over here. So what is the default tag that it will pull? Yes, you are correct. It will pull the latest tag. Okay, so let me just execute it. So it is using the default tag, and it will be pulling the image from Docker Hub, and it is further it is classified into multiple layers, and that's the reason you can see it is saying pull completed and download completed. Now once everything is done, it is seeing the status that downloaded newer version of Nginx latest. Now how do I validate that the Nginx image is actually downloaded? I will run the command docker images again. Let me clear the screen. Docker images, and here you can see Docker image is present. Now what if I want to run Nginx and see the output into the browser? How do I do it? Okay, so for that we have a command docker run. Okay, but along with that we will be adding few more parameters, and what it may be. So docker run -d, since I want it to run into the background, it is a daemon process, and I want to map it with the port from my computer host port 8000 to the web port, okay, to the outside world port. Okay, so when I say outside world port, so basically I'm mapping the Nginx port with the computer ports. So it would be -p 8000 colon port number 80. Okay, so docker run -d-p followed by the port number. Here we did the port mapping, and here we will specify the Nginx image. Now this time let us do something different. Instead of providing the image name, let me provide the image ID. Will it perform the action? Let us check. All right, here you can see some SHA values present, but did the image execute it? Did it convert it into a container? How do I validate it? So for that, I will run the command docker ps. Oh, you can see this time the service is running. Okay, and here you can see the command that is executed is the entry point. It is created 15 seconds ago. It is up, and here you can see the current status. Earlier, in the case of hello world, it was exited, right? And here what we did, okay, it is showing the container is running, but why we are not able to see the container, the Nginx page? It's because we mapped the port number 80 from our container to 8000 port from the outside, right, into the security group. So the first thing that we have to do is we have to go to the security again in security group. Let me edit the inbound permissions, and here I just have to delete the custom rule, and here I'll just add custom TCP, and it should be 8000, and let me just save the rules. Okay, now once everything is done, I'll just go back and hit the public IP with port number 8000. And here you can see it is showing welcome to Nginx, and this is done completely, entirely with the help of Docker, right? So that's the power of Docker. Now, how do I stop this container? Is there any command? So yes, definitely there is. So Docker stop followed by the container name or container ID. So I'll just pass the container ID, and it will stop the container. Now, what would be the behavior? So once the container is stopped, the page that was displaying into the outside, okay, the page will get stopped. Okay, it will not display anything. When I just refresh, it should not show me anything. Okay, it is saying the site cannot be reached. But again, when I rerun the command and I just mention over here docker start followed by the same container ID, and I go back and I just do a refresh, you can see it is up and running within an instant. How good is it, right? So let me just stop it once again, docker stop, and let me just clear it. I hope this gives you the clarity. How does containers work? What are Docker images? And how does things work with Docker, right? So it is just one single command that is creating the container, restarting the container, stopping the container. Everything is within the fingertips, right? Now, cherry on cake thing, that is something that I wanted to tell you. Okay. Now, let's say I want to pull an Ubuntu image. How do I do it? The first thing would be I will just go to the Docker Hub and search for the official image, and I will pull it. So I will run docker pull Ubuntu. Okay, UN Ubuntu. Okay, so it is pulling from the latest tag and the image is pulled. Now see here, you literally pulled an entire operating system, which is the base OS. So when I run Docker images, it should show me the Ubuntu image. You can see the Ubuntu image is present. And what is the size? It is 190 MB. Okay, it is 119 MB. Now, what if I want to pull an Alpine image? So Docker pull Alpine. Okay, so it pulled the Alpine image. Let me check the size of Alpine image now. So here it is showing as 13 MB. All right, let me pull the last image and I will tell you what we are up to. Okay, I will pull the BusyBox image. So Docker pull BusyBox. It must be BusyBox. Okay, and it pulled the BusyBox image. Let me just list all the images. And here you can see all the images are present. Let me remove the unnecessary images which are not needed. So how do I remove it? So I will first remove the hello world image. So Docker RMI, that stands for remove image. Okay. And here it is saying that there is a conflict unable to delete. It must be post. There is a container that is using this reference image. Okay. When I do Docker PS-A, here you can see all the containers are present. I have to kill all those containers which are not in use. How do I do it? So Docker RM followed by the container ID, and that will remove the containers that are not in use. All right, I'll delete it. And by passing all the IDs, I'm deleting all the containers at once. And then when I run the same command, that is Docker RMI followed by the image, it will get deleted. Let me clear it and let me run Docker images once again. And here you can see we just have to focus on three images, that is Alpine, BusyBox, and Ubuntu. Okay. Now let me remove Nginx image too. How do I remove it? So I will just copy the image name, Docker RMI followed by the image name. Okay, it is deleted now, and let me just fire it once again, Docker images. All right, so here we have the area of focus where we would be just focusing on these three images. Okay, now here you can see we have three images, Ubuntu, BusyBox, and Alpine. Now, why I dedicatedly choose these three images is because just to show you the size difference. See, whenever you are working with the Linux-based system and you want to pull an Ubuntu image, a Linux-based image, you use a Docker image. Okay, there is a lighter version present for it, that is Alpine, which is again based out of Linux, and that is just of 13 MB in size, which is not even the half of it. It is very small. And again, if you just want an Linux environment where you just want to do the hands-on, okay, there is again a lighter version to it, that is BusyBox, that will do the job, that will perform all the basic tasks that you want to do. Now, what if I want to go inside the container inside of this image and perform the Linux task? How would I do it? So for that, I will run the command Docker. Let me correct the spelling. Docker run, okay, -it followed by Ubuntu. Okay. Now here you can see the terminal difference. Earlier it was showing Ubuntu at the public IP, and here you can see the shell is changed to root. When I do ls, you can see all the executable correctly present. Now, how do I identify, how do I verify whether I am inside Ubuntu or not? So let me just run the cat command, cat/etc/os-release, and this will give me a proof that I am inside the Ubuntu machine. Okay, and here I can literally perform all the operations that I perform in Linux. Okay, so what we did, we pulled an image, we turned out into a container, and now we are inside that container. Now, how do I exit from this container? I'll just type exit. All right, we were able to perform this Linux operation in Ubuntu. Then why did you ask us to pull Alpine in BusyBox image? Is just to show you that you can perform the same operation into the less sized image, right? So here Alpine, you can see it is of 13 MB. Let me run the same command, Docker run -it interactive terminal, and I want to run the Alpine image. So I'll just write Alpine. And here you can see again, the shell got changed. Let me do ls. And here you can see it is showing me all the files and directories. Let me just verify cat/etc/os-release. And here you can see Alpine Linux, which is the lightweight version Linux distribution itself. Again, whatever task that we were doing on Ubuntu, we can perform the same task literally into Alpine based image, which is of less size. And this is how we are doing the space management. Let me just exit from this container too. Are we able to perform the same operation in BusyBox? Yes, definitely. So let me just run BusyBox image. So Docker run -it for interactive terminal, since I want to run the commands inside it. And I'll just type the image name BusyBox. And I am inside the BusyBox container. Here, if I do long list, okay, ls, you can see there is a binary directory. Okay, now here I just wanted to tell you that Alpine is based out of BusyBox, and BusyBox has very limited since the size is very less, it has very limited capability, right? But we can perform the Linux operation. Now when I go to /bin, you can literally see all the commands that we actually execute is present over here. Let me run the echo command, echo hello world. And here you can see it printed the output into the console. Now you mentioned that Alpine image is based out of BusyBox. What is the meaning of that? Let me just show you. So here you can see we have Ubuntu. Okay, that was the base OS that we had, but the size was huge. That's the reason Alpine came into the picture, and we had BusyBox that is again the minimized version of it. Okay, here we are talking about the size, but again I told that BusyBox comes with limited features, but we can literally perform the Linux operation. But when I say Alpine is based out of BusyBox, what do I mean by it? Let me run Alpine and show you what do I mean actually. So Docker run -it, and I want to run Alpine image, Alpine, and let me press enter. And let me just run ls, and let me go to bin. And here inside bin, when I do long list ls, okay, here you can see we have something called BusyBox. That was the basic thing that I wanted to explain, because whatever BusyBox is capable of doing, it will be done by Alpine 2, which is the lighter version of Ubuntu, of lighter version of Linux, right? So yeah, that was the main purpose for me to showing you everything that I wanted to, because here we learned 3-4 things. We learned that for every image there is an image ID, and we learned about the disk usage. Now let's consider that you want to run an application that require Linux capabilities. Which image will you choose? Will you choose Ubuntu? Will you choose BusyBox, or will you choose Alpine? Now it will completely depend on you whether it just need Linux functionality. If it just need Linux functionality, then it is of no use that we will be pulling Ubuntu image, because that will consume the size. The size of that image is very high. Then we can consider two operations, two option and variations, that is BusyBox and Alpine. I hope that made sense. Let me clear the screen. Docker images. So that was the basic reason for me to showing you what is the difference between Ubuntu, BusyBox and Alpine. If you didn't understand what actually it is, don't worry. We are still on a journey to understand Docker, right? Today, we just have to focus on creating container. This was just to demonstrate that how would you do the things if you want to do it into limited resources. So that was the main reason of it, right? Now, as promised, I will tell you how you can do the same thing with Docker Desktop. Okay, so let me just run Docker Desktop in my local, and here I'll just open it. So until it gets boot, meantime I'll just terminate my instance so that it won't occur me more charges. So I'll just go over here, instances, and let me just stop it. All right, this is done. And here, let me just close my terminal too. Okay. All right. So here you can see we have Docker Desktop. Now, whatever we did in a command line into a console, how can be done into the Docker Desktop? See, everything you need is present in a single place. Now, let's say if you want to search an image, go to Docker Hub, search for, let's say, Ubuntu, search it. It will search, and here you can see there are multiple images which are present. And if I click on the first one, here we have the official Docker image. We don't even have to go to browser. Everything is present over here. Now here you can see there are multiple tags which are present, different version. If you want to pull it, it will directly pull, and if you want to run it, it will directly run. Let me pull the image. Now here you can see it is pulling the image. earlier what was happening at the backend, we were running Docker pull Ubuntu latest, and it was actually pulling it from Docker Hub. But here we have a GUI which will do the job. We don't even have to worry how things are done, how it is doing. Everything will be present. Now, since the pull is done, let me go to images and check whether the image is present or not. And here you can see Ubuntu image is present. If I go back to Docker Hub, let me take a OpenJDK image. Okay. Okay, let me take the first one. Okay, now let me just pull this image, and here it is showing that pulling OpenJDK 27. All right. And now when I go to images, you can see the OpenJDK image is present over here. It is pulling. That's why it is showing you the progress bar. Now let's say if you want to make this image as a container, how to do it? Just click on this action button. It will run, and there are option setting if you want to do. But since we are just learning, don't worry on that. Just click on run. And what it will do, it will just execute that image and convert into a container. Now, if you can see here, you can inspect it. Here you can see the build mode, exec, everything is present over here. But we don't have to worry about it. If I go to container, it will show me all the running container. And here you can see Angry Ramen is present. All right. So in this video, we saw what actually is Docker, what actually is Docker images, how we can use, how you can run the first container, what is Docker Hub. We literally pulled multiple images for practice. We even saw what is the significance of ID, how you can perform the same operation in Docker Hub. Okay. And before even we close, there is one more thing that I wanted to show, that is terminal. If you want to run the same command into Docker desktop, that same command can be executed over here. All you have to run is Docker images. And you can see all the things which were mentioned, which were executed, okay, which were pulled actually is present over here. If I run Docker PS, Docker, you can see all the running containers are present over here, right? So basically, see, there is one more thing before I close. So basically, if you want to execute command to run the container, you just have to upgrade. No need about that. We will just run the command into the terminal and you will be able to go inside the container. So yeah, that was the difference between Docker Desktop and CLI. In this video, we literally learned a lot more things. Okay. So just focused on the basics. Just try to create the container. And if you face any issue, just let me know. I will definitely help you out with that. So yeah, that was all. And I will see you in the next one. Till then, keep learning and thank you very much. All right, welcome back. So in the previous video, we learned how you can execute your first container. We literally executed multiple Docker commands. We saw how to list images, how to run a container, how to kill a container. Okay, so those were the multiple commands which we executed. We even passed few arguments, which I told that I will tell you later. And this is the video where we are going to learn it. But the question remains, do I need to memorize all those commands? The answer is straight away no, because if you understand the structure of Docker, then it would be easier for you to write the commands, right? In this video, we are going to understand the command structure which are used in Docker. So let's get started. So the Docker structure is classified into three segments. First is command, option, and arguments. If you understand this, then you can literally write any Docker command. Okay. Now let's start from the basics. So here we have the first thing, that is Docker. Now, what does Docker signifies? It tells the system, okay, that Docker will do the job. For example, if you want Docker to list the image, what command do you use? You will use Docker images, right? So the system will get a notification, hey, Docker, list the images. So the user will type Docker images and the images will get listed. And second is the command. So it tells Docker what action to perform. Okay. And this goes to Docker program. Okay. So backend, when you run Docker images or Docker PS, this is something that has been referred. Now, option. Now, in the previous video, you might have seen that I was passing the options -d, -p for port mapping, -d for running it as a background image, right? As a background container, background process. So those were the options which I was passing. So this gives us the clarity that if we want to run a service into background mode, or if we want to do port mapping, that can be done with the help of option. Okay. Last is arguments. So arguments are the image name, or it can be container. So if you want to sum it up in a single word, let's say if you want to run an Nginx image, how will you do it? So Docker run -it t. Okay. And then since I want to run it into background process, I added -d, and then I will do the port mapping -p. Then I will map the host port along with the container port, and then I will pass the argument. So it would be the name of image, and it will be converted into a container, right? So let's move forward. Now, whatever I said, let us visualize the same. So it contains of command, options, and argument. So basically here Docker, it mentions that the system tells the system to use Docker, and in order to perform the operations, it will need the command. So it will tell Docker what actions to perform. Now there can be multiple actions that we can do. If we can run, we can build, we can pull, and we can stop. Right? These are the multiple actions that can be done with Docker. Now, we provide option to modify the command behavior. Let's say if you want to run something at the backend as a daemon process, you will pass -d. If you want to do port mapping, you will pass -p. And if you want to rename something while execution, you will pass -name argument, -name option, right? And that will actually rename the container when you run Docker PS. And at the end, it will expect you for an argument, and that argument can be your image name, it can be your container name, or it can be a file path. Okay, don't worry if this sounds too much technical or too much theory. We are going to do the hands-on, and at that time it will make sense to you. Now, what sort of commands do we have? So the commands in Docker are categorized into two sections. First is image commands and container commands. There are system commands too, but that is something that we will cover in the later video. But for now, let's focus on image commands and container commands. Now, image commands are used to manage images, whereas container commands are used for managing the container images. For example, the image commands can be docker pull, build, init, and RMI. Okay, we are going to make use of all these commands in today's video in the hands-on, and it will make sense to you. When it comes to container commands, it can be docker run, docker ps, docker start, docker stop, and docker rm. And all of these commands we saw in the previous video. But today I'm going to tell you exactly with the Docker structure so that it will help you to understand how does the commands are framed, right? So let's get started, and let's start with the practical demonstration. So I already have booted my EC2 instance, and let me just do an direct sh. I'll just copy the sh command and I'll go over here. Yes. Okay, let me open the structure over here so that it would be easier for me to explain you each and everything. Now, let me clear the screen. And the first thing that I will check is whether the service is up and running. So system ctl status docker. Okay, so here it says the system is up and running. All right. Now, the first thing is I want to pull an image. So for that, I have the command docker pull. So if you go through this command structure, we just need to make use of docker and command. And there is no need for passing the options and argument. Okay. So let's say I want to pull nginx. So docker pull nginx. Okay. So what it did, it first checked it's first added the default tag that is latest, and then it searched for the image in my local. Now, since it was not present, it pulled it from Docker Hub, and finally the image is present now. Now, what will happen if I rerun this command once again? So it will say that the image is up to date and the tag that we are using is nginx latest. All right. This time it didn't went to Docker Hub. It literally checked in my current system. Now, let me go to the last slide that we were referring to. That is Docker images command. Okay, let us explore all of them. So first we made use of docker pull. Now let's say we want to list all the images which are present. So I'll just write docker images. And here all the images which are present are listed over here. And here you can see nginx latest, which we just pulled, is listed over here, right? And let's say I want to remove an image. So let's say I want to remove Ubuntu image. So how will I do it? So docker RMI remove machine image, and you can either pass the image or you can either pass the image ID. Okay. Now here we got an error. Why? Let us go through it. Error response from daemon conflict unable to delete Ubuntu. It should be forced. There is a container that is using this image. All right. So let me just check the current running container. All right. We can see there are no container running, but there must be a container which was referring it earlier. So we need to delete all the containers which are using Ubuntu image. So what will I do? I'll just remove all these container. Now, since these are this container already did their job, that's the reason they are under the status exited. So how do I remove a single container over here? So I'll just write docker rm and I will add the container ID, or even I can pass the container name. So I'll just pass the container ID. And this is so I will remove the container. Let me clear the screen. Let me rerun the command once again. That is docker ps fne. Now here you can see we have the containers which are utilizing BusyBox image, Alpine image, Ubuntu image. And now since we want to remove the container that is utilizing Ubuntu image, let me remove that one. So docker rm to remove the container that is utilizing the Ubuntu image. All right. I passed it and let me clear the screen. And now when I run docker images, we can see Ubuntu is present over here. Now in the current scenario, there is no container which is referring to Ubuntu image. Now it is the perfect time for us to delete it. And this time it won't throw any error because no container is referring to this image. So I'll write docker rmi remove machine image, and I can either pass the ID or I can even pass the image name. This time I will pass the ID, and you can see it is deleted now. If I rerun docker images once again, you can see Ubuntu image is deleted now, right? How clear is that? So the only difference when it comes to removal of image and container is when you want to remove a docker image, you will make use of docker rmi, and when it comes to removing a container, you will just make use of docker rm. I hope that is clear to you. Let me just clear the screen. And now let us make use of the command structure to run the Nginx container. All right. So let me just list the Docker images. So Docker images. Now what I want to do is I want to run Nginx. So for that, we have the command docker run. Okay. Now I want to run this Nginx. Now, since it is a service, I want to run it into the background. I will pass -t. Okay. And I want to do the port mapping. So for that, I will pass -p. Now here, if you see, we are using docker command, and now I am passing the option. So here the docker, okay, I need to first correct the spelling. Let me just correct it. Okay. So here we pass docker. It will tell the system to docker that run this image, right? So we specified docker, and here we pass the command run. Okay, we made use of command, and this will tell docker what action to done. Here we are asking docker to run something. Okay, and then we are passing the option. Here we pass the option to -t to run that service into background. Now since we want to do the port mapping, we passed -p. Now what we want to do, we want to map the host port with the container port. That's why we pass 8000:80. Nginx runs on port number 80, and on the host we want to leverage it on port number 8000. That's why we passed 8000 over here. If you want to change this to 8001, go for it. Okay. Now docker run -d -p. We did the port mapping. Now what's the next thing? It's the argument. Okay. Now argument is it expects you to write the image name or the container name. So what's the image name over here? The name of the image is Nginx over here. So I'll just write Nginx. That's it. But again, one more thing. In the previous video, I told you how you can name your container, right? So that is also I'm going to tell you today. But for now, let's just execute this command. All right. When I run docker ps to list the running container, you can see Nginx is up and running. But here, how do I refer this container? Because you can see currently, if I just zoom out, you can see the name of the container is equivalent Walhart. I don't want that name. I want to give a custom name. How do I do it? So let me just do a little bit zoom once again, and I'll just rewrite that command once again. But let me just change the port number. This time the port number should be 8002. And I want to rename this container. Instead of equivalent Walhart, I want some custom name. So I will pass -name, and I will pass the name of the container. So I want the name to be Nginx container followed by the image name. And when I press enter, the container is created. And let me just list the container docker ps. And here, this time you can see when I zoom out, earlier, the container which we were using, it was equivalent Walhart, but this time the name of the container is Nginx container. So here, what we made use of, we made use of the command structure, and it was very easy for us to do the reference. So here we mentioned Docker, so it will tell the system Docker to do the job. But what job needs to be done? That for that we will need to pass a command. So here we pass the command name run, and then we pass the option -d -p. Okay, and then we passed one more option, that is name. Okay, all these options are passed. Then we pass the last thing, that is the argument. We pass the name of the image, and then it converted it into a container, and now it is up and running. How do I validate this whether it is actually up and running? I will go to my browser, okay, and I'll go to instance. I will copy the public IP, and first thing I will check is the security group. Here, I will check whether port number 8002 and 8001 is open or not. So I'll go to edit inbound rule. Here I can see port number 8000 is open. I'll just change it to 8001, and I one more rule for adding port number 8002 so that we can verify both the containers are showing the same result. I'll just save it, and I will open a new tab, http:// followed by the public IP, and I will add port number 8001. Enter. Here you can see a welcome message from Nginx. Now let me check what will happen if I change the port number to 8002. Okay, it is taking load. Okay, now you can see it is again running on port number 8002. We made use of Docker command structure, and it was very much easier for us to go through it, right? I hope this video made sense to you. Today we learned about the command structure. After this video, whenever you are writing any Docker command, it would be very much easier for you because you will be referring this command structure. Now, if I ask you to run an Ubuntu image, how would you do it? So this is the homework for you. Let me know in the comment. So yeah, that was all, and I will see you in the next one. Thank you very much and keep learning. Hey everyone, so in this video we are going to talk about two most important yet simpler Docker commands, that is Docker version and Docker info. And here we are going to understand why these are used, and basically the main use case of this command is it is used for DevOps troubleshooting, and it is used for production server inspection. So let's understand what these commands bring us into the play, right? This command looks very simple, but it definitely carries a deep meaning, right? So let me explain you everything. So let me just launch my terminal, and yeah, feel free to execute these commands over console because it will show you the same output, right? Based on your system configuration. All right. Right now you can see I am on terminal, and I have Docker desktop installed in my local. So let's talk about the first command, that is Docker version. So let me just write Docker version, and I hope this is visible to you. Let me just do a little bit of zoom. All right, so I hope now it is visible to you, right? So we are talking here about Docker version command. Okay, so what are all these details, right? Because we were very happy with the life and we were executing the command Docker -" version. Then what are all these things? Let us understand each one of them in a nutshell. Okay, so here we have a client section, we have a server section, okay, and let's explore each of the components. So the first thing here is the client version. So here it actually tells us the installed Docker client version. All right, and here we have the API version. So which version of Docker API is used by the client to communicate through the Docker daemon. So that is this API version. Now, if you remember, Docker is written in Go. So basically, what version of Go is used is actually mentioned over here, right? Same goes for the source code commit, which was used to build this Docker release, that is mentioned over here. So in this section, basically, we are targeting what sort of details we can get. Okay, and this is definitely used into the inspection, right? So in client, what operating system is being used, right? So here it is telling us the operating system and CPU architecture, that is Darwin ARM64, right? And what is the context? So basically Docker context is what Docker context is currently being used. The context defines which Docker environment the CLI is connected to. So right now we are connected to Docker desktop. That's the reason here it is written as Docker desktop Linux. But in your case, it might differ. Now let's go to the server section and understand what sort of information we get. So basically this part shows the information about Docker daemon running on the machine. right? So the first thing is about the engine, and here it will shows the engine details such as the engine version number. Okay, that is 27.4.0. The basically this is the version of Docker engine installed on the system. Okay, now what is the API version used here? So basically when we about it in this specific segment, we are talking about the server API version and the minimum supported client version, right? So the minimum version that is supported by the client is 1.24, and the API version of the server is 147, right? Now again, the Go version which is used to compile the Docker engine is go.1.22.10, right? Now, which source commit is used to build the Docker server? It's basically the SHA-1 hash. And then we have few more details, just like build. So basically the build date of Docker Daemon that is actually mentioned over here. And again, the operating system and the architecture where Docker is running, that is mentioned over here. So the architecture type here is again used as ARM64, and the OS type is Linux, right? So again, now last thing that we have to keep in mind, that is experimental, which is false by default. So this shows whether the experimental Docker features are enabled or not. So here by default it is false, and that's the reason it is showing as false. Now, what is the remaining thing that we see over here? So basically this is the third and the last component, that is the runtime component. So Docker internally uses several runtime tools such as containerd, which is mentioned over here, runc, right? So basically what is the version of containerd which is used over here? So it is 1.7.21. Okay, so containerd is basically responsible for managing container lifecycle. Now against which commit ID it is reflecting the changes. So basically here the SHA-1 hash is given. Same goes for runc. Now what is runc? So runc is low level container runtime that is used to start the containers. Okay, here again the version for the same is given along with the commit ID. Okay, now what is Docker init? So basically it's a small init system that is used inside container to properly manage the processes, and the version that is used for Docker init is 0.19.0. So basically if you want to understand Docker init, it's just like understanding Git init in the very first place, right? So Docker init is just like saying just like it, right? So yeah, here we understood about Docker version. I hope that gave us the clarity what sort of details to be get. So basically we talked about client section, we talked about the server section, and then we talked about the runtime components. Now let's explore the Docker info command. Okay, let me clear the screen and I'll just run Docker info. Now again, this gives a lot more of information as compared to Docker version. Okay. All right. So let's go through it and understand what are the details which are currently present over here. Now see here it again gives us the client information. So basically here it is showing us the Docker CLI version that is 27.4.0. Okay. Here the context is a desktop Linux because we are using Docker desktop. In your case, it may be default because you might be connected to Docker environment, that is the CLI that you are connected to. Debugging mode is by default false. That is actually used for logging. Okay. Now, what sort of plugins we are using? Now, see, since we are into Docker desktop, it utilizes multiple plugins. That's the reason everything is mentioned over here. All right. Here it is showing us the extension, the version, and the path where the extension is located at. Right. If we scroll down, then we'll come directly to the server section. Now, this is one of the most interesting and my favorite section because you will get a complete clarity on what things are running over here. Here you will get the details of the total containers which are on the system. Okay. Here you will get the details of the currently active containers, the running containers. Here you will get the detail of all the post container which are used by which are actually generated by using the command docker pause. I know we are yet to cover that, but basically Docker pause is used to pause the container, and then how many containers are stopped. So basically here you can see there are 17 containers which are stopped, right? And here you can see there are 12 images in total, right? So it shows the Docker number of Docker images that are stored locally, right? So these are all sort of information that we get. Again, we have the server version, so don't need to worry about that. The last thing that we have over here is the storage driver. All right. So storage driver basically manages the container image layers. So just like here you can see we have overlay 2. Okay, so overlay to is one of the most common driver used in modern Linux system. Okay, and here we have login driver. So here login driver is showing as a JSON file. So basically it specifies how container logs are stored. So the default format of Docker generating the logs is in JSON, right? And the logs can be viewed with the command docker log followed by the container name that we are going to cover in the later section. But for now, we are just exploring what sort of details, fine-tuned details we'll get when we run docker info command. I hope that makes sense. Now, if you scroll down just below login driver, you will get this three group configuration. So basically, it controls how system resources like CPU and memory are managed for the containers. And here you can see C group version is 2, and here we have plugins that are currently working over here. Right. So basically, when you see the plugin section, here we will be talking about networking and plugin. Here we have the volume. Okay, and volume is set to be as local, and the network is bridge, host, IP, VLAN, math, VLAN, null, and overlay. Don't worry, we are going to cover all of these network type. By default, the network that is used by Docker is the bridge network. Okay, for now, just keep in mind, but we are going to cover this in Docker networking session. So these are the networking and the volume drivers that are available in Docker. Now, finally, let's talk about the system information, right? So let me just scroll down, and here we have kernel version, what kernel is being used, operating system, what operating system is being used. So here using Docker Tech. In your case, it will show you as Ubuntu long-term support, or maybe when you are into Red Hat, it will show you Red Hat. So basically, that is something that it will show. Then OS type is Linux, architecture is x86 and 64, and here it is. You can see it is ARC64, right? It shows the host system where the Docker is running. Now, when it comes to system information, then it will also show you the hardware resources. Here you can see it is utilizing 8 CPUs, system resources that are available for running the containers. So basically, there are tools that are available for running the containers. And right now, you can see the total memory that is been occupied is 3.8 GB roughly. Right now, the next level detail that we get over here is the Docker host details. So here you can see the Docker host detail currently present over here, and the name of the Docker host is Docker desktop over here. In your case, when you are into Ubuntu, it will show you the IP or the username. Basically, it's the unique identifier and the host name for a Docker desktop. Right now, let's talk about the storage location. And here we have the storage location. It's where leave Docker, and the main directory where Docker stores the changes are in. Basically, it's the directory where Docker stores your images, the containers, the volumes, the network, and all the information, right? So this is the directory that we were talking about. Okay, don't worry. Right now, we are just logging all the details, what sort of fine-tuned details we get when you run the execute when we execute Docker info command. Okay, I know this is too much, but believe me, once we are done with the networking and mounting section, this will actually make some sense to you, right? Now, let's move forward and yeah, here yeah, now let's talk about the registry configuration. So basically, you can see the registry configuration. So here you can see the registry is hub proxy docker internal. So basically, it shows the registry that allow HTTP connection without TLS. So that is actually it is talking about. So let's summarize whatever we learned so far. Okay, so basically, we talked about Docker version, and Docker version shows Docker client and Docker and server version, and Docker info displays full Docker environment details. These commands are very useful for production server inspection and DevOps troubleshooting. I hope these two commands made sense to you. And yeah, so that was all in this video where I just wanted to tell you a brief about Docker version and Docker info. So yeah, that was all, and I will see you in the next one. Till then, keep learning, and thank you very much. All right, so we are done with the Docker fundamentals, and finally, it's time to move into the core concepts of Docker. In this video, we are going to see the operational aspect of Docker. We are going to see what operational command we can make use with the help of Docker into images and into container. And I believe that we are done with the Docker command structure video. If you are yet to watch that video, I will highly recommend you to watch that video before even watching this one, because that will give you the clarity how does Docker commands runs, what is options, what are arguments, and that will actually give you a clarity what actually that command will do. Okay. So yeah, if you have already watched that video, then feel free to continue with this one. Here, my instance is already up and running and we can directly fire the commands. Now, let's say if I want to pull the images, let's say Ubuntu, Fedora, and MySQL, how to do it? So basically, we have a command called docker pull, and I will write the name of the image. So Ubuntu. So that's the image that I want to pull. First thing that it will do is it will first go and check into my local whether that image exists or not. If that image doesn't exist, then it will go to Docker Hub and check for that image. If it exists, it will pull the image. Now, since we didn't define the tag, it will pull the latest image. Now, what do I mean by tag? I already told it in the previous video, but for the sake of understanding, tag is just an identifier which version we are using. So here we will be using latest version of Docker of Ubuntu. All right. Now let me pull Fedora image. So what would be the command? So it will be docker pull Fedora gain to local and then pull it from the Docker Hub. Now let's see if I want to pull MySQL image. How will I do it? So again, the command will be docker pull MySQL, but there might be one question how Shubham knows that this image already exists or not. Basically, here I am taking a reference of Docker Hub because I already went into Docker Hub and searched whether those images exist or not. And here, when I search on the search bar, here you can see there is an official image of MySQL with 1 billion plus downloads. Okay, and that is how I came to know that MySQL image actually exists. And if you scroll down into the overview, you can see the documentation of MySQL, such as what is MySQL and how to use MySQL in the very first place. Okay, I will tell you how to use this documentation by referring it, but for now, just focus how to pull the image. So I'll just press enter and it will pull MySQL into my system. Right. So the first thing is done. We pulled an image from Docker Hub. Now, what is Docker Hub? Docker Hub is a place where all the images are hosted. Just like GitHub, it is a place where we store the code. Docker Hub is a place where we store the images. Now let me clear the screen and let's say I want to list all the images which are present in my system. How do I view it? So basically, we have the command called docker images, and these commands are something that we already covered in the previous video. It is just for the revision for reference purpose that what are the output that we get, so that multiple times when you execute this command, you are habituate of it and you actually know what output will it give. So here you can see in the previous video, we executed the command, we pulled the image Alpine, BusyBox, and HTTPD. All of them are still present. And along with that, we pulled 3 images today, that is Ubuntu, MySQL, and Fedora, which are listed over here. Now, let's say if I want to get more detail about the images, how do I do it? So basically, we have something called Docker Inspect. Now, what Docker Inspect does is it will tell you more information about that images, such as it will tell you or envs, what is the name of image, what is the digest that has been used. Let me show you practically. So I will make use of Docker image, and let's say I want to inspect Ubuntu. So I'll just copy Ubuntu, inspect, and I'll just write Ubuntu. Here you will get the output in JSON format. Here it will tell you what architecture it is using, what is the OS type, what is the size, root file system, what are the layers. So it will tell you the value of layers. Okay. If I go to the top here, it will tell you the image ID. It will tell you the repo tag. So here we are making use of latest. So basically all this information are present over here. Also, we will get all the environment and the runtime commands that will be executed when you are turning it into a container, right? Let me just clear it. Now, let us perform the same with Fedora and with MySQL. So let me just list it once again, Docker images, and I will run the command docker image inspect and followed by the image name. So here it would be Fedora. And again, you can see we got the same output in JSON format that gives all the information related to it. But will the output change in case of MySQL? Because MySQL is something that is a daemon service that runs in the background, right? And Fedora and Ubuntu is a base operating system, right? So will there be any changes in the output? Yes, definitely. So let me show you how the output will look like. So I will go here and I'll just type MySQL. And here you will see a complete detail, the inspection of MySQL image that is done. Here you will find the repo tags. Here you'll find the created date. Okay, here you'll see the port number. See, this is how you find the port number of a service in Docker, right? So here we didn't even execute it and made it a container. Right now it is still an image, but with the static image, you found against which container, which port number it is be executing, right? What are the environment variables that it will be utilizing, right? What is the entry point command that will be executed, right? Now it is a daemon service. Here you can see MySQL D written over here. What volumes is being there? What would be the working directory? What would be the architecture? What would be the OS that it should be utilizing? Everything is present over here. I hope the inspect command made sense to you. Let me just clear the screen. Okay. Now let me run Docker images once again. And here this time, let's run one service. Okay. So let's say I want to run Nginx. How do I do it? So I will just run Docker run Nginx. Now, will this command run? Let us check. Okay, the command got executed, but you can see my terminal got occupied. Why? Because this is a daemon service that runs in the background, right? Let me just run Control C. Okay, it got exited. Let me just run Docker PS. Okay, nothing is running. Let me run Docker PS -a. Here you can see Nginx exited with error code 0, meaning it executed and it finished its job, and then the container is at stale and it's of no use for now. Let me just remove this from here. So how do I remove it? So Docker rm followed by the container ID. I will provide the container ID and it will be removed from here. Let me clear it. Docker images. Okay. Now, how do we run an Nginx image, right? So for that, we need to pass few options. Now, if you already have watched the Docker command structure, you already know what options are. So Docker, I want a Docker run Nginx container. So Docker run Nginx. Okay. I want to run this image called Nginx, but I want to run in the background. That's why I'm passing -d. And also I want to do port mapping. Now, what is port mapping? See, there will be a dedicated video mapping, but now just understand that we want to map the container with the host port. So how do we do it? So what I'll do, I'll just map port number 80 of the host port with the port number 80 of the container. Okay. And followed by the image. Now, will it work? Yes, definitely. But along with that, what I want to do is, see, whenever we were running the command, let me just comment it down. I just want to show you one more thing. Docker ps -e. So whenever we were executing a container, we were getting some random names. For example, here you can see the HTTPD was executed and we got the name as Crazy Bharti. We don't want those random names. We want the customized name to be given to a container. How do we do it? So let me show you that as well. Let me clear the screen. I'll do zoom, and here that was the command that we were running, right? So till now, I think that is clear. Docker run -d, because we want to run it in the background, and we want to pass one more option, that's -p, because we are doing the port mapping of the container with the host, okay, and followed by the image. But before even that, we want to name this container as Nginx app. So for that, I will pass -name equals to the name of the container. So it would be Nginx -app followed by the image name Nginx. Now, will this run this time? Let me press enter. Okay, we got the SHA value, and when I do Docker PS, you can see Nginx is up and running. Now, how do I validate it? I'll go to browser, I'll copy my public IP and check whether Nginx is actually running or not. I'll go to the details, I'll copy the public IP, http:// and I didn't provide it colon 80 because by default it is 80 only. So let us wait. My internet is, I think, a little bit slow. That's the reason the output has been delayed, but it will definitely show the output. I'll check whether port number 80 is exposed. Okay, I need to manually expose the inbound rule. So I will edit the inbound rules and will check whether port number 80 is present or not. So here port number 80 is not specified. So I'll just add rule, and here in the custom rule, I will tell that allow port number 80 from anywhere. I will save the change, and now the page will be visible to us. Welcome to Nginx. Welcome people. And you already run your first container in the previous video, but this time you will get more clarity because we are rerunning the command again and again along with understanding in depth, right? So congratulations on that. So, all right. So we know we actually executed an Nginx container. Since it is a service, it runs in the background. We passed -d, and we know that it runs on port number 80. So we mapped it with the host port, and then we renamed the container as Nginx app. Here you can see the name of the container as Nginx app, and that's all the image was converted into a container. Now I told you we ran a inspect command on image. Is there any inspect command that we can execute on containers? Yes, definitely. So the command is very straightforward. Docker inspect followed by the container name. And what is the container name? I will copy nginx-app and I will press enter. And it will give me all the information of that container. Now let's go through it. So here you can see a very big output which is present over here. Don't worry for now. Right now you will get the information such as what is the entry point command that got executed, right? What are the arguments that were passed? What are the states? So current state is running. Okay. Here if you scroll down, you will find the image SHA hash. Okay, if you scroll down again, you can see restart count is 0. You will find the driver that is overlay FS, platform is Linux. If you scroll down again, you will find the port binding mode that is 80/TCP, and the host port through which we mounted that is port number 80. Right now, it won't make sense because we are yet to cover that topic. That topic we are going to cover in the coming videos. But for now, just understand that when you run inspect command on Docker container and on Docker images, you will get all the information related to that container and that images, right? If you scroll down, there are multiple information that you can see within that container, right? So, yeah. And also you can see IP address of this container. Now, I know it is very difficult to read this output. Is there any shortcut way to read the output? Yes, definitely. So what we actually do, or should I tell you later? Now you decide. Let me tell you now. So let me just clear the screen first. So clear. Now let's say if you just want to know the IP address of this running container, how do you do it? So first of all, let me just run docker ps, and here you can see Nginx app. Okay. Now I want to know the IP address of Nginx container. How do I find it? So I will run docker inspect Nginx Nginx-app pipe. Correct. Now I want to find what is the IP address. So I will run -a, and I just want to see 4 line. This is basic Linux, by the way, and I want to see the IP address. So IP address. Press, and here you can see we found the IP address of Nginx container. How cool is that, right? We didn't even go on through the multiple lines. We just run a grep command and we found the IP address of Nginx container, right? All right. So that was about running a service. Now, how do we run a base operating system? So do we have any base operating system? Let me check. All right. We have Fedora, we have Ubuntu. Let's run Fedora inside Ubuntu EC2 instance. How do we do it? Okay. And here you can see we are inside the Fedora container. Let me just exit from here. Docker images. Okay. And let me run it once again. Docker run -it Fedora. And what I want to do, I want to name this one as -name. And the name of the container should be Fedora followed by the image name. Enter. Okay. Now here you can see we are again inside the container. Let me press Control C and I'll to exit. So what I want to do is I want to run Fedora into the background. How do I do it? Right. So for that I will run Docker run -it for interactive terminal, because the first command that gets executed in Fedora or in any base OS is the shell command, right? And then it goes into exited mode. But what I want to do is I just want it to keep running. So that's why I will pass -d to run it into the background. I just want to give this application name as Fedora OS. This would be the container name, and I'll pass the image name. So Fedora, and it will take the latest image of Fedora. Here you can see again we found the SHA hash, and when I do Docker PS, you can see Fedora OS is listed over here. Now, if I want to go inside the container of Fedora, how do I do it? So basically, what I want to do is I want to go into the into the shell of Fedora. How do I do it? So basically, we have a command called Docker exec -it interactive terminal, and I want to go inside Fedora OS, and the shell that I would be using is /bin/sh and you can see I am inside the Fedora container. And if I do ls, you can see all the informations are present over here. All the directories are present. Let me just reconfirm whether I'm actually inside Fedora or not. So cat/etc/os-release. This will give me the information. And here you can see in the name of operating system, Fedora Linux is data. Let me just exit it. Let me clear the screen. Now, let's say we want to delete the containers and want to delete all the images that are present. How to do it at once? Should we delete it one by one, or is there any specific command that will delete all the images and containers at once? So let's go through it. So before even that, I just wanted to show you one more thing. So let me just run Docker images, and here it will list all the images, and here I'll just run Docker PS Docker images and Docker PS for the running container. So the first thing that I want to test is, let's say Fedora is running over here and I want to delete that image. Will it allow me or not? So for deleting an image, we have the command called docker rmi, and I just want to delete Fedora latest. That is the image through which this container is created. So here we got an error that there is a conflict. We are unable to delete Fedora because container is actually utilizing it, and this is a reference image. That's the reason it is not allowing it to delete it. So what should I do? First thing that I will be doing is, let me just remove the container, docker rm followed by the container id. Okay, it is saying the container is running because we passed -d, it is running in the background. So I will need to first stop the container. How will I stop the container? So I will pass docker stop followed by the container ID or the container name. Let me pass the container name this time. It stopped Docker container for Fedora operating system. And let us wait for some time. It is terminating the container. Okay, it is stopped. Now, when I run Docker PS once again, you can see only Nginx container present over here. Now, if I rerun the deletion command of the image, will it allow me? Let us check. Docker rmi. Let me correct the spelling. Docker rmi and Fedora. Okay, it is saying unable to delete. Why? Because if you run docker ps-a, Fedora image is still present over here. Now, how do I clean all of these? Okay, we have a command called, let me clear the screen, docker rm. Now, since we want to delete it forcefully, we will pass the option -f. Here, again, we will run the command docker ps-a that will list all the containers that have exited with error code 0 and due to with any sort of failure. So along with the exited container, it will also delete the containers which are running. Let me verify docker ps-a. Okay, there is nothing present over here. And when I run docker ps, okay, Nginx is also not present. Now, when I run docker images, and if I want to delete all these images at once, how to do it? We are going to follow the same pattern. So that would be docker RMI for remove machine images, hyphen F to delete it forcefully. I will pass a dollar argument, and here I will pass the command docker images hyphen Q. Okay. Now when I press enter, it will delete all the images which are present. Now if I clear the screen and rerun docker images once again, you can see there are no images which are present over here. Okay, so in this video, you learn about how to delete all the images at once, how to delete all the containers at once, right? So I hope that was a very time saving activity we did, right? Now, there is one more thing that I wanted to tell you is when to use -it and when to use -d. So IT is used when we are dealing with interactive terminal, that is base OS images, and we are using -d when we are dealing with services such as Nginx, such as HTTPD, right? I hope that made sense. Now let us see how we can view the logs of the images. Let's take two example, CentOS and HTTPD this time, so that we will get a clarity when to use IT and when to use -d. Okay, so the first thing is right now there are no images present in my system, and I want to run the container of CentOS. How to do it without even pulling it? So there is a command called docker run. Okay, now what docker run is capable of? Even though that image is not present in my local, it will pull it directly from Docker Hub and directly run the command. So there we eliminated one more command, that is docker pull, right? So, but the first thing again it will check. The first thing it will check is it will check whether that image is present in my local. If not present, it will go to Docker Hub and will pull the image. So what image I want to run, that is CentOS. So CentOS is a base operating system that is derived from Linux. So I will write the name of the image. So CentOS. It is freeze now, I think. Let me clear it. System issue. Okay. So what I want to do is I want to run docker run CentOS. So this is the name of the image that I want to run. But since it is an operating system, I will pass -it to pass it as interactive terminal. The first thing that will get exited, that will execute over here would be the sh command. Now, since I don't want it to get terminated, so I will pass -d. Okay. But for now, I will just pass -it, and here I want to name this container as CentOS app. So CentOS-app followed by the image name. Now what it will do, it will check the image exists in my local. If not, it will go to Docker Hub, it will pull it and it will run it directly. Enter. Now what it said actually, unable to find CentOS locally, error response from Daemon, failed to resolve reference, and it didn't find CentOS latest image. Okay, let us see if there is any image in Docker Hub for CentOS or not. So I'll go to explore here. I'll search CentOS. My internet is slow, I think. Okay, here you can see the CentOS image is deprecated. That's the reason it was not pulling. But I know there is one tag that is currently running. That's the reason which we can use. Let's take an example. Let's take, I think, let's take 7 over here. Okay, now let's say I want to pull CentOS 7 image. Okay, so what I'll do, I'll go over here. My system is lagging, I think. Let me just do a restart and let me rejoin once again. All right, so the system is updated. So the learning period, whenever the system acts crazy, just update it if there is any update. And after the update, things will run smoothly. So I am back into my terminal and we were pulling the CentOS image. We were here in this page and we were selecting the version that we want to execute. So let's take any random version from here. Let's take CentOS 8 or maybe CentOS 7 for now. And here you can see we have the command over here. Let me just copy it and pull the CentOS image. The same thing we are going to do with HTTPD. Now, why specifically these two images is because there is one base OS image and there is one service image, right? So Docker pull HTTPD. Now, since I didn't specified any tag, you can see pull latest image over here. But here in this case, I just pulled a version 7, the tag 7, because latest was not yet available, because CentOS image is deprecated, which is even written over here, right? Okay, let me clear the screen and let me list the images, Docker images. Now, how do I run this image and convert it into a container? So let me first run the HTTPD first. So Docker run -it, and I want to run it into background. That's why I will pass -d since it is a service, and I will name this as HTTPD -app. So this would be the name of the container, and followed by I will pass the image name. Okay. And when I execute it, a container named HTTPD app is created, which is created with the help of HTTPD latest image. Now let's do the same with the base OS, that is CentOS. So Docker run -it, and I want to name this as CentOS app, followed by the image name. So CentOS. Now, what will happen if I don't pass any tag? See, there will be error, because what it will say, unable to find image locally. But you will see the image is already present. The difference is, in case of HTTPD, we didn't pass any tag over here. So the Docker by default, it will tag the latest image, latest tag. But if no tag is provided, it will the by default behavior of Docker is it will add the latest tag into the image if not specified. But since this version is no longer maintained by Docker itself, we need to specify tag 7 over here. So what I'll do, I'll just add the tag, and now my container will be running. And here you can see I am inside CentOS app. Let me just validate it. So cat/etc/os-release. This is the directory which will tell us that we are inside CentOS. Okay. Now, if I want to see the running state, running logs, so I will make use of ps-ux. This will tell me what are the current services that are running. See, here the only thing that is running is /bin/bash. That is the first command that gets executed in any base OS when it is turned into a container. Now, what will happen if I exit from here? Will it still be present into the container section when I run docker ps? No. Why? Because if I show you Docker PS Alpine, it exited with error code 0, which means it finished its job, and that's the reason it is present over here, right? Now, when it comes to HTTPD, it is still running. So let's say if I want to see the running processes of the container, so how do I check it? So I will write Docker top followed by the container name. So here, let me pass HTTPD app. And these are all the processes which are running inside it. And here you will see the process IDs also written over here. Now, let me run the same command, docker top, on the CentOS app that we created. Here it is saying error response from the container. It is not running. All right. Let me just clear it. Docker ps-a. And now what I want to do is, now see, why we got that error, because it is not something that runs in the background. It is a base operating system. The only thing that runs is this /bin/sh that got executed during the creation. But if I want to still run it, so let me just do one more thing. Let me just start this container. Docker start this container. When I do docker ps, again you can see it is up and running. And now when I do docker top followed by the container name, the only thing that is running is /bin/bash, as I mentioned. Right now, let's say I want to see the log, whatever are running inside these containers. So how do I view it? So we have something called docker logs followed by the container name. So CentOS-app, and whatever logs are present, it will be printing over here. Now let me do the same. If I want to see the logs of service, docker ps first of all, and this will list all the running containers, and I want to see all the logs that are generated by HTTPD. So I will just copy the container name and I will write docker logs followed by the service name. And here, all the logs that are generated by HTTPD is written over here. If I want to see the logs of CentOS, what will I do? I will just write Docker logs followed by the container name. And here you can see all the logs are present over here. Now, let's say I want to copy a file from my local to a container. How to do it? So first of all, let me just run docker ps and I will create one file over here. So first of all, let me just define my path. I am in /home/ubuntu. Okay. I will create one path that is echo hi there. And I want to name this file as new.txt. And when I do a cat on new.txt, the message is printed over here. Now what I want to do is I want to copy this file from my host machine to the container. How to do it? So basically, first of all, the thing that I want to do is I will find the path where I want to paste the file, right? So I will go inside a container. Now, how to go inside a running container? So for that, we have command docker exec -it followed by the container name. I will go inside the CentOS app and here I will define the shell and I want to go into bash shell. I'm inside the CentOS container and when I do pwt, I am on slash. When I do ls, these are all the directories which are present over here. Let me make one directory folder and this would be named as folder and inside folder I will be pasting all my data. So I will go inside the folder and I will print the path. So slash folder. This is the place where I want to move the new file which I created in my host machine. Let me exit from here. Let me clear the screen. Docker ps. All right. So here what I want to do is I want to move the file new.txt into this container into slash folder path. How to do it? So docker cp followed by the file name. What is the file name? We created new.txt. So new.txt, where do we want to copy it? So I want to copy it into CentOS app. That is the name of the container. And where do I want to copy it inside the container? It is into slash folder. Enter. Here it shows a message successfully copied to CentOS slash folder. Okay. Now let me go inside the container. And how do we go inside a running container? So docker exec -it interactive terminal, since it is a base OS, I will pass the name of the container that is CentOS app. And I will go with /bin /bash, that is the shell. And when I do ls, I will find the folder which I created earlier, but this time when I do ls again, new.txt is present, and when I do cat, hi, there is println. So this was the file which we copied from our local host into the container. Now what if I want to do the reverse? How to do it? So what I'll do, since I am inside the container, let me create one more file. So I'll just write echo file from container and I will store it into new2.txt. This is the file that we are creating inside the container and I do cat on new2.txt, file from container is printed. Now I'll just do exit. Now see the syntax. Let me go back and let me show you the command that we used earlier. So this command we used to copy the file from host to the container. Now we want to do the reverse. How to do it? So I will use the same command but with small minor modification. So the commands goes like docker cp. Now what I want to copy and where do I want to copy it from? So I want to copy it from CentOS application and inside folder there is a file named new2.txt and where do I want to copy? I want to copy it into my current host. So for that, what I'll do, I'll just print the current working directory because this is the place where I want the file. And if I do ls, right now only new.txt is present over here. So I'll go back to the command and here you can see a docker copy from container CentOS app and inside that container we have a folder and inside that folder we have new2.txt which we want to copy in /home/ubuntu. Now what will happen when I execute this command? So I'll just remove this hash, enter. successfully copied to /home/Ubuntu. When I do ls, new2.txt is present, and when I do a cat on it, you can see file from container is present in my local. So yeah, that was all. In this video, we literally gone through multiple things. We saw how you can pull an image, how you can go inside a running container, right? What is the significance of Docker run command, right? How to copy an image from local to host and from host to container, a container to host, right? We also saw how you can list the running processes, how to see the logs of the container, right? Yeah, that was all about Docker operational commands. I hope that literally made sense. And that was all for today. And more thing before even we close down, whatever we did so far in today's video, everything is documented in the subfolder 3. You can go through all of them, okay? And this will literally give you a clarity what things are being doing, right? So you can take this as a note. So whatever we have done is already documented here, and you can take it as a reference. And I literally added everything in detail so that you will know why we use -d, why we used it, right? So yeah, that was all, and I will see you in the next one. Thank you very much and keep learning. Imagine that you deployed a container in prod and it got crashed. Now the question is, should Docker automatically restart it or not? So this is where restart policies come into the picture. In this video, we are going to understand what actually restart policies is, what are its type, why it is important in production environment, and why it is very important when it comes to learning Docker and Kubernetes, right? So without wasting further time, let's get started and understand restart policies and its type. Alright, so let's start with restart policies in Docker. Believe me, this is one of the important topic that you will be learning because the same concept is used in Kubernetes, right? So let's first understand what is restart policy. So restart policies are the defined rules that tells us the behavior of the container. It helps us in managing those containers, right? So how does a container behaves when it is crashed, when our daemon is restarted, when Docker host is restarted? On that scenario, how does a container should behave? That is been defined by the restart policies. So these policies helps to ensure that the containers automatically recover from the failures and maintain the application availability. Now let's consider that there is an application and for that application you require core services to be up and running every time. How do you make sure that thing is done? So that thing is been made sure by using restart policies. There are multiple sort of restart policies that we are going to see, but for now let us first focus on what actually restart policy is, right? So restart policies are commonly used in DevOps, production environments, and microservice architectures while maintaining the uptime, right? Because see, whenever any application goes down, so it will create the downtime. So that's the reason restart policies came into picture, and believe me, this is one of the very important topic that you should learn when it comes to Docker and in Kubernetes, right? So restart policies are configured using the -- restart flag with a starting container, okay? Now one more thing to note down, you can only apply the restart policies on the container during the runtime, but if an container is already running, you cannot apply the restart policies, right? So that was the thing that we have to keep in note. Now we understood what actually is restart policies. Now let us understand why we should consider restart policies in the very first place. So there are 5 reasons. So first is automatically recovery. So now before even we do a deep diver on this thing, let's first understand what will happen. Let's say you're running an Ubuntu container and suddenly you restart your machine, or suddenly you restart Docker daemon. What will happen? When you restart it, it will go into exited state. But what if you want it to be up and running? How would you do it? So basically that answer has been answered by restart policies. So the first thing is automatic recovery. If a container crashes due to an application error, Docker can automatically restart it, right? Second is high availability. So important services like web server or API or the core service that need continue availability that can be maintained with the help of restart policies, and that's the reason we should consider restart policies in the very first place. Third is reduce manual intervention. So when you apply restart policies, so we don't have to manually restart the container after the failure has been occurred. Okay. Fourth is a system reboot recovery. Now the current behavior, the default behavior of Docker is none, that is no. So whenever you restart any container, it will go into exited state. But if you want it to up and running even after the reboot is done, then you can make sure that thing with the help of restart policies. So container can automatically start again when the Docker host reboots. Fifth, improve production stability. So restart policies ensure that services stay up and running even during the unexpected failures. So that is one of the big thing why we should learn restart policies in Docker and in Kubernetes, right? So we now understood about why we should consider restart policy and what is restart policies. Now let's do a deep dive into the important part, that is what sort of categories do we have in restart policies. So in Docker, we have four sort of categories in restart policies, that is no, always, unlearn stop, and on failure. So by default, till now, whatever container we have created, it by default restart policy that was applied on it was no. Now in the coming video, we will do a practical hands-on and we will see how we can find out what sort of restart policies is been applied into a container, right? So the default is no. Okay, and we can apply always, unless stopped, and on failure based on our requirement. Now let's first understand what is the restart policy, what is the meaning of the default one when it comes to restart policies. So when the default when we run any container and we don't even specify the restart policy, the by default restart policy that is been applied is none. So this is the default restart policy when no policy is specified. And what is the behavior? So when a container stops, when a system is reboot, when Docker host restart, okay, so the container remains in the stop state. Docker will not restart the container automatically. You will have to manually do it. So in this case, the container will not restart when a Docker daemon is restarted, when the system will reboot, when the container is crashed or it exited normally, and it will not restart when the container is manually stopped. Okay, so here we have to do the manual intervention. Every time you have to go check and then you have to restart it. Now, since there is no restart policy specified, the container will stop permanently if it exists. So what are the use cases over here? So it can be used in a testing environment, debugging. It can be used in debugging containers. It can be used in temporary containers conditions, and it can be used for short-lived tasks, right? But this policy is not generally recommended for production environments because that environment requires uptime availability. So the by default restart policy that is applied is none, but it is not recommended to used in production. Then what is recommended thing? So it's like the always. So the always restart policies ensure that the container is always restarted regardless of how you stop it. So in this case, Docker will restart the container when the container crashes, when the container exists with an error, when the daemon restart, and when the system reboots. So even if the container fails, Docker will attempt to start it again automatically. You don't have to do the manual intervention. This will be done automatically. In the coming video, I will show you practical hands-on for both the hands-on for all the four policies that will give you the clarity how things are being performed. Right now, let's move forward. So what are the use cases of always restart policy? So this policy is best for critical production services. For example, you can utilize always restart policy for web servers, API servers, backend services, microservices, databases. Sometimes if you need uptime availability, right? So if the container is stopped manually, in this case, Docker may still restart it after the daemon is restarted. For time being, during the runtime, the container will be stopped. But when you restart the container or reboot the machine, at that time, it will restart again, right? Okay, now let's move forward with the third restart policy, that is unless stopped. So this policy is very much similar to always, but there is only one difference. So what is the behavior? So Docker will restart when the container crashes, when the Docker daemon restart and the system reboots. But if the container is manually stopped by a person, Docker will not restart it. Okay, so here it will give a signal that we want to manage it by our own hand, but the condition is if it is if we didn't provided any manual instruction to stop it, it should again restart it, right? So in that case, we should make use of unless stop. That is the only one difference between always restart policy and unless stop. Because here we are putting a manual intervention that for now, for time being, during this runtime, I don't require this service to be up and running. But again, if I restart Docker, if I restart the host, if I restart the server, it should be up and running, right? So if an admin stops the container intentionally, Docker respect that decision and it will stop it during that runtime. But when that system is rebooted, when Docker system is restarted, it will again run the service. So what are the use cases for unless stop? It is commonly used for production services, long learning containers, web application, and internal services. So many DevOps engineer prefers this policy because it gives control against always, because in always, even if you stop it, it will restart it. But again, if you want control over it, you may use unless stop restart policies. Now let's move forward with the last one, that is on failure. So this restart policies is defined specifically for handling application failure. So what is the behavior over here? So Docker will restart the container only if it exists with the non-zero exit code. Okay, so remember when you run docker ps-a, at that time you see that status. So during that status, when you see non-zero code, if you see a zero code, meaning the container run successfully, it finished its job and now it is in exit state. But if there is another number apart from zero, if it is a non-zero character, then it indicates that the application encountered an error. So in this case, Docker will not restart the container if the container exit successfully, the container is manually stopped, the Docker daemon restarts, and the system reboots. Okay. Now let's move forward and understand what are the retry limit. So what is the meaning of retry limit? So you can limit how many times the Docker retry this thing, right? So let's say you stopped a machine. Okay, so let's say a container just got into non-zero. So let's understand retry limit. So basically you can limit how many times the Docker retries it. Okay, so let's say the container exited with error code 1 or 2. Okay, and you want to apply one condition that Docker should retry it for multiple times to restart. Let's say I want to retry it 3 times if it goes into failure. So that thing can be defined with the help of retry limit. So in this case, Docker will restart the container based on the retry limit. So what is the use cases over here? This policy is useful for batch jobs, working container, worker container, data processing job, CI/CD task, background process service. So these workload may fail temporarily but need automatic retries. So in this case, we make use of on failure. Right? So what are the best practices when it comes to restart policies? So avoid default policy in production. So when I say default policy, we are talking about none, which is applied by default. So the default no policy should be rarely used in production workloads. Second best practice would be use unless stop for most service. Why? Because this gives us complete control when it comes to Docker container. It provides automatically recovery along with it respect the manual control. Third is use always for critical infrastructure such as core service. So if the service must never stop, it should be used. It is recommended to use always retry policy, and that would serve as a good option. Fourth is use on failure for jobs. So it is ideal for background tasks that may fail and require retries. So in on failure restart policy, you can define the number of retries for which it should try to restart the container. Okay, don't worry if the theory is going too long, because in the next video I am going to tell you the practical how to do each and everything, how to verify each and everything. The next video may be long, but believe me, this concept will literally blow up your mind. It will give you the clarity how things are working. So when you see things working in action, it will give you the confidence that yes, I know restart policy and I can literally explain it to anyone. Right? So let us do a recap whatever we learned so far. So Docker restart policies allow the container to automatically recover from the failures and system restart. There are 4 sort of restart policies that we saw today. No, that comes with automatically restart container. Second is always, that restart in every situation. Third is unless stop, it restart unless it is manually stopped. And fourth is on failure, it starts only on error. So Choosing the correct restart policies helps us to ensure better reliability, stability, and uptime for containerized application. I hope this video made sense. It is one of the most important concept that you should learn in Docker and in Kubernetes. So yeah, that was all for today, and I will see you in the practical hands-on. So that was all, and I will see you in the next one. Thank you very much and keep learning.
Alright, welcome back. So in this video, we are going to do the hands-on on restart policies on Docker. So if you're someone who is directly jumping to this video, I will highly recommend you to go to the theory first, because in that theory, we explain what is restart policy, why it is used, how many types of restart policies do we have in Docker, right? So all those things are covered over here. So basically what actually is restart policy? Restart policy is something that defines how the container behaves when the system is restarted, when the Docker system is rebooted, right? So all those things is managed by restart policies. In this video, we are going to see all the 4 types of restart policies, that is default, none, always, unless stopped, and on failure. We are going to see all of them, right? And how to check whether the container is applied with restart policies or not. Those are the things that we are going to do. So this will be a purely hands-on that we are going to do today. So without further ado, let's get started. So I have my instance up and running. I'll just take my SSH to my terminal, and here we go. So let's start with the first restart policy that we are using, but we are not even aware of it. So what's that? So basically here we are talking about a default, that is none. Let me clear the screen and let me clean everything that is present on the system right now, so that I can tell you the difference between each one of them. So let me just run docker ps-a to see all the exited container who has served their purpose and are of no use for us right now. So how do I remove all these container at once? So basically I will run docker rm-f to delete all of them forcefully, and here I will pass one more argument, an option, where I will be running docker ps-aq to list all the containers which are exited over here, which are displaying on running the command docker ps-a. When I press enter, all of them will be deleted, and in order to validate it, I will run docker ps-a. So here you can see all of the container that got exited are deleted. So when I run docker ps-a, you will see nothing is present, and when I run docker ps to check what are the running containers, there won't be anything present. Now when I do docker images, let me delete each one of them, because right now these are of no use to me. So how do I delete all of them at once? So again, the pattern remains the same. So I will make use of docker rmi remove machine image -f to delete all of them forcefully. Then again I will pass this argument docker images, okay, and then I will pass -q and enter. It will untag the images and it will delete it. Now when I run docker images, you can see nothing is present over here. Alright, so the system is ready for us to perform the practical on restart policies in Docker, and I hope you are in same pace with me, right? So one thing that I would recommend you to is basically first go through the video first, understand how things are working, take your notes, and then perform it alongside with me. Because if you try to do it alongside with me, so in the first try, so like you might miss something. That's the reason I will request you to go through the video first and then take your notes, and then next time do it alongside with me. So that will give you results, right? Okay, let's get started and let's understand default policies in Docker. So when I say you already were using it, so how do I check whether which restart policies is applied on my container? So let's get thing directly straightforward. So there is one command that I wanted to tell you in the previous video, but I forgot. So I will cover in this video. Let's say if you want to run a container without even pulling it, how do you do it? So basically we have a command called docker run, because this will do two things. First, it will pull the image and then it will run it. Okay. So here in this case, we are going to run nginx image, right? So I want to run nginx over here. So I want to run it into background because it is a service. So I am passing -d over here and followed by the name of the container. So -name, and the name of that container should be nginx default. Okay, and followed by the image name. Now you are already aware that I just deleted all the images, all the containers in my system, so there is nothing present. So when I press enter, what it will do, it will first find nginx image locally into my system. Now since it was not present in my system, where it will check? Yes, you are correct. It will go to Docker Hub. It will pull the Nginx image. Now, since again I didn't specify the version, it will take the latest version of Nginx which is present in Docker Hub. It will pull it and it will turn it down into a container. Now, how do I validate whether the image got pulled and the container is created? For that, we have the command called docker images that will list the images that are currently present. And here you can see Nginx latest image is currently in use. Now when it says it is in use, meaning any container is utilizing it. So when I use docker ps, you can see Nginx default named container is created, and here you can see Nginx image has been used. Now, alright Shubham, till now you mentioned, so like I mentioned earlier that how we can check a restart policies of a running container, right? So basically it's very easy. We will make use of inspect command. Now remember, in the previous video I showed you how to run inspect into a container and into an image. Here we are going to make use of inspect command. Alright, so let me run inspect command into the Nginx default container that we created. So how do we do it? So basically docker inspect followed by the container name. So it is Nginx default. Alright, so here we get lots of information, right? As I mentioned earlier, it will give you all tons of information that is currently being used into the container, right? But here we need to search for the restart policy. How do we do it? So I'll just search for restart policy over here. Okay, so in the network mode, here you can see the restart policy, and the name of the restart policy is no, meaning the default policy that gets applied by default is none. Now, is there another way? Because I don't want to go through all these logs. Yes, definitely. So what I'm going to do is I'm going to run docker inspect followed by the container name. It is Nginx default. Now I'll make use of pipe Linux grep. What I want to grep? I want to see the 3 lines which are matching the cases restart policies. Okay, now since I want to check case insensitivity, right? Basically, even if the arrays caps or small, it should ignore it for now. So that's why I'm adding -i. Okay, so grep -ia, and I only want to see 3 lines after that text. So what is that text? Restart policy. Enter. Okay, so this is how you can see the logs without even going inside and searching through lot of information, right? So let's move forward and let me run docker ps. Okay, now in the theory we learned about restart policies defines what will the container will behave when the Docker system gets restarted and when the system is rebooted. So let us see the behavior of none when the Docker system gets restarted, right? Let me just restart Docker and check what is the behavior after we reboot Docker, right? So how do we do it? So basically we have the command called systemctl restart docker. This will restart the Docker service. Now since we are running this thing as a user, it is asking for the password. Let me run the password. Okay, authentication is completed, and let me run docker ps to check what is the status of Nginx default container that we just created. Okay, right now you can see it is not running. Now when I run docker ps-a, you can see the container is in exited state because there was no restart policy that was attached. Now what I will do, I will run this container once again. So docker start the container. This time I'm passing the container ID, and when I run docker ps-a, you can see it is again up and running, and here you can see it is currently running. Now what will happen if I restart the base operating system on which Docker is installed? Let me go to AWS, let me go to instance, and this time I will go into instance state and I will reboot the system. Now this will take some time, okay, and once the system is restarted, we are going to check what is the state of Docker this time, right? So that's actually restart policy none that comes by default whenever we are running any sort of container. Now, is it a good practice to use the default policy in a Docker container? Well, definitely no, because in production we don't even use default policies which are given by Docker. We make use of either always, or we make use of unless stopped, because that gives us the complete control, and that helps us to run the container, run the services that requires to execute it every time, right? I hope you understand. Now let me just connect to my EC2 instance once again. It will take some time, and then we'll check how does it behave. Okay, so we are connected to the EC2 instance, and now when I run docker ps, you can see nothing is running. Now when I do docker ps-name, you can see it got exited with error code 0, meaning there was no issue with Docker, there was no issue with the container. It was just like it completed its job and now things got exited. That's the meaning of exited status, right? So I hope you learned about the default restart policy. Now let's move on with the next restart policy, that is always. Let me clear the screen. Okay, so for this demonstration, let us make use of a different service. Now we did the practical on Nginx. Let us take one more service, that is HTTPD. Okay, now let me pull that image. So docker pull HTTPD. Okay, now again it was not present in my local, it searched into Docker Hub, it pulled into my local. How do I list HTTPD image into my system? So for that I have Docker images, and that will list the HTTPD image over here. Now I will turn this into a container, and alongside I will apply the restart policy. How to do it? So for that I will run the command docker run -d to run it into background, followed by what should be the name of the container. So here I will pass the name, so httpd -always. So I am deliberately writing always none default. Why? Because it will give us the clarity what that container signifies. So for now I am writing it as httpd always, because this will give me the clarity which service is been applied, just for my understanding. But again we can check it with the help of a docker inspect command. So apart from that, what is the command that will help me to apply the restart policy into this container? Yes, we have ---- restart. Here I will write the name of the policy that I want to apply. So this time I am going to apply always policy, and alongside what image do we want to use? We want to make use of httpd return. So I hope you understood this command. If not, then I will request you to go again and understand docker structure, docker command structure, because that will give you the clarity how these commands are phrased, right? So let me press enter. Now this image is turned to a container. Let me clear the screen, and when I run docker ps, you can see httpd is up and running. Now here comes the best part, where we are going to check whether the restart policies got applied or not. So how do we do it? I will run docker inspect followed by the container name. This time I'll pass the container name actually. I'll make use of grep -ia. I want to see 3 lines after restart policy text. Enter. Now here you can see in restart policy what is applied, it is always. Alright, now as per the theory, whatever we learned, basically what we said, basically whenever you apply restart policy in any container, whenever you reboot docker container, whenever you reboot your system, it will still run. Let us verify. So let me just restart docker container now. systemctl restart docker. Enter. Let me write my password. Enter. Authentication completed. Now let's see whether that container is running or not. So docker ps. Oh, you can see that service is still running. That's because of restart policy always, right? Now let me restart my operating system. Let me restart my EC2 instance. I'll go back to AWS. I'll go to instance state. I'll click on reboot. and here you will see it will get disconnected automatically. See, it got disconnected because the system was going into power off. Basically it is doing a restart. Now what is the expected behavior? Once the system is up and running, what we want to see, basically it should run the container once again, right? So let us wait for some time and validate whether that system whether that service is still running or not. I will not cut this video because I want to keep it in a single shot, so that you will also have a clarity that how things are working into the actual one, right? So let's keep it as it. So let me just connect to my instance once again. Okay, now the system is up and running. Let me check the Docker status, and how do I check it? So system ctl status docker. So Docker is up and running. All right, let me clear the screen and let me run docker ps. And here again you can see httpd always is up and running. Now there is one more thing that we can verify, is that what will happen if I stop this container, docker stop httpd, and now when I run docker ps, it is stopped, and when I run docker ps -a, it should be into exited mode. The status is exited, right? Now last thing that we want to try is what will happen if a container is restarted, when a container is applied with a restart policy always, and docker service is restarted, right? So right now you can see the container is stopped, okay, and it is in exited state. Now what I'm going to do is I'm going to restart docker service, and we'll check what will happen when the docker service is restarted. Is it still running or not? Okay, so actual thing is it should run. So let us validate the same. So system ctl restart docker. Okay, I added my password, and now once the docker service is up and running, let me run docker ps and check whether it is still running or not. So I will check the status, system ctl status docker. Here it is up and running, and now let me run the final command docker ps, and voila, it is still running. That's the power of always. So when should we use always policies? So basically you can use it into production environment, mostly for those services that require uptime, okay, and when you want that service to run every time, for that you can make use of always policy, right? Let me just stop it. Docker ps, and let me just remove that container too, so that I can give you the clarity for the remaining ones. Docker rm, I want to remove httpd, I want to remove nginx default. Okay, both of them are deleted now. Docker ps -a, let me clear the screen. Now we are good to start with the third policy, that is unless stopped. Now what is the key difference between unless stopped and always? It's just like unless stopped will give you the complete power, because in always you can see whenever you are even stopping a service, it is getting started, okay, on the next boot. So during the runtime it is stopped, but the next time when you start the service, it is still up and running. But you want complete control over it along with the power of always, you can make use of unless stopped, right? So let's do the practical hands-on on unless stopped, and this time let's make use of httpd service. So let us create a container out of httpd image. So let me list it once again. Docker images, we have httpd here. So docker run -d, I want to run it into the background, and this time I want to call that container as httpd unless stop. Okay, I know this is a big name, but for now please bear with me so that it will give you the clarity. All right, now let's add the restart policy. So -- restart. And what is the restart policy that we want to apply? We want to apply the restart policy unless stop, because we want complete control over the container. So unless -stopped stopped, followed by the image name, so httpd, enter. Now when I run docker ps, you can see it is up and running. Now let us test the same thing. Let us first inspect this container. So docker inspect, inspect followed by the container name. I will write a pipe. I will pass a grep -ia, and I'm going to do 3 lines. So restart policy, and here you can see the restart policy unless stopped is applied over here. Now let us validate the results. So what will I run? I will just restart Docker service. So system ctl restart Docker. Okay, now let me check the current state. Now it is getting restarted. Docker server will get restart, and then let us see the actual behavior of the Docker container. What is the expectation out of this activity? We want to see that the container should be up and running. That is something that we are validating. Okay, and these steps will be the same for all the policies, because we want to see what is the actual behavior on different policies on the containers, so that we have the clarity how things are looking right now. Okay, let me clear it and let me run docker ps, and here you can see httpd unless stop container is still up and running. Now let me reboot the EC2 instance and check how does it behave now. I'll go here, I'll reboot. The connection will get lost over here. It will take some time, and once the system is up and running, we are again going to run docker ps and check whether it is still up and running. See, we mentioned that there is only one difference between docker restart policy always and unless stop. The first thing is always will always run, and even if we stop it, it will be stopped only during that runtime. So the next time when you restart Docker's service or restart your machine, it will run. But we want complete control. Let's say if I want to stop this service, and even when I boot the system or even when I restart Docker service, it should still stop. That will give me complete control over my containers, and that is something unless stop policy gives me. So let me just connect to my EC2 instance. Alright, so we are connected. Now let me run docker ps, and here you can see, let me clear it, and here you can see it is still up and running. We restarted the Docker service, we restarted the EC2 instance, and here you can see it is still running. Now let us validate the final thing that makes unless stop policy different from always. That is, let me stop it and restart the container and check what is the behavior. All right, so docker stop the container name http unless stop. Okay, when I run docker ps, you can see it is not running, and when I run ps-a, it is in exited state. Okay, now let me restart Docker service. So system ctl restart Docker, enter Ubuntu. Okay, let me just type the password once again. All right, authentication is complete. Let me check what is the state of this container. Clear docker ps. Oh, it is still not running, and that is what we were expecting, right? And now when I do docker ps-a, you can see that container is still present, right? And when I inspect this container, docker inspect container name followed by grep -ia, 3 lines, restart policy. You can see it's all because of this policy called unless stop. So this policy is actually used in production because it gives us the complete control over the containers. So when to use always and when to use unless stop. So for the core service which require complete availability, at that time we make use of always, but for the remaining service we make use of unless stop. So I hope that made you the clear picture, the difference between unless stop and running and always, right? So let me clear it once again, and let's cover the final restart policy, that is on failure, right? So what is on failure basically? So on failure policy is something like it will restart the service if something goes wrong. Okay, so let me make use of this time, let us make use of nginx. So let me run docker run -d, and I want to name it as nginx on fail, followed by the restart policy -- restart, and this will be on failure, followed by the image name nginx. Okay, docker ps, you can see nginx is up and running. Okay, now the next thing that I want to do is I will check the restart policy. So docker inspect, followed by the container name. I will pass grep -ia. I hope these commands are making sense right now because we are repetitively using it, right? Followed by the 3 lines. What will happen if I pass 4 lines? Let us check the same. Let me pass 5 lines. Okay, and this time let me just search for restart policy, enter. Okay, here you can see the number of lines increased because here instead of 3 I wrote 5. That's the basic difference. But what we are looking here is basically we are looking on failure, and here you can see restart policy on failure is applied over here. Now let us validate the same thing that we did with the remaining policy. Let me first restart the Docker container. So here you can see the container is currently up and running. What will happen if I restart the container? Doc systemctl restart Docker. Now tell me, once the Docker service is restarted, what will happen to the container? That is an homework. So let me just run docker ps, and this is what we'll get when we restart Docker container. So okay, why it is not running? See, we applied on failure. So on failure is used whenever a container is going through an error. At that time, if you want to restart it, at that time it will come into the picture, right? So when I run docker ps -a, you can see the container is in exit state. All right, now let me just start the container once again. Okay, clear docker ps, and the container is up and running. So how do I validate whether this is still running or not? So for that we need to go inside the container. Now how do I go inside a container? So for that we have something called docker exec -it for interactive terminal space, followed by the container name or the container id. Let me pass the container id this time, followed by the shell that you want to use. So I want to use bash /bin/bash, and yes, here we are inside the nginx container. When I do ls, you can see everything is present over here. Now here we are trying to check how do we validate on failure, right? So for that, what I'm going to do is I'm going to do something with the configuration of nginx file. Okay, so what I'm going to do is I'll write echo hi, and what I'm going to do is I'll just make changes into the main configuration file that will lead to the failure of the service. So /etc nginx. What is the configuration file in nginx? It is nginx.conf. Enter. Let me exit from the container. Let me list it. Docker ps, it is still up and running because the changes are yet to be reflected. For that, I will need to restart Docker, and let us see what happens after that. We have to keep an eye on the status. Right now it is up and running, and after restart, let's see what actually is the status. Okay, so systemctl restart Docker. Okay, now let me run docker ps once again. It is not listed. When I run docker ps -a, you can see it is saying exited 5 seconds ago, but I feel there is some difficulty for me to check how do I validate whether it is actually applied or not. Don't worry, there is some extra thing that I kept it for telling you. So basically it's just like we can apply the retry intervals, right? So let me clear it. Docker ps, let me run one more container out of the image that we are using. So docker images, So here this time, since we want to we are applying on failure restart policy, we want the container to automatically retry it for multiple times. And how do we define it? We can define it during the runtime. So how do we do it? So basically docker run -d hyphen name, and the name is htt, let's say it is nginx with restart, okay, followed by the restart policy. Okay, so restart equals to on failure, and how many times do I want it to check, do I want it to restart on whenever it encounters any failure? Let's say I want to check it for it should restart 6 times. That's why I'm writing 6, followed by the image name nginx, enter, docker ps. Okay, it is up and running. I'll perform the same activity this time, so let's do it fast. So docker exec -it container name /bin/bash. I will run the command echo failure, and it should go into /etc nginx.conf, enter. Okay, exit. Now let me just restart the container, and for that I will write systemctl restart docker, and when I do docker ps-a, this time I will do one more thing. I will write watch. This will tell us how many times the container will restart. Just keep an eye on the seconds. Okay, so here those seconds will let us know how many times the container is getting restarted. Okay, so we applied the restart policy on failure and with a retrial interval of 6, so it will restart the container 6 times. Keep an eye over here. 33. See, it got restarted again, right? That's the reason we are getting about a minute ago. It will again try it once more. So this is how it is going to try 6 times. So in order to get out from watch, you just have to press Ctrl C. So here I am checking the restart policy that is currently applied into Docker with restart, and here you can see the maximum retry count is 6. So this is actually telling us how many times the container will get restarted when it encounters any failure, right? So that is how we are dealing with the containers with the restart policy. I hope it made sense. Now there is one more thing that I want to tell you. So for that I will need to run one container. Let me just list all the images and let me run one of the container. So docker run -it, and let me run nginx Control C, docker run nginx /bin/bash. Okay, I will exit. Docker ps -a, docker start the container id, docker ps. Okay, it is up and running. Now let's say if I want to update anything into this running container, or let's say if I want to add a restart policy into this container, how would I do it? So basically we have something called docker update. So docker update what I want to update. So basically the restart policies that is currently applied on it. And what is the default restart policy that is applied onto a container? It's none, right? So this time I want to change it to always. So -hyphen restart equals to always, and I will pass the container ID. Oh, let me clear it. Okay, so docker update restart always, and here I will pass the container ID, and this is the container ID, docker ps. It is up and running. Let me just inspect it. So docker inspect container ID followed by a grep, where we are going to pass ia and check restart policy. Enter. Okay, it is a spelling mistake, a typo. Clear it. Okay, and here you can see the restart policy is updated to always from default, that is none. I hope in this video you learned about the restart policies. We came across with 4 restart policies: default, that is none, second is on failure, third is always, and fourth is unless stop. I hope that made sense. And there is one more thing that I wanted to tell, that what will happen to the containers that are present over here, that are in exited state. So basically, let me just clear it so that it will make more sense to you. Docker ps docker stop, and let me just remove this container. Docker rm. Okay, docker ps-a. So we were here, right? So let's say that there is a scenario that whenever you are coming back or restarting your machine, every time when you press docker ps-a, you don't want this container to be present when you restart your Docker service. How to do it? So basically we have something called docker rm, okay, that will basically remove all the containers when it is not in use. Okay, so that we can pass during the runtime. Okay, so for that what I'll do, I'll just remove all of them at once. All right, so we were deleting all the images, all the containers that were not in use. So let me remove all the containers that are in exited state. So how do I do it? Docker rm -f followed by docker ps-a, and here I'll press enter. Okay, because I got this error because I didn't pass this $. Okay, done. Docker ps-a, nothing should be present, and we are good. All right, so we were talking about -rm, and that is basically used in a case when basically you want whenever you are stopping a container, whenever the containers are not in use, it should automatically remove it, so that we are done with the elimination of the exited state container, right? So how do I do it? So basically, let's say docker run -it. I want to run an Ubuntu container. Okay, so I passed -it, then -rm. So this option basically specifies that whenever the Ubuntu container is not in use, at that time it should delete it, right? It should not be in exited state. All right, done. Followed by -name equals to Ubuntu, and here I'll pass the Ubuntu image. Okay, and let me press enter. Okay, the Ubuntu image was not present, it pulled it from Docker Hub, and now when I press docker ps, we are actually inside the Ubuntu container. When I press exit, when I do docker ps, okay, the container is exited. When I do docker ps-a, it is not present. I hope that gave you the clarity. Not understood? No worry. Let me repeat it once again. So let's take a different example. Let us run a service this time. So docker run, let's say I will run httpd. Okay, so -name httpd rm, and this time what I want to do is I want to remove the container whenever it is in exited state. So -rm followed by the service name, the service image, httpd, enter, docker ps. You can see it is up and running now. When I do docker stop, the container id, and when I do docker ps -a, it is not present. But is -rm option, is it something related to restart policy? No, because it is not a restart policy. We are learning it together because we should know what is the behavior of -rm option on the Docker container. Right now you can see whenever any container goes into exited state, it automatically removes it from there, right? So you can make use of that knowledge. So let me do it into one more image. So Docker images, and let me do it for Nginx this time. So Docker run -d for Nginx, and what I want to do, I want to do it into -rm form, enter docker ps. Let us validate whether restart policy is changed or not. So see, here we didn't even define the restart policy, so the default policy will be applied over here. And what is the default policy? It is no, right? So docker inspect followed by the container id. Here I'll do a grep -ia, and there should be 4 lines for restart policy, enter. Here you can see there is no restart policy applied, and hence it proves the result of -rm. Now when I do docker rm or when I do docker stop, okay, the container, it should actually stop that container, and basically it should not be present in exited state because we made use of -rm ps-a, and here you can see nothing is present, right? In this video we did a lot of hands-on, and I have documented everything so that you can utilize it for your revision. One request before we close, it's just like first just go through this video, understand everything, write down your own notes, and once you are done with that, perform it alongside with me, and that is how you will be able to understand what things are going on. But for your clarity, I have written the notes in the md file into subdirectory number 4. That will give you the clarity what all things that we did today. So we learned about restart policies in Docker. What is restart policy? So basically restart policies define the behavior of container whenever it goes into exited state, whenever a container is restarted, whenever any instance is started, right? So the first policy that we were using till now, it was the default policy, that is no. So that actually tells what to be done to the container whenever the container is stopped, the Docker service restart, or the system reboot. So since we are not defining it, the container will remain in the exited state. Okay, so that's the behavior of it. So let us move with the next one. Here whatever things we did so far is already documented here, maybe with different images, but this is just for your understanding. This will give you the results. If you face any issue, just let me know, write it into the discussion section, the comment section, and I will definitely try to resolve it. Okay, let us go with the next one. We understood about the second restart policy, that is always. Now always policy ensures that Docker will always attempt to start the container whenever it stops. So when you restart the Docker container, whenever you restart the EC2 instance, it will still up and running. The third policy that we came across was on failure. Okay, that was unless stopped. So unless stopped is an alternative to always, because in unless stopped we get complete control over the containers. Because let's say if there is a container that you don't want to start every time, you can just mark it as stop, and Docker will not touch that container. That is the power that is given by unless stopped. Okay, so if the container is running, it will automatically start after the daemon restart, after the host machine is rebooted. If that container is manually stopped by us, then it will remain stopped. The Docker will not touch it. The host machine will whenever the host machine is restarted, it will still be in the exited state, right? So that's the reason it gives us complete power on the complete control over the container. The last thing that we came across with the fourth restart policy, that is on failure. This is used on the application wherever it encounter any issue, whenever the container goes into the failure. So let's say if a container goes into the failure, how many times should we retry it, how many times should we restart it? That thing is something that is defined with on failure. We even saw the practical demonstration, and along with that we even saw how you can pass one delimiter, that is how many times should it get restart. That thing can be passed during the runtime, and here we defined that it should restart 10 times, and you can see the maximum retry count is set to 10. So whenever a container faces any issue, it will restart 10 times, right? So that is also that we saw in today's video. And apart from that, we also learned how you can update the restart policy into any running container by making use of docker update command. Alongside, we also came across with one more option, that is -rm, which is not a restart policy, but it is basically used to remove the container automatically whenever it stops or it exits, that we saw just now. I hope you get to know, I hope you got to learn a lot more in this video. I know this video is very long, but it definitely added learning to your journey with Docker, right? So yeah, that was all in this video. If you face any issue, please do not hesitate to write the issue into the comments and discussion section. I will be very much happy to help you out with that. So yeah, that was all, and I will see you in the next one. Till then, keep learning and see you in the next one. Now let's consider a scenario where you are running the command docker run nginx along with -d option to run it in the background. I want to show you something that we have been looking so far, but I want to do a deeper dive on it so that you can also understand what's actually happening behind the hood. So when you want to run any container in the background mode, what option will you use? Yes, correct. You will use -d, that is detached mode. So docker run -d nginx. This will run nginx into background. So see, till now everything is clear. What we did, it will pull the image of nginx. It didn't find it locally. It will search it into Docker Hub and turn it out into a container. Now if I do docker ps, you can see nginx container is up and running. But the question lies is over here, the very first line when it got executed, that is unable to find image nginx couldn't latest locally. This gave us a clear indication that nginx image was not present locally. That's the reason it proceeded forward and went to Docker Hub and pulled the image. But again, if you noticed, I didn't mention latest anywhere in the command. How did it know to pull the latest image of nginx? And is latest is equals to the latest version of nginx? That is something that we are going to look into today, right? And apart from that, you might have seen or you might be seeing the dangling images, something which looks like this. So when I run docker images -f dangling equals to true, you might have seen few images like this and you might see it in future. So what are these? What is the reason behind it? So let's demystify everything into this video and let's get started and understand what are tags in Docker images and what is dangling images and how to handle them. So let's get started. So what is a tag? So a tag is something that is specifying the current version that the image is currently occupying. So let us understand a very big example. So let's talk about in software industry. So let's say you are using Python version 3.14. So that gives you the clarity that what version of Python that you are talking about. Now if I say I'm using the latest version of Python, right? So for now it is Python 3.12, but in future it may be Python 4. Python 5. At that time that statement won't be relevant, but if you talk in terms of version, that will make the things very much relevant for you. Now why we are focusing so much on tag? Because that will give us the clarity which version of image we are utilizing into the environment. But when it comes to production, are we using latest tag everywhere? No, that is not a standard best practice. Basically, the standard practice is to use the image with the version tag. That will give us the clarity what sort of images are used into the production environment, right? Now, let's take an example. When I do Docker images, you can see we have three sort of images. One is CentOS 7, second is HTTPD latest, and third is nginx latest. Let's talk about nginx latest. So what sort of information is it giving us? It is telling us that we are utilizing the latest version of nginx image that is used to create the container. But when I say it is the latest version of nginx, do I mean the actual latest version? So it can differ because latest is not always equivalent to the latest updated version of nginx, because sometimes what happens, latest version tag is given by default to the image. Now it depends upon the maintainer whether he has updated the tag or not. Now you can say latest is not actually latest, it is the default tag that is set by default by Docker. right? So if you want to see the latest version of any of the images, just go to Docker Hub and check the actual latest tag, and that is how that will give you the clarity what actually latest version of that image is currently running, right? Secondly, now in production environment, do we use latest tag everywhere? No, definitely not. We use a specific version image that will give us the clarity what sort of images are running into the prod environment to avoid the last moment chaos. Because if you are using the latest images, meaning if there are new changes pushed into the image, meaning those bugs which are present on the latest thing is present into the prod, and that thing we can eliminate by using the specific version of the images, right? Second is, how do I mark the version of the image? So for that we have to learn something called tag. So a tag is something that will give you the clarity what sort of version of image we are using. Now think of it like you are going to an Apple store and you want to buy an iPhone. So if you go to the shop counter and say, hey, I want an iPhone, so the salesperson will say you, okay sir, which sort of iPhone you are looking for? Is it iPhone 13, iPhone 14 or iPhone 15, right? So here we are talking about 13, 14 and 15 of the iPhone version. Likewise, the same thing applies over the Docker images, and that will give us the clarity what version of images are we utilizing, right? So let us learn how to tag any image. So we are going to make the tag for Nginx. Now let's say if I want to mark the tag for Nginx latest. So the syntax is very much simpler. Docker tag, what is the current image? So this is my source, Nginx latest, and I want to convert it to Nginx v2. Enter. When I do Docker images once again, you can see Nginx v2 is presented over here, and this makes sense because this is giving me the complete clarity what sort of version of image I am utilizing, right? So that is one of the topic that I wanted to cover, because versioning will give you the control, and if something goes wrong, you know which issue is present in which sort of version. Instead of using latest, it is recommended to make use of the versioned images, right? So that was the first part. Secondly, we were talking about dangling images. And I told you something in the beginning that you might get something like untagged. It can also look like none. So what actually is dangling images? Now see, whenever you are building any images, now I know we are yet to build any of the images that we are going to see in the coming videos for sure. But for now, just wanted to tell you, if you see any sort of images that contains no tags, that is you will see untagged over here, or if you see something like none, so those images are called as dangling images. It has nothing to do with the current image because those are created through layers, and those are currently not in use for any image or not in use for any container. So why it is said dangling image? Because those are occupying the resources. So what is the best practice to deal with the dangling images? It's to remove them, because it is consuming the resources, it is consuming the space. Now how to remove that dangling images? So it is very much simpler. So in order to list the dangling images, you just have to write docker images -m dangling equals to true, and that will list all the images that are not in use for any image and that are not in use for any container. How to delete or remove any dangling image? So for that we have a command called docker prune. So I will write the command over here, docker image prune, and this will again come with a warning. And what's the warning? It is saying that this will remove all the dangling images. Are you sure? Do you want to continue? So basically this will remove all the images that are not utilized by the image or that are not utilized by the container. So if you see, whenever we are pulling any images, it is consisting of multiple layers, right? So these are the images that are created through one of those layers which are not even utilized. So if you want to sum it up into simpler words, it's just like the draft that was never even sent, right? So those images are of no use, and those are consuming my disk usage, right? Those are consuming the resources, so it's better to remove them. So I'll just press yes, and this will delete that dangling image. And when I do docker image -f dangling equals to true, this should list me nothing, because
there is nothing present. Let me just rerun the command once again. Okay, and here you can see all the dangling images are removed. I hope in this video you learned about what is the significance of Docker tag and what value does it add into software development, and what is the standard practice of handling the images into the prod environment. So that's the basic reason why people prefer versioned images over latest. This is the actual reason, right? So yeah, that was all, and I will see you in the next one. Thank you very much and keep learning. So you probably have heard this many times. Docker runs container. But what exactly is a container? Is it a virtual machine? Is it a small server? Or is it something completely different? Right. So today we are going to answer this directly, because in this video we are going to understand what actually is a container, how does it works internally, and why containers are so powerful. So before even we move forward, just wanted to give you a quick recap that Docker works with images and container. So here let us understand the relationship between images and container. So images are the blueprint through which containers are created, and containers are the running instance, right, that we actually see and we can actually experience the application. So think of it like the recipe book as the Docker image, and the cooked meal is the container, right? So let us define what actually is a container. So, Docker container is the running instance of Docker image. It is a lightweight environment where the application runs with its code, with its dependency, with its library, and with its runtime. So, everything that you require to run an application is present inside the container. Now, let us take an example. Think of container like a shipping container, where inside the container you pack your goods, you pack your boxes, you pack your equipments, and the container protects everything and allows it to move it easily, right? So the container protects everything and it will allow us to ship it from place A to place B, and Docker containers does do the same thing, and it apply the same application over here, right? So so basically they package everything, and they package it in such a way that it can run the software everywhere. Now, what happens when a container start, right? So let's say you are running an Nginx image, that is a service image that runs in the background. So you probably have executed the command docker run -d nginx, where -d stands for as a daemon process that it will tell Docker that to run it into the background, or else your console will get occupied. Okay, so let's say you executed docker run -d nginx. Now what Docker performs, it performs several operations that we are going to discuss. So the step one would be it will pull the image. So Docker downloads the image, whether if you specify the tag, it will download the latest image. If you don't, so basically when you specify the tag, it will download the specific image. If not, then it will pull the latest image, right? So basically it will first check into your local machine. If that image is not present, then it will pull from the Docker Hub. Now after the image is pulled, the step 2 would be to create the container. So Docker will create the container using that image, right? And that container will have its own file system, it will have its own network, it will have its own space, right? And then once the container is created, we have to start the application. So inside the container, the main application starts. So let's take an example of Nginx server, the Python script, the node application. So once the process starts, the container is actually up and running, right? So one of the most important thing that we need to take care when we are dealing with container, and that is containers are processes. This is the one of the most important concept to understand, right? So container is not a virtual machine, that we are clear of. It is actually a running process of your host operating system, which comes with the isolation using the namespace and Cgroups, which we already saw. So the containers are lightweight, it is fast to execute and efficient, right? Now think of your computer like an apartment building. Each container is like a separate apartment, which will have the same building, which will have the same electricity, which will have the same plumbing. So there will be same things for everything, but each apartment is isolated, right? Now let us understand the life cycle of the container. So container go through the different phases, right? So typical life cycle of the containers are:
First, the container is created, then the container is executed, it is in running state. Now then, post is optional because that is something that we do from our end. So the container is in running state, and the container stops, and the container is deleted. So we discussed the stages in detail earlier. So remember, containers exist only while the process are executed. And that's why I said in the previous slide that containers are the processes, right? Now let us move forward and understand what actually do we have inside a container, right? So a container typically includes the application code, the libraries, the runtime, and the configuration file. But it does not include the full operating system, and that is the reason it is different from virtual machine, right? So containers share the same host kernel, and that is why containers are so lightweight, so that it will spin up in an instance, right? Now let us take the recap. So in this video we saw what actually is a container. So container is a running instance. We saw the container package. Container is equals to the package of the application and dependency. Containers runs on the isolated processes, and containers share the same operating system, and containers are lightweight and fast. So it is very important to understand this foundation of the Docker, because Docker is all about images and container, and today we cleared the concept of container, right? So now that you have clear understanding of what Docker container is, let us move forward. In the next video we are going to see the lifecycle in action by performing the operations into the console. So yeah, that was all, and I will see you in the next one. Thank you very much and keep learning. Okay, so let's talk about the life cycle of the container. In the previous video, you have gone through the life cycle of the container. We actually understood what actually is a container and what value does it add, right? And whenever we are talking about Docker, what is the thing that comes along with the image? It is actually container. So Docker involves two components, that is images and the container. In this video, we are going to do a deep dive on the life cycle of the container. And here we go, right? So the first thing is, in order to demonstrate this specific demonstration, and in order to show you what does the life cycle of container looks like, what are the different phases that the container have to go through, let us take example of a service image, and here we are going to talk about Nginx. So but before even that, let me clear up the environment. So when I do docker images, here you can see an image is already present and it is currently in use. So one thing that I wanted to show you, what will happen if you delete an image, if you try to delete an image that has been utilized by a container. How do I list the container? So basically I will run docker ps, but you can see there are no container which are in running state. But if I want to see all the containers regardless of the state, I will run -a option, and that will list all the container. Here you can see a container named Nginx has been using this image, okay, and it is in exited state. Okay, now what will happen if I try to delete the image? So docker rmi for removing that image followed by the image name, it will give an error. Now let's go through this error. So it is saying error response from the daemon. There is a conflict. It is unable to delete the Nginx latest image. It must be forced. Why? Because the container with this ID is using for the reference image, and here it provided the image ID. Let's validate. So here you can see the image ID is present over here, and here in the error itself it mentioned which container is using that image. Here you can see the container ID. So what it is asking you to tell is, basically it is asking you to delete the container first and then delete the image. How do I do it? So docker rm followed by the container ID that is in exited state. Due to that reason we were not able to delete the image. So when I press enter, the container is deleted. Let me just re-verify it, and here you can see there is no container running. Okay, now let me remove the image itself. So docker rmi followed by the image name, and here we want to delete Nginx. Let me clear it and let me just list it once again. Here you can see the environment is clear for now. There is no container, no image for us. Now let's start with the actual hands-on on the life cycle of container. Now since we want to understand how does a life cycle of a container looks like, we are going to take a reference of an Nginx image. So let me pull the image. Okay, now since we want to create a container, we need a prototype through which that container will be created, right? So for that I will pull the image docker, and here we are going to pull nginx. So docker pull nginx, and here it will search the image locally. Now since it was not present in my local, it went to Docker Hub, it pulled the image. Now again, one more thing to note, now since we didn't define the tag, it pulled the latest tag. Okay, whatever tag that was defined as default, it is pulling that image. Right now, in order to validate whether the image, the blueprint is actually present in my local, I will run docker images, and here you can see nginx latest present. Let me clear the screen. Now the first thing is we have the blueprint through which the container will be created, and now let us move the state from none to running. Now how do I run a container that is in none state? So for that we have a command called docker run. So what will happen if I just run docker run nginx? Now I mentioned earlier that it is a service that runs in the background. What will happen if I just run it directly? Enter. It actually occupied my terminal, and if I type anything, I won't be able to, because it is something that runs in the background and it will consume my console for now. In order to get out of this, I'll just press Ctrl C, and here it gave a signal. Okay, it gave the signal to the container nginx that your work is done, and here we are good to go. And that's the reason it will show us the exit state when we run docker ps-a. Let us validate. Let me clear it, and when I run docker ps, no container will be present. Why? Because we gave an termination signal to the container. Let me just docker ps-a, and here you can see the nginx container present along with the exited state 0, which means that the container was running and then it received a signal and then it got terminated. Let me remove this container now. So docker rm followed by the container id, and here I will be removing the docker container. Okay, now let us rerun and create a new container with few options and argument that we have learned so far. Right, I believe you have already gone through the video docker command structure. That video will give you the clarity how to frame a command. Okay, so docker run. Now since I want to run nginx image, I will write the image name. Here we are talking about nginx image. Now since I want to run it into the background, I will pass -d. Since it is a daemon process, it should run in the background, and I want to call this name. I want to give this container a name, right? So I will pass -- name tag, and I want to call this name container as web app, and then I will press enter. Now what it will do, basically it will run the container in the background, and that's the reason you can see my console is now free, and I am able to type the commands. Now I want to call that container as web app because I don't want to refer it with the container ID, right? Let us validate whether the container is up and running or not. I executed docker ps command, and it actually listed all the running container. Now here you can see it has a container ID, and now since we passed -d, it is currently running in the background. Secondly, you can see the name of the container is web app. Now if I want to get more information on this container, basically I will need to inspect this. So if I run docker inspect followed by the container name, you can see all the information about this container is actually present. Information, for example, which network is it using, what is the IP, right? All those information are currently present into the inspect command. It will tell you what is the status of the container, whether it is running true or false. All those information will be present over here. Let me clear the screen right now. So basically what we learned so far, we actually pulled an image, and during that case basically the state of the container was none because it was not yet created. Then we converted an image into a container by executing it. So we ran docker run command so that it changed the state from none to running. Now if I press docker ps, you can see the container is up and running. Now what if I want to suspend the services for time being? How do I do it? So basically we have a command called docker pause followed by the container name, and here the container name is web app. Enter. Now how do I validate it? Again, you need to go and run docker ps. And how do I validate whether the container is paused or not? Here you can see the output. Again, when it was running, at that time you can see the state, it was up about a minute, and basically it was running. Now again, when I executed the command docker pause web app, it actually suspended the services, and here you can see the container is paused. How do I unpause it? It is very much simple, straightforward. How do I do it? Docker unpause, followed by the container name web app. And now when I do docker ps, you can see the container is up and running again. Now let us go with the lifecycle. We change the state from none to running, then we post the container, then we unpost the container. Now what if I want to do a soft delete? Okay, how do we do it? So basically, let me clear the screen. So whenever we are talking about soft delete, we are talking about stopping that container. How to do it? So basically docker stop container name. You can even pass the container ID. Now here you can see the command got executed. If I do docker ps, you can see nothing is present. But again, if I do docker ps -a, you can see the container is in exited state. How do I start the container? So basically we have command called docker start. This will start the container from exited state and it will be again up and running. Okay, if I do enter, you can see docker ps and the container is actually up and running, right? So basically we saw docker pull, it actually pulled the image, then we executed the container, it was into running. Post that, after running we stopped the container, and now let us restart the container. How do I do it? Let me just stop the container once again to show you how does restart works. So I will just write docker restart web app, the name of the container, and when I do docker ps, you can see the container is actually up and running. We even saw soft delete. Basically what it does, basically it will move the container into exited state, right? Now what is docker hard delete? How do I do it? So basically here we are talking about killing the container. How do we kill a container? So docker kill followed by the container name, that is web app. If I do docker ps, the container is not running. If I do docker ps -a, you can see it got exited. So once everything is done, let's talk about deleting the container, because once it is served its purpose, let us remove it. So docker rm followed by the container name, and that will actually remove the container. Let me clear the screen and I will show you the history. So this will give us the complete idea of the lifecycle of the container. I will attach one screenshot into the screen and that will give you the clarity about the lifecycle of container. So in this video, we have covered all the commands that are involved into the container, and that actually demonstrated the lifecycle of the container. From pulling the image till the termination, we covered everything. So yeah, that was all, and I will see you in the next one. Till then, thank you very much and keep learning. Okay, now let's take a scenario where you are working in a container and there was a need to make few changes inside that container. You went inside that running container, you installed few software, you modified few files, you did some configuration changes. Now that you spent near an hour or two, you realize, how do I save this work? Is there any way to take a snapshot of this running container? So yes, Docker commit will give you the answer for the same. In this video, we are going to understand what actually is Docker commit, why it is used, and what is the power that it brings us into the plate, right? So let's discuss about Docker commit. This video, we are going to see the theoretical part of what actually Docker commit does, what it is capable of, what is layers in Docker images. And in the following video, we are going to do the hands-on so that it will give you the clarity about Docker commit. So without further ado, let's get started. Okay, so let us understand what is actually a Docker commit. So Docker commit is nothing but creating a new Docker image from a running container. Okay, so here basically just take an example of Notepad in Windows. So let's consider that there is a file name new.txt, and within that new.txt there is a text written as hello world. Now what will happen if I add more text onto it? So like hello world from Shubham, right? And when I click on save as, it will ask me for a new file name and a new file will be created. Let's say new text 2.txt, right? Likewise, Docker commit does the same. Okay, so basically here your container is your working file, that is new.txt, where the text is written and image is the saved version, right? So basically Docker commit will act as save as option in Windows that will create a new 2.txt. Right? So it is very much simple to understand. Now when we do the practical hands-on, it will make more sense because at that time you will be able to visualize what actually things are being done. Now we understand what actually is a Docker commit, but why we should consider and why do we need Docker commit? So let's take an example. You start a container, you make changes in it. That changes can be anything. You can install any software, you can modify a few files, and then suddenly container stops or it is deleted. The thing here is, the problem here is, since those changes were made in the running container, all those changes are lost. And as we are already aware of the nature of the container, containers are temporary by nature, right? Once the service is completed, once the process is completed, it by default goes into exited state. So how do we save the changes? Basically by converting them into an image, right? So here is where Docker commit helps. It will help us to create the snapshot out of that running container, so that whatever changes you made during that runtime will be saved as an image. So the next time you don't have to install and manually make the changes onto this file, right? So what actually happens internally when you create a Docker image from an container? So basically here you can see there is a syntax written over here: Docker commit container name and the image name. So basically here the container name signifies the current running container on which we made the changes, and here is the image name that we want to provide. So basically this will be the name of the image where we will be storing all the data as a timestamp, as a snapshot, right? So it will take the current container state, it will capture all the changes, that will include the file changes, that will include the installations, that will include the configuration changes. It will create a new image with all those changes and it will store it locally. So by any chance, by any problem, okay, if the container stops or if the container gets deleted, you have that snapshot and now you can reuse that image anytime, and all those files, all those configuration will be handy. You don't have to worry about it. Now let us take one important concept about the container, that is image layers. Now as we are already aware that whenever we are pulling any image, whenever we are dealing with Docker image, we are actually dealing with the layers. So Docker images are made up of layers. So when you commit, a new layer is added on top of the existing one. Now let us take an example to understand. Now let us take the example of Ubuntu as your base image, and on top of it you install Nginx, and then you commit and you create a new image. So here your new image will be equals to your Ubuntu image plus Nginx layer. So next time when you run that new image, you don't have to install Nginx again. It will be present on that image by default. So that's the power of Docker commit, because you don't have to manually do that configuration, do that installation again. Now when we should use Docker commit? So we can use Docker commit when we are experimenting something, we are debugging something, we want quickly resolution, and we want to save the container state, and if we want to create quick custom image. So it is very useful for a quick state save and for testing. But here we understand when to use it, but when not to use Docker commit. So basically the general term in production, we usually do not use Docker commit because those changes are not reproducible. Now what do I mean by that? Now let's say that a DevOps engineer A made changes into that running container. He created a snapshot out of it, but if someone else comes and join and runs that container, he doesn't know what changes are being made, and that's the reason we are not using Docker commit into the production. So that's the reason it is not reproducible. There is no clear history or track of changes, and it is hard to track what was modified and who modified it. So instead of that, we make a wonderful use of Docker file. It is clean, it is version control, and it is automated. Now what is a Docker file? That is something that we are going to cover in the coming lecture, but for now just understand Docker file is a regular file where we wrote down all the instructions that we want to make within an image, within a container, and when executed it will create an image, and when executed it will create a container. So from Docker file it will create an image, and from that image we will create a container. So that is an alternative that we have, that we actually use into the production. Now let us take a real world use case. So let us take an example that you are debugging an issue into the production. So basically what you do, you enter inside the container, you fix something, you want to save that state, and instead of losing it, you basically commit the container into an image. Then later you can analyze, you can share, you can reproduce the issue, and it is very much helpful for a debugging scenario. So here you don't have to wait, you can directly share it with the people, right? So that was one of the use case that we can use. However, it is highly recommended not to use Docker commit into the production. That should be only used for debugging and testing purpose. So let us take the example and let us take the recap of whatever we learned so far. So Docker commit is equals to the snapshot of the current running container that will create the image, so that the next time whenever we execute that image, we don't have to make those manual installations and configuration and the file changes that were made. It will save the current state of the container. It is useful for testing and debugging, and it is not used in workflows.
production, that is, it is not used in production workflows, and instead of that, Docker file is preferred to use in real world production environment. So yeah, that was all in this video where we learned about the theoretical aspect of Docker commit. In the following video, we are going to do a practical hands-on that will give you the clarity how does Docker commit work and what value does it add into the DevOps lifecycle, right? So I will tell you how to do it. So let's wait for the next one. Till then, keep learning, and thank you very much.
Okay, so we are well aware of Docker commit. In the previous video, we have gone through the theory, what actually is Docker commit, why it is used, when to use it, and what we use in production. In this video, we are going to do the practical hands-on on Docker commit, and that will be something that we are looking forward to, right? Let's get started. So for this specific demonstration, we are going to make use of Nginx because that will help us to clearly understand how does Docker commit works. So let's pull Docker image. So Docker pull Nginx. And since I'm not defining any tag, it will take latest tag by default. And secondly, since that image was not present in my local, it went to Docker Hub, it pulled that image, and now it is present in my system. Right now, here you can see there are multiple SHA values. Now what are these? Basically these are nothing but the layers, and finally you can see the digest value, and here you can see the SHA hash value for that specific Docker image. Now as I mentioned, in Docker, whenever we are dealing with images and container, we will be dealing with the layers, and these are the layer of the images. Now where does Docker store these images, these layers, right? So basically there is a path for that. Let me just turn it as a root user, and let me just navigate you to that path, right? So cd slash where lib container d, and then io dot container d context.v1 content, and inside that path we have blobs, and then inside that directory we have sha256. And if I clear the screen and if I do long list, you can see there are multiple layers which are present over here. Now how do I validate whether my image SHA is present over here or not? Let me run docker images, and here you can see the id is present, and when I do long list, I will pass grep, and we are here looking for this image, and here you can see the current date and the time and the SHA value of that image. So this is nothing but the layers that has been referenced by the images and the containers. So yeah, that was all about layer. Let us move forward with the main topic, that was Docker commit. Let me clear the screen and let me just go back, exit, and we will be executing the commands as a regular user. Now if I run docker images, you can see there is this image called Nginx. Now what I want to do is I will run this image and I want to turn it to a container. How do I do that? So basically we have something called docker run command. Now since it is a Nginx image, it is a service, I know this runs into background, so I will pass -d, and then I want to run it into port number 80. So I will need to do the port mapping. So I want to map the host port with the container port, and both are port number 80, and then I want to call this container as web app, and I will pass the name of the container, the image, that is Nginx. Now when I clear the screen and when I do docker ps, you can see the container is actually up and running by the name web app. It is mapped to host port 80 with the container port 80. What do I mean by port mapping? So basically we are mapping the container port with the host port. So whenever we are referring, whenever we are calling that specific service, it will respond to port number 80. Right? So how do I see the welcome page of Nginx? So basically, like, you can just open the browser, and on the browser you just paste the public IP, you will be able to see. However, in the console, if you want to verify, just write curl localhost, and here you can see the welcome message from Nginx has been displayed over here. But if I want to pass the IP specifically, how do I do it? Basically we have a docker inspect command which we have already made use of. So docker inspect web app, that is the container name, and here I want to use grep, and I am passing few options, that is case insensitivity, and I am looking for 4 lines after IP address, and here my IP address is present. And now when I do curl you can see the welcome message from the Nginx container printed over here. Now the first thing for Docker commit is already done, that is we created a container. Now what we are going to do, we are going to modify this page so that we are modifying this page in such a way so the next time whenever we are referring that committed image, we will get the newest data, and that will prove how does Docker commit works. So the container is currently up and running. Okay, now what I want to do, I want to modify the files. So what I will do, I will go inside that container. How will I go inside a container? So yes, basically we will run docker exec command. So docker exec -it, because I want an interactive terminal space followed by the container name, that is web app, and then I want to have a shell. That's why which shell I'm referring to. You can either go with sh shell, but I want to go with bash shell. Enter. Right now I am inside the container. Okay, now where does Nginx store the index.html file that was just displayed over the screen? So it is stored in /user share Nginx HTML, and here we have the file called index.html. Okay, now if I just do a cat on index.html, you can see the welcome message is mentioned over here. Now what I will do, I will just do a vim over here and I will replace this entire thing, right? See, since it is Nginx container, vim is not present over here. What I will do, I will make use of basic commands that will replace the entire index.html file. So echo welcome to Docker commit, and I want to replace the entire index.html file. Now when I do a cat on index.html, you can see the message is printed over here. Now let me go outside the container, and now when I do curl on the IP address that we just found out, let me just rerun the command. So I will make use of docker inspect to find out the IP address, and here it goes. So when I do curl, you can see welcome to Docker commit is present over here. Now what does the theory says? So a Docker commit is used when we want to save the snapshot of the current running container. Right now I have modified the file, and next time let's say whenever I am spinning up a container, I want these changes, but right now I don't have it handy. So what I will do, I will create a snapshot out of it. So what does the syntax says? So basically docker commit, and here I need to pass the container name. So that is web app, and now on which image do I want to store it? What should be the name of image? So here I will call as web app, and this will be a v2 image. I will pass the tag, enter. So from this running container, we just now created an image. Let me validate it. So when I run docker images, you can see web app v2 is present over here. Now what I will do, I will delete the entire container. I will delete the entire images that we were just using. Let me clear the screen, docker ps, and I will delete this container. So docker rm-f, I will delete web app. Web app is deleted. Now let me delete the base image through which that container was created. So docker rmi, and I will delete Nginx latest image. Now everything is clear. Now when I do docker ps, nothing is present, and when I do docker images, only one image should be present, and this is the image that we created to docker commit. Now let us run this image. So docker run -it. I want to do the port mapping, and this time I want to map the host port 8080 with the container port 80. So whenever I make a call on port number 8080, it should display the result. What do I call this container? So I will call new docker app, and I will pass the name of image. So what will happen if I just pass web app? This will throw an error because this time we are not dealing with latest image, we are dealing with a tagged image, and here it is v2. When I press enter, you can see the container is actually up and running. Why it is consuming my terminal? Because I didn't pass -d. Let me just terminate it, clear the screen, docker ps -a, and let me just start the container. Docker start. Okay, docker ps, and here you can see the container is up and running. Now let us run the curl and check whatever data was there in the previous nginx image is been listed here or not. So let me just run inspect command. So docker inspect new docker app, and I'm looking for the IP address. So grep -ia and IP address. Here I have the IP, and now let me just run the curl. Here it is displaying the message as welcome to docker commit clear. And now even if I want to run it as localhost or localhost, what will happen if I just run curl localhost? It is saying failed to connect to localhost port 80 and couldn't connect to server. Why? Because the host port is mapped to to port number 8080. So I will need to pass it explicitly. And here you can see the message is present. All right, I hope you understand how does docker commit works. So basically what we did, we pulled an image, we made the changes, we created a snapshot, we deleted entire thing, and then we created a container through that committed image. And then here you can see the reflected changes are present. So docker commit is very handy when we are doing testing and debugging. However, please avoid this practice into the production. So whatever we have done so far is already documented into the repository, sub repository number 5, that will explain you what actually is a docker commit, okay, and why to use it, okay. And here you will find the syntax. So whatever command we just executed is already documented here. Please go through the entire documentation. I personally have maintained it so that you can just go through it and learn from it. So whatever we did, so basically we pulled an nginx image, and then we ran a container with port number 80. Post that, we updated the configuration file that was hosted by nginx, and then we deleted the file. We committed the container, and we got a new image that was web app v2. Then again we deleted entire stuff, and then finally we mapped it with port number 8080, which was the committed image that we created. And finally we can actually see the live result as a snapshot that was created from the previous container. And this is the visual flow. And finally we discussed in the starting about the storage part, where does the layers are being stored by docker. This is the path basically which is present over here. Now at the end I have added few interview questions that will help you to understand what actually is docker commit. So yeah, that was all in this video, and I will see you in the next one. So till then, keep learning, and thank you very much. Now let's say you are running a container, and within that container you create files, store data, and view information, right? And then you delete the container. Now what happens when you delete a container? All that data is now gone. Scary, isn't it? In this video, we are going to talk about Docker volumes that will help us to prevent these issues. Docker volume is one of the important concepts where it comes to storing the data. As we are already aware of the nature of container, so whenever you delete the container, all the data is lost forever. So that is something that we are going to discuss in this video. Now take an analogy that you are using a hotel room. So you will use the resources, you will use the room, and once you are done with the things, once you do the checkout, everything is back to square one. So in this video, we are going to do a deep dive on the theoretical aspect of Docker volumes, and in the following video, we are going to do a practical hands-on on Docker volume. So yeah, let's get started and understand what is Docker volume. Okay, so before even moving forward with Docker volume, it is very important to understand two concepts, that is stateful and stateless application. Now what are stateless application? So basically those application which doesn't rely on the previous search data, on the previous queries. So these are the application that doesn't need any sort of data, that doesn't store any important data. They can restart anytime. For example, a web server. Now what is a stateful application? Those application which relies on the previous search queries, which stores data. For example, MySQL, these application needs persistence. So all those application that stores the previous context, those applications are known as stateful application, right? So stateful application needs volume, and stateless application may not need volume. Now we understood what is stateful and what are stateless application, because in stateful application we need the previous query context, in stateless we may not need it, right? So that's the basic difference. Now let's move forward and understand what actually is Docker volume. Now here you can see there is a big definition which is provided over here. So let's go with the official definition. What is a Docker volume? A Docker volume is a mechanism for persisting data generated and used by Docker containers, ensuring that data remains intact even after the container using are stopped, removed or replaced. Volumes are preferred method for persistent storage in Docker. If I summarize the entire definition into a single line, it is a storage location outside the container that is mounted inside the container, right? So if I summarize the entire definition, if I want to tell anyone what actually is a Docker volume, it's just like a folder that I will store in my host machine that will be referred by the container is called a Docker volume. It is just like using a pen drive onto a PC or a laptop, right? So when you plug in that pen drive, your laptop will be able to access the data, and if you plug out that pen drive, the data won't be there. So that is the ideal example of Docker volume, right? Now where does Docker volume exists? Docker volume, does it exist in your container or does it exist in your host machine? Docker volume exists on your host machine, that is on your system. It doesn't exist on your container. So the container uses Docker volume, but the data will live outside the container. That is why the data survives, because we are already aware of the nature of container. Once the service is done, once all the processes are completed, it will go into exit state, right? In order to save that data, we are mounting it to a place. We will mount it into a local host machine. That's the reason every time whenever we are booting a machine, we have a volume that we mount to the container and the data will be able to accessible, right? Now where does this volume exists? So Docker volume exists on your host machine. It does not stay inside the container. Now how does Docker volume works? So it is very easy, and we are going to do the practical hands-on in the next video, so it will give you the clarity. But for now, just understand how does the volume works. So you will create a directory on your host machine, then we will mount it inside the container, and whenever the container writes any data, it will be stored into the host machine. So when you stop the container or delete the container, the data is safe because it is not stored inside the container. It is present in your local host machine. So you can attach the same volume to the new container and you can see the data is still present. This specific demonstration we are going to do in the coming video, so don't worry about it. Right now we learned about what is Docker volume, why it is used. Now how many types of Docker volume we have? Basically there are two sort of classification of Docker volumes. First is bind mount and secondly is named volume. What is bind mount? So just imagine that you are mounting your local directory into the container. That is something we call as bind mount. What is named volume? It is a managed Docker volume that you mount with the container. That's it. So here you can see the syntax of Docker bind mount and Docker managed volume, right? Let's move forward. Okay, now when we take the real world example, so this is something that we are going to see in the coming demonstration. Imagine that you have a database container. So let's say MySQL, the user will store the data, it will write through the query, and without volume, the data will be stored during the runtime of the container. But when the container is terminated, the data will be lost. But when you're dealing with Docker volumes, the data is safe even when the container is terminated. Next time when you spin up the container, you will just have to mount this volume and your data will be present there for sure. So this is why Docker volumes are critical in production, right? So let's take the recap of whatever we learned so far. Containers are stateless by default. That's the reason we need Docker volume, because data is lost when the container is deleted. Docker volumes provide persistent storage. So where does the volume stays? It exists into the host machine, and we can reuse the same data again and again across the container. So yeah, that was all about this video where we learned about Docker volume. In the next video, we are going to do the practical hands-on on Docker volume. So yeah, that was all, and I will see you in the next one. Till then, keep learning and thank you very much. Now that we are finally aware with the power of Docker volume, let's do the hands-on, right? So this video is divided into two segments where we are going to do the operation on container without Docker volume, and in the another segment we are going to utilize Docker volume and understand what is the nature, what is the behavior of container when we perform Docker volume in it, right? Again, in the previous video we have gone through the theory, so I believe you are already aware what sort of what types of Docker volume we would be dealing with. So yeah, with that note, let's get started. And before even we move forward, so this demonstration may be a lengthier one, so I would recommend you to take your notes. You can write it on your notepad so that it would be easier for you to understand. Either ways, I have already documented everything into the GitHub repository, sub repo number 6, and you can just refer it. But I would recommend you to take your own notes because that will help you and help you to get the clarity, right? In this specific demonstration, we won't be just running the commands, we would be seeing how we would be able to visualize things, and it would be easier for you to understand, right? Let's get started. So before even we move forward, we are already aware of the application type. We know application are of two types, stateful and stateless. What are stateless application? So those application where the data is not persistent is called as stateless application, and those application where the data is persistent is called stateful application, right? And we are already aware the nature of container. It is stateless, meaning if the container is deleted, the data is gone forever, right? And that's the reason we are learning Docker volume. Okay, so let's get started. So the first thing that I want to do is, let me first check any image present in my host. There is nothing present over here, and there are no container which are running, right? Docker ps-a, and here you can see no container are running, meaning my system is ready, nothing is running, and I can actually show you how does Docker volume works. So the first thing that we would be doing is, let me take example of Nginx this time. So docker pull Nginx. Now we already saw there are no images present in my local. Now since it was not present there, it checked it and then it took the latest pull from Docker Hub, and here you can see multiple layers are being pulled, and finally my Nginx image is present over here. Alright, now moving forward with the next one is, let me just list the image by running docker images. Here you can see Nginx image is present. Let me clear the screen. Now since we have the blueprint, now let us first create the container. How do we create a container from an image? So for that we are going to make use of docker run -d. I want to do the port mapping, port number 80 of my host to the port number 80 of the container space. Now I want to call this container as web server, and then I will pass the name of image. Enter. When I do docker ps, you can see the container is up and running. Here we are interested with two things, that is web server, the name that we passed over here, and secondly we performed port mapping, which you can see over here, right? Now before even we move forward, let us note few more things. Let me run docker inspect, and here I want to inspect the web server. Here we are interested in getting the IP address of it. We copied the IP address, and when I do a curl, you can see a welcome to Nginx is present over here. Now what I want is, I don't want this custom message to be present when I do curl on that IP. I want to get a custom message over here. This is something that comes by default by Nginx, right? How do I do it? So for that I need to go inside the container, make the changes, and then do a curl once again. Now comes another question. How do I go inside a running container? Yes, we are going to make use of docker exec. So docker exec -it. Now since I want to run commands inside it, that's the reason I want an interactive terminal. That's the reason there is a need of interactive terminal. Then I will pass the container name followed by the shell that I would be using inside that container. So it would be /bin /bash, and I am inside the container. Now the next thing is, where does Nginx stores the index.html that we saw in this specific console, right? So we need to go to usr share nginx HTML. So this is the path. When I do ls, there is an index.html present, and when I do a cat over here, when I read this file, the same default message welcome to nginx is present. Now the statement over here is we don't want this default message, we want a custom message to be printed. I will remove that index.html file and I will create a new one. So echo this is without volume, and I want this to be present in index.html. Now when I do a cat on index.html, the new message that we wrote is printed over here. Now when I go outside the container and when I run the curl command once again, you can see this is without docker volume present over here instead of welcome to nginx. Why? Because we went inside the container, we changed the file, we changed the context, and here we are getting the expected output. Now due to some reason, let's say accidentally I deleted the container, docker rm-f web server. When I do docker ps-a, nothing should be present. Now in this case our data is gone, the effort that we made to make these changes is gone. How do we make sure this specific condition doesn't occur once again? So that's the reason docker volume comes into the picture. Let me clear everything. We only have one thing with us, that is the blueprint through which we created the container. Let me list the image, and here we can see nginx image is present. So step number 1 is to create a directory where we would be storing the data. So mkdir, and I will create data name directory over here, and if I go inside data, I will need the path of it, and here it is stored in home Ubuntu data. Okay, so this will be the directory that we would be mounting inside the container. Okay, I will parallelly show you how does things are been visualized. Okay, so it would be easier for you. So step number 1, we created a directory that is data. So I'll go to excalidraw, and here the first thing that we are doing is, here this is our host machine. Let me mark it as green, and inside this host machine we created one directory named data. Okay, and here let me mark it as blue. Okay, all right, we have this directory where all the data will be stored. So this is something that we just did. Now let me, okay, I'll just keep it as it, so everything is present in front of your eyes and you will be able to do. Step number 1, we created a directory. Now step number 2, create the container. Docker run -d, and then I want to map it with the port number 80 of my host with the port number 80 of the container. Now here comes the important section, that is -v. We want to mount the /data directory that we created with /usr/share/nginx/html. So this was the path that we noted earlier, remember? And now I want to call this container as web1 followed by the image name nginx. Okay, so what we are doing, we are running a container into background, we are mapping it with port number 80. We perform docker volume mounting over here, that is from a /home/ubuntu/data with /usr share nginx html. This is the place where index.html was present, followed by we wanted to name it as web1, that is the name of container, and the image name. Enter docker ps, and you can see the container is up and running, where the container name is web1, and we did the port mapping with port number 80 of host with the port number 80 of container. Now let me run docker inspect on web1. This is inspect. Okay, here we are interested in two things, that is, first is the IP address, and secondly is the mount. Search for mount over here, that will give you the clarity whether volume mounting has been done properly or not. Here you can see the mount is present, the type is bind mount. So we did a bind mount over here, that the source is /data that we just created, and the destination is usr share in nginx html. So this is the path that we noted earlier when we were inside the container. Let me clear everything, and when I do ls and when I go to data, nothing is present right now. ls, nothing is present, right? I'll go back, clear the screen, docker ps. Okay, now what I will do, I will go inside web1. So now since it is a running container, docker exec -it web1 /bin/bash, enter. We are inside web1 container where we performed the docker volume mount and the mount type was bind. Now I will go to the directory where we mapped it with our local directory that we created, usr share nginx html, and here what I will do, I will first list if something is present. If not, I will create a new index.html file, and here I'll write, hi, this is from docker volume, this is web1. Okay, and here I will write the name of file, that is index.html. Okay, exit. We are outside the container. When I do ls, when I do cd inside the data directory, here you can see index.html is present. If I do a cat over here, whatever we wrote inside the container is been printed. What actually happened, I'll explain you. Now what we did, we created one container, and let me mark this container with yellow. Okay, and this is container1. Okay, I'll write the same name, that is web1, and inside web1 what we did, we mapped it with the path, that is /usr /share /nginx /html. Okay, and let me just expand it so it would be easier for you to read. This is web server 1. Okay, and this is the data, this is the directory that we created, that is /home /ubuntu ubuntu /data. So this is the directory that we created. Okay, and now what we performed, basically with this directory we linked the web1 container. How did we did it? With the help of docker volume. So here it is mapping to this container. Now what will happen, let me first clear it. First we are going to curl this, so let me just curl it with the IP that we had earlier. So let me just get the IP of it, docker inspect web1. Here we are interested in mount type. We already saw the mount type was bind, and it is linked with the source and the destination that we provided. So it's /home ubuntu and data. Destination is usr share nginx html. Now let me get the IP address from here and clear the screen, curl with the IP address, and here you can see this is from docker volume and this is web1. And let us create a new container this time. So what I'm going to do is, I am going to create one more container where we would be mounting web2 again with this specific directory. Okay, let me get one more arrow. So this will be again mapped from here to here, and let us do the same. Docker images, docker run -t -name equals to web2, and then I want to mount it to /home /ubuntu /data with /usr /share /nginx /html along with the image. So nginx, let me just re-verify, docker run, we are running it into the background. Then the name of the container should be web2, and then we are mounting it from the local directory that we created with the container directory, that is usr share nginx html followed by the image name. Enter. Docker ps, and here we have web2 available over here. Let us inspect web2. Docker inspect web2. Here we are again interested in one more thing, that is the mount type. Mounts type is bind, source is /home ubuntu data, and the destination is usr share nginx html. Now what is our expectation? We will be getting the same output this time or not? Let us go inside the container. Docker exec -it web2/bin/bash. We are inside web2 container. Let us go straight directly to the linked directory that we mounted with the Docker volume, usr share nginx html, and when I do ls over here, index.html is present. Now when I run a cat command over here, you can see the same output is listed over here. How it is getting the output? Again, it is fetching the output from the linked directory, that is /data that we created. That same data has been shared with web1. Now, what if I make some changes from web2? Will it be available in web1? Let us validate the same. So I will write echo, this is from web2 container, thanks Docker volume. Okay. Now what I want to do is I want to append this line to index.html. When I do a cat to index.html, we are getting that second line which we were not getting earlier. Exit from the container, docker ps, both the containers are running. Now what I will do, I will run a curl command on web1, right? So docker inspect web1, which is the container 1. Okay. Now I am interested in the IP address. Let me get the IP address, and here we have it. Clear the screen, curl, enter. Here you can see the second line that we entered from container 2 is been listed, meaning whatever data we are sharing with web2 is been shared with web1. Why? Because this directory has been shared, right? Now, so by this we came to a conclusion that even if we delete web1, we can still access the data with web2. Why? Because we have this Docker volume present with us. That's the power of Docker volume. Now let me go inside data over here. When I do ls, index.html is still present. When I do a cat, you can see the second line is present over here, meaning the data has been shared from container to the host, right? Clear the screen, docker ps. So this was method number 1 of Docker volume, where we did the mount type bind. Now let us create the actual volume, because whenever we are running the command, there is one thing that is very hectic for us. If you remember, we were every time mentioning the path, right? Let me just show you the command. One second. Here, see, it is very difficult for us to write this command, right? What if I just pass the name and it should just create the Docker volume for us, right? So let us explore the second option of Docker volume, that is Docker volume create. So let me just remove everything. Clear. Now let me create a volume first. So Docker volume create and the volume name. So this would be new underscore vol. This is the volume that we are going to create, or let me just write it as new data. This would be the name of volume. Now what if I want to list it? So Docker volume ls. This is how you will list the Docker volume. Here you can see new data is present. Now if I want to get more detail where this is exactly stored, how do I get it? So for that, docker inspect new data. Here you can see the mount point is present, so we don't have to worry about the path. Docker itself will take care of it, right? So we are going to explore underscore data. What exactly is underscore data? Is basically the place where all the files will be stored, right? So we don't have to pass this path every time. We just have to pass new data, right? Let us do the hands-on. Okay, now we are going to create a new container. So docker run -d, and I want to name it as web3, and then I want to do the volume mounting, but this time I will not pass this entire path. I will just pass new data, the volume that we created, with usr share nginx html followed by the container name. Okay, there is nothing changed. The only thing that is changed over here is the path. Okay, we are not writing the entire mount path, we are just writing the volume that we created. Enter. When I do docker ps, you can see web3 is up and running. Let me just inspect this because this is something that we are very much interested in. So docker inspect web3. Now let us go all the way to the up. We are searching for mount, and here we are interested to see the mount type, and here you can see earlier it was bind for web 1 and 2. This time the type is volume. Here it is telling us the source, that is where lib docker volumes new data, and the data is stored in underscore data folder, and the destination is usr share nginx html. I'll go over here. We did nothing, but here instead of passing the entire path, we just made use of new data. And what is new data? New data is the docker volume which we just created again. So here basically what will happen, let me just remove it. I'll just create one more section so that it would be easier for you to explain. So here we created one more thing. So this is new data, the docker volume that we created, and again here it will point to web3 same path. So let me just pull an arrow, and here you can see this is how things will work, right? So whatever data that we were sharing earlier, it will behave the same way, but the only thing, we don't have to give a rigid name /home /ubuntu /data. Instead of that we are just going to pass new data. That's it, and it will be directly shared with the container, and that is how things will be work. So for the demonstration purpose, I will create one more server over here, that is web4, that will be linked with new data. So we are going to validate whether the data will be shared from new data to web4 or not. So we are going to again make few changes and validate the changes. Let us go back and do the hands-on. Let me clear the screen, go back, docker ps, and here we have web3. So let us go inside web3. So docker exec -it web3 /bin/bash. We are inside web3, and let us go to the path where the docker files are stored, usr share bin uss share nginx html, and when I do ls, here we can see index.html is present. Now I will rewrite the entire file, rm-f index.html. I am not interested with the default data. I want to give a custom data over here, right? So I will write echo, this is from web3, thanks docker volume, and we are creating index.html over here. Our work is done. Now let us create one more container, docker run -d -name. This will be web4, and I want to do a mount from docker volume that we created. And what is the name of that docker volume? It is new data. So new data colon, and here we want to link it with to the internal directory, that is /usr /share /nginx /html followed by the image name. Docker run -d -name, this is the name of container. Here we are doing the volume mount, enter. Docker ps web4, ladies and gentlemen, is up and running. Let us do an inspect. Docker inspect web4. Again go up, search for mount, and here again you will find the mount type as volume. The name of the docker volume is new data, where the source directory is present over here, where lib docker volumes new data underscore data, and the destination is present over here. Now in web3, if you remember, we made few changes, and now let us validate whether it is reflected in web4 or not. So for that we need to go inside web4. So for that we are going to run docker exec -it web4 /bin/bash. I'm inside web4. Let me go to /usr /share /nginx /html, and when I do ls, index.html is present. And now when I run a cat over here, you can see the data from web3 is present over here. How cool is that? Now what I will do, I will just clear the screen and I will add few more data over here. So echo new line from web 4. So this is just to demonstrate that whatever changes we are making across the container, that is been shared or not, right? Now we are outside the web 4 container. Let us go inside web 3 container this time. So we are looking for docker exec command, and I will go inside the container web 3. So I will run a cat command /usr share nginx html index.html, and here we have the line from web 4, right? So this was the demonstration for both type, that is bind and volume. Now you mentioned, you might be wondering that I mentioned earlier that data has been stored somewhere in docker volume. Where do I find it? So again, that can be again seen over here, docker volume ls. Here it is new data, and now let us inspect docker inspect new data. This is the place where the data has been stored. In this video, we demonstrated how the things work without docker volume and with the help of docker volume. Now let's say I want to delete that volume. How do I delete it? So first of all, let us list the docker volume, and now I will remove it. So docker volume rm, or it is docker rm followed by the volume name. Okay, 1 second, let me just get some water. Okay, so the command is straightforward. So for that, what I'll do, I'll just run docker volume -help. So this will give me the list of all the available commands. Here we are looking for rm. So the command that we wanted to execute is docker volume rm followed by the volume name, and here the name of volume is new data, deleted. And here we are getting one error, that is it is still in use, and that's the reason you are not able to delete it. Let me remove everything. So clear docker rm-f, and here I will pass docker rm docker ps-aq, and it will delete all the containers. Let me remove nginx image to docker rmi nginx. Okay, clear it, and now what I will do, I will remove the volume that we created. So docker volume rm new data, and when I do docker volume list, nothing is present, we are good. Now there is one more thing that I wanted to demonstrate so that your foundation is clear. Now this time we are going to do the same operation with the help of MySQL image, right? So before even that, let us understand how does MySQL works. So I'll open a new tab, docker hub MySQL, and here I'm searching for MySQL official image. So how does this thing work? Basically, whenever you want to run a MySQL image, it is expecting you to pass an environment variable, and that we specify with the help of -e command, -e option. Okay, so let's do the same. Let me pull MySQL first. So docker pull MySQL. Now since we didn't pass any tag, it took the latest tag by default. It is pulling the data from docker hub, and here whatever you are seeing, pull complete, download complete, and extracting, these are nothing but the image layers. Now what are image layers? That we have covered in the earlier video. So if you are directly jumping to this video, I will highly recommend you to watch the previous video, because that will give you the clarity of how things are working. Now you can see the image MySQL is pulled into my local host. So what I will do, I will run docker images, and here you can see MySQL latest is present. Now we have the blueprint this time, and now it's time to finally create the container. We are going to do the same operation, but this time with the database. So what we are going to do, we are going to create a container of MySQL with the help of the image that we just pulled, right? So here we are going to run docker run -d. I want to run MySQL into the background. Then I want to pass an environment variable. Now where do I find the environment variable? It is present in the documentation itself. So that is MySQL root password, and the password would be admin for now. And I want to call this container as database space nginx, not nginx, it's MySQL. Okay, so what is happening over here? We are going to run the image MySQL, we are going to create a container out of it. So for that, what we did, we are making use of docker run command. We passed -d because we want to run it into the background. We passed -e so that it is getting its credential, that is root password. We pass the admin password. We want to call that container as database. That's the reason we passed a database over here. And final thing is image. Now where did we get all the intel? We got it from the official documentation on Docker Hub from the MySQL image, and this MySQL image is the official Docker image that has been maintained by Docker Hub itself. Again, it shows there is 1 billion plus downloads and there are 10k plus stars in this specific repository. Okay, if you want to learn more about MySQL containers in Docker, I would highly recommend you to go through this documentation, right? So here again, whatever we are executing, all the options are being explained over here, so it would be very much easier for you to understand how things are working over here. Now let's go back and press enter. Now when I do docker ps, you can see MySQL container is up and running. Now what I want to do is, we are going to demonstrate the things with the help of Docker volume and without the help of Docker volume. So here, since we didn't mounted any directory, okay, here we are going to demonstrate what problems can occur when we are not utilizing Docker volume. So for that, I need to go inside the container. So let us go inside the container. So docker exec -it, I want an interactive terminal where I can interact with MySQL, and then I will pass the name of the container, that is database /bin/bash. Okay, now let me get some water. Okay, now since we are inside the container, now let us log into MySQL. So MySQL -u, and the user is root -p, the password that we passed. Just press enter. Here it is expecting for the password, and this is the same password that we are going to pass, admin. Enter. And here, ladies and gentlemen, you can see we are inside the MySQL console, and here we can literally fire all the commands that we want to that we can run in a database. So let us run show databases, and here you can see information schema is present, MySQL is present, performance schema is present, and sys is present. That comes by default with MySQL. Let us create one database. So create database followed by the database name. So this is new underscore db followed by a semicolon, and when I run show databases once again, this time you can see new db is present. Now if you are someone who don't know MySQL, go to the web browser, search MySQL W3C schools. It is a very good platform where you can learn about MySQL. Okay, now since we are creating a database, you can just search on the left hand side, and here you can see create database command is present, and whatever I executed, you can just take reference over here. Okay, now here it created a test db. Let's take the example itself. I'll fire the command create database test db, and now when I do show databases, you can see test db is present over here. Now considered we did a lot more work over here. We created the table, we added the signatures and everything, and again, due to some reason, some person executed docker rm-f followed by the container id, and when I do docker ps-a, the container is gone. It was stateless, meaning my data is gone forever, and now I have no means to recover it. So that's the bad practice, right? And that's the reason docker volume came into the picture. Now again, let us clear the screen and let us create one more directory where we would be mounting. I will perform bind mount over here. So I will create a new directory over here. So mkdir, and I will write database. Okay, and if I do ls, you can see database present over here. Now let us create a container once again. So docker run -d, and then I want to do the volume mount, that is -v, and that is present in /home/ubuntu ubuntu slash database, the folder that we just created, folder or directory, that is one and the same. And let me press over here. Okay, I will provide one colon over here because that's the syntax. Now where does MySQL stores its data? Go to the web browser and search for it. If you go to the MySQL documentation itself, if you scroll down, you will find the path where the data is present. Okay, I can show you actually. So you can find it over here. So this is the place where MySQL stores all the data. So let's copy entire path, that is where lib MySQL. Okay, so this is the place where we would be doing the volume mounting. Okay, here you will always get the documentation of what things are happening. Here again it is performing a volume mount. So here basically what it is doing, docker run, and it is calling the container as some MySQL. Here it is performing the volume mount, passing the environment variable and the SQL tag. We are doing the same. And then let me pass the path, that is where lib MySQL, followed by the name of the container, and here we are going to call it as db, just db. Okay, so docker run -d, and then we performed a volume mount. We are calling that container as db, and let me pass the environment variable. What is the environment variable? We are looking for MySQL root password, and I will pass MySQL root password. This time I will pass abc space followed by the container name, container image, that is MySQL. Enter. Docker ps. You can see the new container is up and running, that is of MySQL, created through MySQL image. Name of the container is db. It is running on port number 3306. That's the port number of MySQL, and it is up and running right now. And we performed a volume mount this time, so we are considering that even if this container is deleted, we have a backup ready. So let us go inside the container. So docker exec -it db, the name of container, but this time I will pass container id just to showcase it works the same, /bin/bash. Okay, now if I show you where the data is present, so basically if you can see it is present in where lib MySQL. Let us go inside that directory. So cd, we are inside where lib MySQL itself, and here we have all the data present, right? We mounted it to /database, and if you remember, it was the fresh directory that we created, meaning nothing was present over there, right? So let us go inside MySQL console. And how do we go inside it? So MySQL -u, the name of the user is root -p. And now one more thing, if you want to pass the password in single line, you can just directly write it, and the password that we shared this time was abc. So I will just write abc over here. Make sure there are no spaces over here. If you add a space, it will throw an error. Alongside, if you don't want to pass the password like this, you can just pass -p, press enter. It will prompt you for entering the password, then you can proceed with that. Let me just show you this way alongside, and here you can see MySQL console is up and running. Let me run show databases. Okay, and here you can see things are present. Let us take help of W3C schools, and I'll go over here and let us create a test db. Okay, so create database test db. If I run show databases once again, test db is present. Now we are going to create table inside test db, right? How do we do it? So first of all, we need to select this db, right? We need to tell SQL that we want to perform all the operation inside this database. So use test db, and the database pointer is changed to test db, and whatever tables creation command we would be executing, it would be under test db. Go back and here search for create table, and here you will get the syntax of create table, right? So what's there over here? Create table, table name, column 1, and data type. Then you are aware what sort of data type we have: integer, string, varchar. That's the thing that we can cover in MySQL. But for now, let us take everything that is present in this example. We are creating a table named persons, where we have person ID that is of type integer. We have the last name, first name, address, and city. All of them are of variable character type, right? When I do show tables, we have the data present over here and the table created is person. When I want to see the signature of this table, I will run desk persons and you can see everything present over here. Now let us go and search for insert type so that we can add a few data just to showcase you how does things work. So let me see in the left hand side. Okay, so this is the syntax: insert into table name followed by the columns and the values with the value that is present. So let us take the example of this one where we are referring to person ID. So what the command will look like: insert into, and the table that we created is persons. So insert into persons, and then the syntax says we need to pass the column name followed by the values. So let me pass the column name. So what we have person ID, then we have the last name, post that we have the first name, and then the address, and alongside we have the city. I'm showing you in very basic so that you can actually understand how things are working. And now let's follow the syntax. We have values and then we need to pass the values. Okay, values, and here we are passing the values. Now remember, whenever you're passing the values in MySQL, it should be in a sequence itself. So what is the person ID? The person ID is 1. Now since we are aware that the variable, the data type of person ID is int, I can directly write the number. Now let me write the last name. So I will write my last name itself, it would be Gour, and I will write the first name, it is Shubham. Then we have address, so it is India, and then we have one more thing, that is city. Okay, so I will write the city name too, let it be Hyderabad. Okay, everything is done, semicolon, entered. Now I want to see the entry that we just entered, so select star from persons, and this will list all the entries over here. And if you are someone who is finding it difficult, don't worry, refer this documentation. This is wonderful website. Even I refer it every time for understanding MySQL. This is one of the best website that you will find over the internet, right? So here we have one entry, exit from MySQL, and now let us go inside the directory where all the things are stored. So it is cd/where lib MySQL. So this is the place where all the data is been stored. Let me go outside this container, ls, let me go inside the database directory that we created, and here you can see all the things that we just saw inside the container is actually present over here. So by accident someone deletes that container, we have a backup over here. Docker ps, you can see the container is up and running. Now let us see whether will it be working fine or not. Let us delete the container, docker rm-f, and then let me delete the container named db. Let us create one more container, because here we just lost our container. We are already aware the nature of container, that it is stateless, meaning the data is gone if the container is deleted. But when we have the lifesaver, that is docker volume, we will have everything under control. All right, so let us recreate one more container. So docker run -d -e, I want to pass MySQL root password. So MySQL _root _password. This should be in caps, upper caps, and I will write admin as password this time. Space, I want to do a volume mount, that is from /home /ubuntu ubuntu/database. I hope the spelling is correct, database, database, space /where/lib/MySQL. This is the place where we would be storing everything, space, followed by the name of the container, and I want to call this as web wall, and I will write the name of image. So what we are doing, we are running, we are creating a container that we want to run into the background. For that, we will need an environment variable, that is MySQL root password, which we just passed. We created, we are binding it with a volume that we just created into a local, that is database. We passed the entire path, and then we are linking it with where lib MySQL. We are naming that container as webvol1, and finally we are passing the image name. Enter. Docker ps. The container is up and running. Let us go inside the container, and before even that, let us inspect the container. Docker inspect. The name of container is webvol. Okay, here let's go upwards and check the mount type. The mount type is bind. Here is the path, and it is destination is to where lib and MySQL. Clear the screen. Docker exec -it followed by the container name. What is the container name? It is webvol, and then we are going to pass the shell, that is /bin/bash. Enter. We are inside the container, and when I do ls, we need to go to where lib MySQL. So this should be the same as the thing that was present in database folder that we created in our host. Now let us go to the console by running the command mysql -u root -p, and this time we gave the password as admin. It is saying access denied for root user using password yes. Let me just check one more thing. What is the issue? Okay, so finally, after a lot of research, I found that you cannot change the password when you're mounting the Docker volume. So what actually happened, I was trying to log in with the new password that we entered. Basically, since we have mounted everything into a Docker volume, all the data along with the PEM files are stored over there. So that's the reason whenever we are doing the password, whenever we are recreating a container, it should be the same credential. So I again tried with the previous credential, and now I am inside the container. Now let's move forward, and I will just attach the screenshot of what was the actual issue. I tried to search it in Stack Overflow, I did ChatGPT, and finally I got the resolution, and here you can see it on the screen. Now let me run show databases over here, and here you can see we have testdb already present. Use testdb and let us see whether we have the person's data that we created. Show tables. Here we have the persons table, and let's do select star from persons, and again whatever we entered earlier is present over here, meaning the data is persisted and life is good. Okay, if I do ls over here, and if I go and do a cd against database, you can see every file is present over here, right? So that's the power of Docker volume, right? In this video we have literally seen many things. I think it's been 1 hour that we are doing this hands-on. The final thing is about Docker volumes. Let us do the same setup with Docker volume. So let's be fast this time. Docker ps, let us list all the running container. Docker ps docker rm-f. Let me delete this container, that is webvol, and everything is done. Now Docker images. Let us create a Docker volume for this MySQL DB. So Docker volume create, the volume name, it is DB data. This will be the volume. So Docker ls volume ls, Docker volume ls to list the volume. Here we have DB data present over here. Now let us create the container. So Docker run -d, and then I want to call it as new DB as the database, and I will pass the environment variable, that is MySQL _ root _ password, and that would be admin this time because we are creating a fresh DB. Space, we want to do a volume mounting, that is the volume that we just created, that is DB data, along with /where lib MySQL, space, the name of the image. Let us verify the same. Docker run, we want to run it into the background. We want to call it as new DB. We pass the environment variable. Here is the password, and then we did a volume mounting to where lib MySQL and the image name. Enter. docker ps, and here we can see the container is up and running. Let us run and inspect over here. Docker inspect, that is new db, the name of the container that we created. Here if you scroll up, we are interested in mount, and here you can see the type here is volume instead of point. The name of the volume is db data. The source where the data is stored is where lib docker volumes db data underscore data, where the data will be stored. Let me clear the screen. Let us go inside the container, docker exec -it, and the name of the container, that is new db, followed by /bin/bash, the shell that I want to use inside the container. Now we are inside the container. Let us log in with the creds mysql -u root and -p. The password is admin, and here we have the MySQL console. So show databases, and here we have the database. Let us create the db this time. Once again, let us take the reference of the documentation. So I'll go over here, create db, and I'll create a test db again this time. So let me just create test db2 this time for our reference. When I do show databases, we have both testdb and testdb2, but we are going to do the operation on testdb2 this time. So use testdb2. We selected and changed the pointer to testdb2. Let us create the table. And how do we create a table? So search for the documentation, mysql create table. Here we have the entire syntax. You can just exactly copy it, paste it over here, and now we have show tables. You can see the data present over here. Let us do the insert. How do we insert? So insert into the table name. What is the table name? That is persons. And where we want to put the data, so basically we have person id, we have first name, and we have last name. So we are just going to enter these details, and that's it. And then we are going to provide the values. So values, and what are the values? So the person id will be 1 because it is of integer type. Now let me write the last name, that is of variable character. So this will be gour, and I will pass my name to, that will be into first name, so Shubham. And again I'll close it and pass with it a semicolon. When I do select star from persons, we should have this data. Okay, now this time we didn't pass address and city. That's the reason we are getting null. If you are interested to learn more about MySQL, go to W3C schools. Very good resource. Everything is documented, mostly recommended. Just go for it. Now what I'm going to do, let me just exit from here. Let me exit from here too. This time we won't be dealing with the local directory. We are directly dealing with the docker volume that is present over here. So docker volume ls, and here you can see the volume db data is present. Now what I will do, I will delete the container that is currently running. Docker rm-f new db. Let me just delete this new db. The container is gone. Let us recreate the container. Docker run -d, then -- name. This time the name of the db will be db vol, okay, space -e with the environment variable. So mysql _root password. This is the environment variable that we have. I will pass the same password that we created earlier time, so that the previous time, so that we won't troubleshoot it once again. We know what actually is the cause, and that's the beauty of troubleshooting the issues, right? I went through the documentation, I went to ChatGPT, I went to multiple sources, and finally I am aware, like, if this sort of issues arises, what actually can be the issue and what resolution we can give. Space. Now I will write MySQL over here, but before even passing the image name, I will need to do a volume mount, that is by -v. What is the name of volume we created? That is db data. I will paste it over here, and I will map it to /var lib mysql enter. So docker run -d, name of the container will be db vol. We pass the environment variable with the same password. We created a volume that is db data, where the data of the previous db stored, and we mounted it to var lib mysql, and we are passing the image name. Enter. Docker ps, and here the container is up and running. When I do an inspect this time, docker inspect db wall. We are interested to mount section, and if I scroll upwards, here the type is volume, and here the name of the volume is db data. Here is the source where the data is stored and the destination which is present. Now if you don't want to go through the entire inspect, just run docker inspect db wall again, grep -ia, and I am interested in next 5 lines of mounts, enter. You will get entire data whatever is needed, right? So if you want to see the complete log, let's say the next coming 10 lines, it will give you the entire data over here. And here you can see the type is volume, the name of volume is db data, where it is stored, and what is the destination. Now everything is done. Now let us go inside the container. So for that, docker exec -it followed by the name of the container /bin/bash, enter. We are inside the container. Now let us log in through the CRED. Let us go to the MySQL console, MySQL-u, and the name of the user, that is root, and then -p, enter. Again the password admin, enter. We are inside the container. We are inside the MySQL console. Let us run show databases, and this time we should be able to see 2 databases that we created, that is testdb1 and testdb2. Let us use testdb, and here we need to verify the tables and the data entry that we did. So show tables, it should be persons, and here you can see persons is present. And then when I do select star from persons, we have all the data that we entered in the previous db which was deleted. How cool is that, right? I hope this video gave you the practical understanding of the importance of Docker volumes, right? Let us visualize everything, and we are going to do the summate of everything that we have done so far. So let me just do docker ps again, and let me remove everything, docker rm-f. We are clearing the environment for the coming tutorial, so it would be easier and we won't be messing up things. And clear. Now let me just list the docker volume ls, docker volume rm. I want to delete this volume, that is db data. This is how you delete the volume. Now we are good to go. Now let's go to Excalibur, and I will show you what did we did so far. Now let me create one more square over here. So this is our host machine. Okay, let me mark it as blue. Okay, and what we did, we created a volume. Okay, and here is the volume. So here we created a volume name db data, and then what we did, we created the container, and the container name here is, let me mark this db data with yellow, and this is the container. We created a new db named container where we mapped this db data directory with the new db. So whenever we were firing and we were operating on this container, all the data was getting stored in db data, and then whatever data was deleted with the previous container is been restored in the new db data, right? So this was the earlier container that we were working on, right? And due to some reason it got deleted, and then that's the reason we created a new db container where the data was stored with the help of the docker volume that we created, right? Let's summarize whatever we did so far. So for this specific demonstration, everything is documented into sub repository number 6, that is docker volumes. I will recommend you to go through the video once. In the second attempt, try to take the notes, and in the third one, try to do it with me, and in the fourth time, do it with yourself, so that you will have the complete clarity how does docker volume works. So let me take the revision that whatever we did so far. So here we actually did a practical demonstration on docker volume. Here we understood what actually docker volume is and how does we see it into the real world. So we understand about application. So application can be stateless and stateful. Okay, and then what is stateless? Stateless meaning data is persistent. Stateless is data is not persistent, and stateful is data is persistent. If the container is deleted, then the data is lost, and that's the reason Docker volume came into the picture. Here I have given the example for Nginx, where whatever we have done so far is listed over here. So here what we did, basically we did the operation with Nginx container, and once we delete the container, the data is lost after deletion. Same goes with MySQL. Then we came up with the solution called Docker volume, where basically we worked with two sort of volume types, that is bind volume and the second one is Docker volume, right? Then what is bind? It is volume type where actually you are binding your directory with the container directory. What is Docker volume? It is something that is being managed by Docker itself, which is stored in underscore data, right? We saw it into the practical, and then the data is been shared with the container. So the next time whenever the data is deleted, it can directly refer the Docker volume. We don't need to worry about the path. So everything is mentioned over here. Please go through the entire documentation. Even I have added the interview question, that is what is Docker volume, what is the difference between bind, mount and volume, what happens when the container is container data after deletion, how do you persist the data in MySQL container in Docker, and then how can multiple containers share the same value, right? With the help of this documentation, with the help of this diagrams, I believe Docker volume will be very much easier for you to understand. So yeah, that was all for today, and I will see you in the next one. Till then, keep learning, and thank you very much for watching this video, and I will see you in the next one. Now let's say you are running a container and then you want to debug some issues inside that container. Now you are basically introduced with two commands. First is docker exec and second is docker attach. Now which one to use, because running one of the command can literally kill your container, right? So in this video we are going to understand about docker exec and docker attach. This is one of the most important difference that you should be aware of, because if you use either of the command in production, this can literally kill the container in prod, right? So in order to avoid that specific scenario, it is very much important for you to understand the key difference between docker exec and docker attach, why we usually prefer docker exec over docker attach, right? So in this video we are going to understand the difference. Second, why we are considering docker exec over docker attach, right? Let's get started. So let's move with the problem statement. Okay, and the problem statement was that when a container is running, you want to debug some issues, you want to check the files, you want to run few commands, and like maybe you want to inspect the log. So here you need to give container a way so that you can interact. Okay, and with docker you can interact with two methods. First is docker exec and second is docker attach. Now let us first understand what is actually docker exec. So till now we have been executing the command docker exec -it followed by the container name, and then we provide the shell, right? And we are already aware what actually is -it, right? Interactive terminal, so that whenever we are inside the container, we can actually fire the commands that will give us a shell so that we can literally perform the operations, right? But what happens when we execute that command? Okay, so it will open a new terminal inside that container that will help us to run the commands, right? And it starts a new process, and that process is bash. If you remember, every time whenever we were running this command, we were providing the shell /bin/bash, and that's the reason it will start a new process. And then once you are inside the container, you can literally do anything, you can perform your operation, and that's it. So basically that is something that docker exec does. It will give you the power so that you can create a new process within that container so that you can fire the commands and go through the logs, right? So docker exec is equals to running a new command inside a running container. Now what exactly is docker attach? So in order to run docker attach, we have the command called docker attach followed by the container name. And what happens when you execute this command? So you connect directly to the main process, right? You can see the live output and you interact with the container directly. So docker attach is equals to, it connects to the container's main process. Now if I want to understand what is the difference between docker exec and docker attach, what exactly it is. So imagine that you want to go inside a room. Okay, now let's take the example for docker exec. Now let's say you want to go inside a room and you don't want to use the main door from which everyone is coming. So what a docker exec does, it will create a new door so that you can go inside the container, go inside the room, right? Now when it comes to docker attach, what it will do, you will basically use the main door itself to interact with the people inside the room, right? So that is actually the difference between docker exec and docker attach, right? I hope that made sense. Now let us cover the main difference, which is very important, between docker exec and docker attach. Now what docker exec does, it will start a new process. It will be safe because we are creating one more process on top of the current one, and then you can open multiple sessions and it won't affect the main container. So this is the main reason why we consider docker exec over attach, because it will not affect the main container process, right? Now when it comes to docker attach, so it will connect to the existing process, the main running process. It is very much risky because if you just press Ctrl C, you will literally give the container a signal that we are good to go, and now you can kill the container. Now if you accidentally exit, the container will stop, and there is only one main session which is running when it comes to docker attach. So that's the reason it is highly recommended for everyone to run docker exec, because it won't disturb the main process unless and until we did it from ourselves. But in docker attach, it will definitely disturb the main process. That's the reason we consider docker exec over attach. Now why docker exec is used in real life? So most of the engineers prefer docker exec because it is safe, it doesn't stop the container, that is the main process. It is easier for us for doing the debugging, and multiple user can connect at the same time. So with this docker exec command, you can check the file, you can do debugging, you can run the commands, and without affecting other user, you can perform the operation. And the main thing is you won't be disturbing the main running process. Okay, now we understood why we should consider docker exec. Now let us understand why docker attach is dangerous. So when you run docker attach command, you are connected to the main process. That's the exact reason why everyone avoid this. Now in order to understand this in a very good manner, let us take an example. Imagine that your website is running in production and you went inside the container with the help of docker attach command, and then suddenly you press Ctrl C to get out of the running container. Now what will happen? Your website will go down. That's the main reason we don't consider docker attach, right? Let's move forward. Now let us do the practical comparison between the commands. So basically we run docker exec -it followed by the container name and the shell. So what it will do, it will create a new shell, the app will keep running, and there won't be any risk. But when you run the command docker attach followed by the container, it will connect to the main process itself, and if you press Ctrl C accidentally to get out of the container, it will stop the container and we would be in trouble. That's the reason we should not use docker attach. Now when to use docker attach, right? So you should only use it when you want to see the live output, when you understand what actually you are doing, and you want to debug special scenarios. At that time only you should consider docker attach, but that can be done with the help of docker exec too. So that's the reason in real companies, basically we make use of docker exec for debugging, we make use of docker logs for monitoring, and we avoid attach in production because we don't want to take any chance to kill the container. Now let us summarize whatever we have learned so far. Docker exec is equals to creating a new command inside the container. It will create a new command line. Docker attach will connect you to the main process, and that's the reason we don't consider docker attach in the main point. Third is docker exec is safe and is widely used. Fourth, docker attach is risky and it's rarely used in special scenarios. So if we summarize the entire video, what we learned, so basically we should always prefer docker exec. Why? Because it don't disrupt the main running process. We create one more process on top of it so that we can just do the troubleshooting and then we can get out of the container. Instead, if we use docker attach and accidentally if we press Ctrl C, it will kill the container and we would be in trouble. I hope that made sense. So this was one of the most important topic that even is asked into the interview. What is the difference between docker exec and attach? So you can just tell the interviewer directly that we can consider docker exec over attach. Why? Because docker exec will create one more process on top of the main one so that we can perform the operation. Instead, what docker attach does, it will connect us directly to the main process, and that's the reason we avoid docker attach and we consider docker exec. So yeah, that was all in this video where we learned about the difference between docker exec and attach. We understood why it is very much important to understand and avoid docker attach, right? So that was all in this video, and I will see you in the next one. Till then, keep learning. Thank you very much. Okay, now that we are well versed with the difference between docker exec and docker attach, let us do the final hands-on, right? So in this video we are going to take an example of nginx image so that it would be easier for us to understand what is the actual behavior of docker exec and docker attach on the container, right? So let's get started. My machine is up and running. Let me clear the screen, and the first thing that we would be doing is let us pull the nginx image. So docker pull nginx. Now since the image was not present, it went to docker hub, it pulled the image, and now when I do docker images, you can see the image should be listed over here, and here is the image, that is nginx latest. Let me clear the screen, and if I run docker images once again, my image nginx latest is present over here. Okay, now let us take an example. Let's say that there is a building and there are two routes to go inside that building, right? One is the main door and second is the side door. So let us take the example of the side door, and you will understand the analogy this time, right? So what I will do, I have the blueprint. Now let me convert this blueprint into a running container, right? How do I run an image? So we are going to make use of docker run -d, since I want to run it into the background, and then I want to name the container as exec nginx. Okay, and then I will pass the image name, enter, and when I do docker ps, you can see the container exec nginx is up and running. Okay, now as I mentioned earlier, now let's consider there is a building where there are two paths so that you can enter into that building. First is the main door through which everyone goes, and second is the side door where only few people can go. So this is the example that will demonstrate the side door, so that whenever you go inside the container, the main door is not blocked. The people can come inside, they can do their work, but you can do a side entry. And how to do that we are going to do today. So for that, if I want to go inside a running container with the help of docker exec, I will run docker exec -it, as I want an interactive terminal, followed by the container name, that is exec nginx, and then I will provide the shell that I want to use. Enter. Now see, the first thing that happened over here is we created one more process on top of the running process that nginx is already running, so that we would be able to run commands like ls. Now if I take the analogy of that same building, now if I'm inside that building, I can go to any room, I can view all the records, literally I can do any operations, and then once everything is done, I can go out of that building by pressing exit. And when I do docker ps, my container is up and running. There is no harm to the building, right? Let me clear the screen and let us take the example of docker attach and observe the behavior of what it happens to the container, right? Let me create one more container for attach. So docker run -d -name, and this time the name of the container would be attach nginx, followed by the image name, enter. When I do docker ps, it will show me all the running container. Now here you can see there are two containers. We made the use of exec nginx, where I demonstrated you how you can go inside the container, do all the work that you want, and then you can exit from the container. By doing so, we didn't do any harm to the main process that was running, and we successfully came out from that container. Now let us see the behavior of attach over the new container that we created. So what is the attach command looks like? So docker attach followed by the container name, enter. Now you can see I am inside nginx container, but I am not able to do anything because the main process is actually running. So if I take the example of the same building, here I entered with the main gate where everyone was entering. Now if I try to exit from here, I won't be able to do anything. All I am left with is to press Ctrl+C. But what it will do, it will give a signal to the container that yes, your work is done and now we are good to go. Now when I do docker ps, my container is dead now. And when I do docker ps-a, you can see all the containers with the exit state. And here you can see the container that we created, that is attach nginx, is exited with error code 0, meaning it gave a signal that your work is done and now we are good to go, meaning the building got disrupted and the building is no more. Right now, that was the actual reason why we considered docker exec over docker attach. But let's say accidentally you go inside the container with the docker attach command, how would you come out? Let us perform the same. For that, let me take the example of this container, the running container. So I will run docker attach exec nginx. Now let's say I am inside this container and accidentally I executed docker attach command. Now without even pressing Ctrl C, is there any way to come out from this specific console? Yes, definitely. All you have to do is press Ctrl P along with Ctrl Q. Alright, so I got the issue. So basically why we were not able to exit out of that container is because during the runtime when we were creating the container, we didn't pass the flag that is -t, and that was the reason it was not allowing us to press P and Q. Now basically when we pass -t, it will give the container a virtual keyboard. So whenever I was pressing P and Q, it was not reading it. Now we need to pass -t so that it will act as a virtual keyboard. So whatever we are pressing, it will take it as an except sequence character, right? Let's do the hands-on. So let us create a new container for this demonstration. So docker run -itd. I want to run it into the background, and here the main option is T, because this will give the escape sequence character. So it will basically give the container a virtual keyboard. Whatever we are typing from the keyboard will be implemented in the container. Then -- name, and this time the name of the container would be attach engine and followed by the image name nginx. Now let us go inside this container with the help of attach command. Docker attach followed by the engine name followed by the container name, that is attach engine. And now you can see we are inside the container, but in the previous section when we tried to do it, we were not able to do because we didn't pass this flag. Now if I press Ctrl P and Q, you can see read escape sequence is present, and when I do docker ps, here you can see attach engine is up and running. Right, so this is something that I wanted to explain you, what is the demerit with the help of attach command, because whenever you execute it, it is not even considering the escape sequence character, because during the creation itself it is expecting us to provide the -t option, right? But again, this gives us the clear indication why to prefer docker exec over docker attach, right? So yeah, that was all in this demonstration. I just wanted to show you what are the problems that can come along with docker attach command and why we should consider docker exec every time. So 99% whenever you are dealing into production, you will definitely make use of docker exec command, right? That was all in this video, and I will see you in the next one. Till then, keep learning, and thank you very much. Alright, so now that we have covered multiple concepts, multiple topic about Docker, I want you to focus on the screen right now, because this is something that will help you to understand and visualize the next concept that we are up to. Right, today we are going to kickstart with Docker networking, but before even we move forward, let us first understand why we are learning that problem, and that's the reason today we are going to visualize how does things looks like. Now let us say that there is a person who is operating through his laptop, and here let's call him as a client. Okay, so yep, so what he does, basically he pushes a request into the internet. Let me just mark this one as like this, and this is internet. Now what he makes, basically he makes a call from his laptop to internet. Now let's consider we have our own server, which is over here. This is the server, and within this server we have Docker engine installed, and within that Docker engine we are playing with containers, right? So this is the server, and within that server we have the operating system, this we have already seen, operating system. And now what happens is, let me move it into the center, and above this operating system we have something called the Docker engine. So what this Docker engine does, basically Docker engine is responsible for creating the resources into the server. Basically it is responsible to create the container, it is responsible to manage the containers. And let us consider we have this container 1, and then we have again one more container, that is container 2. So far so good, everything was working fine. So whenever we were hosting anything, like let's say an Nginx application, right, what it is to do, basically we used to go over here, we used to get one IP, we used to map it with the port, and we were able to view the application, right? But the question lies, how does container 1 connects with container 2, whether container 1 is able to get the data of container 2, whether it is able to ping or not. How does container 2 connects with container 1, what are the rules that defines the connectivity. And let's say if someone from the internet, okay, let's say a client wants to view the data of container 2, or let's say if he wants to see the data of container 1, is it possible or not? Okay, so that is one thing. And secondly, what happens if the client want to see the data of container 1 that has been hosted, right? So what will happen basically? So basically from internet, that request will go to the operating system, it will go to NIC, and then it will reach to the engine. How will the internet, the client, identify that this request is supposed to send to container 1? Okay, how will it identify whether it will go to container 2? Let's say this application runs on port number 80, container 2 also runs on port number 80. How does Docker engine identify which one to share the request to? Okay, and again, if I want to create isolation between the containers within that system, how will I do that? Let's say this is something called container 3. Okay, and this is container 3, and I don't want these two container to connect with container 3, only the Docker engine should connect with container 3. How will I make it happen? How will I create complete isolation within container? How will I create the isolation from internet to the containers, right? How will this communication happens, right? What sort of networking options are available? All of these things we are going to cover in Docker networking. And yes, this is one of the important concept, because Docker networking will give you the clarity, will give you the vision, how does these problems are being solved, right? Because at the end, the main thing that happens is the container is up and we want to access, okay, the public want to access the container, but how we are going to make sure that it goes to the correct container, and how does port mapping works, how does networks are created, how it is managed, right? All those things we are going to cover in Docker networking section. This section was just to let you know the current existing problem, basically how does things are working, right? So this will just give you a pictorial representation of the problems, and in the coming video we are going to see what sort of options are available, what value will it add, right? So in this video we just are exploring how does things look like. So I will see you in the next one, where we are going to see the resolution, the answer provided by Docker with the help of networking. So yes, in the coming video let's discuss about Docker networking, types of networking, and what value does it adds. That was all in this video, and I will see you in the next one. Okay, so you run a container and your container is up and running, but when you go to the web browser, you hit to that IP with the correct port, you don't see anything. Why? Because the mapping is not correct. And how does that thing happen? How does this networking things works internally into Docker container? Let's understand the same with the help of Docker networking. So in this specific video we are going to learn what actually Docker networking is, what are the values does it add, what are the types of Docker network. So let's get started. So here we are talking about networking. So what is Docker networking? So Docker networking is nothing but it tells us the behavior, how does the container can communicate. The communication can be either one of the types, it can be container through internet, a container through host machine, or a container can connect to the other container. So these are something that will be resolved with the help of Docker networking. Now that we understand what actually Docker networking is, let's understand why do we actually need networking. So by default, we are already aware that the containers are isolated, meaning they don't automatically talk to each other and they do not expose services to the outside world. Okay, and in order to do that, we need to enable networking. So we need networking to access the application, connect the microservices, and enable the APIs to communicate. We already have seen the -p option when we were running the Nginx container, right? Remember, if you we were executing the command docker run -d for background, -p for port mapping. So that is something has been a part of networking, and here we are going to see it in depth. So what is the default behavior of networking when it comes to Docker? So basically, Docker will create a private network, a default bridge network. So in this case, your app is not accessible from the browser, but no port is exposed. So when you run docker run nginx, nothing will happen unless and until you will give the parameters the option. Then only it will start and display the application over the internet. So that's the reason port mapping comes into the picture, right? So if you run docker run -p 8080:80, what is the meaning of that? So what does this mean? So 8080 here stands for the host port, and port number 80, that stands for the container port. So whenever the container is running on port number 80, you can map it onto the another port which is available into your host. So whenever someone access the URL such as localhost :8080, it will be redirected to the port number 80 of the container, and that is how port mapping works in Docker. So now that we understand upon port mapping, we understood how does application are been showed into the internet. Let us understand about the types of network in Docker. So by default, Docker provide three sort of networks, that is bridge, host, and none. And out of that, bridge network comes by default. So there is no need for you to create an additional network, that will be considered by default. So let's first understand the default network, that is the bridge network. So bridge network is the network that comes by default, that is used for containers to talk to each other. It is isolated from the host, and it is one of the most commonly used network, right? You don't have to explicitly define. Second is host network. So host network is used when the containers want to connect with the host directly, so they don't need any isolation. This is faster, and it is used in only in special case, but mostly the only network that is utilized, that is the bridge network. And even we can create our custom bridge network, that is something that we are going to see in the following video. Third is none network. So what is none network? When we don't want any network connectivity for that container, which means we want to provide complete isolation at that specific place, we make use of none network, right? So basically this will provide no internet and no communication will be done from and within the containers, right? So and next is container to container connectivity. So let us understand, by default containers can communicate with the help of IP. So better way of doing this is you can make use of custom network. So how do you create a network? So as I mentioned earlier, by default the network that comes is the bridge network, and if you want to create your own network, that is you can make use of create network command, and what it will do, it will create a custom network for you. And then when you want two applications to connect with each other, to communicate with each other within the same network, you can make use of -hyphen network, and then your application will communicate with it. Let us understand this. So let's say here you created a new network named my network, and then you want two Nginx application, that is my network and app1 and app2, to connect with each other. So for that, what we did, we explicitly mentioned that the network that these two containers should use is my network, so that whenever you are doing a ping from app1 to app2, it will show the ping. But again, if you create another application but you don't mention -hyphen network over there, so what it will do, it won't consider that network, and that will be considered outside the network, and that's the reason the pinging will not work, meaning there won't be any communication with that third container with these two, right? So here app1 can talk to app2 using the name, and there won't be use of there won't be any need of IP, because you can directly ping them. So let's move forward. Why custom network are important? So without custom network, it will be hard to manage the IP. Communications will be very messy, and with the help of custom network, it is very easy for the discovery. You can make use of inspect command, you can fetch the IP. It is clean architecture and it is used in microservices. Now, let us take the recap of whatever we learned so far. So we learned about Docker networking and the concepts of container. How does containers communicate with each other? And then we talked about port mapping. How does port mapping works? We already saw the demonstration, but don't worry, we are going to cover it in the next module. Third is we talked about 3 network types in Docker, that is bridge, host, and none. Bridge network comes by default, host where we don't want any isolation, and third, it can be utilized when the container doesn't need when the container needs complete isolation, and fourth is custom network, which is best for communication. So yep, that was all in this video where we covered the theoretical part of networking. Trust me, you are going to learn everything in the hands-on. It would be very much easier for you to understand how does networking is working with Docker, right? So yeah, that was all in this video, and I will see you in the next one. Till then, keep learning, and thank you very much. Now that we are done with the theoretical part of Docker networking, let's move with the practical hands-on. We are already aware that there are 3 sort of network in Docker, that is bridge, host, and none. In this specific video, we are going to demonstrate the bridge network, that is the network that comes by default. Why do we need networking in Docker? Basically, whenever we want the containers to communicate with each other, we will make use of networking. So here I have already prepared a documentation on bridge network. So here you can see what actually is bridge network. So it is a network driver that comes by default with Docker. When I say by default, you don't even have to explicitly mention, and it will by default go into the bridge network. Okay, in this specific demonstration, we are going to make use of the default bridge network. We are going to create our own custom bridge network, and we are going to see what are the behavior change. How we can perform isolation with the help of networking, that is something we are going to see today in this hands-on. Now here let us see the overview of Docker bridge network. So it says that the bridge network is a network driver that comes by default with Docker, which is capable of the following. Okay, and these are the characteristics of the bridge network. So here it can provide the default CIDR block that is assigned automatically to the containers. Containers in the same bridge network can communicate with each other, and then containers can initiate outbound connection to the internet, meaning if you ping from within the container, you can ping google.com, right? And here bridge network does not accept inbound traffic from the internet by default, and bridge network is configured as NAT, that is network address translation. And bridge networks are private network, meaning if a container is present inside a bridge network, then another container which is not a part of this network cannot communicate with it. How do I prove it? We are going to create a scenario, and that will give you a picture how does things are working. Then containers in different bridge network cannot communicate with each other. That is something that we are going to see today. Docker host can communicate with each container in the bridge network, and it provides application isolation through network segmentation. All right, enough theory done. Let's directly jump to the console and let's do the hands-on. Okay, so let me connect to my EC2 instance. Okay. Okay, now I am inside my EC2 instance. Let me clear the screen. Okay, now since we are talking about network, let us first list what all networks are present in my device, in my system. So in order to list the networks, I will run docker network ls, and here you can see the 3 sort of network types, that is bridge, host, and network none is present. Okay, here when I say network, we are talking about the driver, that is bridge, host, and null. Okay, now when I say bridge network is the network that comes by default, so for that let me first inspect the bridge network. So docker network inspect followed by the network name, that is bridge. Now why we are inspecting that network? So basically it is just to find out how many containers are utilizing that network. Right now you can see there are no containers which are utilizing the bridge network. Let us create the scenario. Okay, so let me just show you what we are up to. So I will go to Excalibur, and here, so let's consider that this is the VM, this is the virtual machine that we have. Okay, and within that we will create this is the virtual machine, and here let me create a network that is, this will be the bridge network that comes by default. Okay, and let me just move it downwards. I'll add it later. So what I'll do, I'll just add one more thing over here, that is within that bridge network I will add two containers. This is container 1, this is container 2, and let me mark it as yellow, and this is the bridge network. Container 1, this is container 2. Okay, so right now the default behavior would be that container 1 will be able to connect to container 2, and container 2 will be able to communicate via container 1 with the help of IP. Why? Because both of them fall under the network called bridge network, and that comes by default. Okay, now the second scenario would be we are going to create our own bridge network, meaning there will be another level of isolation we would be doing. So what I will do, I will create one more network over here, and this would be that network, and we will name it as new net. So, and within that what we will do, we will create another container, and this would be container 3, and we will create one more container that would be container 4. Okay, and here again we are going to do two-way communication, that is from container 3 will ping container 4, and from container 4 we would be pinging container 3. And in this case the communication will work fine based on the theory that we have learned so far. And here the name of the network would be bridge network, that would be the driver that we would be using. So bridge network, and the name of the network would be new net NAT. Okay, so this is something that we are going to perform today. And apart from that, I mentioned that the network would be in the isolation. And how would we test that? So basically we are going to try one more thing, and that would be we are going to ping from container 3 to container 2, and we are going to see whether it happens or not. So that is something that we are going to demonstrate today. I hope you got the picture what we are about to. Now let's get things started. Okay, so right now you can see there are no containers running. So here I will make use of CentOS image. So I will pull the image right now. So CentOS would be docker pull CentOS :8. And since I know that CentOS is deprecated in Docker Hub, I made use of 8 tag. Okay, feel free to check out the Docker Hub documentation. Okay, now let me clear the screen, and if I run Docker images, you can see CentOS image is present over here. Now let me run the container. So docker run -itt -name, and I will name it as container 1. We are going to create the exact scenario. That's the reason I am writing the container name as it is, and then followed by the image name, that is CentOS :8. So this is the first container that we have created. Along with that, what I will do, I will create one more container, that is container number 2. When I do docker ps, you can see 2 containers are up and running. And when I do docker network ls, docker network ls, here you can see 3 networks are already present. We didn't created a new network, meaning in this case it is using the default bridge network. How do I validate that these containers are actually inside that bridge network? So basically I will need to just inspect the container, inspect the network. So docker network inspect followed by the network name. So docker network inspect followed by the network, that is bridge. Now here just make note of the container name, and here the container name is container 2 and container 1. When I press enter, you can see when we did inspect to bridge network, container 1 is present and container 2 is present over here along with their IP address. So The second workaround would be, let us ping container 1 from container 2. Let me clear the screen. When I do docker ps, it will show me the current running container. And now what I want is, I want to inspect these container and get the IP out of it. So what I will do, I will just get the IP of container 2. So docker inspect container 2, and what I want is the IP address. So I will run grep -ia. I want 4 lines of the IP address regardless of the letters, whether it is capital, whether it is in uppercase or in lowercase. So IP address, and here you can see I got the IP address of container 2. Let me go inside container 1 and let me try to ping container 2. So how do I go inside a running container? So basically we have something called docker exec -it followed by the container name, and here in this case it is container 1. And then what I will do, I will pass the shell through which I will be passing the commands. I am inside container 1 and let me just ping Google first. Ping -c3 and google.com. So here we demonstrated that the container can communicate with the internet, and now let us ping the container 2 from container 1. So ping -c3 followed by the IP address, and the IP address for container 2 is 172.17.0.3. When I press enter, you can see the communication is flowing. Now let me exit from here, and this time I will go inside container 2 and I will ping container 1. But before even we do that, I will need the IP address of container 1. How would we do that? Basically we are going to make use of docker inspect command, and here instead of container 2 I will pass container 1. We are making use of grep, and then finally we have the IP address of container 1. Okay, now what I will do, I will go inside container 2. How to go inside a running container? So we are going to make use of docker exec -it followed by container 1, that is the container name, followed by the shell that through which we are going to run the commands. I am inside container 1. Let me ping first Google. So ping -c3 and google.com. So here it is able to ping Google. Now let us run the same command, but here instead of google.com, let me pass the IP of container 1. And here you can see the container is responding, meaning the connection is flowing. Now what we did, so you can see right now we created 2 containers, that is container 1 and container 2, and through that we are able to communicate with each other. Now what we are going to do is, we are going to create a new network that would be of type bridge, and we are going to create container 3, and then we are going to try to connect container 3 with container 2. We are going to ping container 2 with container 3, and we are going to see what is the actual behavior of it. But before even we move forward, how do we create a new network? So clear the screen and type the command along with me. So docker network create followed by the network name, that would be new net, followed by -driver, and the driver name would be bridge. Okay, and when I do docker network ls, you can see the new net is present over here, and the driver type is of bridge. Now when I do docker inspect for this bridge, let us see what is the output that we have. So docker network inspect followed by the network name, that is new net. You can see here no containers are present. Yeah, you can see there are no containers present, and if I scroll up, you can see the name of the network is new net and the type of the driver that it is using is bridge. Now what we are going to do is, we are going to create container 3 that would be falling in this network, and we are going to ping container 3 with container 2 and 1, and let us observe the behavior and pattern. So let me clear the screen and let us create one more container from the CentOS 8 image. So docker run -itd -name, and the name would be container 3. Here, since we want to this container to fall into that specific new network that we created, we need to pass a special option, that is -network. and the network name that would be newnet space followed by the image through which we are going to create the container. So it would be CentOS 8 CentOS colon 8, enter. When I do docker ps, you can see container 3 is up and running, but let us inspect docker network, that is the new net that we created right now. So when I go back here, you can see container 1 container 3 falls over here, and this is the IP address of container 3. Now let me do the first thing. So, and that would be, let me go inside container 2 and ping container 3. Okay, so let me clear the screen first. I already have copied the IP address of container 3, that is 172.18.0.2. Control C, and let me just clear the screen. And here let me go inside container 2. So docker exec -it container 2 followed by /bin/bash, and now comes the interesting part, ping -c3 followed by the IP address. Now since it is into a new network, even though if it is of same driver, that is bridge, it won't be able to connect with it. Why? Because we created an isolation, and that's the reason it says that 3 packets transmitted, there is 0 packets which are received, and there is 100% packet loss, meaning container 2 tried to connect to container 3, but it didn't receive any response from it. And why? Because we created an isolation from it. Let me go out of the container 2 and let me just list the running containers first. And this time we are going to do the other way around. This time I'll go inside container 3 and I'm going to try to ping container 2 and container 1, but for that I will need the IP address. How will I get the IP? So basically I will run inspect command, docker inspect followed by container 2. I will get the IP of container 2 first. Grep -ia4 IP address. So this is the IP for container 2, and now this time I am going to go inside container 3, which is on different network, even though it is of bridge type. I'll go over here and now I will try to run ping -c3 followed by the IP address of container 2. Now since we tried to ping a container 3 from container 2, there was a packet loss. This time we are going to do the reverse, and again the result would be expected, and again there would be 100% packet loss. And as you can see, we are getting the packet loss over here. Why? Because we performed an isolation, we created a new network over here, and that's the reason it is not able to communicate with that container. Right now let us do one more thing. Let me exit from here and let me just create one more container within the new network that we created. How should we create a new container into that network that we created right now? So docker run -itd -name, the name of the container. So here it would be container 4, and I want it to fall into the new network that we created. That's why I'm passing -network, and the network name, that is newnet followed by the image name, that is CentOS 8 CentOS:8. Now what will happen? Let me first inspect the network and I will show you that these two containers, that is container 3 and 4, falls into the new network that we created. Docker network ls. Okay, and here I will just inspect it, docker network inspect followed by the network name, that is newnet, and here you can see both the containers are present over here, that is container 3 and container 4. Right now we have the IP of container 3 and container 4. Now what I will do, I will go inside container 4 and I will ping container 3 with container 4. So how will I do that? So I will make use of docker exec. So docker exec -it followed by container name, that is container 4/bin/bash, and here I am going to run the command ping -c3 followed by the IP address of container 3 which we just copied. And what is the IP address? It is 172.18.0.2. Enter. And here you can see the packets are been received. Why? Because they both fall into the same network. Let us do the other way around. Let me go inside container 3 this time, and I will need the IP address for the same. I will just change container 4 to container 3. I will run the command ping -c3, and here I will copy the IP address of container 4 this time. And what's the IP of container 4? That is 172.18.0.3. Control V, enter. And here you can see the communication is happening. But what will happen if I try to connect to container 1 or container 2? Let us do the same. So for that I will need the IP address of them. So let me first exit from here, clear the screen. I will run docker network inspect followed by the network name, and the network name here is bridge, BRIDGE, enter. And here I have the IP address of both container 1 and container 2. Let me go inside container 3 this time, and here let me ping -c3. I will ping container 2 this time, that is 172.17.0.3. Now since it is on different network, we won't be able to connect to it, right? And again, we performed isolation. We kept container 1 and 2 in one network, we kept container 3 and 4 in another, and that is the exact reason it is not able to perform communication, and that's the reason of 100% packet loss. I hope it made sense. Let me show you the diagram once again, whatever we performed so far. So here you can see we created a we were working with the default network earlier, that was the bridge network, okay? And then we tried to connect container 1 with container 2, and the ping was success. There was no packet loss. But when we created a new network named newnet and we tried to ping container 2 with container 3, we got 100% packet loss. But again, within that same network, we created another container 4. It was able to do the communication. Why? Because they both fall under secret, the new network that we created, right? So that's the reason bridge network is used for isolation of the network, right? Isolation from the containers. And due to that reason, container 2 cannot ping to container 3 and container 3 cannot ping to container 1 and vice versa. So yeah, that was all in this video, and I hope you got the practical idea how does networking in Docker actually works. So there is one more thing I wanted to share, that if I scroll down, you can see everything is mentioned over here. If you are someone who were making notes, you can definitely go out and check out the readme.md file. Along with that, there are a few key takeaways that you should consider. That is, containers do not have their own NIC. They use the NIC of Docker host. Network isolation is achieved through the namespace and routing rules, not the physical NICs. So only the containers on the same bridge network can communicate with each other by default. That is something we saw in this video. Along with that, we use of different bridge network to isolate the application and microservices. I hope that made sense. In this video, we literally covered a lot, and I believe with the help of this diagram, it made sense to you. So yeah, that was all in this video, and I will see you in the next one. Till then, keep learning, and thank you very much. Okay, so we just saw how does Docker bridge network works. So basically why we are making use of networking to do the isolation from one container to another. So we just saw how does bridge network behave. Now let us see how does host network behave. Now in order to understand host network, let me give you a very good example, and that will literally help you to understand how does host network work. So let's consider that if you are in a hotel, then you are making use of a bridge network. So let's say if someone wants to connect with you, what it will do, it will come to the hotel, it will go to the front desk, and here the front desk is the Docker, and then that front desk will tell you that you are staying in that room and that room is your container. But if that scenario is changed to your house, now let's consider if you are living in your own house and if your friend comes to meet you, he can directly reach out to you instead of a middleman person, that is the front desk, right? It can directly connect to you. So host network in Docker just works like the same. So let us go with the definition first. So the host network driver removes the network isolation between the Docker host and the Docker container. So when you use the host network mode, the container shares the host network, the namespace, and it does not get its own IP address. So basically when you create the container with the network driver as host, it won't allocate the own it won't give the virtual IP address, the private IP. It will take the IP of the host itself, and the container uses the host network interface directly. So what are the characteristics of host network? So basically the container shares the host network stack. No IP address will be assigned to the container. The container can bind to any port on the host, and no network isolation will be there between the host and the container. Till now what we were doing, we were providing the isolation because we were making use of the bridge network. Even though it was by default, it was providing some sort of isolation. If you remember, we were doing the port mapping every time. Here in this case, it will occupy the host port itself, right? So the next point is direct access to host network interface, and container processes are visible on the host network. Enough theory, let's do the hands-on directly. So I am inside my EC2 instance. Let me first list the network, docker network ls, and here you can see we have all the networks that we have created so far. Let me just inspect the host network. So how would we inspect a network? So docker network inspect followed by the name of the network, inspect, and the name of the network is host. Here you can see there are no containers present and there are no IP because it will directly connect with the host, right? Now what do I mean by that? Let me just clarify it. So let me make use of Nginx this time. Let me first check whether do I have the Nginx image or not, and here I have the Nginx image. So let us run a container. Okay, so docker run -d -p followed by port number 8080 from the host, and I want it to map with the container port that is 80 followed by the name of the image. And here I want to call this container as host ng, and here I will pass the image name that is nginx latest. Now what it will do, it will map my host port number 8080 with the container port 80. Okay, when I do docker ps, you can actually see port number 8080 has been mapped. Now if I go to my browser and if I go over my instances, I will need the public IP, and in the security group I will first need to check whether port number 8080 is be enabled or not. So I will just have to edit the inbound rule, and let me just edit the inbound rule over here. I'll go here and update the inbound rule, edit, and I will add one more custom TCP rule. Port number 8080 is mapped with my container port number 80, and now what I will need is the public IP. And if I go over here, I will just need the public IP when I open a new browser with http:// followed by the public IP and port number 8080. You can see welcome to Nginx is present. This is something that we have been looking so far, right? But here we are not occupying the host itself. Now what do I mean by that? I will go back again here, and this time what I will do, I will just run one more command, that is docker run -t, and I will name the container as Nginx, and here I want it to occupy the host network. So I will pass -network equals to host followed by the image name that is Nginx. Enter. Now when I do this, when I do docker ps, you can see the container is up and running. And what will happen if I inspect the host network? So docker network inspect host. Here you can see Nginx is present, but there is no IPs allocated to it. When we were inspecting the bridge network, there were IP address which were provided, but here it is consuming the host IP. Now what do I mean by that? So for that I will again go to browser, and this time I will copy the public IP and I will open a new browser, http://, and when I just press enter, you can see welcome to Nginx is present. We don't have to do the port mapping. Why? Because it consumed the host port number 80, and now when I create a new container and when I try to make use of port number 80 of the host, it won't allow me. Do you want to see that? Let's do it. So let us occupy port number 80 of the host while running a new container. So docker run -d-p. I want to occupy the host port 80 with the container port 80, and the name of the image is nginx. Let me call this as test. And when I execute this command, it will throw an error, and what it will say that the daemon, there is an error response from the daemon. It failed to set up the container networking. Why? Because driver failed programming external connectivity endpoint on test. Why? Because port number 80 is already in use. And that's the basic behavior of host driver when it comes to networking in Docker, right? So what it does, instead of creating an isolation, it uses the host port directly, and that's the reason we were not able to use the port once again. I hope this gave you a pictorial understanding of how does host network works in Docker. Now let us go back, and in subdirectory number 8 we have everything that we have performed so far. Right now we did the operation with nginx. You can perform the same with the help of httpd image. I want you to go through this entirely. Everything is documented over here, and at the last you will see that there are few key takeaways that I want you to go through it. So when you are working with host driver, there is no network isolation. The container shares the host network namespace completely, and that is occupied for sure. There is no IP assignment done, which we saw when we actually inspected the host driver. And here the containers are using the host network mode. They don't receive their own IP address, so there is directly port binding. Application in the container port can directly bind to the host port. And performance, so it is showing up slightly better network performance due to no network virtualization, because it is directly mapping it to the host port. Security, there is reduced network isolation and may possess security issues. That's the reason we usually prefer bridge network over the other two networks, that is bridge, that is host and none, right? And what can be the use case when we are using the host network? So basically it is useful for the application that needs direct access to the host network, and when maximum network performance is required. So that's basically all about host network driver. I hope you got the clarity. How does host network works, what are the values that is at, and why we consider bridge network over other networks, right? That was all in this video, and I will see you in the next one. Till then, keep learning. Thank you very much. So we are aware of the working of bridge and host network. Now let's talk about none, which sounds maybe useless for now, but it has good applications. Let's start with it. So what is Docker none network? So the Docker none network in Docker is a special network driver that completely isolates your container from any network. So basically you won't be able to communicate from any container. The only thing that will work is the local host, right? So when a container is attached to none network, it has no external network interface, meaning you are giving complete isolation to that container, and it can only connect with the loopback, that is localhost, that is 127.0.0.1. and we also know there is no place like localhost. Like this means that the container can not communicate with other containers, that is the host or the internet. That is something we are going to see today. So what can be the use case for none driver? So basically the main part would be security. You can make use of none network when you want to run untrusted code or application that should not have network access. You can make use of none network when you want offline processing, the tasks that don't require internet connectivity. It can be used for testing, for isolating components for testing purpose. It can be used for isolation, the compliance, that is it meets the security requirements that are prohibited for the network access. Enough theory, let's do the hands-on now. So I'll go to my terminal. Let me clear the screen. Let us list the network. Docker network ls, and here you can see we are talking about the none network, that is the driver null. Okay, now let me just inspect this. Docker network inspect followed by the network name, that is none. Now here you can see there is no IP, there are no containers which are associated with it. Let us create a new container and we are going to see what are the application of it, right? So it can be used for password generator, it can be used for a parser, and that can be one of the application of none network because it will provide complete isolation. So even if we try to connect from localhost, even if you try to ping from any other container, it will give 100% packet loss because there is no network which is available over there. Now let's do the application. Let me clear the screen over here and now let's make use of Alpine image. So I will pull the Alpine image from Docker Hub, Docker pull Alpine. Now since I didn't provided the tag, it will take the latest image from the Docker Hub, Docker images, and here you can see Alpine latest is present over here. Now let us see the practical application of none network. So let us create a container from it. And how do we create a container from a blueprint? So we make use of docker run command. So docker run -itd, we want to run it into the background. I want to name it as none container, or we can make it as ISO later for now, and then I want it to use the network called none. So network none, and then the practical use case, what I want it to take all the files from the current working directory. So I will write print working directory, and this should be mapped with the /files of Alpine image. So Alpine. And before even we run this command, I want to just 1 second, I'll just mark it as a comment. Clear. Right now if you can see, there are two things that are present over here. If I run tree, okay, you can see, okay, tree is not installed. Let me install tree, apt install tree. Okay, so okay, it is saying permission denied. All right. So what tree does, basically it will give you a graphical representation of what all things are present in your folders and subfolder, right? So this is a very useful tool and I frequently use it. So let me clear the screen, and when I run tree, you can see these are the files which are present over here. Now what I want, when I am working with none container, I want it to take all these file and process inside it. So what I'm going to do is I am going to run this command, and what this command does is we are going to run a Alpine image. Let me clear the screen first so that it is visible to you. So what we are doing over here, we are running the Alpine image and we are naming it as isolator. We are making use of network none, and we are mounting the volume. I hope you are aware with the concept of Docker volume. If not, go through the previous section, go through how does Docker volume works, and then come through this video. So we mounted a volume that is from the current working directory. It should mount to the files of Alpine image. When I press enter and when I do docker ps, you can see isolator is present over here. And now the next thing is, let me list the network again, docker network ls, and the main part is we mentioned that it won't be connecting with internet, it won't be communicating with the container. So that says that it won't have any IP. So let us verify the same. So docker inspect, docker network inspect, followed by the network name, that is none. And when I enter over here, you can see the isolator container is present, but there is no IP. And that's the reason it won't be able to connect with any of the container. Now let me go inside the container and validate the same. So when I go inside the container, so how can I go inside it? So I will make use of exec. I will pass -it followed by the container name, that is isolator, and followed by the shell, and make sure in Alpine it makes use of sh. So here I am inside sh shell, and let me first ping Google. So as per the theory, we know that it won't be able to connect with the internet. So that's the reason we are trying to perform the same, and this will give the demonstration that none network containers do not communicate with internet, and they do not communicate with any of the container. And here we have the output as bad address, meaning it tried to connect but it didn't got any output, meaning 100% packet loss. Okay, now if I go inside files, Now since we performed volume mounting, all the files are present over here. Okay, now also one more thing we saw that it can only connect with the loopback address, that is the local host, that is 127.0.0.1. Let us validate the same. So ping -c3, and that is localhost. When I press enter, you can see pinging is done because it is just pinging its own loopback address, right? And that was all about the demonstration of none network. I hope you understand the key difference between bridge, host and none, where none provide complete isolation to the container, and when host, it actually take overs the host ports, and when it comes to bridge, it provides isolation per network, right? That was the key difference between bridge, host and none. Now let us go back to the repository. Now, so whatever we did in this demonstration is already documented over here. Just go through it. I would recommend you to go through all the readme.md file because it will give you the complete picture of whatever we did so far. Now, once everything is done, don't forget to go through the key points because it contains few important notes that you should be aware of. So what are the key points over here? So containers on none network have no IP address assigned, that we just saw. So there won't be any communication possible with other containers or the host, that again we saw. Third is it can only communicate with the loopback address, that is 127.0.0.1, and still works for local communication. Third is volume mounts will still work, allowing the file access, and this is one of the most isolated network in Docker. Why? Because it doesn't allow communication to other containers and it gives complete isolation. I hope that made sense, and in this video you are complete clear about the network none. That was all in this video, and I will see you in the next one. Till then, keep learning and thank you very much. Now let's say you are asked to install a software, and that requires number of steps to install it perfectly. You are provided with a manual in which all the steps are written, and then you finally start to follow that manual. You start with step A, step B, and finally after 30 to 1 hour you are done with the application setup. But when you start the application, it crashes. And then finally, once you're done with the investigation, you find that some steps are missed, and that's the reason the application is not behaving as it used to be. Same happens with the development environment if you are doing the things manually, and that's where a Docker file comes into the picture. Now, what is a Docker file? Docker file is nothing but a file which consists of all the steps that were written in the manual into a programmatical file, which consists of instructions, commands and argument, that makes it very much easy to replicate the installation process every time in every environment wherever we need it. So let's understand what actually a Docker file is and why we should consider Docker file in the very first place. Let's get started and understand what actually is a Docker file. Okay, so let's start with Docker file, and before even we proceed forward, let us first understand what actually is a Docker file. So if I put this into a simpler term, Docker file is nothing but a recipe to create image. If you are someone who know how to cook, you definitely know how to create a Docker file, right? Because here we follow step-by-step instructions which are written into the Docker file, and that helps us to create the images, and finally we create a container out of it, right? So let's understand with the definition. So a Docker file is a text document containing the ordered instruction used to build a container image, right? As I mentioned earlier, if you're someone who knows how to cook, you follow a pattern for creating the dish. The same pattern has been followed here, but instead of cooking, here we are dealing with the application. So it automates the environment setup, including the operating system, the libraries and the code, ensuring that consistent operations of the application are being done, right? And hence it results into application deployment without any discrepancies, right? Now let us take an example that you ask your friend to install Node into your application and then run XYZ commands on it and then start the application. But due to some reason he forgets to run X command after installing Node. You will face issue and the application will not work as per the requirement, right? And that's where Docker file come into the picture, because here we are writing down each and everything as an instruction. Now Docker file consists of instruction, commands and arguments that makes us very much easier to understand what is actually happening behind the scene, right? So it's just like execution of the instruction line by line, and that is something that we call as a Docker file. Now we are going to understand how these instructions are written, but in this specific video we are focusing on what actually is Docker file and why we should consider it, right? So now that we are aware of what actually is a Docker file, now let's understand why do we consider Docker file in the very first place. So let's understand the problem first that Docker file is solving. So life without Docker file used to be like you need to install everything manually. If you forget the steps, the team will become inconsistent, and if something goes wrong, then you are someone who is to be blamed. So, and again, without Docker file, the classic sentence used to arise that it works on my machine, because everything used to be set up manually. Because as far as it comes to instruction, we try to follow with the given document, but by mistake, due to some human error, if we miss any of the instruction, that may create the trouble, and that creates the issue that it works on my machine. Now what happens when we deal with Docker file? So everything is written, steps are repeatable, anyone can build the same environment, so there is no guessing, no manual setup, no confusion, everything is done automatically, and with the help of Git you can even version control it. So that's the power of Docker file, and that's the reason we should consider Docker file in the very first place. Now how does Docker file work? So basically there are 3 steps that are involved in it. First is to write a Docker file, which defines what operating system to use, what to install, and what to run. These 3 things are mentioned in a Docker file. Second is to build an image from that Docker file. So Docker will read the Docker file and create an image through it. And finally, the third step, it's like creating the container based out of that image. So the simple flow would like Docker file will turn into an image, and then image, that blueprint will turn out to be a container. So that's the basic simple workflow of the Docker file, and that is how it works. So let us first take the example of a very basic Docker file. So here in the screen you can see we have 3 commands, that is from, run, and cmd. Don't worry, we are going to see this in the demonstration, and at that specific point we are going to explore it in very depth. So what we have from, so this defines the base image. It says that which base operating system to use. Second is run apt install. So these are the commands that we want to run inside that base image, so it will run the command inside that image. Third is once everything is done, like once the system is updated, once it installs the nginx, then the final thing that we need to run is nginx-g daemon off, and that's the default command that gets executed when the container is started. So that's a very basic Docker file that you are looking over here. Now let's understand what are the important Docker file instruction. First is from. So this is the very start point of any Docker file, because here we define the base image. So every Docker file will start with this. Second is run. So run is used to execute the commands during the build time. Third is copy. This will copy your files from the system to the container. Fourth is work directory. This will set the work directory, and it will tell that where to actually look for the files. Fifth is cmd. It is the default command that executes when the container is started. You don't have to worry about memorizing all of this, because everything will be learned through the documentation itself. So you just need to have a fair idea of what things is actually doing, right? So let's move forward, and here let's understand the real world use case. So in companies, developer writes the Docker file because they are the one who know how does the application work. The CI/CD builds the image automatically, and the image is then deployed to production. And why do companies love Docker file? Because the steps are reproducible. We can implement version control in it. It is easier for the deployment, and it works everywhere. So the flow would look like the developer will write the code. He will provide us with the Docker file. That Docker file will create an image, and then further it will be deployed. So that's the basic workflow looks like. Now that we have done so far about, now that we are now aware about the Docker file, let's take a recap. So Docker file is nothing but a file that consists of the instruction, the options, command, and argument. It is used to build the Docker images. It works like a recipe book. It eliminates the manual setup and ensures consistency, and that's the reason it is used in real world DevOps. I hope in this video you learned about how does a Docker file works like, and yeah, that was all, and I will see you in the next one. They'll keep learning, and thank you very much. Alright, so let's get started with the Docker file. In the previous video, we saw what actually is Docker file and why we should consider it. So in a nutshell, Docker file is nothing but a file which consists of set of instructions that are required to run an application, right? For this specific demonstration, I would recommend you to start with Visual Studio Code. And why? Because it will give you the clear IDE and it will help you to understand what each command, each instruction means. Right, let's get started. So before even I move forward, just wanted to tell you, for this specific demonstration you need to refer a subdirectory number 10, that is 10-docker file, where everything is documented, right? So for today's demonstration we are keeping everything light so that it would be very much easier for you to understand. So today what we are going to do, we are going to run the basic commands that we have been running so far, and that we are going to compare it with the Docker file. So it will be just like running the commands but with the help of Docker file, right? So let's get started. So what actually is Docker file? Docker file is something that contains the set of instruction. It's just like a recipe book which contains what needs to be installed, what needs to be executed, right? So here you can go with the documentation. So what actually is a Docker file? Docker file is something that is permanent, and what is Docker run that we were doing? It was something that is temporary, right? So what is Docker run? It is a single command which is hard to repeat, because if you want to create multiple containers out of it, right, so you have to pass the parameters again and again, right? So that's the reason it becomes hard to repeat. It is manual process. It's just like cooking something instantly. But when it comes to Docker file, it is a file that consists of step-by-step instruction. It has a process. Each thing can be controlled with the version control. So if something goes wrong, you can any which ways go to the point back where it was correct, and it can be automated. And finally, it's a recipe book that can be used by multiple chefs and they can cook their own dishes. Right, so let's move forward and understand about Docker file. So before even we move forward with it, let us run one basic command. So what do we have over here? We have docker run -d -p 8080:80 followed by nginx. What do this mean? So basically it is telling Docker to run a container with the help of the image name nginx. I want you to run it into the background. That's why we have provided -d, and we want to do port mapping with the host port 8080 along with the container port 80, meaning the application will run on port number 80, but we want to map it on port number 8080 so that whenever the user hits on port number 8080, he will be able to see the results. Let us take the SSH and view the result of it. So let me connect to my EC2 instance and I'll go over here. Okay, yes. All right, we are ready for the first demonstration. Let me first clear everything that we have. So docker rm-f, and what I want to do, I want to delete all the images. So docker ps-eq, and here everything is deleted. Alongside what I want to do, I want to delete all the images that are currently present to clear up the environment. So docker images-q, and here I will write docker rmi remove machine images, and let me remove -q from here, and this should be images. All right, all the images are now deleted. Let me clear the screen. Docker images, and here nothing is present. All right, so let us run the first command. And what do we have over here? We have docker run -d -p 8080:80 followed by nginx. So we are going to run the same. What it will do, it will first check whether the image is present in my local. If not, it will go to Docker Hub and it will pull the image from here. When I do docker ps, you can see the image up and running, and which image it is using. If I do docker images, you can see the nginx latest image is present over here. Now as per the expectation, what we want, basically when we view with port number 8080, we should be able to see the nginx welcome page. Let us go to the browser, and here I will need to go to the instances. I will copy the public IP. Here I will write http:// followed by the public IP along with port number 8080, and here we are getting nginx over here, right? So that is something that we did with the help of docker run command. Now let's do the same with the help of docker file, right? So as I mentioned, docker file is nothing but step-by-step instruction, right? So that is something that we are going to do today. So what I'll go over here, and here
First, I want to show it to you on Visual Studio Code. Make sure that the D is in uppercase, and here I'll write Docker file. So as I mentioned earlier, Docker file is nothing but a recipe book that consists of instructions, commands, and arguments, right? So here the first thing that we would be using is from. Now what actually is from? So here if you hover, you can see it is saying that the platform of the image if referencing a multi-platform image. So what it is used for? So from is actually used for telling the base image. It is used to set the base image for the instruction that we want to do. Now what do I mean by base image? Let's say your application runs on Python, right? So in that case your application, your base image is nothing but Python, right? So from must be the first instruction in a Docker file. That is something it is showing. When I press enter, it will give us the emit. Now here, since we are dealing with Nginx, I will write Nginx latest, and that will serve as a base image for me. Now if I want to write, one second, latest. Now if I want to write any comment over here, so it's just the same. You just have to write a slash, and here you can write all your comments over here. So here what we are doing, we are using official Nginx image as per the base image. Now the next thing is what we want to do. What we did over here, we took Nginx as a latest image, and then what we did, we actually exposed port number 80, and that's the reason we made use of expose. Now here if you write expose, it will give you the emit, and what does that emit says? Let us go with that. So let me write expose once again. Here what it is saying, it is saying to define the network port that the container will listen on the runtime. So here what we need, we want the application to run on port number 80. That's the basic thing that it is doing right now, right? Let me write a comment for it. So here expose port 80 for the incoming traffic to the Nginx server, right? Next is what we want to do, we want to run Nginx. And how do we run Nginx inside it? So basically you need to write the command cmd-g daemon off, and what it will do, it will basically run start Nginx in the foreground to keep the container running. Now everything is running. So what it will do, it will just create a binary image for you, right? Let me go to the console, and this time let me just create a new file. So vim docker file insert mode escape :wq, and before even I proceed with building the image, just make sure that there are no spaces below in between the codes, and there is a single space left after each colon, right? Enter. Let me just write over here escape :wq. The file is safe, and now let us build a new image. So docker build -t new ng dot. Why dot? Because that docker file is present in my current working directory. Now when I press enter, what it will do, it will create a docker image layer by layer, right? So the number of lines that are present over the docker file, it will increase the number of layers. Now here how many layers do we have? Here we will have only 3 layers because we have added only 3 lines: from, expose, and cmd. Now what about the comments? So the comments are ignored by default as per any programming language. Now when I do docker images, you can see we have new ng latest image present over here, right? So now let us execute the same image, but before even that, let me kill the current running container docker rm. And what I want to do, I want to stop the current container. So first of all, let me list docker rm. I will copy the container id. The container is stopped. Let me stop docker stop, and then docker rm. Okay, now there is nothing that is running on port number 8080. Let me clear the screen, and here we have the new image that is present over us with us. So what I want to do, basically I will run the same image again. So docker run -dp. I want to run it on port number 8080 along with the container that it is running on. Remember expose 80, so that is something that it is defining. Then followed by the image name, that is new ng latest. Now when I do docker ps, you can see the container is up and running, and when I go to the web browser and I will do Windows Shift R, and it will reload the page, and we are getting welcome to Nginx the page once again. Now this was something that we did on something that we were doing with the docker run command. But what if I want to change few things, right? Because we write docker file because we want to adapt based on our code. Right now it is something that we are using from docker file itself, from docker hub itself, right? We are pulling the nginx image, we are running something, and then we are getting the result. Now what if I have my own code base and I want to push that image into docker hub? How do I do it? So let me first clear everything. So docker stop, let me first list the container, docker stop followed by container id, docker rm followed by the id itself. Okay, it is successful. Now docker ps again to check whether something is present or not. Nothing is present. Let me clear the screen. All right, now let's say there is an index.html file that I want to host as a part of nginx, and then I want to push it to docker hub. How do I do it? So what I will do, I will first go to web browser and I will search for html boiler template. But since you are using Visual Studio Code, just create a new index.html file, index.html, and here I will write doc, and it will create a boilerplate for you. And here you can write few messages. So I will write one heading such as hello world, lorem 45, and here I will make use of format document. Okay, and here again I will make use of h1 hello world. So let's consider that is that this is a web page that we want to host. All right, so what I will do, I will go over here first and I will recreate index.html into my ec2 instance. So vim index.html, and here what I will do, into the insert mode I will copy this html file entirely and I will paste it. So now consider that this is the web page that I want to host. And secondly, what I will do, I will just remove the current docker file, rm docker file, and the file is removed. Now let us create a new docker file for this case. Now what will be the changes over here? Now if I go to the documentation, you can refer everything. So what we did actually in the previous one, we actually took a nginx image that was a ready-made web server that we had. We exposed port number 80 because the application runs on port 80, and then we made use of cmd that gave the image instruction to start the nginx. Now then we build the image and then we executed the image. Now since what we did, we created an index.html file. So step 1 is clear over here. Now what we are going to do is we are going to run it with the manual method. So what we are going to do over here is we are going to make use of docker run. We are going to do port mapping, and then if you remember, we made use of volume mounting, and here we are mounting the current volume with the index.html. And then if you run the same command, okay, now what's next step? So what I will do, I will again run nginx container, but this time what I will do, I will make use of volume mounting because I want to take all the files which are present in my local and I want to move it to the hosting place where nginx stores the index.html file, that is usr/nginx.html. So what I will do, I will run the command docker run -d-p. I want to run it into port number 8080. This is where the host port is getting mapped with the container port 80. I am mapping my current working directory with usr/share/nginx/html followed by the image name, enter. And when I do docker ps, you can see the current image is up and running and it is turned down to a container. Now if I go to the web browser and if I just do a refresh, you can see the content has been served over here. Now how can I perform the same with the help of docker file? So let me first stop the container. So docker stop container id, and I will remove it, docker rm followed by the container id. This will stop the container and it will remove the container. Now let us focus on writing the docker file. So for that I will go to Visual Studio Code once again and I am going to edit this file. So what we did, I will go back again here, and here what we are doing, basically we are running it into port number 80. So here we need to expose port number 80, that we already did. So what is the extra step that we have done? We did the volume mounting. So for that what we are doing, basically we need to copy the index.html file to to usr/share/nginx/html inside that folder, right? And that's the reason we made use of copy command over here. So let me just write a comment for it. So copy the index.html file from the current directory to the nginx.html directory. And in order to avoid the conflict, because every time whenever we are running nginx container, we get a welcome to nginx page, that is the default page that comes by nginx. In order to avoid that, we need to run a command to remove the default files that comes with nginx. And that's the reason we made use of run command. Now what run does, basically it will remove the default nginx html files, and it will be preventing us to delete the html file that comes by default, right? So that's the reason we make use of run command to run the commands inside the running container, right? So here we have everything. Let me copy everything and I'll go back and I will update my Docker file. So T is in caps, insert mode, escape:/wq, and now let us create an image out of it. So docker build -t new app dot, and it will build an image for us. When I do docker images, you can see clear. You can see the new app is present over here. Let us run a container. So docker run -d -p, we want to run it into port number 80 of the host space. And now this time I don't need to pass everything because we are directly running the container, followed by the image name, app latest, enter, docker ps, and here you can see the container is up and running. If I go to my browser and if I do Windows Shift R, you can see the page is actually up and running, and here the document is served. Now what if I want to push these changes to Docker Hub? How would I do it? So basically you need to log into Docker Hub. That is something that we are going to see in the upcoming lecture. There we are going to explore Docker Hub in detail. But for now, if you want to push any image from your local to Docker Hub, so basically you need to do tagging. What Docker tagging is, so basically it is just renaming your images. How do you do it? So basically docker tag followed by the current tag that is present and the tag that you want to provide. So here I will write my username, the Shubham gour, followed by a slash, and here I will write new -app, enter. And here if you see docker images, once again a new tag is present with the same SHA hash, and if I do docker push followed by the image that I just created, it will push the docker image from my local to my Docker Hub account. If I go over here and if I refresh my Docker Hub account, you can see the new nginx new image app is present over here. I can pull it from here and I can run it directly. So no need to do the things again and again. And if I share this nginx file, the image file with everyone, he can build the image, he can run it. Even if I share the Docker image, he would be able to run the container, right? So that was all in this video where we learned how you can write a Docker file. Here we came across with few keywords. Let us go through it once again. So if you go through the documentation, at the bottom you will find the Docker file instructions. Here we made use of from. Now what actually from is, from defines the base image for your container. It is always the starting point for any Docker file. So for example, here we made use of nginx latest, but in your case it can be Node, it can be Alpine, it can be Ubuntu, right? So think of it as a foundation of your software. Then workdir, it specifically defines inside the container where to work from. So it sets the working directory inside the container for running all the commands, right? It is exactly the place where we are running the cd command, right? So it's just telling where we are storing the files. Usually it is /app every time I have seen, but here it is optional. Then the next thing that we saw is copy command. What it does, basically it copies the files and directory from your local computer inside the container file system. So here it is doing nothing but it is doing the volume mounting, right? If you move forward, we made use of run command. What actually run does, it executes the commands inside the container during the build process. This is typically used to install the dependency or set up the environments. So here we made use of rm-rf because we are setting up the environment in order to avoid the conflicts of the default nginx file that comes by default. So that's the reason we made use of run command over here. So yeah, that was all in this video where we came across these 4 keywords. I want you to go and write the Docker file. It will give you the clarity how does things are working, right? So yeah, that was all in this video, and I will see you in the next one. Till then, keep learning, and thank you very much. All right, welcome back. So in the previous video, we learned what actually is a Docker file, what are instructions, what are commands, what are arguments, and we learned how we can write the first Docker file. And now it's time to step forward, and today we are going to cover 2 most important instructions, arguments, that is CMD and entry point, because this is something it is very important when it comes to interviews, right? So let us understand what is the differences between CMD and entry point, what are the application of each of the commands. So let's get started. So before even we move forward with the hands-on, just keep one thing in mind, that CMD is a default command that can be changed over the time, right? But when it comes to entry point, this command get appended. Now this is the theory that we have to keep in mind when we are doing the hands-on. So enough theory done, let's finally start with the hands-on. So let's get started with the differences between CMD and entry point. So here we go. Okay, so I am in my console, and now let me first clear my screen, and for demonstrating the same, let me first list whether I have anything. So let me first clear everything, rm-rf, and I don't want anything over the current place. When I do ls-ll, nothing is present. All right, so the ground is clear, everything is set up. Now let's get started and do the hands-on, right? So before even we see the differences, let us first understand each command. So right, so for that we need to write Docker file. In the previous video we actually saw how to we write a Docker file, and here we are going to see the applications, right? So let's start with CMD. So let me just create a Docker file. So Docker file, and here the first thing that I will be demonstrating would be for CMD. So here let us create a Docker file for CMD. So the first thing would be, I will be creating a very simple Docker file so that it would be easier for you to understand. So I will write from. Now what from does, it will define the base OS or base application that we would be using. Now since I want to demonstrate CMD and entry point, for this specific demonstration Ubuntu would be the best base image for this case. So I will write Ubuntu and UPUNTU Ubuntu, and here the main command that we would be using would be CMD space, and here we would be writing the command, so square brackets, and here we would need to pass the commands. Now how do we print anything into Linux? So we write echo followed by the messages, right? So the same thing we are going to do here. So here I will write echo. So this is the command that we need to pass, comma, make sure that you are adding one space, and then write the message that you want to print. So here I will write hello from CMD, and here I will do escape :wq because my Docker file is ready. When I do a cat over the Docker file, here you can see the Docker file is ready. All right, now since the Docker file is ready, it's time to create the image out of it, the blueprint, and then we are going to run the container. Let's do it. So I will write docker build -t, and here let me write the image name as cmd-demo. Now since the Docker file is present in my current working directory, I will add a dot over here and I press enter. What it will do, it will create an image from that specific Docker file, and when I do docker images, you will see the CMD demo latest file is present, the image is created. Now let us run it. And what is the expected output? So when we run that specific Docker image, and when it converts into a container, it should print a message that we wrote inside the Docker file. And what message do we actually wrote inside the Docker file? It is hello from CMD. Let us run that image. So for running that image, we just need to write docker run followed by the image name, and the image name is cmd-demo, enter. And here you can see we got the message hello from CMD. So it is very much easier. Now let us try to override this specific output. How do we do it? So when we are running the image, when we are converting it to a container, we will pass one more command, and here I will write hi another, enter, and this time you can see the output got changed, meaning the commands can be override when it comes to CMD, right? Now let us see what will happen, what would be the behavior when it comes to entry point. right? Let me first clear the screen, and here I will create one more Docker file over here. So let me just create a new Docker file over here. So vim new -docker file. Now here I know you will be saying that how can I write new Docker file as the name of the Docker file? So for that we are going to use one more flag, that is -f, that will give us the clarity that if you have multiple Docker file to test, how do you pass it, right? So I will just create a new Docker file. The base thing would be the same, that is Ubuntu ubuntu, and here I will use ENTRYPOINT. Now again we are going to make use of echo command, so square brackets open and close. Here I will write echo comma one more space, and here I will write hello from ENTRYPOINT, and the file is ready. When I do escape:wq, the Docker file, that is the new Docker file, is actually ready. Let us build image from this Docker file. Now you already know that in order to build any image out of a Docker file, the nomenclature should be the capital D, but here we created our own custom Docker file. How do we create a image out of a custom Docker file? So here we are going to pass -f flag. So docker build -t for the tag name. Here I will write ENTRYPOINT -demo. This would be the name of the image that we would be creating, that we are interested in, and then I will pass -f, and it will mention that new -docker file is the file that you should take as a reference while creating the Docker image, and I will press dot because that file is present in my current press, right? And I will press enter, and here it is building an image. When I clear the screen, when I do docker images, you can see ENTRYPOINT demo latest is created. Now what will happen when we run this file, right? Because in the ENTRYPOINT, if you see, when I do a cat over here, it should print hello from ENTRYPOINT. So let us do the same. So docker run followed by ENTRYPOINT demo, enter, and here you can see ENTRYPOINT is printed over here. Now let us try to override this Docker image. So how do we do it? We are going to do the same. Here we are going to pass echo command followed by the new message. So try overwrite, enter. Now if you see the behavior between cmd and this command, you can see when we executed the same with cmd, it replaced the entire output, but when it came to ENTRYPOINT, it actually appended the output. So that is the difference between cmd and ENTRYPOINT. So ENTRYPOINT is fixed over here, but it appended the output, right? So I hope it made clear the difference between cmd and ENTRYPOINT. Let me rerun the same command once again so that you can see the output parallelly. So here I will run the command docker run followed by cmd demo, and I am going to try override over here. Now what will happen? The expected output would be try override, because here it didn't printed the default message that was written in the Docker file. It replaced the entire output, right, with the current that we provided. But when it came to ENTRYPOINT, it actually appended it. So cmd will replace the entire output, but when it comes to ENTRYPOINT, it will append the output, right? Now there must be one more question. Now what if in a Docker file we use both ENTRYPOINT and cmd? What would be the behavior? Let us create the same. So for that I will create another Docker file. So here I will write as combo would be the name of the Docker file, and enter. And here I will write the base image, that is Ubuntu Ubuntu, and here what I will do, I will define the ENTRYPOINT. So ENTRYPOINT, and here in the ENTRYPOINT I will pass the echo command. So here we are using ENTRYPOINT plus cmd together. Here we are demonstrating what will happen if we use both cmd and ENTRYPOINT together. So here I will write cmd, and what I want to print. So basically here I am assuming that ENTRYPOINT echo would be taken as a command, and whatever we pass into the cmd, that would be taken as an argument. So here the argument would be hello from combo file, and when I do escape:wq, let us build an image out of it. So docker build -t, here I will write combo-demo, and I will pass the file name as combo, and the file is present in the current working space. That's the reason I'm passing dot enter, it will create a new Docker file. And let me just validate it, clear the screen, and here I will write Docker images. Okay, now here you can see combo latest is present over here. Let us run the file docker run combo demo. Now here you can see what is the message over here. Let me first do a cat on the combo file. What it did, basically it printed hello from combo file. It took echo as the command and it passed cmd as the argument. Now what will happen if I try to append it with some another command, right? If I write let's say instead of this hello from combo file, I want to write hi Shubham. What is the expected output over here? Enter. Here you can see hello from combo file got entirely replaced with the message that I printed after the run command, right? So that is the behavior of entry point and cmd when it works together in a docker file. What is the conclusion out of it? So basically cmd gets replaced completely, whereas when it comes to entry point, it only accepts the argument. So yeah, that was all in this video where we learned about cmd and entry point. We learned about the differences, how do they work independently and how do they work when they are together, right? That was all in this video, and I will see you in the next one. Till then, keep learning and thank you very much. You might have observed when you are building an image, it takes some time the very first time, but again if you build that image, it will build instantly. How does this happen? So it happens all because of Docker layer and caching. In this video, we are going to understand what actually Docker layers and caching are, right? Because if you understand these concepts, it will help you to fasten your builds and it will make your build smoother, right? So let's first discuss about Docker layer. What actually is a Docker layer? Now, as I mentioned earlier, whenever you are dealing with a Docker image, you are directly dealing with the Docker layers, right? Because every instruction in a Docker file is creating a new layer on top of it. Now let us visualize the same. Let's take it that you have a burger. How a burger is prepared? You have a bun at the bottom, then you add some cheese, you add some veggies, you add some noodles, you add everything, and finally you stack it, and then finally your burger is ready, right? Same goes with the Docker image, right? You add multiple layer of instructions, and finally when you stack all the instruction in the Docker file, your Docker image is ready. And that's the reason it is said when you are dealing with Docker image, you are directly or indirectly you are working with the Docker layers. Let us take an example to demonstrate how does Docker layer works. Here we are going to write a very basic Docker file which will help us to understand why it takes some time to build the Docker image the very first time and how it happens instantly the very second time. So let's do the hands-on. Okay, so let's do the hands-on on Docker layers. So I will be creating a very basic Docker file that will give you the clarity how does layer and caching works in Docker, right? So for that I will create a new Docker file, and yeah, just want to give you an heads up that I am on my MacBook terminal. Feel free to run these commands into your EC2 instance, it will work the same, right? So let's get started. I will write vim docker file, and here I will be using a very base image, and that would be for Ubuntu. I want to run few commands, and remember each instruction in a Docker file will turn out to be a layer, right? So the base layer is here is the Ubuntu, then another layer would be run apt update, so second layer. The third layer would be to install nginx, so apt install -y nginx. So this is the third layer, and the fourth layer, let's copy anything from my current working directory to the /app. That would be the folder into the container. So that's it. And finally, if you want to add anything, but right now these are the 4 instructions that I am interested in. Escape :wq. If I do a cat on Docker file, I want to show you that there are only 4 lines which are present over here, meaning there will be only 4 layers that we would be dealing with in this Docker image. Now let's build a Docker image out of it. So docker build -t new app1 dot. Now here just see how much time is it taking, because we are going to run this same command, but we are just going to change the tag the second time and see how immediate it will show the results. Now here you can see I mentioned that each instruction in a Docker file will turn out to be a layer. So here you can see step 1 of 4. Now what it is doing, it is pulling the Ubuntu base OS image. Now here you can see the second layer is working, it is into the picture, it updated the system. Now the third layer, that is apt install nginx, and the fourth layer, it copied everything. And finally, if I show you Docker images, our image should be listed over here, and here we have new app 1, right? If I scroll to the top, it took 31.1 second. But what will happen if I clear the screen, if I rerun the command, if I change app 1 to app 2, how much time will it take, right? Earlier it took 31.1 second. If I press enter, this time let us wait, it only took 1.5 second. That's the help of Docker layer and Docker caching. Now how does thing worked over here? In the previous build, it collected all the layers, but in this build it took the cached layer, and that's the reason it built it fast. Now let us understand how does caching work after this demonstration. But for this specific demonstration, this final image is basically a combination of all the layers, and in the previous image that we created, it actually pulled all the resources, it gathered into one place, and then it created an image for us. And in this case, all the things were referenced. So that's the difference between Docker layer and Docker caches. Now what layer gives us? Basically it gives us faster build, it gives us reusability, it gives us efficiency, and it gives us the flexibility to give the smaller updates. Now what will happen if I just make a smaller tweak into the Docker file? If I just remove the copy command, the copy instruction from here, and if I just write cmd and I'll type over here echo comma hi. So let's say I want to print hi, and here I made the change in the fourth instruction. And now if I build the third image, how much time will it take? So see, the thing is, here we only made change to the third instruction, right? And what it is, basically it is printing something, but it only took 1.2 seconds because cmd is a command that will be executed inside the container, right? It is not an operational change. But let's say if I go again inside the Docker file, and here let's say if I just make change over here, after nginx I run one more command, that is apt install -y tree escape :wq. Now this image will consist of 5 layers. If I just build the image again, let's note the time. See, it took the reference from the previous 2 builds, and here you can see it is a cache layer, then it installed tree over here, and finally the image is ready for us. And hence it proves that Docker works on layering and caching, and it reduces the build time by taking reference of the previous build, and that's the reason caching come into the picture. Let's discuss about caching now. Okay, so now let's discuss about Docker cache. Now what actually is Docker cache? So Docker cache is nothing but save layers from the previous builds, and when it comes handy, basically let's imagine that you wrote a Docker file and there are 4 instructions in it, and you built an image out of it. So the very first time it will take some time, right? But when you rebuild the same image from that same Docker file without even changing anything, it will be done instantly. Why? Because Docker cache will check for 2 things. Is the Docker file changed? If yes, it will rebuild from that specific instruction, but if not, it will reuse the previous layer and then it will build the image, right? And that is how it is reducing the build time. That's the reason Docker cache is very much helpful, and it reduces the build time. So that's the reason it is very much important for us to understand the concepts of Docker layers and Docker cache, right? Now in order to understand this completely, let us take an example of a node application, right? Now if you're dealing with node application, you might be aware that when you run npm install, it installs all the dependencies which are mentioned in package.json, and it puts it into node underscore modules. Now let's take a bad example. you did npm install, it took the reference from package json, node underscore module folder is created with all the dependencies which are present in the docker file. You are copying entire node underscore module folder. Then you are again writing a step, an instruction to run npm install. So when you run npm install, what will happen? It will refer package json and it will install all the dependencies. But let's say there are no changes present at that time, why we are rebuilding it once again, right? That's the reason the best practice is you just need to copy package json and then run npm install. Now what will happen if there are any changes into the dependencies? It will be reflected into package json and we won't be changing the entire setup, right? That's the reason it is recommended to not to copy the entire directory. Instead, just copy package json and then run npm install. This will definitely reduce the build time because we are not changing the package json dependency frequently, right? Let us take a demonstration and hands-on that it will clear how does docker cache works, and it will give you the clarity how does things work behind the hood, right? So let's get started with the hands-on of docker cache. Alright, so let's take an example for Docker caching. So here I have a very basic node application, and here you can see the main important thing that we have is the package JSON, right? We are going to see a very bad example right now, because that by doing the bad example you will understand what things to actually avoid, right? So let's take the example. Now let's say I'm creating a new Docker file, and what usually we do is we define the base OS. So here from the base OS would be node 18. I would be making use of node 18 image, and here I will define my working directory inside the container, right? And that would be /app. And then let's say if I want to copy all the code to the container, I will make use of copy ... and the final thing that we would be doing is cmd, and here I'll pass the command that I would be running inside it. So here it goes. Here app.js, and here it would be node escape:\wq. Now why this is a very bad example? Because what it does, here we made use of the base OS, that is node 18, then we defined the working directory within the container, that is /app. Now here is the mistake in the third layer, the third instruction, that is copy. Because what we are doing is we are going to copy all the things which are present over here inside the container, and here we missed one more thing, and that is after copying you are running the command run npm install escape:\wq. What it does basically, now it will so what it will do, it will copy all the files and folder into the container, and then it will run npm install, and based on all the changes which are mentioned in package json, all the dependency, it will run the changes fine for the very first time. But the actual issue here is, let's say if there are changes into the readme.md file, again it will trigger a build. Let's say if there is a comment that is added, again it will trigger a build. So that is a very bad practice that we should avoid. Now here what if I will have to do in order to create an image out of this docker file? So docker build -t node bad dot. Now what it will do, it will refer the docker image, it will refer the docker file, and that it will run the multiple instructions that are mentioned over here. But again the catch is we should avoid this practice, because we are copying entire thing that we shouldn't do, because the only thing that we should be worrying about should be the package JSON file, because that is the file where all the dependencies are mentioned, right? And then we should copy all the things. So let us create an optimized docker file that will do the job for us, because here what is happening, it will increase the build time again and again, and it will unnecessarily occupy our time, and that is not a standard practice, not a good practice. Now in order to avoid that, we would be doing one best thing, that is we would be just copying the package JSON file. We are going to run npm install, and later we are going to copy all the code files. Now what it does, it will actually reduce the build time. Second, we won't be triggering the build again and again. Let us wait for some time for the build to get complete, and here it is dealing with multiple layers. Now since it is a very first build that we are dealing with, it will take some time, so let us wait. And then one more thing that we should practice is, let us create one more image out of it and check the time the build is been taking for the second image, right? So here we are going to check two things. First, we are going to rerun the command, the build command, and check how much time it is taking. the second time. So here it would be demonstrating the Docker cache, and second we are going to make changes in the Docker file exactly, and then we are going to see how does things behave, right? So here it actually took 93.7 seconds. Now let us rebuild one more image out of it. So docker bad1. Now here let us wait. Here it only took 0.8 second, right? So here we demonstrated Docker cache once again. Now let us make the changes into the Docker file and make it a better one and optimized one. But here instead of just copying everything, I will write package.json, spelling, yeah, package.json to the current folder, or here you can even copy it into /app. So I'll just copy it into the current path where it would be present. Then we are going to run npm install, and then we are going to copy whatever is present in the current working directory inside the container. Now it will copy all the configs, all the coding file, and then it would be optimized for us. Let us build one more image out of it, and here I will write node new dot, and let us wait and see the results. So what it will do, it will just install package.json dependencies, and then it will copy all the files. Here we are optimizing the Docker file, and here we are reducing the build time, and here you can see the build time only took 11.3 seconds, right? Now what will happen if I rebuild the new node image once again? It will just take few seconds, and here it took 2.6 seconds, right? So that's the reason it's a standard practice to not to copy all the coding file inside it. Let me just run a cat over here. Yep, so here it is standard practice not to copy everything, just copy package.json first, install the dependency, then copy all the code files, right? So yeah, that was all in this video where we learned about Docker cache and Docker layers. I hope it made sense with the practical, and I will see you in the next one where we are going to do a deep diver into Docker file, right? So that was all, and I will see you in the next one. Okay, so let's talk about .docker ignore and build context. So if you're someone who knows how does Git works properly, you might be aware of .git ignore. So how does .git ignore works? So basically, if you add anything, any file, any folder in .git ignore, okay, it will be not added into commit, it won't be pushed to your GitHub repository. Same goes with .docker ignore. Whatever files you add, it won't be added into the build layer, right? So that is the basic uses of .docker ignore. Now what is build context? So from the starting itself, we have been using this command docker build -t, then followed by the tag name, we add a dot, and as I mentioned earlier, dot represent the current working directory, and that is nothing but the build context. If you go with the official definition, what is build context? So basically, build context is the set of files that Docker sends to the Docker daemon for building an image. It's everything in the directory where you run docker build command, right? So how does this work? So when you run docker build -t my app dot, the dot at the end specifies that the current working directory as the build context, and it will share all the files with Docker daemon, right? So what will happen? It will package all the files in the current working directory and subdirectories, and it will send it to Docker daemon, and then this will be used to build the Docker file, the Docker image from the Docker file, right? So how does build context matter? Why? Because due to that context, it takes time to build the image. So larger the context, lower the build, and more network traffic will be there. There will be unnecessary files that will be playing around in the picture if we don't set the build context, if we don't correct the build context. And that's the reason docker ignore and build context play at the same level. If you add unnecessary files which are not even needed during the build time in the docker ignore, it will fasten your build time, and that's the reason both goes parallelly along together. So what is docker ignore file? So it is a file that works just like git ignore, but for Docker builds. It tells Docker which files and directory to exclude for the build. Okay, and let's take an example that it will give you a complete clarity how does docker ignore works and how does the build context work. So we are going to create a basic node application, and again we don't have to worry about coding right now because here we are present to learn about build context and docker ignore. So search for geeks for geeks, and here we would be referring this site. I will be adding this into the comment, or I will add it into the GitHub repository. Here you can refer this documentation for today's demonstration. So what we are going to do, basically we are going to create an application with npm init, and we are going to install the module. So basically this would be just a basic application that we would be hosting. It would be printing a message over the console into the web browser. So let's get started. So let us follow the documentation, and whatever it says, let us do it. So we are going to create a directory name my node app, then we are inside the node application, and then we are running the command npm init -y. So what actually it is doing, it is actually creating all the necessary files which are actually needed to initialize the node based application. And when I do ls-ll, you can see we have package.json. If I just read this package.json, you can see we have a very basic node application present over here with no test cases, right? If I clear everything, let's move forward, and here we are going to install the modules that are required for this specific application. This would be a very simple demonstration. We are going to pick up very small applications so that it will give us the idea how does things are working, right? So we will install fs, file system, for handling the file operation, and path for working with the file operations. All right, done. So npm install fs, and we are going to install npm install path. We can just run it in a single one, and it is done. If I just run a cat on package.json this time, you can see it added more packages here. Let me clear the screen, and there is one more file which is present right now, that is package log.json. If I do a cat over here, okay, if I do a cat on package log.json, you can see everything is present over here. Don't need to worry about that, because we are not concerned right now on what is inside package log.json and what's inside package.json. Okay, now let me move forward, and here we are going to create one file named index.js. okay, vim index.js, copy this file entirely, paste it, and save it by pressing escape:\wq. And I know you all are very much aware of how to use vim editor or vi editor, right? And final thing, we are going to create a message text file to print the message. So vim message.txt, and here this is the message that we are going to print, escape:\wq. all right, and here in order to run that application, we need to run the command node index.js. So how cool is that? So let's run node index.js, enter, and here we are getting one error. So what's exactly it is giving us a warning to load ES module type set, and if you scroll down here, we are getting a syntax error, and it says that cannot use import statement outside a module. All right, so here what we need to do, we are going to clear the screen first. We want to see the error message again, list all the files, and here we need to update something. So if I go to the package.json, let me check the package.json over here, package.json. here we are dealing with modules, so let me just check it, and cat index.js. Okay, so I just did a small search. I made use of ChatGPT and find out that we need to make change in package.json file. So vim package.json, and here just below the license we need to add one more line, and here we need to define the type. So here the type would be module, comma escape:\wq. now clear the screen and rerun the node command once again, node index.js, and here it says that the application is running on port number 3000. I will go on my web browser, I will open localhost, and I will pass the port number 3000, and here it says hello, this is a node.js application without express. Okay, so the application is working fine. Now let's start with the main part, that is let us dockerize this application. So for that we will create a docker file. So docker file over here. Now since we are working with a node based application, we are going to make use of a base image, and that would be a node image. So node 18, this is the image that I would be using. Next thing that we will be doing is we will be defining the working directory over here. So for that I will write work dir. So if you don't define this work dir keyword, it will consider slash by default, and that will create some permission issue. So better define the working directory for your application. Next, now what we are going to do is we are going to copy all the files which are present in the current context inside the container. So copy from the current context, and if you write, even if you write slash app, or even if you add dot, it will be one and the same. That won't create any difference. Now the next thing that we would be doing is we are going to run npm install to install all the dependencies with the help of package.json, and finally we are going to expose the application, expose, and this app works on port number 3000, and finally we are going to run the cmd command, and what's it, it's node index.js. so node comma space index.js escape :wq. Now let us build the docker image out of this docker file. If I do a cat over here, you will find the entire docker file. So what we did, we took a base image of node 18, then we defined the working directory, we copied all the files to slash app, then we executed npm install, we exposed port 3000, and then finally we executed the command node index.js. so docker build dot. So what exactly is happening? We provided the current build context, meaning it passed all the file into the it passed all the file from my current local working directory to the docker daemon, and then from there it is going to the container, right? So this is how things are working over here. And if you can see over here it's saying load build context, right? But the thing is, the transfer context size is 63.75 KB. But let's say if there are multiple files which are present in my current working directory, that will create an issue because these do have a capacity. That's the reason we are making use of docker ignore. Now if I do ls, you can see these are the files which are currently present, but out of these there is node underscore modules, which is of no use for us, because even if you delete it, it won't create an issue, because at the end, if you remember, in the docker file itself we are running npm install, and what is the job of npm install? To install all the dependency based out of the package.json file, right? So this is something which is unnecessary, so this is something that we can eliminate. So for that we will write vim.docker ignore, and here I will mention the folders and subdirectory. But if you want to get a pre-written template based out of your project type, you can again go to web browser and search for generate docker ignore file, and based on your project type you can actually generate your docker ignore file. So if you go over here, here you have already node.js selected, you can actually copy it and paste it into your docker ignore file. How simple is it? If I do a cat on docker ignore, what it will do, it will remove the unnecessary file which are not even of any use to us, because these are something which are getting generated automatically inside the container. So if I do a cat, all the log files, all the node underscore module folders are been getting ignored by default, right? Here you can also ignore .git folder because this is of no use for us, right? If I scroll upwards, you can see here it ignored all the .env because secrets are sensitive. These are something that we should not even pass even in the build context. So that's the thing that is provided by docker ignore and build context. Now this time if I clear the screen and when I do ls, if I remove the node modules folder which is of no use to us, if I do clear over here and if I rebuild the image, so docker build dot, what will happen? It won't throw any error because everything is done inside the container, right? And that's the reason this time it build it fast, right? Because we are not passing huge files during the build context. The number of files are less in the context. That's the reason the build time reduce. That's the reason we have to learn about build context and docker ignore. I hope in this video you got to know about how does docker ignore works and what is the importance of build context. Now let's go to the repository that we have created. And here if I scroll down, you can see all the docker file examples are already mentioned over here. Why we are using is everything is mentioned over here. Okay, you can ignore the compose example which are written over here, because compose is something that we are going to cover in the coming videos. But for now, just focus on how does build context and docker ignore works. And if you face any issue, you can just go through the documentation. You will find ample amount of information that is required for you to get started with build context and docker ignore, right? So let us take the summary. What basically build context does, it sends the files to docker daemon and then it helps us to build the image. Secondly, what is docker ignore? It excludes the unnecessary file during the build time and it enhances the build time. Okay, third is what are the benefits. Basically it ensures that the faster builds are done, smaller images are there, and it provides better security because here we are not compromising with .envs. And fourth is what is a bad practice, because what is the best practice, always to use a .ignore file. So remember, a clean build context lead to efficient and secure docker images. So yeah, that was all in this video. And again, if you want to learn more about build context and .ignore file, so search for build context in docker image. So build context in docker, and here they have a wonderful documentation, and here you can go through each and everything, because this will give you the clarity how does build context work, right? Here it gave you here it tells about three sort of build context: local file context, git repository, and remote tarballs, right? Right now we saw the example of local repository. Here you can explore git repository and remote tarballs, right? Yeah, so that was all in this video, and I will see you in the next one. Till then, keep learning, and thank you very much. Writing a docker file is really very easy, and after this video you will also say the same. So let's not discuss about the theory, let's do the hands-on. And in this video I will show you each and everything, the maximum commands we write, the maximum understanding you will get. And at the end, don't worry, I have prepared a wonderful cheat sheet along with the examples, so that you will just have to go through that documentation and it will literally help you to understand how to write a docker file. So without further ado, let's get started. So right now I am on my MacBook, and here I will be using Docker Desktop. So let me just start Docker Desktop right now, right away. And 1 second, it is asking me for my password because I just updated it. So right now I will be using the latest Docker Desktop. Okay, and yeah, things are ready for us, and now let's get started with the hands-on. So let me create a new docker file over here. So docker file, and alongside what I will do, I will open my terminal so that whatever command I fire over here, it would be visible to you. Okay, right now we don't need the left side, so let's just remove that everything, no distractions at all. Okay, so what we learned so far, whenever we are writing a docker file, the first thing that we need to take care of is the name of the docker file itself. And the docker file starts with a capital letter, that is uppercase D, and docker file, right? Now we learned in the previous videos and before even the previous video that docker file consists of instructions and argument. And in the previous video we learned about the docker layers and cache. The number of lines we add in a docker file, the number of layers increases in a docker image, right? So keeping those things in mind, let's get started. So let's say if I want to add a comment before even I start writing the docker file, right? Because I am someone who loves to document each and everything, I will make use of hash, and here I will write each and everything about that specific statement. So let's say we are talking about from. So what does from does? So from defines the base image used for the docker image. In this case we will be using not official Python 3.9 image, we would be using Ubuntu image. Okay, so I am getting the emits. Why? Because there is an extension which is added over here, but we don't have to worry about emits. We are here for doing the hands-on. So let's write from, and here from is used to define the base image, and here you are getting the definition too, and that's the reason it is preferred to use IDE for writing the Docker file, because it gives you multiple flexibility, it gives you an helping hand for writing the Docker file, right? So here we are making use of Ubuntu, so Ubuntu latest. This will be the image that I will be using as a base image. So now what will happen if I run docker build -t app dot, okay, here. So before even we start with the demonstration, I just want you to note the size of the application. So the number of lines we add in this specific Docker file, I want you to note down the size of the image too, because if we add, if the number of lines are increasing, the size of the Docker image will increase too. Okay, let me clear the screen, and if I do docker images, enter, here you can see we are getting the size of 101 MB. Okay, and here is the app which we just created. Now I think the from keyword, the instruction is clear to you, and if you want more clarity in life, then do nothing, just go to your Google Chrome and search for docker file, enter, and here you will find the reference from docs.docker.com, and here you will find all the keywords, all the instructions that we are using in this tutorial, and also have documented in the MD file that I will show at the end of this video. But for now, just focus on each and every instruction that I am showing you right now. Okay, so the first thing is done. Now let's say this image is created. Now what if I want to run few commands inside this container, how will I do? So basically here I will make use of run command, and as per the command what it says, it executes the commands in shell. Here we are updating the package list, and we are not installing anything. So let me just remove this, because I want to demonstrate one more thing to you. So I will write run apt update, okay, enter, and then let us rebuild this file once again, docker build -t app dot, and now here note that the size of the Docker file, the size of the Docker image is 101 MB. Okay, now after this update, what is the size of this image? Okay, let us wait for some time. So here you can see one more thing. Now since I added one more line, one more layer is also added over here. Now if I rerun the command docker images, you can see the size changed from 101 MB to 167 MB. Okay, now let me clear the screen. Now let's say if I want to install any package, so I will write apt install -y nginx. Okay, so this is something that I want to install, and alongside I am documenting few things. So install nginx web server. Now what I will do, I will run docker build -t app dot again. Now what it will do, it will take the reference from the previous two layers, and then it will execute the third layer. But here you can see we got an error. Why? Because there is a spelling mistake. So I will write docker install -y nginx. Let me clear the screen, and I will rerun the command docker build -t app dot. Now what it is doing at the backend, it took the reference from the previous to build. So those were the cached layer that it used. Now if you are someone who is wondering what is Docker layer and what is Docker caching, please refer to the previous video, and then it will make sense when you are doing this thing. Now what it did, it took the it actually executed the third layer, and then it installed nginx for us. Now if I clear the screen and if I run docker images, there must be the change in size, and again here you can see the size changed to 174 MB. Now what if I want to check the version of nginx without even going inside the container? But before even that, how do we go inside a container? We make use of docker exec command, right? And we provide the shell, and then we go inside it, and then we check the version. But what if I want to check the version without even going inside the container? So for that, you need to make use of docker run command. Yes, docker run command, docker run. What we want to run? We want to run app, and what I want to do, I want to check the version of nginx. So nginx -version, enter. And here you can see we got the output, and here it says nginx version 1.24.0. Now what if I want to check the OS version? Now see, here if we define the base OS as Ubuntu, but how do we validate it? we have a directory called /os release. So let me rerun the command once again. So here I will run docker run app, that is the name of the image, followed by cat /etc/os release. Enter, and here you can see the name of the operating system that we are using for this specific image would be Ubuntu. Okay, I hope that made sense. Now let us move forward. Now here we are working with the run command. We made use of base image. Okay, now let's say I want to check, after doing all these things, I want to check what is the current working directory that I am currently presenting. So here if I go and run pwd, that is print working directory, it says /. Now it is a very bad practice to work on this directory because it is the root directory, right? And that's where work dir comes into the picture. Now what it is work dir? It says the working directory of for any subsequent command that we are running, which is used in the Docker file. In short, work dir is used to define the working directory where you would be working, right? So here I will write /app, and this would be the working directory for me. So I will just correct it to work dir, and here you can see I am getting emits, and that's the power of IDE. I am repeating it once again. When you are using IDE, it is very much easier for us to write the Docker file. But for beginner, when you are starting, I recommend do not use any sort of extension because you are learning. Once you are done with the learning, then this will be very much helpful for you because you know what thing you are about to. Now let me write the comment for it. So work dir, so what work dir does, it sets the working directory for any subsequent command. In this case we are setting it to /app. Now let us build the app once again. So docker build -t app dot enter. It will check for the fourth layer, that is work dir. In the previous layer we saw actually the size of the image changed to 174. Let us recheck what is the size this time. Here again the size is 174 because we didn't install anything, but the change over here is docker run app, and here I want to check the working directory, and this time, ladies and gentlemen, the working directory is /app instead of /, right? Okay, now let's say there are few files which are present over here. So let's say if I add few files over here, so index.html, here I'll just write some random text, and let's say this is the file that I want to move this from my local to the /app which I have created. So for that I have something called copy. Now what copy does, it copies the files or folder from my source to the destination inside the container. So basically I will write, I want to copy index.html, and it should get copied to /app. Now what would be the difference if I write dot, and what would be the difference if I write /app? It will be one and the same. How? Let me show you. So if I just save it and I just build it, docker build -t app dot, and now let me just clear the screen, and this time I will run docker run app, and I want to run ls-l. Now here you can see we have index.html. Now here we made use of dot, but what if I made use of /app? So basically let me just create one more file, so it will give you the clarity that there is no difference between dot and /app. Why? Because we have already set the working directory. Here I will create one more file. So here I will say admin.html, and here I will write doc lorem ipsum. So control Z once again, lorem 45. Now what it will do, basically it will generate 45 lorem ipsum text. So if you are someone who knows HTML a little bit like me, so you will be able to understand what actually it is. So format document, save it. I'll go back to my docker file, and this time I want to copy admin.html to the /app. So here we are going to demonstrate when we are defining /app, it will copy both the files. Even if you mention dot or /app, it will take the copy from your local into the container. So now let me build it. So docker build -t app dot. Now when we do ls-l, what we are going to see, okay, docker run app, and here we want to run ls-l. So our expectation is when we define /app, it will take it will define the working directory as app, and then when we are using dot or when we are using app, it will take all the files into the app folder. When I do ls-l, you can see index.html and admin.html are inside the /app. When I do pwd over here, you can see the current file is present over here, right? All right, so we made use of copy, we made use of copy dot, we understood what actually is what actually it is doing when we are using dot, or what actually it is doing when we are actually mentioning the absolute path. Let me write the comment over here so that we can understand what actually happens over here. Now scroll down. Now you might have heard about add. Now what does add does? So basically add also performs the same operation just like copy does, but apart from that, it also basically copies the file from remote repository. Let me show you how it does. So I will write add over here, and here you can see copy the files and folder or remote URLs from source to destination. Okay, let's do it. So I will go here and I will copy this URL that is from my repository itself, and here I will write copy this from this repository and add it to dot. Okay, and when I do docker build -t app dot, okay, let's wait for some time, and then when I do docker run app, and then after that I will run ls-ll, you can see we have docker tutorial folder present over there. Clear the screen and let us see what is present inside it. So I want to go inside docker tutorial, so I will run cd docker tutorial, or what I will do, I will read the readme.md file which is stored at the root. Let me just check. If I go to docker tutorial, there must be a readme.md file which states the name of the docker tutorial, because till now I am yet to write it. Once the series is completed, then I will complete it. So let us read the md file. So cat from docker tutorial, and here / I will make use of readme.md file, and here readme.md is in caps, so readme.md, enter, and let's wait for some time. Okay, it says it's not a directory. Let me just validate it. Docker run app get docker tutorial readme.md. So one sec. Okay, so it's at the root level itself. So what I will do, I will just run a cd command, cd docker tutorial, and cat readme.md. Okay, we are getting an error. So let us first find how do we run multiple commands in this short when we are dealing with containers. So let me just check what actually is the issue. Okay, so we learn with the mistakes, and that's what happened right now. So what happened in the add instruction, what I did, I didn't mention .git, and that's the reason it was behaving improper. Now what I did, I just added .git, the proper path of the git repository, and I added a dot, and then when I executed docker run app cat readme.md, it gave the expected output, right? So that was all, and now let's move forward with the next one. So I will write one more comment for add over here. So add is similar to copy, but it can also handle remote URLs. In this case, we are adding the contents of git repository to the /app directory of the docker images. Okay, now let's move with the next one, that is, let's say if you want to expose any application, right? So for that you will make use of expose, and here let's say your application runs on port number 8080, you can just make use of expose over here, right? So the next thing that we need to make sure is so that's about expose, so leave it for now. For expose we have a dedicated video, because I will be creating a small projects that will give you the clarity how does expose works. So now let's move, and let's say if you want to run a command from a specific user, because what happens right now, let me just rebuild the docker file once again. So docker build -t app dot. I just want to demonstrate one more thing, because here whatever commands we are executing over here is coming from the root user. So docker run app, and I want to check what is the current user I am currently logged in with. So I am currently logged in as root user. So now let's add the user. So for that I will make use of user. So here the user will be delta, and I will add a comment for it. So user sets the user ID when the container is been executed, and in this case we are setting this to delta. And then what I want to do, I want to run few commands. So let's say I want to run mkdir, so I will run mkdir, and here I will make use of logs, and this should be executed with the user delta. So let us see how does runs behaves when we are actually making use of user, right? Okay, so let me just rebuild it. So docker build -t app dot. Okay, it took the caching from the previous layers and it is building the 7th and 8th layer, and it says there is an error. Why? Because it says we are creating directory called logs in the /app, and it says fails to solve, did not complete it successfully, unable to find user delta, no matching entries. So because we didn't even created the user, so for that we will create the user with the help of run command. So user add -g, and I will add it to the sudo group, and I will create the user delta. And then let's give the permission. So run chown, and I will give the user and group permission /build image. So we actually changed the ownership of the /app to from root to delta, so that it have all the required permissions. Now it is running on layer number 8, and here you can see, and the remaining 7 layers are been cached, and that's the reason we understood this thing, because we are clear about build context and layer. So everything is done. Now let me clear the screen. Okay, my laptop is slow because it is consuming a lot more RAM. That's the reason it is showing slow input, and that should use EC2 instance. So when I do a docker run app, and when I run who am I, you can see the current user that we are actually logged in as delta instead of root. So it is taking some time because the laptop is acting weird, and here you can see the output is present, that is delta, right? Okay, so now let's say that your application required environment variables, and that you need to mention it to the docker file. How would you do it? So for that we have something called env, and env is basically requiring a key value pair. So you can just write environment equal to production. Now what env actually does, it specifies the environment variable that you need for the execution of your application. So let me just rebuild it. Docker build -t app dot, and then when I run print env, it will show all the environment variables that are actually set with the help of this docker file. So let's wait for it to get rebuilded. Okay, so it is done. Let me clear the screen, and here I will run docker run app, and here I will print the envs, and here after this execution you will see environment equals to production should be listed into the list of all the environment variables which are present inside that container. So after this, the next thing that we would be learning about is label. Now what label does, so basically it adds metadata to the docker images, and in this case we will be adding the label maintainer equals to Shubham Gaur. And yeah, let's wait for the execution of the previous output because the laptop is really working very slow. And here you can see the environment equals to production is actually listed over the screen. So yeah, that was all in this video where we learned about multiple instructions in Dockerfile. And if you are interested to learn more about the instruction in Dockerfile, then feel free to learn more about Dockerfile than docs.docker.com. And apart from that, you can also refer the repository that I have created, and you can refer the sub repository number 13, where you will find the documentation of all the Docker instructions that we used in this video. And also there are all the Docker instructions that you should be aware of. The specialty of that repository is that all the instructions are actually mentioned along with the example, so that it would be easier for you to understand. So yeah, that was all in this video, and I will see you in the next one. Till then, keep learning, and thank you very much. Hey everyone, welcome back. So till now we have been learning a lot about Docker. We know what actually Docker file is, what are environment variables, we know how does Docker layering and caching works. So now let us put everything into a single place and let's explore DataBridge Lite. So what is DataBridge Lite? So it is a 3-tier web application. It is a very simple application that I created with vibe coding. It is very much easier and this will actually give you the idea how does the application works locally, and this will give you the clarity how does things behave when we dockerize it into EC2 instance or any cloud, right? So let's get started and understand how do we plot everything into a single place. And yeah, welcome once again, and this would be one of the very important video because here we would be implementing all the concepts that we have learned so far. So let's get started by understanding DataBridge Lite.
Alright, so before even we move forward, let us first understand the architecture of this application. Now, why we are referring to this architecture diagram, it's because this will give you a visual representation of the entire application, and also it will give you the information what port has been used, what technology has been used, and what Docker component is actually involved, right? So let's start with it. So the first thing is basically the client. Now, how will the client able to access this application? So basically he will be able to make the interaction with the browser. Now, since it is a web app, it will have a front end, it will have a back end, and it will have a database. So this is a 3-tier web application where the front end is created with the help of Nginx, back end with Node.js, and database is MySQL, right? Now again, here you can see the front end is using port number 880, the external port 880. So whenever the client want to view the application, he will just have to write localhost colon 880 and he will be able to view the application. Now same goes for backend. It is running on port number 3000, and MySQL DB, it is isolated, and here it is only accessible to the front end and back end framework that we have created, the front end and back end services, right? Now in order to protect this application, in order to keep this in isolation, we have created a custom network, a custom Docker bridge network, that is databridge-net, and that will help us in project isolation. And further, in order to provide system consistency and in order to provide the persistence, we created Docker volume. Now why this is created? Basically, let's say if something goes wrong, if the backend goes down or if the MySQL DB crashes, we have Docker volume which we will be mounting to the current system, and that will help us to get back where we actually were. So this is how the system architecture looks like. Now here everything is documented, and if you want to learn more about things, I have this repository DataBridge-Lite. You can go on my GitHub profile, get this GitHub repo and just go through it. Now whatever we have learned so far, basically it is present in the architecture diagram. So all you have to do is just run this index.html and you will be able to parse it on your browser. The next thing is here we have front end, back end, and the database. Let's go with the back end first, which is created with the help of Node.js. Now here if we go with the Docker file, here we use the base image as Node 18. It is a slime image. Now why specifically I used slime image? It's because I wanted to reduce the size of image, right? That's the reason I refined the base image as node 18-slime. Second goes the work directory. It is the place where we would be working and interacting with the application, where all the operations regarding the backend will be done over here. Then what we did, we copied the package JSON to the current working directory, that is /app, and followed by we actually ran npm install to install the dependency which are mentioned in the package JSON. Next we copied the entire source code to /app. Then finally we expose port number 3000 and we started the backend by running the command npm start. So this is how the backend looks like. Now let's go to the DB. So how does the database looks like? Here we are making use of MySQL. So here I made use of SQL 8. Then I made use of label. Now what is label over here? So label is nothing but an identifier. Basically it is used for tagging. So it gives more information about your Docker file. So basically here the label is nothing but then metadata that provides more information about this Docker file. Now what is metadata? Metadata is a data of your data. Now let's imagine there is a classroom and there are 60 students, and let's say there are 4 Shubhams present. Now if I specifically target, if I specifically mention Shubham Gaur, then I will be only targeting to that specific person. Why? Because I defined the metadata there, and there the metadata is the surname. Likewise, tags and these metadata come into the picture. Next, if we go forward, we already know that MySQL works with environment variable. If you want to spin up MySQL container, you need to provide the environment variable during the creation of it, and that's the reason we defined the environment variable. Now there is one more environment variable that you can see over here is, that is MySQL underscore database, that is appdb. So this is required when we spin up the MySQL DB. If you want to know more about environment variables, please go through the environment variables video, and if you want to go with the documentation, just search Docker Hub MySQL, and here you have to go to the official image, and if you scroll down you will find the section where the detail is mentioned. So if I scroll here, you can see if you want to start a MySQL instance, all you have to do is you need to mention -e, that stands for environment variable, and you need to pass the value. Now since we are creating our own backend, that backend requires this database, and that's the reason we created this variable. If I copy this variable directly, and if I go to the documentation and paste it, you will able to see this specific keyword over there, environment variable over there. Why? Because it is the actual definition defined by Docker in the actual definition of the page. That's the reason we are able to reference over here. So when I was creating the Docker file, I was actually following the Docker docs. Now coming back here, after everything is done, we define the volume where all the data will be mapped, and finally we copied the init.sql. Now what is init.sql? It is the startup script that we want to create when the backend starts. So basically it is responsible to create the database, select it, create the base table where the data will be stored, and once everything is done, it will run a health check with the interval of 10 seconds, and then finally once everything is done, our database will be ready. Now let's come to the main part, the main phase where the client will be viewing the application, that is the front end. If I go over here, if I click on the Docker file, we already know that this is created with the help of Nginx. So basically here we'll use Nginx Alpine. Now why Alpine? Basically it is a lightweight image, that's the reason. Then we copied all the statics file to user/share/nginx/html, a place where we store all the index files, and finally we expose the port 80 and we started the server. This is how a front end is working. Now what should be the sequence of starting this application? Now if I go back to the architecture diagram, the first thing that you need to make sure is your database should be ready. Now once your database is ready, you need to make sure that the backend is ready, and once the backend is ready, then you should work with the front end. Okay, now when it comes to Docker, when you are containerizing it, what is the first thing that you will do? The first thing that you will be doing is to create the network, create the volume, then start the MySQL container, start the backend server, and then start the front end server. That's it, and that is how you will be able to view the application. Now enough theory, we have a bit understanding of the application. Now let's run the things in local and see how does it works. Let me close the tabs over here, and I would recommend you to go through with the documentation present in the MD file, present in the GitHub repository. Everything, every setup is present over here. Okay, now there is one more thing I wanted to mention, that when you are doing the testing, if the backend is designed with zero configuration, so if it doesn't detect MySQL, it will fall back to SQLite just to avoid the inconsistency. So that is something that I wanted to pinpoint. Now rest everything is mentioned over here. If you want to run it in local, all the instructions are mentioned over here. Now let's start. Let me open Visual Studio Code and show you how does the application looks and feel like, and how we can actually interact with the application. Alright, so let me show you how do you run the application locally. But before even you move forward with it, just make sure that Nginx and npm is installed in your local, and then feel free to start with it. Right now my MySQL and everything is set up here, so I don't have to worry about everything. Now when you're starting with it, just make sure these things are present, and I'm considering in local environment everything works fine. That's the reason I'm showing you, and then we are going to move forward with the containerization. So here I'll follow the readme.md file that is already created in the GitHub repository itself, so it would be easier for you to reference to. What I'll do, I'll just open the integrated terminal which is present in the IDE itself, and I hope that the screen is visible to you and the font is visible too. Now the first thing that you need to do is, now my database is ready. the first thing that I will be doing is I'll go inside the backend, and the first thing would be to install the dependency. How do we install an node based dependency? By running npm install, and this will install all the dependencies that are mentioned in the package.json, and we should be good. Now once everything is done, now based on the Docker file, we are going to just run npm start. Now here it is running on port number 3000, and here it is using SQLite, and let's start with the front end now. Now let me open one more terminal, and here what I will do, I will run the npx serve command so that we would be able to see the front end over here. Now right now in my current local port number 3000 is already occupied. That's the reason it won't run, but the code is written in such a way that even if port number 3000 is occupied, it will just look for another port which is open, and here it look actually basically you can see it says the port number 3000 was in use. That's the reason it shows port number 49935. Let me click over here, and here you can see the application is currently present. Now let us view the application. How does it works like? When I press hi and click on submit, here you can see the entry is present over here. When I do a refresh and when I click on fetch all data, it actually pulled all the data from MySQL DB. Now you might be wondering where the entry are coming from 1 till 6, because this is something that we didn't even entered. This is something which is coming from MySQL DB, which I was performing while creation of the application, and that's the reason it is showing me the data. But this is how the look and feel of a 3-tier application looks like. I know this is a very basic application, but believe me, this will give you a lot more clarity and understanding when we are trying to containerize it. So yeah, let me stop the instance, like let me stop it on my local. Let me press Ctrl C so that I don't run out of RAM, and the work for CMD, the work from Visual Studio Code is done. Let me go to my favorite terminal now. And in order to perform the operation, I will go to my EC2 instance, click on connect, and I will do an SSH. So here I am on my downloads, and I will do the SSH now. Yes. Okay, let me clear the screen, and I will remove everything which might be present over here. rm-rf, and let me see if there are any images. There is nothing present. When I do docker ps-a, nothing is present. Let me run docker system prune, and when I press y, everything is clear. Now the environment is set up. Let us start by containerizing the application. So let me go over here. Right now if I run node-v just to check whether node is installed, here you can see node is not installed. And when I do nginx-version, you can see nginx is also not present, so meaning nothing is present in this machine, so we should be good on that. Now what I am going to do is I am going to take a pull of this repository in this EC2 instance. So git clone, and a copy will be copied on my current EC2 instance. Now it will clone Databridge Lite. Let me go inside the repository. Let me go inside the directory. When I do ls-ll, you can see all the files are present over here. Now based on the architecture diagram, what's the first thing that we are going to do? We are going to first create the Docker network followed by Docker volume. So let me scroll all the way to the bottom, and here we have the command to create the Docker network. So let us create the private network for our application, and here the command that we are going to make use of is docker network create databridge-net. Enter. Now what sort of network, like what type of network it would be? Now by default the network which is created in Docker, it would be a bridge network. Let us verify the same. So docker network ls, and when I do ls, here you can see the driver that is being used by default is the bridge driver. Now let me just clear the screen and let's create the Docker volume. So why we are using Docker volume? So let's say if the application crashes or if the container restarts, so in that case, in order to persist that data, we are making use of Docker volume. I'll go over here and I will create a new Docker volume. So Docker volume create name of Databridge DB vol, and the volume is created. Let me run docker volume ls, and when I show you here, you can see the local driver for Databridge DB vol is created. Let me clear everything. Now let's start with MySQL DB. Now if I scroll down here, we would be able to build the MySQL image. Now how we are going to build that image? So basically in the SQL folder there is a Docker file which is present. When I paste it and enter it, it will build the image for me. Now here the base image that we made use of is MySQL 8 followed by the remaining instructions, and once everything is done, it will create the Docker image for us. Now once the Docker image is ready, the next thing that we are supposed to do is basically we are going to map the volume for it. So we are going to make use of docker run -d. Let me first copy the command and I will explain it to you. So what we are doing over here, so if you can see, we are running it in background. So docker run -d, the name of that container would be MySQL DB. Then the network that we are using is the same network that we just created right now, followed by we are doing a volume mount. Now where we are doing the volume mount, so basically the volume that we created with /var/lib/mysql followed by the name of the image that we want to do. When I press enter, docker ps, you can see MySQL data is currently up and running. Now if I go here, and now let's move forward and create the backend. So let me build the backend image first. So the commands remains the same. First we are building the image in a sequence, we are spinning up the container, and then we are actually verifying the things. So right now it will build the backend image. Now once it is ready, now what we have to do, basically we need to spin up the container. Now let's wait for some time. Now here you can see it is working on layers, and if someone is coming from that video who has a clarity on layer and caching, he or she would be very much getting everything what actually happening over here. What's the actual meaning of this blue text, right? Let me clear the screen, and if I paste it over here, oops, let me clear the screen once again. Clear. Okay, now let me just copy the command and let me just press Ctrl V. Okay, so what's happening over here, we are running the container on background and we are naming the backend service as API server, and then the network that we are using is Database net, the one that we defined, and here we did the port mapping, and then finally we are passing few environment variables and followed by the image name. Now when I do docker ps, here you can see the backend and the DB are actually working fine. Okay, it is currently up and running. Now let's start with the last thing, that is build the front end image. So docker build -t databridge frontend dot, and it will create a front end image for me. Now once it is done, then we would be utilizing port number 8080 to access the application. Now let me run docker run command. The name of the container would be web UI, the network would be databridge net, and the port that would be used is port number 8080. The internal port is 80 and the host port is port number 8080 followed by the name of the image. Now when I clear the screen, when I do docker ps, here you can see all the three containers are up and running. Now the first thing that we need to verify is the network, because here we are talking about isolation, because here we explicitly mentioned -- network is equals to databridge net. So let me just check the network, docker network ls, and when I do so, I need to inspect this network. So docker network inspect, followed by the network name, and here just notice inside the container we have all the three containers which are present over here. Now what is the meaning of that? It means that all the containers are running and they are able to communicate with each other. So first thing is verified that the network is actually working. If you want to further verify it, just go inside the container and try to run a ping from front end to back end, and it will actually ping, right? You just need to get the IP address. Now how do you get the IP address? Just run and inspect and get the IP address from it. Now let me show you how do you do it. So basically docker inspect followed by, let's say if I want to get the IP for backend, here I will run grep -ia4 IP address, and here let me just correct the spelling, IP address. Okay, docker network, I think I used the wrong container name. Let me just pass the correct container name, docker ps and docker inspect. So the name of my backend container is API server, and here I will run grep -ia4 4 IP address. And here you can see I got the IP address. Now what you have to do is go inside the container, ping container A, and then come back, go to the container 2, ping container 3. So this is how you will be able to verify the connectivity. The one thing that I wanted to verify is, if you remember, when we go to DB, here we passed init.sql. The main purpose was to check, to create the database and to create the table. Let us verify the same. So let me just go inside the container. How do I go inside a container? Docker exec -it to get an interactive terminal, followed by the container name. Then I will pass bin/bash, and this is how I will be able to go inside the container. Let us first check whether the database and the tables are created or not. So let me just log into MySQL. So MySQL -u root and -p for password, and the password that we have created, the default is root, and here you will be able to log into the MySQL container. Now when I run show databases, enter, here you can see appdb is created. Let me just select the appdb, and then when I do show tables, here you can see messages is created, and that is something that we were expecting. Now what comes by default when we create this? So select star from messages, and by default nothing will come, because this is something that the application is responsible to add it over there. Right now let me exit from the container 2. Now let us view the application. Now let me go to the browser, and here I will be experiencing my application. I will go to instances, I will copy the public IP, and here I will write http:// followed by Ctrl V, and the application runs on port number 8080. And here, ladies and gentlemen, we are able to see the application, the front end side. But if I click on fetch all data, it will try to connect to the bridge. Now, will it be able to connect to the backend or not? Just answer it into the comments, answer it into the description section. And what will happen if I just post one hi? It will keep on load. It will keep on loading. Why? Think about it. Now it happens because we didn't even expose the backend port, and on which port does the backend runs on. If I go to the backend, if I go to the readme.md file, here we need to search for on which port the backend runs on. So if you go over here, here we are getting one information that it runs on port number 3000. So what I need to do, I will go to instances, I will go to security, I will open the security group, and I will update the inbound rules, edit inbound rule. And here what I will do, I will add a rule, and here I need to write 3000, and then I will enable the traffic, and then I will click on save rules. Now once this is done, what you have to do, it actually connected to the DB and it actually fetched the data. Now again, if I write Shubham over here, it will send the data, and here I will write, hi, this is from cloud server EC2. Again, submit it. It will get you the data. Let me refresh it. Let me fetch all data. It will connect to the MySQL server and it will get the data for you. This is how things work. But wait, there is one concept that it's still pending to verify now. What? Let me go inside the container. I will run docker exec -it. I am inside the MySQL container. Now I will again run MySQL -u -root p. I will log in with the password, and here if I do show databases, enter, and if I use appdb, I should be able to see the entry over here. So show tables, and here we have the tables name messages. Now what will happen if I run select star from messages? I should be able to see all the entries that we were able to see on the browser. Enter, and here you will see all the data is present. But here is the catch. Let me exit from here. Let me again exit from this container, clear the screen, docker ps, and right now let us imagine that due to some reason all the application goes down, meaning the container stopped. So docker stop. Let me stop the front end. Let me stop the back end. Let me stop the MySQL DB. Enter. All the containers are down now. And if I go to the browser, if I do a refresh, here it says this site can't be reached. Now I want to ask you one question. What will happen if I just start the container once again? And what about the data, the 3 entries that we did? Think about it. Okay, so let's see the result. How does the things look like? Now what will happen if I just start the container? So let us go with the sequence. So docker start, I will start the MySQL DB, then I will start my API server, and then I will start my web app UI. Okay, now if I do so, will I be able to get the data? Here we made use of Docker volume, so we should be able to get our data back, right? So I will go over my EC2 instance, and here you can see it's already running. I will just do a refresh, and when I do fetch all data, it says the bridge is empty. Start by pushing some data. But where is my data which was present? You remember I mentioned I entered 3 data over there. Where it's gone? Let's figure out. So let me first stop it once again. So docker stop. Let me stop all the containers over here. So where did we missed over here? So see, whenever we are dealing with the application, the first thing that we did correct over here was we started with the backend. We started with the database first. But the thing that we did wrong over here is we didn't give it time to collect the data. Okay, it needs some time to gather all the information from the volumes, and that's the reason we made use of health check over there. Okay, now let me just do docker ps -a, and here this time note what we are about to do. Docker start, and let me first start my database first. Now let's wait for 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now at the backend or a database be like everything is ready. Now you are good to start with the backend. Meantime, what I will do, I will copy the API server and I will run the command docker start followed by the API server. Now what will happen? It will initialize. Everything is done already. Now since we are dealing with layer and caching, everything is ready for us. But the thing that we are doing over here is we waited for MySQL DB to be at stable state. Now it should be ready. Now when I do docker start API server, it should be ready now. Now when I do docker ps, here you can see the backend and database is ready. Now the one thing that is left is let me run docker logs for API server. Now here what it says connected to MySQL DB, meaning our data should be back, and whatever we mounted, remember we made use of docker volume. So when I do docker volume ls, this volume should have the data that we are looking for and it should be present right now. Let me clear the screen. When I do docker ps, here you can see the backend and the DB is running. If you want, you can manually go inside the container and check it, but the best way is to check by running the front end. So docker ps -a, and this time let me start the front end. So docker start followed by the web UI, and let me go over here. Let me refresh the screen and let me click on fetch all data. Now it will go to the MySQL DB. It will fetch the data from there. And this is how we solved one more issue. We understood one more thing, that database come first, backend goes the second, and lastly the front end. And that's the reason we are able to get the data right now, right? I hope this gave you the clarity how things are working. Okay, now let me just show you one more thing. Now during this practical we were doing multiple operations, and here is one more thing that you need to take care of. See, whenever we are working with this sort of application, there are multiple things that we were doing manually. But you say that we are learning Docker, we are optimizing thing, we are containerizing thing. That's okay. But what about this manual stuff? Can it be automated somehow? Yes, that can be automated with the help of Docker Compose. That is something that we are going to see up next, and this is the same project that we are going to use in the coming demonstration, because this will give us the clarity how pretty the life can be when we are using Docker Compose. Because here we just have to wait for the SQL to boot up, then we have to start manually the backend, then we have to start manually the front end, and finally we are able to see the data. but what if this can be done within a single file, within a instance, right? That can be achieved with the help of Docker Compose, and that's the next topic that we are up to. I hope this video gave you the clarity about how things work when you containerize it, how things work in local, and what problems you may face when you are dealing with these applications. So this 3-tier application will definitely help you to understand how does containerization work, what challenges we face. This will help us to learn the next topic, and it will actually resolve maximum things. Now if you go to the repositories itself, you will find multiple information over here. I want you to go over here and go through the application, run it in your local, containerize it, make this application better, and that is how you will be able to learn more. You will get more out of this video. So yeah, that was all in this video, and I will see you in the next one. Till then, keep learning, and thank you very much. Hey everyone, welcome back. So in the previous video we came across with the Databricks Lite, a 3-tier web application, and by the end of that specific video we learned that we were doing many things manually. We were executing those Docker file commands, the build command, everything was been done manually. And at the end of that video we came to know that there is one method that can be automated, and that can be done with the help of Docker Compose file. Now what actually is a Docker Compose file? Docker Compose file is nothing but a single file written in YAML that consists of all the instructions that are required for our application to run. Now if you remember, we were creating the MySQL DB, we were waiting for 10 seconds for MySQL to boot up perfectly, then we were initializing the backend, then finally we were booting up the front-end service. Now finally, after doing all of them, the system was running perfectly for Databricks Lite. Now when it comes to Docker Compose, all you have to do is just run Docker Compose up and your work will be done. But how to define those instructions? For that you will need to understand YAML. And what actually is YAML? So let's understand in this video. So what is YAML? YAML is nothing but yet ain't another markup language. YAML is basically a format which is used to write the data in very clean and human readable format. And basically think of it just like a structured way of writing information that can be readable for both human and machine, so that everyone can understand easily. Now in DevOps world, YAML is like everywhere. Like whenever you work with DevOps tools like Docker, Kubernetes, Jenkins, YAML becomes mandatory over there. So whenever you are working with Docker, YAML comes into the picture. When you are dealing with Docker Compose, when you are working with Kubernetes, YAML is essential because all the manifest files are actually written in YAML, right? So in our case, for Docker Compose, we write a file called docker-compose.yaml. That entire file is actually written with the help of YAML. So if you don't understand YAML clearly, Docker Compose will be a kind of confusing for you. So let's understand YAML, and once you understand YAML, things will be very much easier for you. So now let's compare YAML with JSON. So most of you might already know JSON, but it's more machine friendly than human friendly. You have brackets, you have quotes, you have commas. It's look a bit cluttered when the file is big. But when it comes to YAML, it removes all the unnecessary clutters and noise. So instead of writing something like the curly braces like it is written in the JSON, you will just write app : followed by a single space node. So here we are not cluttering everything, and it is actually more readable. So here the main idea is YAML focuses on readability, and there are less symbols that are used, and it is giving us more clarity. And this is why tools like Docker and Kubernetes prefer YAML. So let us understand few rules when we are dealing with YAML. So there are 3 golden rules that we need to keep in mind when we are working with YAML, and if you understand these rules, you will avoid literally 90% of the errors. Rule number 1, that is always use spaces, never use tabs. So YAML does not like tabs at all. If you add that extra space using the tabs, it will actually break your file. So remember, whenever you are dealing with YAML file, make sure you are always writing with the help of spaces. Whenever you want to give spaces, make sure you are using the space button, not the tab button. Okay, second rule, that is indentation matters. Now in YAML, indentation is not just a formatting, it actually defines a structure. Meaning if something is indented inside something else, then the meaning is simple. It says that this A things belongs to that B thing. That is key value format. Everything in YAML is written in key value format, and it is very much important because there must be a space after colon. Now here if you see, if I write port 3000. So basically I need to make sure that after this colon one single space is written. So now here is the catch. So even if a single space mistake is present, then it can break your entire file. That's why most of the people struggle with YAML, not because it is hard, because it is checked. Now let's understand data types. Now in every programming language, we know there are data types. Now what actually data types? The type of data that is used. It can be integer if it is a number, it can be float if it is a decimal value, if it can be a string if it is something related to text. But when we are dealing with YAML, the good thing is you don't have to explicitly define the data type like we do in programming language. YAML automatically detects it, and that's the reason it understands what actually you try to say. So here let's take the example of this one. If you write 3000, it understand it is nothing but a number. If you write true, it understand that you are talking about boolean. If you write null, then it is understanding that it is nothing but a string. But sometimes to avoid confusion, we use quotes. So in Docker Compose, it becomes very much important when you are dealing with quotes and environment variable. So always you have to keep this thing in mind, that what value you are writing. Now let's go and understand about lists. So what is list? So list are basically multiple values under one key. Now if you remember, I gave you the example that your mom is going to a mall where she is purchasing goods for you and you provide them with a list. Same thing goes over here. Now here if you see, the items are defined here with the help of dash. That gives a specific list here, right? The list of ports. So in YAML, lists are written using a dash and followed by a space. So each dash represents one item in that list. For example, if you have multiple ports, multiple volumes, or multiple environment variables, this is how you will define them, like the example which is shown over here. So in Docker Compose, you will use list a lot, and specifically you will be using this in ports, volume, and maximum time you will be using list in environment variable. So the syntax is something that you should be aware of and you should be very much comfortable with. Just make sure after this colon there is single space present. This goes inside posts, and then after this hyphen there is again one single space, and followed by you can define the ports. Right now let's talk about maps. It is a very important concept. So maps are basically the key value pairs grouped together. So if I put this into simpler terms, you define a key, and inside that key you define more keys. So this is exactly how Docker Compose works. For example, let's say you define a service, and inside that service you define web, and inside that web you define the image that is actually used. So so basically it becomes a kind of hierarchy. So think of it just like folders inside the folder. So this structure is what makes YAML powerful, because here it is giving us the feasibility to define the structure within the structure. Now since we are talking about structure, let's talk about nesting. So if there is one concept that you should master in YAML, it is nothing but nesting. So nesting means placing one thing inside another using the indentation. So each level of indentation belongs to the above item. So when you see something like services, app, images, so it means that app belongs to a service and the ports and images belongs to app. So now here is basically where we can make mistake, is mess up the indentation. YAML will completely change the meaning, or it will throw the error. So always read the YAML just like a tree structure, where the top things becomes the parent and the one inside it becomes the child. So here the services becomes the parent of app, and the images and ports become the child of app, and here app becomes the parent, and basically whatever goes inside it becomes the child, right? So now let's talk about comments. Now why comments are used in programming language? It's basically used for documentation. Same happens over here. So comments are very simple, but it is very useful. So when you want to explain something to someone for your YAML file, you make use of this hash symbol, and this is something that is used for writing the comments. And this is especially helpful when you're dealing with the real world projects where your YAML file is very large. At that time you can use this for explaining what service does what and what certain configuration is added and why it actually is added. So always use comments to make your files more readable for others, and you can even use it for future self, so that whenever you are referring the same YAML file again, you will have that comments written over there, and it would be easier for you to understand, okay, why this things is been added. Now let's talk about strings and quote.
So in YAML, quotes are optional in many cases, but sometimes they are required. So for example, you have special characters like colon or numbers with dots like float value. So in Docker Compose, ports like 3000 colon 3000, which you can see over here, should always be on quotes. Why? Because without quotes, YAML might misinterpret it. So it's a very good practice to write it in quotes. So a basic suggestion, basically whenever you are in doubt, just add the quotes and it will prevent the unexpected errors. Now let's talk about multi-line strings. So this is something that is used very rarely, but when you are dealing with multiple lines of text like scripts or command, you will make use of multi-line strings. So basically, in order to pass the multi-line strings, the first thing that you will need to pass is this pipe, and followed by the command that you want to run. So this is not a very common basic thing that you use in Docker Compose, but in advanced setups like whenever you are running any script, it becomes very useful. So just remember, a pipe symbol is equals to multi-line block that will help you to run the commands, right? Now let's talk about environment variables. Now here comes the main part, because in Docker Compose, environment variables are very common, and YAML allows you to define the environment variables into format. So whenever you are dealing with Docker Compose, you might see either two of this method. Okay, so let's talk about the first way. So the first way is map style, and the second one is the list style. When we are talking about map style, it is separated with a key value pair by a colon, and when we are talking about list, it is basically written in a list manner, and here you can see a hyphen or dash present over here. So both are correct, both works the exactly same, but in real projects, teams usually prefer to choose any one of them to stay consistent. So basically that was the main reason for me to add environment variable section over here, because you should be comfortable in reading both of them. Now let's talk about what are the common mistakes that we can make as a beginner when we are writing the YAML files. So the number one is using tabs. Now you might be hearing this from the starting itself from me, that whenever you are dealing with YAML, please avoid tabs, use spaces, right? Second is like wrong indentation. If the alignment is wrong, the YAML will break. And YAML is very much specific when it comes to indentation. It follows strict indentation rule. Third is mixing list and map incorrectly. So these are the small mistakes that a beginner can make when it is when he or she is dealing with Docker Compose, and that's the reason it fails, and that is absolutely normal. Don't worry about that. The more YAML files you write, the more practice, the more hands-on you will do, the more confidence you will get over the YAML, right? So these small mistakes are the biggest reason why Docker Compose fails for beginners. So whenever you are getting an error, don't panic, just open the YAML and check the structure, because maximum issues are nothing but it is the indentation issues, it is due to structure, and it may be due to the tabs. Now let's take an example. Okay, now think of it as a person's profile. Now that person can be anything. Now here we are taking the example of Rahul. Now you have a person with name Rahul, and he has a lot of skills to present. So how do we write in YAML? So basically it is very much easy. In order to write it in a structurized way, we will define the key name person. Now since there can be multiple person, we wrote it inside that person. We provided one space followed by name. Again there is a space we provided with the name, and within that name we provided skills. Now skill can be a list, there can be multiple things that he can offer. That's the reason we defined Docker and Jenkins over there. So if you understand this example properly, then Docker Compose will feel very much easy to you. This is because internally it's just a structure that actually it is using, right? So let's take this carefully, and here we have a real Docker Compose file, and if you look closely, there is nothing new over here. Here you see maps, list and nesting. It's just all the combination of these three things which we already run right now. So Docker Compose is not just a new concept, it's just a YAML applied to the containers. Here you can see we have two services, front end and back end. Front end is used with the image name Nginx, and back end is used with the image name Node, right? So yeah, that's all for today, where I wanted to give you a brief about YAML.
and basically this will give you the clarity how does YAML works, like what things to take care of when you are writing a YAML file. So if you understand this video properly, you have you have cleared one more biggest hurdles in DevOps, that is writing the YAML file. Now in the next video we will go to take it to the next level, because we are going to write the actual compose file, and trust me, you will enjoy a lot. So yeah, that was all in this video, and don't worry, if you want the documentation for this specific MD, this is already published to my GitHub repository. Go to sub repository number 14 and it is already published over there. So yeah, that was all in this video, and I will see you in the next one. Till then, keep learning and thank you very much. Now let's imagine you want to deploy an application where multiple services are involved. For now, let's take the example of data bridge light, where there is front end, there is back end, and there is a database which is present. Now when you want to work on all these three services, you need to make sure that the Docker file is present. That we already know, but in order to implement that, we need to fire multiple commands. We need to build the image, we need to run the image, and during running that image, we need to make sure that we are mentioning all the environment variables every time when we want to spin up that application, right? And also the pain point is we need to make sure that the network is created, all the application falls under the same network, so that the project isolation is created. And also we need to make sure that the data is persistent, and that's the reason we need to create Docker volume every time. And let's say if we want to stop everything, we need to run docker stop, docker rm command. This is something that we have to do multiple times. We are literally firing this command 5 to 10 times for a single application. Is there any way to minimize this? Yes, definitely. We are going to learn Docker Compose, and that will definitely help you to reduce this thing, because Docker Compose is what? Basically, it's just like a recipe book that will help you to minimize all this manual thing. And also it will give you the clarity that what all things are actually needed for that application to run, because everything will be mentioned on that specific recipe file, so that you don't have to ask the developer here and there. You will have all the things present in the single place, and that will be your point of contact whenever you want to spin up that application. Docker Compose is a very good utility provided by Docker, a very good service provided by Docker, which will help us to spin up the container instantly without even worrying about the remaining dependencies, because every dependencies will be mentioned in that same file. In this video, we are going to learn how to create a Docker Compose file. We are going to see multiple examples, and finally we are going to optimize the data bridge light 3-tier web application that we have created in the previous videos. And here you will get the clarity how does Compose work, right? So without further ado, let's get started with Docker Compose. Okay, so let's get started with Docker Compose, and that too with a very basic example. Now you already know, if you want to run an Nginx into background and you want to do the port mapping to port number 8080, you know which command that you have to run, right? And here what makes this video special is we are going to refer those commands, and from those commands we are going to adapt and create the compose file, right? So it will become very much easier for you to understand and visualize how do I create a Docker Compose file. So what I'll do, I'll just split my terminal into two, so that it would be easier for you to visualize what command is running where. Okay, so let me just go inside my desktop into Docker folder, and let me just do zoom over here, clear the screen, and I will clear the screen again. Okay, so what we'll do, on the right hand side, as you can see, I will write the Docker run commands, and on the left hand side, getting inspired from those Docker run commands, we are going to create the compose file. And we are considering that you already know YAML. If not, please go through the previous video, and if you know it already, then you are very much ready to learn Docker Compose. Okay, so let's start. So now let's say if I want to run an Nginx container, how would I run it? So Docker run -d to run it into the background, -p to do the port mapping. Now I want to do the port mapping to port number 880. That, so basically the context over here is I want the user to go on port number 8082 in order to view my application, but internally my application runs on port number 80. And what is the name of my application? The name of the application is nginx-app followed by the image name nginx. Now if I just show you what actually command we made use of, docker run -d to run it in background, -p for port mapping, then we named the container, and finally we provided the image name. Enter. Now what is it is trying to do? You already know the things. It is first trying to look into the local, whether do I have Nginx latest image. If not, I will go to Docker Hub, pull the image and run it as per the user requirement, and those requirement are been mentioned over this command, because we want to run it port number 8082. We want to give that container a specific name, and that's what we actually are doing over here. On the left hand side, we are going to create the equivalent Docker Compose file that will give you a complete understanding how does things are working over here. So let us design a Docker Compose file getting inspired from the command that we just wrote on the right hand side. So how do you create a Docker Compose file? So just write vim docker-compose.yaml. This would be the extension. Okay. Now whenever we are working with Docker Compose, we are working with the services. So you need to just define the services colon, make sure about every detail that I am mentioning specifically. Whenever you are dealing with Docker Compose, you are dealing with YAML, and YAML is very strict about indentation and spaces. Make sure you are not using tabs anywhere. Okay, so after services, just press enter and give one more space. Now what does it defines? Basically it says whatever things that falls under services are the service that we want to run. Okay, it can be a front end service, it can be a back end service, it can be a SQL service, right? So right now we are interested in creating an application name Nginx app, then provide a colon, press enter and give one space. Okay, now what it is signifying, basically there is a service that we are interested in creating, and the name of that service is Nginx-app. Now how do we create that service? How do we create that container? We will need something, correct? We are talking here about the image. Now what is the image? It is Nginx. So you just write the name of the image, that is image colon space followed by the image name. Now what is the image name? It is Nginx. You can even provide the name, you can even give the tag name Nginx colon latest. It will work same. But since when we were running docker run command, we didn't specify the tag, I am going to create it exact replica of the docker run command. So let's move forward. What's the next step that we did after creating and naming the things? The only thing that is left over here is port mapping. So how do we write the port mapping over here? You just need to write ports colon, press enter, give 2 spaces, and here give one more dash, and here write the port mapping, port number 8082, and do the port mapping to port number 80. That's it. And this is how we have created a compose file for Nginx app. Escape colon wq, enter, and when I do a cat on docker compose file, this will work same as it worked over here. What I will do right now, let me just remove this image. So docker stop, and I will stop the Nginx app over here, and then I will remove the image so that it won't create any issue. Okay, things are clear for us. Now how do we work with docker compose file? Because see, based on this command we created the compose file without any effort, right? And let's say in future if I want to change the port number, how will I change it? Just open the compose file, change the port number over here, and then the changes will be reflected. You don't need to remember the commands in this case. Okay, now let's apply all the changes that we have created. So just run docker compose up -d, and now with -d this command is completed. Now what actually it is doing, it is running a container in the background along with the port mapping, and the name of the container is specified followed by the image name. Now what is happening over here? It is running a service by the name of the image Nginx. It is doing a port mapping, and that service will be executed in the background. When I press enter, what it is doing, it is actually running the container, and when I do docker ps, you can see the container is actually up and running, and here the port mapping to port number 8082 is also done, right? So that is how you work with docker compose. I'm sure that after this example things will be very much clear for you. If not, don't worry, there is another example that will make your mind very much clear when you are working with docker compose. I literally have prepared 3 to 4 examples so that it will be very much easier for you to understand how does compose work, right? So let me clear the screen, and when I do docker ps, there is one more thing I wanted to highlight, that is whenever you are working with docker compose, every time it will create a default network for that specific service. You don't believe? Just run docker network ls, and here you can see docker default network is created. And now when you just inspect this network. So docker network inspect followed by the network name. Here you can see the Docker app, the Nginx app which we created is actually inside that network, right? So that is one of the beauty when you are working with Docker Compose. Now, okay, you told us how we can work with Docker Compose. We don't even have to worry about the commands. When you were shutting down this container with the command, you have to first run docker stop nginx app, then again you executed docker rm nginx app. How do you do it with Docker Compose? It is very much simple. All you have to do is just write docker compose down, enter. It actually removed the container and it actually removed the network. When I do docker network ls, the network is removed. When I do docker ps-a, the container is removed too, and we didn't even have to run multiple commands. The only command that we have to remember is docker compose up and docker compose down. That's it. All right, so that was all in the first demonstration. I know you want to learn more. I have prepared multiple scenarios for you so that you can just deepen your knowledge with Docker Compose. So yeah, let's start with step number 2. Okay, so now let's take the second scenario where we are thinking that you are dealing with multiple containers. For now, let's say a front end and a backend container, and here you also have to make sure that they both fall into the same network. So what would be the first step? You will first create the network, then you will create the backend and the front end, and while creating of that container, you will mention the network name too. So let us do the same with the commands, and then we are going to do the same with the help of Docker Compose. So let me just create the network. So docker network, create a name of the network, and the network is new-net, and this will be of bridge type. So docker network ls, and here you can see new net is created and the type of that network is bridge. The driver that would be used for this network is bridge, right? Now the next thing is we need to create the backend. So docker run -d to run it in the background. I will name the container as backend. Now which image we are going to use? I am going to make use of HashiCorp HTTP echo. Now what it is, basically it is an in-memory web server that echoes back the argument that is given to it. So I will just copy the image name and the argument that we are passing inside it, and here before even we run the command, I will need to define the network. So --- network equals to new net, new-net, followed by the image name and the argument. Enter. Now it will try to search the image locally. Now it is not present locally. That's the reason it goes to Docker Hub and it will pull the image, and then finally it will run the backend container for us, right? When I do docker ps for validation, you can see the container is up and running. Now let us create a front end service too within the same network. So docker run -d -p. Let's take nginx for now. Port number 8082 again, and I want to map it with port number 80. Now I want to call that container as or let's say web-app, and let me just define the network. So -network equals to new-net, and let me write the name of the image, that is nginx, nginx. Enter. Now when I do docker ps, you can see both the containers are actually up and running. Now the first thing that I need to validate is whether these two falls under the same network or not. So let me clear the screen, and here I will just run docker network inspect new-net, that is the network that we created, and here I need to correct the spelling, network, and here you can see both the containers fall inside the network that we created, that is new-net. Now let us do the same in Docker Compose, but before even that, let me just clear everything. But how do we clear it? So the first thing is I need to remove the running container. So docker stop, I will need to copy the container ID for the backend, container ID for the front end. Then I will need to run docker rm-f to remove the stopped container, and here I will pass both the container IDs to remove it, and then I will delete the docker network that we just created. So docker network rm followed by the network name, that is new net, and everything is wrapped down to 0. Now In the previous module, we created the compose file, and if I do a cat, this is something that we just created, docker compose. So what I'll do, I'll just make a new folder and I'll just copy it over there, and I will give you these compose file for your reference, so that whenever you are practicing, you can just have a reference material. So I will just create a new file, mkdir compose files, and I will just move this docker compose to compose file. And what I will do, I'll just go inside this compose file, and the first thing that I will do is I will rename the file. So mv docker compose to compose -1.yaml. so you will have a clarity which compose file you are referring to. All you have to do is just rename the file whenever you are executing, so it would be easier for you. Let me go back and let's start fresh with this new requirement. So let me create the docker compose file. So docker -compose .yaml. Okay, now since we are dealing with two services, here we need to define both of them. So services colon enter space. Now what sort of service you are dealing with? There is one front end service and there is one back end service. So front end colon, and we are dealing with back end, so back end colon. Now let's make things very much easy. So when you are dealing with front end, what image you are using? So again one space, and here I'll write image. So which image I was using? I was using the nginx image, so nginx. And when I'm dealing with backend, which image I am dealing with? So image colon, I will copy the image that I just used, so that is HashiCorp HTTP echo, and I will paste the image over here. Okay, now let's move forward. Now when we were dealing with the front end, what port it was mapped to? So I will define the ports. So ports colon enter space dash, and here I will define the port mapping. So it was mapped to port number 8082 with port number 80. Now when it comes to the backend, after the image, what was the next thing that we did? Okay, so if you remember, we ran a command, right? So here we need to define the command that we were executing. So commands colon, and here I will provide the command that I executed. So this is the command that I executed. I will just give a square bracket followed by the command that was just executed. So I will remove the quotes, and this is something that will get executed during the creation of container. That's it. Now when I do docker escape colon wq cat, let's just read the file. Here we created two services. First is the front end service, and there is a back end service. In the front end service, we required the port mapping, that's why we did port mapping. And in the back end service, there was one command that was about to get executed during the runtime, and that was text hello world, and here it is doing the same. Now you might be wondering, Shubham, you're forgetting one thing, that is isolation. But again, whenever we are dealing with docker compose, we don't have to worry about networking, because whenever you are executing that compose file, it will create a docker default network. If I just list the docker networks out again, so docker network ls, you can see only these three default networks are present. Now when I do docker compose up -d, at that time a new network will be created. Let us run the same. So docker compose up -d enter. Here it says there is an issue with my compose file, and what it is, basically it says services additional property commands is not allowed. Okay, so I think there is an issue with my compose file, and that's the reason it says the issue, right? So it also validates like where you are actually writing the file wrong. And here it says services.backend, meaning there is an issue with my backend service. So I need to just check over this specific thing, and mostly it is saying the commands is not allowed, meaning the issue is with the command section. How do I troubleshoot this thing? I will go to browser and I will just run docker compose, and here I will just run commands and enter. Here you will get a compose documentation, go through it, and here you will definitely find some helps. So if we just scroll down, and finally we will find something over here. So let me just scroll down. Here we are searching for commands. So let me just take a file, and here if I go over here, I should be able to get the output. So docker compose commands and commands syntax in compose file, enter. Okay, it will refer multiple places, and if I scroll down, here it says the only thing that we need to mention is command. Here we made use of commands, that the reason it fails. So what I will do, I will again go to my compose file, and here I will update this file. I will remove that s, I will press escape :wq, and then I will again try it. Now this time it will run. Why? Because the syntax is correct, and this is how you troubleshoot the issues. See, no one is born who has never done any mistake. Right now the things that it is coming is because of some mistakes that I did. And how do I solve a mistake? Is by asking the people. And if people are not present, basically go to Google, search for your error, definitely you will find. And the main thing is, right now AI is present. You have to leverage AI in order to enhance your productivity, right? And here you can see the thing that we were trying to do manually after running multiple commands is actually done with just one single file and with just one single command. Here it created a Docker default network, here it created a Docker front-end network, front-end service, and here it created a back-end service too for me. When I do Docker ps, here you can see both the containers are up and running, both falls on the same network. How do I validate it? So run Docker network ls, and here if I do inspect on this network, so Docker network inspect followed by the network name. Okay, I will need to correct the spelling. So network, here you can see both the container front end and back end is been managed with that same network. And the wonderful thing is, we don't even have to worry about the images now, because everything is mentioned in this compose file. And see how small this compose file is, but how big impact it is creating, because I don't even have to run multiple commands. All I have to just worry about is just create the compose file once and reuse it multiple times. Now let's say in future I have to use another image, or if I need to use the image with other tag, all I have to do is just go to the compose file, update the image section, that's it, and your compose file is ready to run. And if you just implement git over it, you will have a virtual control over it. So how cool is that, and how good is that, right? Now let's say if I want to remove it, earlier you see on the right hand side there were multiple things that we did. We stopped the container, we removed the container, then we deleted the network. How does things will look like when we do with this compose? So Docker compose down, enter. Here it will delete the network, here it will delete the container, here it will delete the backend and frontend both container. And if I check the validation, it is not even present in the existed state. So that's the reason it will do complete removal and it will complete spin it up. Now let's say if I need that both of that container again, Docker compose up -d, it will again spin up the container, and this is done within seconds. See, within 0.2 seconds it did the thing. But what if I asked you to do that thing again with the help of Docker run commands? You would have done it, but basically it would have taken some time, right? So I prefer Docker compose instead of running manual commands, because here it gave a standard. Here we are able to version control it, and there are multiple things that we are able to do within seconds, right? That's the reason we are considering Docker compose. Now let me just stop the container. So Docker compose down, enter, and here it will delete everything within second, and here it again took 0.2 second. How cool is that? Now again, I know there are multiple things that you have to understand, and that's the reason let's move to third module that will give you more clarity of Docker compose. We are going to follow the same approach, because this is how you will be able to understand, because once you already know how to run the Docker commands, but the only thing that you are facing the issue with is creating the Docker compose file and to work with Docker compose file. Why? Because we are not habituated of that thing, right? We are not habitual of that thing. That's the reason we are creating the compose file and running it, right? So let's move to module number 3. All right, so let's start with the third section, and here we would be dealing with volume. So whenever we are dealing with volume, the very first thing that we executed is MySQL container, and that's the reason we are going to take care of MySQL container in this specific demonstration. So what we are going to do is, we are going to create one volume, we are going to map it, then we are going to run the container, create the database, and that is something we are going to validate with the Docker compose, right? Because here there are multiple things that we are doing manually. How can that thing be automated, can be done in a single shot? That is something that we are going to see with Docker compose. So let's start with the commands first. So docker volume create, and name of the volume is mysql underscore data. So this would be the name of the volume that we would be utilizing. So docker volume ls, here you can see mysql underscore data, this volume is present. So this is something that we would be mapping to the docker container. And what is the docker container? It is of mysql. So let us create the container now. So docker run -d, and we want to map the volume. And what's the name of volume? It is mysql underscore data. We want to map it to /var/lib/mysql, and then we need to pass one environment variable. Why? Because whenever we are dealing with mysql, we need to pass this environment variable. So that is mysql underscore root underscore password, and here the password would be again password space. Then we are done with the volume mounting, we are done with the passing of environment variable. Now let's pass the image, and this time we are going to make use of mysql 8 image, and here it is trying to search for the image. Now if it is not present, it will go to docker hub and it will try to pull it from there. Now let us wait for some time, and once it is done, we are going to create one container. We are going to create one database inside this container, right? And the same volume we are going to create, we are going to make use of in the docker compose, so that here we are going to demonstrate that the data will be persistent when we are using docker volume. The first case scenario is by running multiple commands, but the second case scenario that would be bulletproof would be with the help of docker compose. So here it is downloading the image, and here it is taking some time because it is downloading all the layers. I don't have the mysql image downloaded in my local, that's the reason it is taking this much time. But let's wait, and once it is done, let's start with the further operations. Okay, so the image is downloaded now. Let me run docker ps, and here you can see the container is up and running. Now let's go inside the container. So docker exec -it followed by the container id /bin/bash, and now we are inside the mysql containers. Let us log in. So mysql -u root -p password, enter, and here we are inside the container. We are inside the mysql container. Now let me create a new database. Before even that, I will just show you all the database which are present. Show databases, enter, and here you can see all the 4 schemas are present. We need to create a new database. So create database new underscore data. This is something that we would be validating when we are dealing with docker compose. Let me just run show databases, and here you can see new data is present. Now let's say due to some reason the container that we are working with goes down. So when I do docker ps, here let's say due to some xyz reason this container is deleted. So docker stop followed by the container id and docker rm followed by the container id. Now the existence of that container is no more, it is deleted. Clear the screen. But the one thing that I will be checking over here is whether my volume is present or not. So docker volume ls, and here we still have that data. Now let us use the same with the help of docker compose and check whether the data is still persist or not. But before even that, let me just comment out this command so that it would be easier for us to visualize what actually we are doing. Now I will go over here and I will just create a docker compose file. So docker -compose.yaml, enter. Here let me define the services. So services colon. Now what service that we are working with? We are going to work with a database service. Now through which image that database is created. So image colon space, here we are dealing with the image mysql :8. So this is the image that we would be using. So I will provide the same over here, and here we would be dealing with volume. So I will write volumes, and what sort of mapping we are doing over here. So I will just provide the mapping over here. So basically it's mysql underscore data with where live mysql, the same thing we did over there. And along with that we are going to pass the environment variable. So I will write in environment, and here let me pass the environment variable. And what's the environment variable? It is mysql underscore root password. That is something I'm going to pass over here. So the basic thing is ready, but how do the Docker Compose know that he needs to create the MySQL underscore data volume? So for that, at service level itself, you need to define the volume. So volumes, and here write the name of volume, and here I will be writing MySQL underscore data, and here there is one more thing that you have to define is external true. Why? Because we want to use this specific volume only. That's the reason we are specifically mentioning that external equals to true. So that will go inside it. So external colon true. Now our compose file is ready. Escape colon wq. Now let us run docker compose up. So docker compose up -d, and here it says services dot environment must be a mapping. So there is some issue with the environment. Let us fix that. So here I will just have to remove this equals to, and I will go as an insert mode. Here I will provide one column, escape colon wq. Again I will run docker compose up -d. Here it says image must be a mapping. Okay, db, it should be inside db. Okay, there is a spacing issue, so I will add one space over here, and this goes over here, it goes inside it, this also goes inside it, and volume is at root level. So I think we are good with the indentation. Now let me run docker compose up this time, and here the container is starting. When I do docker ps, here you can see the container is up and running. Okay, the next thing that we need to check is whether the mount is been done properly or not. So that thing can be validated with the help of inspect. So docker inspect followed by the container id, and if I scroll all the way to the up, here we need to search for the mounts, and here in the mounts you can see the MySQL underscore data is actually been mount with the source, and this is the destination that has been provided. Now let us go inside the container, because that's where the actual practical lies. When I do docker ps, let me just go inside the container, docker exec -it followed by the container id /bin/bash. And now let me just log in with MySQL. So MySQL -u root -p password. Here I am inside MySQL, and now when I do show databases, you can see new underscore data is retrieved, meaning our data is safe, and this is done within one single command, that is docker compose up. And that gives us one more reason why we should consider docker compose, right? Because when you want to do the same with the commands, you just have to run it once again, but the thing is you have to run it multiple times. But when it comes to compose, you just have to make sure that you are using just one single command and things will be done for you, right? Exit. And yeah, this was about the third demonstration, and I will just move this file right now itself. So let me just rename it as docker compose to compose file, and this would be named as compose-3.yaml. And when I do ls, and when I go inside compose file, here we have all the three compose file listed in front of us. All right, so that was all about the third module, and I know you still want to do hands-on. That's the reason let's move with the fourth module, where we would be covering everything in one shot. So let's get started with the fourth module. Alright, so welcome to module 4, and this will be very much helpful for the developers, because in a single day, I know you have to do a lot more of development, and you have to build the image, then you have to turn it into a container. Finally you are able to see the changes. But what if I say you that with the help of docker compose, that thing can be eliminated too? Meaning, if let's say at 10:30 you did a development, you created an image, and then you turn it into a container, and then in the logs you were able to see the changes. But what if I say that building and the container creation can be eliminated with the docker compose? Will you believe me? You have to, because docker compose will help you in the same. So for the demonstration of the same, I have a very basic Python application, and let me just show you. So here what it does, basically it will print your environment, right? Here it is expecting for an environment variable, and it runs on port number 5002. So for this specific demonstration, it will help us in understanding the port mounting, second is build, and third is environment variable. So three things will be handled in this specific demonstration. So for the same, I have a very basic Docker file which runs on the base image python 3.yaml 10th line. It is a very lightweight Python based image. We are created a working directory. So this is the place where all the code will be stored. We copied all the coding files into /app. Then we installed the Flask. Finally, we are defining the environment variable, and then we are running the command python app.py that will be helping the Flask application to boot. Right, so let's do the traditional method way. So let me just build an image out of it. So docker build -t app dot. So here it will create an image for me with the reference of Docker file. So if you remember in the previous demonstration, what we were doing, we were pulling image from Docker Hub, but here we want our own custom image. Why? Because the code is ours, right? We don't want to push it to Docker Hub unless and until we are sure about it, right? So for that, this is very much helpful, right? Let me clear the screen and let me show you the image. So Docker images, and here the app image is created. Now let me just turn a container out of it. So docker run -d, and this runs on port number 5002. So let me do the port mapping, and here it expects an environment variable. So env equals to prod, and here I will pass the image. How do I know whether which env to use? Basically, if you go and do a cat on app.py, here it is expecting this key, and the value for this is been provided during the runtime. Let me just run this command again, and when I do docker ps, here you can see the container is up and running. Now let me just inspect the container to see the environment variable, whether it is reflected or not. If I scroll all the way to the top, here I should be able to see env equal to prod, which we are able to. Now let us actually see the container live in action. So let's say I run docker logs followed by the container, and here you can see the container is actually up and running. And now when I just do a curl, okay, on this IP, here it says your environment is prod. Okay, so this is a very lengthier process that we just followed. But what if I can tell you that this can be eliminated with a very minimal effort? How to do it? Let us do actually. So let me first stop the container. So docker stop. Even stopping will take time over here, but with the help of docker compose, it will be very much eliminated. So docker rm followed by the container name. Now let us directly move and start creating the docker compose file. So here I will write vim docker -compose .yaml, enter, and here I will need to define the services. So services, enter, and here I will write app, the name of the service, and here instead of writing the image, we want the compose file to build it from the docker file which is present in the current place at the root. So right, I will write over here build, and I will help him with the context. So it is the current place where my file is present, enter. Now what I want to do, I want to do the port mapping. So I will write ports, enter, and it should be inside this. Okay, enter, and here I will define the port, and here it will run on port number 5000. We are doing the port mapping from the host and container, and here I will enter the environment variable. So environment, enter, and what is the environment variable that we are expecting? It is env, and env value, let's say it is production this time. Okay, now escape :wq cat on docker compose file, and here you can see we have created a very basic yet impactful compose file that will take care of all the things, because here we don't even have to build the docker image. Here it will build the image for us, and here it will run the container for us. So let us run docker compose up -d, enter, and here it is actually building the image for us, and then finally it will turn it into a container. Now let me clear the screen, docker ps, and here you can see the container is up and running. Let us validate the environment variable value first. So docker inspect followed by the id, and if I scroll upward, I should be able to see the environment variable value. So let me just scroll downwards. Okay, I need to go upwards. Let me just do a grab over here. So grep -ia 4 on env, and here you can see the environment variable value is present. Now let us do a very simple task. Docker logs followed by the container id, and let me just do curl to see whether we are able to get the same output as we did earlier. Okay, and here we are getting the output as your env is production, and here it was your env is prod. It is very much useful. Now there is one more thing. Now as I mentioned, in a single day the developer have to do a lot more of development, right? Now let's say in the same application app.py, let's say they have made some changes. So let me just mark it as environment. So environment escape colon wq. Now do they have to do the same thing again? No, here they just have to run docker compose up hyphen build hyphen day. Now what it will do, it will just do the same task again, but this time it will also reflect the changes that we have did just now. Okay, so it is just recreating that container, and they don't have to do the same process again. That thing is eliminated, and that thing is done with none other than docker compose. Let me clear the screen, docker ps, and now when I do docker logs for this one, enter, here I got the ip. Let me just do a curl, and here you can see the changes are reflected. We didn't even created the image, we didn't even created the container, but everything is created, taken care by with the help of docker compose. And that's the very much reason why we should consider docker compose. So yeah, that was all in demonstration 4. I will move this file to the configs. Okay, and I will actually create a folder and share it with you, so that whenever you are doing the hands-on, it would be very much easier for you. So yeah, that was all in module 4. Next module is very much important for you, because if you remember, we worked on data bridge, right? So for the same, we are going to create a docker compose file that will take care of our database, of our front end and of our back end. So see you in the final module, that is module number 5.
Alright, so welcome to the module file data bridge Lite project. So this is something that we have executed in the previous sections, and we know how does things work manually. And if you have gone through the MD file, you are already aware that how did we faced issue to execute those command manually. So these are all the commands that we executed manually, and it actually consumed a lot more time. And also when it was time to wrap up things, it used to take a lot more time, right? So now let us perform the next action work of item, that is, let's do the same with the help of docker compose. So I will be referring this same md file, and I will be referring the same commands that we used earlier for running this application. We are going to create a compose file, and that will literally give you complete idea how to run a 3-tier web application with the help of docker compose. So let me create a new compose file. So docker compose.yml, enter. Okay, and let me just minimize this, and here what I will do for now, let me remove the terminal, and this should be at this side, so I will be able to view the commands and run it parallelly. Okay, so what's the first thing that we did over docker command? Basically what we did, we created a network and then we created the volume. So we are going to follow the same sequence so that it will make sense to you. Okay, so let us create. So the first thing that we define when we are creating a docker compose file is services. Okay, after one dot, just create the network. So how do we create a network? So network and volumes fall under services. So network and volumes falls under services level. So I will write networks, and here I will need to define the network that we need to create. So the name of the network is data bridge net. So let us create the same network. So here the name of the network will be data bridge hyphen network. So this is the name of the network that we would be utilizing, followed by the driver, and the driver that we would be using here would be bridge. So let me just write a comment over here defining the bridge network for services to communicate. Okay, so the network is defined. Now let's move forward and create the volume. So let me just write creating the docker volume for the database to purchase the data. And how do we create volume over here? So we will make use of volumes keyword, and here what is the name of volume that we would be utilizing? It is data bridge db vol. So I will write data bridge db and this would be vol, and let me just rename the network same as the one that we actually used, so it would be data bridge hyphen net. So here we have created the network, here we made use of docker volume, so things are created. Okay, now let's move forward with the services. Now after that, the first thing that we created was the database. Okay, so let us create the database service. So here I will give one space, and here I will define the database service space, and here I will write one comment over here for my own understanding. So here I will write defining the first service, that is the MySQL database. Okay, so let's start with db. So for the database we would be making use of MySQL image, so I will need to define the image, so I will write image, and here the image that we would be using for this specific one would be MySQL colon 8.0, right? The next thing is, whenever you are dealing with MySQL DB, you need to pass few environment variable, you need to do the port mapping. So let's do the same. So here I will write environment, and here the environment would be MySQL underscore root underscore password, and the password would be again root. And if you remember, here we passed one more variable, and that is actually defined in the docker file of the db. So here I will go into the db, and here in the docker file, if I'll just bring it over here, and here we are using MySQL database. So I will need to define this variable too, and the variable value is app db, so I will pass this to. Okay, and once this is done, docker file work is done. And now let's move forward with the next thing, that is persisting of the data. And here we made use of volume, so let me define volume. So volume can be defined as volumes, enter, and here we need to do the port mapping, here we need to do the volume mapping. So here we are doing the volume mapping from data bridge db vol. Okay, and this will be done to /var /lib /mysql. And the next thing is, if you remember, here we wanted one more thing. So whenever we are creating the MySQL container, the first thing that needs to be executed is this init.sql, which is responsible for creating the database, and then it is selecting the db, and followed by it is creating a table name messages for us. So how do we define it? So that thing needs to be defined in the volume itself, and here this is how you define it. So here, since that init.sql is present inside the folder named db, I need to provide the path. So here I am providing the paths, enter, and here I will write init.sql, and this needs to be mapped with the entry point of docker. So docker entry point init.sql, init.d, and init.sql. So what it will do, it will actually take my SQL and will move it to the entry point. So whenever the container is pinned up, it will make sure that the database and the necessary tables are created. Okay, now once this is done, the next thing that we need to do is, volume mapping is done, we need to define the network in which that db will work. So the network will be data bridge hyphen net. So now basic things are done. Now let's move forward with the next service. And what's the next service? It is nothing but the backend. And let me just define the service name over here and make sure that it follows the indentation. So I will make use of a single space, and this should follow in the line of db. So I will write this as backend, enter, and here what I will do, I will again make use of the docker file that is actually present inside that folder. So I'll go over here, and here we have the docker file, and if I just move it over here, it will make sense for us. But for now, let us make the let us take the example of the commands that we used. So what's the first thing that we need to do? We need to build an image out of it. So I will write build, and here it will be builded through a docker file. That's why I am writing build.backend. So that is the name of the folder where the docker file is present. Next thing, enter. After building, what we did, we ran it into the background. We named the container as API server. So here, if you want to give the name to the container, you can just write container name, and here I will write it as API server.
and I will give this name to the container. And again, this goes same for MySQL DB too. So here, if you want to give the name to the container, I will make use of this keyword, that is container underscore name, and the name of the container as per this command is MySQL-DB. Okay, container name is given. Let's move forward. And what's happened over here is we made use of network. So I will need to define the network. So I will write networks, and what network to use? It is data bridge net. Okay, next thing, let's move on. After network, what we did, we made use of port mapping. So I will do the port mapping over here with the command ports, and here I will be mapping 3000 with the internal port 3000. So let me just change this to 3000 to port number 3000. Now once everything is done, the next thing that we need to do is we need to define the environment variable. So let me just write environment over here, and I will pass all the environment variables. Okay, colon, enter. Now what are the environment variables that we have? That is db host and the host value. So I will just press a tab because I am getting the emit. I will just correct the values which are used into this command. So the DB host value is MySQL DB, the DB user is root, the DB password is again root, and the DB name is appdb. So that thing is done. And if you remember one more thing, while we were restarting the container, we wanted the backend to wait for the database, right? So for that, you need to define one more keyword, and that is nothing but depends on. And what we are doing over here is we want it to wait for the DB to initialize first, and once the DB is ready, then only it should proceed forward. And there is one more thing that we need to define over here is that is nothing but health check. But how do I know what things to use in the health check? So for that, I will make use of the documentation. So here, let me just open Docker Hub. So Docker Hub compose health check, and here it will show me all the services command that are used. And here in the left hand side, you can see all the commands and all the keywords that we are using. If I scroll downwards all the way to the bottom, I will need to search for health check, and this is something that we would be utilizing. Let me just make use of all of these commands. So I will just make use of this. Just give me a moment. I think indentation is not correct. So environment variable defined, this will fall at environment level, and this will also go to volume level. Okay, now let us make use of health check. So I will write health check over here. Now what we need to do, we need to run some ping commands whenever the MySQL container is up. So for that, what I am going to do is I am going to run a cmd command. So I will just write test colon cmd MySQL admin ping -h localhost. So what it will do, it will actually ping MySQL, and basically the interval would be 10 seconds. We have to wait for 10 seconds for the MySQL to initialize the container, and the timeout that we have defined is 5 seconds, and the number of retries that we want to do is basically 10 times. And also we will define a start period, and that start period would be 10 seconds this time. So basically the number of retries we would be doing, so basically we will just give him a startup period time of 10 seconds so that everything is healthy, and based on that the backend will be initialized. So once the DB is ready, then the backend will be ready, and then the application will work fine. So let's move forward. And the next thing that we need to do is whenever we are saying that it will depend on the DB, that is this one, the next thing that we need to do is we need to define the condition on what basis we are telling him that it should wait. Basically it needs to wait for the database, but the condition is the service should be healthy, and then only it should proceed forward, right? So that is also mentioned. Now I think the database, the backend is ready and the database is ready. Let's start with the last one, that is the front end. And here I will write the comment for backend to I will write initializing the backend service that will connect the MySQL database and serve the API endpoints. Okay, done. Now let us defining the front end and service that will be serving the page to the user. Okay, now how do we define the front end? So basically you just have to make sure that you are following the indentation, and that's the very reason I made use of Visual Studio Code, because this will give me the clarity what actually and how much spaces I need to make sure whenever I'm writing the file. So I will write front end over here. And what's the name of front end? So basically this would be the service that we would be using. And again, what file I will be making use of. So basically there is a file in front end folder
I can show you. And here is the Docker file that we need to make use of. So I will again go back, and here I will give him the build context space build colon space dot front end. So this is the place front end. So this is the place where the Docker file is present. Now I want to give it a container name. So what is the container name as per the command? So we gave the name as data bridge front end. No, the name of the front end is web UI. So I will give the name as web UI. Next thing that we need to do is we are doing the port mapping. So I will write ports over here, and here the port mapping will be done for port number 8080 to port number 80. And then the next thing that we did is we defined the network. So I will write networks over here. The network that we created is data bridge net, and again on what service the front end is dependent on. So it is dependent on backend, and the condition should be it should be started. So right now everything is ready. Let me just go through it once again so that we won't make any mistake. So let me go through the commands once again. What we did, so basically we were supposed to create a network. So we defined the network, and also we defined the type of driver that we want to use. We defined the bridge network. Then we wanted to create the volume, so we created the volume by the same name, that is data bridge db vol. And then we proceeded with creating the database. For the database, what we did, we mentioned that we want to use MySQL 8 image, and then we wanted to name the container as MySQL DB. So that's the reason we made use of this keyword. And followed by we wanted to give the environment variables during the runtime, that is MySQL password and the MySQL DB, which are actually required for the backend to run. And then for the volumes, what we did the volume mounting for the volume that we created, that is database db vol with where libs equal. So whatever data we are going to store, it will be stored in this volume. And let's say if the backend goes down, if the services go down, whenever next time we are spinning up the service, it is actually been ready for us, it is been persistent. Next thing what we did, we basically gave him the initialization script to run during the entry point, so that whenever we are spinning up the container, it is already creating the database and the tables for it. And then finally we defined the network, because we want to keep everything under single network to provide the isolation. Next we defined the health check. We wanted it to try out for 10 seconds, and basically that's the reason we defined the health check over here. What health check will do, it's just basically a ping command that it will ping the SQL server, and once it says that the service is healthy, then it will proceed forward. Then we proceeded forward with initializing the backend, and the backend Docker file was stored in the backend folder. That's the reason I defined the path. Then what was the container name? We made use of API server in the command. That's the reason I gave the name of container as API server. Then the network that we were utilizing was database network. We did the port mapping, followed by we defined the environment variable, and then we defined the condition on which the services is dependent on, that is database. If database is not ready, the backend should not get created. That's the reason we defined that it is dependent on DB, and on that condition that the service is healthy. Then we defined the front end. We build the image which is present in inside the we'll build it the image with the help of Docker file, which is stored inside the front end folder. We name the container as web UI as given in this command. Then we define the port number, that is port number 8080. Then we define the network, and then we define the condition depends on backend, and once the service is started, then the front end is good. Now we are ready with the Docker compose file. Let us run the legendary command, that is docker compose up -d. So docker compose up -d. Now what it should do, basically it should allow to create the MySQL DB. It should do the volume mounting. It should create the network. Once everything is ready, then it should create my backend. Then once the backend is ready, then it should initialize my front end. Now here you can see, based on all the conditions that we defined, it actually created each and everything. We didn't even have to do any manual thing. Now if I just do docker ps, you can see all the services, the 3 services should be up and running. Here port mapping is done. Here you can see again port mapping is done. Here container name are also defined, and things are good for us. Now one more thing that we need to verify is the network. So docker network ls, and now here we have the data bridge lite network created for us. When I do docker network inspect followed by the network name, here you can see all the 3 containers are actually inside that network. So meaning the data is persistent, the all the things are in single network, we provided isolation to our application, and the next thing that we need to verify is the volume. So docker volume ls, and here you can see data breach light volume is present for us, and that's all for now. Now let us do the hands-on. Let us see how does the application looks like. When I press enter, here I will write hi. I will again press this is before compose down, and when I submit, everything is working fine. If I just refresh, when I click on fetch all data, it is fetching the data for me. Now let me just do docker compose down, enter. Now what it should do, it should stop my web UI, it should stop my backend, it should stop my MySQL DB. But the condition is, what will happen if we just respin the services once again? Will I get my these data back? If I just refresh now, the site is down. But what if I want all the data back? Let us test the same. So when I do docker compose up fnd, it should actually spin up my container, and believe me, this time the container spin up will be done immediately, because the layering and caching things are working at the backend. And here you can see within 6 seconds my services are up. If I go to the right hand side and if I do refresh, the first thing that I actually wanted to do is I want to verify whether my data is still there or not. Let me just get that data, and here you can see even after I did the respin, my data is back. Now if I just type a message, this is after compose up restart, it is actually working. I hope this video made sense to you, and this gave you the clarity how to write the docker compose. We literally covered 5 example, and now I believe it will literally give you the idea how to write compose file for any application. Because if you are clear on docker, if you are clear on how to create the commands, right, then you will be definitely clear on writing the compose file. The main issue that you might face is basically the indentation issues, but don't worry on that. You have docker docs, it is very wonderful. Even I take reference from this, so there is you don't have to worry about that you are not able to write the YAML files. It's just like there are some indentation issues that you will learn over the time. Right now the only thing that you should focus is to create and build the application, containerize it, write docker compose, and that's it. And once this is done, I am pretty much sure after doing practice you will be definitely able to create a wonderful docker compose file. So yeah, that was all in this video, and I believe after this video you will be master of docker compose, right? So that was all, and I will see you in the next one. Till then, keep learning, and thank you very much. Hello everyone and welcome back. So in this video we are going to talk about multi-stage docker file. We already are aware of how to create a docker file, but in this specific section we are talking about how we can optimize a docker file. And here we can optimize a docker file by adding multiple stages into it. So let's get started. So what actually is a multi-stage docker file? So the name only suggests there will be multiple stages in that docker file, right? So a multi-stage docker file is a very clever way to build small, secure and efficient docker images. Now if you're someone who is very concerning about the size of the images, then this video is for you. Now let's imagine that you are just printing a hello world message using Python, right? And the image that is created is of 800 MB. Now you might be wondering, I am just printing a simple hello world message, I am just echoing it, I am just printing the things on the console, why it is taking that much of image size, right? So in order to optimize that image, we will make use of docker multi-stage docker, right? And that's actually will help us to create an efficient, a tiny image that will be able to do the job. So with multi-stage, you basically use multiple from statement, and each from statement will start a fresh stage. So it will be just like borrowing the piece of code from stage A and utilizing in stage B. Now let us take an example. Now take the example through this image. Right now let's say you are in a restaurant and you ordered a dish, right? So it is basically divided into two sections, where the production stage is the place where you are sitting, and the bill stage is the place where the chefs are cooking the food for you, right? So once you order a dish, the dish will be presented over here in the stage 1. Here they will be peeling the things, here they will be preparing the dish, and once everything is ready, the final dish will be presented over your table, right? That is how multi-stage docker file works too. Here we will be using multiple from statement, where the work will be divided into two segments.
builders and runners, right? So builders are the one who will be just doing the installation work, and the runners are the one who will be actually serving the things. For example, let us say that you are using a node based application, right? So all the npm install commands will be ran into the builders, and all the serving commands will be executed into the next stage, right? And that is how multi-stage docker file works, and that is how we are able to optimize the image by reducing the size, by reducing the number of layers, right? As we are already aware, the number of lines that are introduced into a docker file, the number of layers are increasing, right? Here we are actually optimizing the image by reducing the size of the image, and this will actually help us to build the image and reducing it so that we can actually deploy it faster, because if the image size is small, then it would be very much faster for us to do the deployments. Now let us move forward. Now here again I have given one more analogy of the kitchen. Now think of multi-stage is like a professional kitchen where it is divided into two stages. The first stage is the preparation station, where all the knives, peeler and bulky machines are ready to prepare the ingredients, and second stage is the serving plate, where you only take the finished dish and put it into a clean plane to serve the customer. So you don't bring the peelers and the bulky machines to the customer table. All you care to bring is the final product. So why we should use multi-stage docker file? So the very first advantage of using multi-stage docker file is the size. So here when we are using the standard docker file, the size is massive, it includes all the tool, but when it comes to multi-stage docker file, it is very tiny because only the app binaries are used. Second is security. Why? Because there are many attacking vectors that are present when we are dealing with a standard docker file, but since when we are dealing with multi-stage docker file, there are very minimal things that we are actually serving outside to the world. Now third is build speed. Now since we are dealing with standard docker file, there will be caches that will be helping us to do the job, but again it will be slower. But when we work with multi-stage docker file, it will be very much fast and efficient. Now when it comes to CI/CD, there will be complexity while handling. Now when I say complexity, it will be just like you have to load that bulky docker image, but when you are dealing with multi-stage docker file, all you have to carry is just write the CI/CD pipeline and write the image name, and it will do the job. Because the image is very lightweight, it would be easier for you to do the deployment, right? Next, here I have prepared 5 examples for us to understand, but before even we jump into the examples, let me go all the way to the bottom, and here I will tell you the pattern. Now this is the cheat sheet for multi-stage docker file that no one will tell you. So here what are the pattern that we are following? Basically, let's just put it into 2 stages for now. Stage number 1 will be responsible for building the application, and stage number 2 will be responsible for running the application. So what we are doing here over is, here we will be defining the base image. Now here you can define literally multiple from statement to reduce the build size, right? So here we would be making use of 2 from statement, where here one would be acting as a builder and another will be acting as a runner. So what we are doing is, let's say we are working on a node based application, because why I am giving example of node every time, because that is something that consume lot more time, lot more space on the device, right? So let's take an example where you are dealing with a node based application and you are running npm install, but after that is done, all we have to do is to serve the static files, right? So that serving part has been done by the second stage, and npm installation will be done by the stage 1. So what it will do, here we will make use of s. Now what this keyword suggests, basically we will be referring the stage 1 into stage 2. So whatever npm install refresher has been done, that would be refreshed, that would be taken here as from the builder. So here we will be write ---- from, and what it says, basically copy all the refresher file from the stage 1, and that's the reason we defined an alias over here, right? So it will take all the reference file and then it will copy it to the second working directory, that is /app, and then finally it will serve the application and life will be good, image would be optimized, right? So enough of the theory, let's get started straight with the practical. Let's start with the very basic, the fifth example, that is Python application. Now what exactly is inside this Python application? It is a very basic hello world program that we would be printing. The only thing that we have to observe in this entire demonstration is how we are actually writing the multi-stage Docker file. Second is we need to notice the differences in the sizes, right? So I will be running the Docker file, and also I will be running the optimized multi-stage Docker file, and then we are going to see the Docker images and the differences in the size, right? So let's get started. Okay, so let's start with the Python application. So let me just take you with the overview what actually is present inside that Python app. So here you will find one Python file, that is app.py, that will just print hello from Python app. Okay, and secondly we have a Docker file where we have defined the base statements that we usually do. So what we did, we defined the base image, then we defined the working directory, that is /app, then we copied all the files, that is whatever is present in the current context, and then we are installing Flask, and finally we are running the application. This is the standard way, right? So let me first run this application. I will open the terminal. Let me just start my Docker service. Okay, and here once the service is started, we will start with the actual hands-on. And here one more thing I wanted to pinpoint is whatever operations we are going to do is already documented in all the directories. All you have to do is just go inside the directories and search for the readme.md. Let me just show you. So let's say if you are working with Python app, here you will find the readme.md specific to Python. And let's say if you are working with Node app, here you will find the instruction, the readme.md file present in that subdirectory. So let's just focus on the existing file that we are doing, right? So in the current file, what are the problems in this approach? Here we will be using the entire Python image. That will cause large size of the image. There is no separation between build time and runtime. Now remember, whenever you are dealing with multi-stage Docker file, you are dealing with stages. And what sort of stages? Build stage and run stage. So, and the third is unnecessary files may be included, and that's the reason it may cause some security issues, right? And fourth is it is not optimized. So let us first see the image size. How much size does it shows when actually we build the image out of it? So I will open my terminal. Let me clear the screen, and here I will run the command docker build -t python app dot. Now let's wait for some time, and once it is done with building the file, the first thing that we are going to check is the size of the image, because that is the main agenda of this video. Because why we are optimizing Docker images, right? Because the image size is high. In order to reduce the size of the image, we are optimizing the Docker file, and that's the reason builder and runner stage come into picture. So let us wait for some time, and here it is working with multiple layer. And if you remember, how many statements are present over here? 1, 2, 3, 4. So here you can see the numbers are also present. It is layer 1 of 4. So it is right now still pulling the Python base image, and that image is heavy. That's the reason it is taking that much of time. It also depends upon your internet speed, but basically Python image is heavy. That's the reason it is taking that much of time. Okay, now it is still pulling the base image. Let us wait for some time, and let us see how much time will it take. Now once thing is done with the standard Docker file, what we are going to do, we are going to switch into multi-stage Docker file, and then we are going to rerun the same command. We are going to create a new image with the new optimized Docker file, which consists of multi-stages, and then we are going to see the difference. How does it looks like? So all right, let us wait for some time. And it will definitely consume a lot more time, because believe me, if you are using multi-stage Docker file, it will definitely help you out with these things. Now let's imagine if you're deploying something. Since it is a very basic application, it will build instantly. But even we are printing, even we are dealing with a hello world application, it is taking that much of time, right? Here you can see it took nearly about 1 to 2 minutes. Again, we have to wait for some time. But if you're dealing with multi-stage, life will be very much easier for us. Okay, so here right now you can see it is installing Flask, and now images is ready. Let me clear the screen, and now when I run Docker images, you can see the size of file. It is 1.12 gigabytes. right? And which file we are dealing with? We are just dealing with a very basic hello world file, right? And for that, this size is not justifiable. Now let us change the things. Let me go to the MD, and here I have defined the multi-stage Docker file. Let me just copy it and I will explain you what things we are doing. So here we have defined two stages. One is builder and second is runtime. In the builder, I have defined the image, right? And here you can even use of a very heavy image because it will just used for the reference. Then we define the working directory. We copied the app.py. The initial thing is done. In the stage 2, what we are doing, we are copying everything from the builder into the slash app, that is working directory, and finally we are running it. Let me just remove the current files from here, and now let me rebuild the images this time, and this time I will name this as python app2 dot enter. Now let us wait and let us see what magic does multi-stage Docker file does into this Python image, right? Now here you can see it is working with stage number 1, and step 1 of 3 is been in process. So once it is done, we are going to run Docker images, and then we are going to see the actual result, and that will be something that we are actually looking up to. Now you can see the staging is done. Now it is working with the builder stage, right? And now it is exporting the layers, writing the image, and now the image is ready for us. Now let us run docker images, and here you can actually see the huge difference in size. The first image that we made use of was of 1.12 gigabyte, but again the second image that we created with the optimized with the multi-stage Docker file is just of 55.6 MB, and that is the reason why you should consider multi-stage Docker file in the very first sense. So here if you go through it, here you will find all the explanation line by line. So here we made use of a builder, the base image, that is python 3.9 slan. It prepares the application, and in the runtime it even uses the smaller image. It copies all the required file from the builders and exclude the unnecessary build dependencies, and that's the reason we should use it. Now why we should use multi-stage Docker file? It reduces the final size of the image significantly. It improves the security by removing unnecessary components. It keeps the Docker image clean and production ready. And fourth and not the last, that is faster deployment and faster pull time. So yeah, that was all in the first one. Let's start with the node application, because here is where you will understand this stage Docker file clearly. Alright, so let's start with Node.js, and let us go with the overview of the application. So what this application does, it actually prints a hello world message, and secondly it runs on port number 3000. Now what all files are involved in this activity? First is package.json, which is used for installing the dependencies like Express. Second, we have app.js, which creates a simple Express server, and here we have the existing Docker file, which is the standard one. So what it does, basically here we have defined the a base image, that is node 18. Second, we defined the slash app, the working directory. We copied the JSON file, and then we installed the dependency using npm install command, and then finally we copied all the coding file to the current working directory, that is slash app, and then finally we started the server, right? What are the issues with the current Docker file? It uses full node image that is of huge size, right? Instead of that, we would have made use of an Alpine image, that is comparatively very lightweight image, right? It installs all the dependencies including unnecessary ones. Third is there is no separation between build and runtime, and fourth, slower builds and heavier images. Now let us first try to build the image. So docker build -t node -app dot enter. Now it will again try to build the node application for us, but here we are making use of the standard file. So let us see how does the result look like. So here all we are interested is the size of the images, right? Here there is no stage which is defined over here. It is a standard regular Docker file, right? So let us wait for it to create the image for us, and once the image is created, we are going to actually view the size, and then finally we are going to update it with the multi-stage file, and then we are going to compare the results, right? Okay, so the image is ready. Let me run docker images over here. So I will run it over here. Docker images, enter. And here again, the size of the image is 1.1 gigabytes, right? Now let us update it with the multi-stage docker file. Okay, all the files are already present in the MD file. All you have to do is just go through it, learn from it, and then execute it. So here what we learned, basically the image size is larger, the security is lower, and the performance is again lower. But now let us see the same with the help of docker multi-stage file. Now let me just explain you what actually is happening over here. Okay, now if I scroll down here, you will find here we have defined it into two stages, builder and installer. The runner, the builder does, it installs the production dependencies and keep the builds isolated. Now what runner does, it copies only the required modules. It is a lightweight image, and this is the final image, which will be very much smaller, right? And here you can actually see the differences in the file, right? I already have pasted the output for your reference, so whenever you are reading the documentation, it would make sense for you, because this is something that is very important for you. So let me go over here and replace the current standard docker file with multi-stage docker file. Now what we are doing over here, we have divided in the image into two sections. First is builder, where we made use of as. Now this alias is actually been referred into the second stage, and that's the reason we made use of as keyword over here. Secondly, now let's say if you want to refer something, then you need to tell from what destination it is coming from, right? That's the reason we made use of the option hyphen from. And from where it is coming, it is coming from the first stage. That's the reason we made use of this alias over here, right? And then what we did, in the first stage, we created a working directory, we copied the package JSON, and we did the npm install for production, and then we defined the runtime. Okay, and here we made use of the Alpine image, and here if you can see, here again we made use of the Alpine image. It doesn't matter if you're using an heavy image in the first stage, because at the end the final image that would be referred would be from the second stage. So here we made use of Alpine image, then we created the working directory, and from the builder we copied all the files which are present in the app modules and we pasted into the current one, and then we copied the app.js, the coding file, the static file, and then finally we executed it with the command node app.js. Now let me just rerun the command and let us build the file once again. I'm clearing the screen, and then I will run docker build -t node app 2 dot. Okay, the system is running slow because I am actually running out of RAM. That's the reason. Okay, so I'm typing docker build -t node app 2 dot, and this time it will build the image with the help of multi-stage docker file, and here we are going to verify the size again, right? So if you are just going through the documentation, that itself will give you the clarity how things are working. But if you want to actually understand what is the meaning of that docker file, then feel free to continue this video, because here I am actually explaining you how does that image is builded, right? Now again I will explain you this same image again, because this will make sense for you. So here we have defined the base image node 18 Alpine as builder. Now here we are using it as an alias, which we are actually referring in this second stage. Second, we defined the working directory, we copied the package JSON, and then we are running npm install command. Now we defined the second stage, we created another working directory in the second stage, then we copied everything from the builder, and what we are actually copying, we are actually copying the node underscore module files into the current working app directory, and then we are copying the app.js from the current place to /app, and finally we are exposing the app, the port number, and finally we are running the server, right? And that is how this multi-stage file is working, because here we have defined two stages, one builder, one runner, and this will help us to optimize the image, and that is how we are actually trying to reduce the size of image. Let us wait for some time for the application to build, and once it is done, we are going to again run docker images, and we are actually going to see what is the actual difference in the size. All right, so the image is built it. Now let me just run 1 second. All right, now let me just run docker images over here. Docker images, and here you will see the actual difference of the node image before and after. So it is taking some time because my RAM is really messed up right now. Okay, so here you can see the actual difference. Okay, the previous output, it generated an image of 1.1 GB, but the right now the current optimized image is of 128 MB, right? So yeah, that was all in this demonstration where we actually have gone through the node based application. Now wait, I have again few more things into my bag that I want to show you. So let's move with the third module. All right, so let's start with the third module, and this is nothing but a Java based application. So what it does, basically it prints hello again. Now here it is built with the help of Maven, and it generates an executable jar file, and where the file is stored, if I just show you to over here, it's stored inside src main java com example, and inside that you will find the main file which is responsible to print hello from Java, and this is a docker build file, right? And here we would be referring pom because here we are going to make use of Maven, right? And here we have the basic Java, the docker file written for us, which defines the base image, which have the working directory. It copies all the files and folder, then runs mvn clean package, and finally it actually generates the jar file for us. It executes the jar file for us, and then we are able to see the result. Let me create a docker file for it directly. So docker build -t java -app dot. So meantime it is building. Let us go with the md that we have created. Now what it is contains, basically it contains a pom.xml which defines the Java version, build configuration, and jar package. So here we have the docker file, and post that here it says what are the issue with the docker file. Here it says it compiles code inside the runtime here, because since we are not utilizing multi-stage docker file, here it is not able to define the build stage and the run stage. It includes unnecessary build tools, it is larger image, and it's not production ready. Now why we should consider multi-stage in this case? Because here first we would be using Maven, and second we would be only using jar. We will be only we are only going to run this using jar, right? So here the multi-stage helps us to separate the build stage with the help of Maven, and the runtime with the help of Java runtime environment, right? Now again, here we have the multi-stage file with us, and here we are using Termurin as the main base image. Why? It is very much lightweight as compared to the one that we are using in the standard one. Then we define the work directory, we are copying the pom.xml responsible to build the Java application, and then we are copying the source, and then we are running mvn clean package -descript test because we don't want to run the test cases, and this is something which is unnecessary whenever we are building it for the final time. Then what we are doing, we are copying, we are creating one more stage where we define one more from statement, and here what it says, we are making use of Eclipse Termurin 17 Java runtime environment image. Then we are using then we have defined the work directory, we are copying everything from the builder, and then we are copying it to the source, and then we are finally running it with the help of the jar, right? And then let us see the image difference. Now when I run docker images, here you can see the size of the image is 535 MB. Now let us update it with the latest multi-stage docker file. Let me replace the file entirely, and now what will happen if I rerun the same command, but this time I will write 2 over here, and let us see the magic, how much, what is the difference between the size of this image, right? Let's wait for some time, and once it is done, we are able to see the difference actually. And what actually would be the difference? Basically the first image that is created, the first image that is actually generated, it is of size 535 MB, but again the second image that we would be generating, it will be nearly about 289 MB, again literally half. Now what we are actually using here, we have defined two stages, builder and runtime. Here in the builder we are using Maven, and in the it builds the jar file and it handles the dependencies, and then in the runtime we are using the lightweight Java runtime environment image. It only copies the jar and no build tools are included. So what are the key takeaways from this exercise? Never mix the build and runtime. Always use Maven for Java based project. Use multi-stage for smaller and cleaner images, and production images should contain only runtime essential. So let me go over here, and then we are going to run Docker images, and then we are going to see the actual result. What is the difference in the size of the previous one and the current multi-stage Docker file? All right, let me clear the screen, and now we are going to run Docker images, and here, ladies and gentlemen, you can see the difference. Java app is of size 535 MB, and again Java app 2 is of 289 MB, right? That was all in this demonstration. Now let's move forward and learn about how does React works when we are implementing multi-stage Docker file entity. So let us move to module number 4. Alright, so let's start with the module 4, and here the module 4 is basically dedicated to React application. Here we are again making use of a standard Docker file, right? Let me just run the docker build command. So docker build -t react -app thought. Now what it does, here we have defined the base image, we have defined the working directory, we are copying all the static files to the /app, then we are running npm install, and then we are building it, and finally we are starting the server. And this is basically running the React server for us, and we are able to view the application. Right now, meantime, let us go and see the what are the issue with the current Docker file. Here there are images which is larger in size. Here we are making use of node full image in the runtime, which is the first mistake. Second, it is development mode in production. Npm start runs a dev server and it is not optimized for production. Third is there are no separation corners, built and runtime are not defined, and there are unnecessary dependencies which are actually which we are installing in the final image, right? That's the reason we should consider multi-image in this case. Here we will be building the React application. There will be two stages. In the first build stage we will be building the React app, and in the second runtime stage we would be serving the static files, right? So simple analogy, cook in the kitchen and serve the final dish. So let me just see the actual difference, and the difference that you would be seeing in this one would be the React app will be created of 1.34 gigabytes, the base standard Docker file which is written. It will create the image of 1.34 gigabyte, but after when you optimize it with the help of multi-stage Docker file, the size will significantly reduce to 6.7 MB. Let me copy the entire multi-stage Docker file, and now once the build is done from here, we will proceed forward with building the multi-stage Docker file for React app. So here let us see what things we are doing differently. So the first thing that we are going to do over here is we are actually taking a very lightweight image, that is an Alpine image. We are defining it as an builder. We are making use of alias. Then we are copying the package.json inside the working directory, and we are running npm install. Once everything is done, we are copying all the static files and we are running npm run build. And secondly, in the second stage, we are going to serve it with the use of nginx. Here we are going to again make use of a lightweight nginx Alpine image, and we are copying all the files into /user/share/nginx html. We are exposing port number 80 because this is the place where nginx works, and then finally we are running nginx server, and we would be able to see the differences. Now if I go back over here, it should finally build the image for us, and once it is built for us, then we are going to see the actual result. Now let us optimize this image with the multi-stage Docker file, and let me just rebuild it again. And now let us see how does the difference looks like, right? So docker build -t react -app -2 react app 2 dot, because we are going to make use of the same Docker file. It will again start the process, but this time just note what is the size of the image, right? Here I'll mark this as 1.34 GB. Let it build the image for us. It literally took a lot more time than expected. Now let me just run docker images and validate the size over here, right? So here you can see the significant drop in size. The earlier image was of 1.34 GB, and after, when you use multi-stage docker, it actually got reduced to 62.7, right? So this was about React. Now let us wrap up the session with the fifth and the final module, with Go. So let's start with the final module, that is module number 5, where we are going to use and implement multi-stage Docker on Go based application. Now here is a basic Go application which prints hello from Go. So this application is written in Go. It compiles into a single binary and prints a very simple message when executed. So here you can see the existing Docker file that we would be utilizing. We made use of from statement where we defined the base image, we defined the working directory, and then we copied all the files into /app, and then we executed the run command go build -o app, and then finally we executed the command. Then what actually is the issue over here is, here it uses full Golang image, which is nearly about 1 GB plus. So let us first build the image. So docker build -t go-app dot. Now here it will try to build the image out of the Docker file. So until the time it is taking time, let us move forward. Now here what actually it is doing, it is using unnecessary tools in the final image. So Go compiler is present even during the runtime, and there is no separation between build time and runtime. So everything happens in one single stage. That is another issue in this Docker file, and it is not production ready because it is slower for deployment, and security risks exist due to the extra tools. So here we will make use of again multi-stage Docker build, and what we are going to implement, we are going to implement Alpine image first of all, because here only the lighter weight image of Go will be used. We defined the build stage and the running stage, and then once we copied the main.go file instead of every file, we are actually building it, and then finally we are using Alpine image, the minimum runtime image, and then we are finally taking the cached from the build layer, that is from this, and that is from the first stage, and then finally we are copying it to /app, and then finally we are executing the application. And here let me just explain you line by line whatever we did. It uses Go application and compiles the application, it produces the binary, and during the runtime it uses a very small Alpine image, it copies only the combined binary, and then no Go compiler is present. So that's the reason we should use multi-stage, multi-layer into the Docker file. Now in the final image it becomes very much more, nearly about 8 MB, and it is very fast to pull. It reduces the attack surface, and it is cleaner, and it is production ready. That is the reason we have implemented multi-stage over here. Now what I will do, I will copy the multi-stage file, and then we are going to update it into the existing one, and then finally we should go to inspect the changes into the sizes of the file. Now here you can see it is still in building phase. Once it is built, we are going to update the Docker file, and we are going to actually experience, we are going to witness what is the difference between the standard Docker file and multi-stage, multi-layer Docker file. Alright, so the image is built now. Let me clear the screen, and if I do Docker images, let us witness the size of the original image, and here it says it is of 849 MB. Now when I change this file from standard file to Docker multi-stage Docker file, let us see what would be the differences look like in the image sizes, right? So I will just mark it as Docker build -t go app 2, and this will actually build another image for us, but this time it will be with different size, and let us see what is the actual difference. I hope you are getting what we are actually trying to do. We are actually trying to reduce the size of image, and that will actually help us in multiple ways, right? Specifically when you are pulling that image, since the size would be very less, it would be quick pull for you, right? That's the reason we are doing these many things, right? So once this is done, we are going to see and witness what the changes look like, right? So also one more thing that I wanted to mention is, all the things that we have done so far is already documented into sub repository number 16. from the starting itself, everything is present over here, and whatever codes we executed is already present over here. All you have to do is just go inside that specifically sub repository, and then you will be able to get the files along with the explanation. Here I have provided the standard Docker file that you can run and see what actually the image size looks like. And if you scroll all the way to the bottom, you will find a multi-stage Docker file in all the readme emd, so that you will be able to just execute it, because you already understand how to write a Docker file. It would be very much easier to catch up the things. Right now, that was all in this video. Let us wait for this to complete. Meanwhile, let me close my Chrome tab, and let us wait for this one to complete. We are going to run Docker images once again. Once this is done, we are going to compare the file size, and then we are good. Right, so the image is also builded, the optimized one. Let me clear the screen, and now let me just validate the changes by running docker images command, and here we should get the changes. And here you can actually see the difference. The original image size was 849 MB, and it now got reduced to 10.6 MB. Right, so yeah, that was all in this video, where we learned about multi-stage Docker file, how to create it, what all things that we have to keep in mind. Right, that was all in this video. So this video will give you, this video have gave you the clarity how we should deal with multi-stage Docker file and why we should consider it. Right, so yeah, that was all in this video, and I will see you in the next one. Till then, keep learning, and thank you very much.
Now let's say you are done with the development, you are done with the testing, you perform some utility, that is unit test during development, and it got passed, and everything looks fine to you when you deployed it, and it actually worked in your server. But now you need to share it with people. Now how will you share your image to someone? Now basically there is one method through which you can actually share the image from your local to someone else's. It would be from your drive. And how do you create a tar from your Docker image? So it will be just like, let's say I have one Docker file, Docker image right now over here. When I do run Docker images, you can see I have a BusyBox image over here. So here you will just make use of Docker save. Now what Docker save does, it basically creates a tar out of your Docker image which is present. So I want to name that tar as busybox.tar and followed by the image ID. So basically you can even write the image ID, or even you can write the complete image name. Now when I do ls, here you can see busybox.tar is present for me. Now what I will do, I will just delete this. So docker rmi followed by the id clear. When I do ls, I have this tar file. And what you did, you just copied this tar file into USB and shared it with your colleague. Now when he wants to load it into the system, how will he do? Basically he will again make use of docker load. So docker load -i for input, and the input would be from this busybox.tar. When you press enter, okay, here there is one more context which is required. So docker load, the spelling needs to be corrected. Okay, now here it says that the layer has been loaded, and it loaded the image busybox latest. When I do docker images, you can see the image is present. So this is one way through which you can just share your Docker images. Now here we are considering your own application, and you wrote your own Docker file, and that's the same image that you want to share. But the problem here is it will be very much a rigid method through which you would be sharing the image. Is there any central place just like GitHub where we store our code? Is there any place where we can actually store all these images? Yes, definitely. So here where Docker hubs come into the picture. So let's first understand what actually is Docker hub. So just like GitHub, a central repository where we store our code, Docker Hub is a place where we store the images, right? So Docker Hub is a cloud storage for Docker images. So Docker Hub is an online registry for Docker images. Just imagine of it as Google Drive for storing the Docker images, right? Because right now you saw what we did. We just saved the file, we just saved the image, created into tar, then we loaded it, right? But here it was just a single image where we were dealing it. But when you are dealing with multiple microservices, it will be very much difficult for you to literally track each of these changes, right? And that's where Docker hubs come into the picture. But why do we actually need Docker hub? Let's understand what would be the life without Docker hub. Now let's consider the same scenario where we are saving and loading the file. Here the first thing would be you need to share each and everything through USB, through any medium. That medium is required, right? Because there is no central place where we are storing the images, and if something goes wrong in the person's laptop, then you won't be able to share the image as well, right? That's the reason we should consider Docker Hub. So without Docker Hub, sharing images will be very much difficult because there won't be any central place where we would be storing the images, and teams cannot collaborate easily, and that's the reason the deployment becomes messy. Now here you would be manually copying and pasting the file, but what if due to some reason you made any pasting error, right? You shared a wrong image, who will be responsible for that, right? That's the thing, life become very much messy when we are dealing with Docker images without Docker Hub. Now when we are with Docker Hub, the sharing becomes easy. There is a central storage where we would be sharing all the images. Anyone can literally access the images at any moment of time. It works across team, and it is mostly used in CI/CD pipelines. So here all you need to do is, once everything is done, once the utility is passed, you just have to build it once and you can literally use it anywhere. So once the testing is completed in dev, in UAT, and then you can finally promote into the production. So the first thing that we would be learning over here is public repository and private repository. In GitHub, we do have the concept of public and private repository. Same applies in Docker Hub. Now, public repository are those repository which can be accessed by anyone. It is free and it is good for open sources. When I say public, it is open for all the people. When I say private, it is limited to specific people. Now, mostly companies use a private repository because they want restricted access, and they want to make sure that their images are secure and it is only available to few sets of people, right? So let us first see the example of public repository, and here we would be talking about Docker Hub. So if you don't have your account created, so just click on sign up and you can just log in via your Google account or with your GitHub account. And I already have created my account, so let me just log in and let me just show you how does the UI of Docker Hub looks like. So here I will just log in with my username and I will press on continue. I can even log in with my Gmail and GitHub, right? So let me just log in via the password. Okay, so this is how the UI looks like, where I have multiple images which are present over here, right? So whatever I will push will be present over here. Now it is a public repository, meaning if you just hover to my repo, you will be actually able to see all these images. Now let's say once my image is ready, so let me clear the screen, and here I say Docker images. Now let's say this is the final image that I am dealing with, and this is something that I need to share with everyone. Now how do I do it? The first step that we need to do is we need to give it a proper syntax. Okay, and the syntax would be, it would be just like your username followed by the tag, colon tag. So this is the syntax that we need to follow whenever we are working with Docker images. So let us first tag the image. So I will make use of Docker tag, and what we are actually trying to achieve, we want this image to be present into the central repository in Docker Hub, where anyone can literally pull, actually run the images. So I will make use of Docker tag. Now which image you want to tag, you can either pass the image ID, or you can either also pass the complete repo and tag. So here I pass the image ID followed by, I need to perform the tagging. So I will just write my username, so the Shubham gour slash BusyBox, or I will write new app colon, and this would be app v1, new application v1. Now here what it will do, it will perform the tagging, and when I do Docker images once again, this time you can see my image is present. Now next step is you need to perform Docker login in order to authenticate the CLI. So I will perform Docker login over here. Now if you have already logged in, it will say login in success, but if not, it will just ask you to provide the token that you would be able to see in your browser, authenticate with the web browser, and then you will finally get login succeeded. Now once you are logged in, the next step that you need to do is just push the image. So Docker push, and you can just push it with the image ID, or you can just write the complete path. So here I will write the repository followed by the tag, and what's the tag? The tag is v1, enter. Now here what it will do, it will prepare the layers, and finally it will push it to Docker Hub, and that image will be available publicly and anyone can literally use it, right? And that is how we share the images. If I go over here into my repository and if I just refresh it, you can see the new application is actually present over here, and here we can see the tag v1 is also present. Now let's say someone wants to use this tag. How will they use it? So let me just copy the tag, and what I will do, I will remove everything which is present in the current context of images. So I will write docker images over here -q, and I will delete all the images. When I run docker images right now, you can see no images are present. Now what I will do, I will run a docker pull command. Now why docker pull? Docker pull is used to pull the images, right? So docker pull, and where we are pulling it from. So right now, since no image is present in my local, it will search into docker hub. And what docker hub is? Docker hub is a place, a central place where all the images are been stored, and it is actually pulling from the path where we defined. Now if I run docker images, you can see my application image is actually present over here. Now let's say I did further development, the testing is completed and everything is passed, and I want to push a new version of this image. How will I do it? So basically, again, once everything is done, you will run the application, and this time I will make use of another tag. So I will write docker tag followed by the application, that is the repository colon the tag, and this time the tag would be v2. Now let's say if I want to make this available to the people, so what I will make use of, I will run docker push followed by the image followed by the tag, right? So here we are actually pushing the image from our local to the docker hub. Now anyone from the world, anywhere, they just have to run docker pull, and then the images will be available to them. If I go to new application repository, here you can see version v2 is also pushed over here, and now see how things are become very much easier for us to share the images. So right now I gave you the example of public repository. It is free, available for everyone, and it is good for open source. Now what are private repository? Private repository is only restricted to few people. It is used in companies, and it is secure. So let's take private repository in the coming session. So right now we just explored and learned about public repository, and that's what actually is docker hub. So in real use case, developers build the docker images, they push the changes into docker hub or any private repository. It can be it can be ECS or anything, and then you can use the image in the Jenkins CI/CD pipeline, and you can deploy it to the server. So how would the flow look like? The developer writes the code, prepares the docker file. From that docker file, the image is created, it is pushed to docker hub, and finally it is deployed to the dev, test, UAT, and then prod production environments. Right now, so here we learned a lot about Docker Hub. So let us take a recap. So Docker Hub, what actually it is, a central place where we store the images, a Google Drive where we can actually store all the Docker images, specifically created to store Docker images. And here we make use of push images to share it anywhere. We can make use of pull command to run to pull the images in our local. Here we learned about public repository, which we saw the demonstration also, and in the coming video we are going to see the demonstration for private repository. And here we saw what are the real world use cases when it comes to Docker Hub into DevOps pipeline. And we also learned the flow where the developer writes the code, prepares the Docker file, creates the image, pushes the image into Docker Hub, then deploys into the environment. So yeah, that was all in this video where we learned a lot. So that was all in this video, and I will see you in the next one. Till then, keep learning, and thank you very much.
Hey everyone, and welcome to the very final topic of this series, and we are going to learn about Elastic Container Registry, a private registry. In the previous section we learned about Docker Hub, a public repository, right, where we can store our Docker images. Now let us understand how you can configure your private repository so that you can deal with your Docker images internally. So the very first thing that we would need to do is we will first create an instance. And here I will be very much quick and straightforward in this section because this is something that we have been doing from the starting itself and we actually know it. So I will just name it at server. I will just scroll all the way to the bottom and I'll just select the PEM file, and finally I'll click on launch instance. The AMI which I used is Amazon Linux. Feel free to explore, you can even choose Ubuntu, right? So I'll just select the instance ID and I will directly take the SSH. So I'll click on connect over here, and then I'll click on the sample SSH command, and in my terminal I will go and just connect to the instance. Now once everything is done, I will directly log in as a sudo user to avoid the permissions issue that we know how to resolve, right? And the next thing that we need to do is, first thing that you will need to work with and private repository is to install Docker itself. So I will write yum install Docker, and once everything is done, okay, so there is a process which is running. So once it is done, we would be able to install Docker inside the system. Meantime, it is installed in Docker. Let us go, and here the first thing that we need to search would be ECR, Elastic Container Registry, and then click on create registry. Now what actually is a registry? Now think of it like we are creating a GitHub repository where we would be storing our code, right? Likewise, in the same sense, here we are creating a repository where we would be storing our Docker images. So here I will provide the namespace followed by the repo name. So here what namespace is, basically namespace is used for the isolation of your images. I will write this as development, and here let's say the service that we are dealing with, a core service. Here it gives you two settings for the images. It is mutable and second is immutable. So mostly you can select for immutable because here you don't want your image tag to be overwritten, right? And next thing is, if you want to add any exclusion in that tag, you can just write it. For now I am good with that setting, and I will go with the encryption configuration, and here I will select AWS KMS, that is a key managed by Amazon itself. And finally, once everything is done, I'll click on create. Now once things are ready, I will go into development/core, and here we would be able to deal with all the images, right? So let me go back, and here I'll just click on Y, and here it will install Docker into my system. Now once Docker is installed, the next thing that we would be doing is we would first check whether the service is up and running or not, right? And in order to perform this demonstration, there are multiple things that you will need. First is you will need an access key. Second is you will need AWS CLI. So we would be authenticating with AWS CLI so that internally whatever permissions we need to connect with Amazon is ECR, it will be directly resolved with that, right? So yeah, it is installing Docker. Now let us wait for some time, and once it is done, we'll proceed with the further step. All right, so let us verify the version of Docker. So docker -- version, and here you can see version is 25.0.14. Now let us first check whether the service is up and running or not. So systemctl status Docker, and here it says systemctl is not found. Let me just check systemctl, it is, so I need to just correct the command, and here it says that the service is inactive. Let us restart the service. So systemctl restart Docker, and this time the service will get restarted. And now let us recheck the status of Docker once again. So let me just paste it, and here it says the service is active and running. Now let us quit it, and now the next thing that we need to do is open the browser and search for AWS CLI install on Linux, and click on the first one, scroll all the way to the bottom. Here we have three sort of option: Linux, Mac OS, and Windows. Now since we are on Linux, click on Linux, and then scroll all the way to the bottom. And now I will copy this command, and in order to work this command, you will need unzip installed in your instance. So let me just paste the command, and once it is done with the installation, we can actually run AWS - version to check the version of AWS. So I'll just copy this, and when I execute this, it is actually saying that AWS CLI is configured in it, right? Now let me clear the screen. Now since everything is done, now let me first run one more command to verify whether AWS CLI is actually installed or not. So I will run AWS IAM list -users. So here it says an error occurred, no credentials, because we didn't even provide the access key and secret key. Now where do we find the access and secret key? Go to AWS, into the instance, go to IAM, and here you need to create one user, right? And I will go to either one of the user and show you. And here I have a user named Shruti. I'll go to the bottom, and here I'll select for security credentials, and here you need to scroll down, and you need to click on create access key, and you need to provide the command line interface, and then you need to click on configuration, and once you click on next, you will get your AWS credentials, right? So right now I already have the credentials. So how do we use it? So you just need to run AWS configure, enter, and then it will prompt you to write the AWS access key ID, and it will prompt you for the secret. Make sure you are storing it in a safe place, and once every day is done, your configuration will be completed. Now let me paste the values over here. So now I am done with the configuration, and once I run AWS IAM list hyphen users, it is actually printing all the users which are actually present. Now we are done with all the configuration. First we installed Docker, and finally we configured AWS and we installed AWS CLI. Now everything is proper. Now we'll go back to the ECR, that is Elastic Container Registry, and you just have to click on view push commands. Now here you will have all the commands that you can utilize for building the images and pushing it into this private repository, right? So first of all, we will need one Docker file. So what we'll do, we'll go to GitHub and let us take any random Docker file that we have been using so far. So I'll go to my repository, and here we'll go to any one of the Docker repository that we have been using so far. So let me just go to repository number 10, and here there is a basic image that we have. So I'll just copy and I will create a Docker file from here. So Docker file, insert mode, escape :wq, and now let me build the image. So here first thing that we need to do is we need to first authenticate whether we are actually logged into ECR or not. So I will copy this command. Now what actually it does, basically it will retrieve an authentication token, and it will authenticate our Docker client to the registry that we have just created. So I will just paste it over here, and once the authentication is completed, we will get the login succeeded message, right? Now the next thing that we need to do is we will again build an image. So docker build -t. Now here is the repository name, and here is the service name, and since my Docker file is present in the current working directory in the current build context, it actually built a Docker image for me. Now when I run Docker images, it says that development/core latest is present. Now the next thing is we will do the tagging, right? So we will tag the development core latest with the current registry, the private registry which we created. If I just copy the command and if I paste it, you can see here we have mentioned 8233 DKR ECR. So basically this is the URI of our ECR, right? Now when I clear the screen and when I run Docker images once again, here you can see a long format of image which is present, right? And final thing that we need to do is we will directly just push this image into the ECR, and yeah, we are done with pushing the image into the private repository that we just created, right? So when I go to ECR and when I close this, here when I refresh the screen, here I am able to see the latest image we just actually created, right? And yeah, so this is the first thing that we can do. Now let us test this now in two ways. First thing is we are going to just delete all the images which are currently present over here. So I will write docker rmi -f, and then we are going to remove all the images which are present in the current context. So I removed everything. When I run docker images, here you can see no images present. Now the next thing that I want to do is, if I am an authenticated user, which I am right now, will I be able to pull it or not? So I will just run docker pull, and here when I run docker images once again, I am able to actually pull the image from the ECR, right? Now let's do the second test where we are not an authenticated user. So whether we would be able to pull the image or not. So here what I will do, I will run docker in my local system, okay, which will define that you are not an authenticated user. Or else what you can do, you can again create one instance and test it. So the best option would be, let me just create a new instance to actually show you how does things will be like when we are not an authenticated user, right? I will again create server 2, and we are going to keep everything by default as is, and let me just
select the key, I will select Ubuntu Lucan, I will create the instance. So again, here we would need to do the same thing once again, whatever we did in the current instance. And this hard work is just to verify whether we are able to pull the image from the private repository, right? But the current thing is we should not be able to pull the images, right? So what I will do, I will go over here, I will click on connect, and I will copy the SSH command, and then I will click on plus, and then let me just do zoom, and I will go to the directory where the keys are stored. Let me clear the screen, and let me take the SSH of the new instance which we just created. Right now, the first thing that we need to do is we will install Docker into the system. So yum install Docker, enter. And again, once this process is finished, we would be able to install Docker into the system. So why we are doing this, basically we just want to make sure whether the authenticated user is able to pull the image and the unauthenticated user is not able to view or pull the images. Why? Because the permissions is only given to the person who are actually working in that specific company, right? So here I am creating one more instance, and we are going to check whether we are able to pull the image, the private image or not, right? And as the name suggests, private means something which is only available to few set of people, right? And public is something which is open to all the people, correct? And that is something that we are going to test right now. So what I'll do, I'll go to ECR and copy the URI, and we are going to fire the same command which we actually used in the in the authenticated instance, right? Now the Docker is installed. Let me just activate the service. So systemctl restart Docker, and once it is done, I will run Docker pull, Control V. And here what it says, correct this, error response from daemon, the head where we are trying to reach has no basic authentication credential, meaning whenever you are trying to pull any image from ECR, it will ask you for authentication credential, and if you are an authenticated user, you will be able to pull the images. And again, second thing is, since it was a private image, we were not able to pull it, right? So that was all in this video, where I wanted to demonstrate to you how we can create a private repository and how authenticated user is able to pull the image and how unauthenticated user is not able to pull the image. So the basic thing here over is, basically when an image is private, we won't be able to pull it unless and until we provide that authentication, right? So yeah, that was all in this video, and I will see you in the next one. Till then, keep learning, and thank you very much. Hey everyone, welcome back. So this video is going to be very much special because today we are going to do a hands-on on a 3-tier web application, QuickByte. So QuickByte is a 3-tier web application that will help you to deepen your knowledge with Docker. Till now we have covered a lot more concepts of Docker, and QuickByte will give you the chance to do the hands-on, right? So this project will give you the idea how do we prepare a Docker file, how can we prepare a compose file, right? So let's get started with this specific video, where this project basically will open your doors with Docker. And after this video, I'm definitely sure you can confidently say that you know Docker, and you can also say Docker is easy. So yeah, let's get started with QuickByte. Okay, so this is the application where we would be working with. So introducing QuickByte application. So from the starting itself, we have been talking about food delivery app. So that's the reason we have created QuickByte application, our own custom application, which we can use for this specific demonstration. Here in the main login page, you will find login button and a sign up button. In the sign up button, you can just define one user. Here I will choose one of the user. I will define the password, and I will select either one of the city. So I will select Hyderabad, and I will click the create the account. Now here it says account created successfully. Now let me just log in over here, and here I will log in with the same user which I just created, and I will click on login. Now if you remember, I selected Hyderabad over there. That's the reason I'm getting Hyderabad over here. Now again I will click create one more user. So I will make use of one more user. So here I will write Neha, the password would be again admin, and here I will select this city as Mumbai. If I click on create account, the account is created, and if I log in with the user Neha, right, if I click on login, you can see it says discovered the best food and drinks in Mumbai, right? Now let's say if there is a party due from Neha and we want some party from her, so what we can do, we can just add the menu item from here. Here we have the cuisines option. You can select from India,
Indian cuisines, and if you go to Chinese, here you can select some Chinese cuisines, and some sweet sections are also present. And now once you are done with everything, go with the cart and click on checkout, and yes, your order is placed successfully, and then you can see everything over here, right? That is how this application works. And again, I have created one more user, that is by my name. I will log in through it, and then I will just order few more things. So this is a regular food delivery application that will help us to understand how do we containerize this sort of application, right? And this is something which will be very much easier, because this is something that we use on a regular basis, right? And now we are going to implement all the Docker concepts into it. We will be implementing Docker networking, Docker volume, and many more. So this was just to show you the overview of the application, how does quick byte works, right? And if you want to contribute in this application, feel free to raise the PR. I have created a GitHub repository where all the code is present. Just go through that repository, raise a PR. I will review it and I will merge it for sure, definitely. So let's start by understanding the architecture of the application, because that will give you the clarity on what stack we are working on. And then finally, we are going to implement this project. So let's get started with the system architecture. Okay, so let's start by understanding with the architecture diagram of the application. Now, why every time we consider the architecture diagram? Because the answer is very much simple. If you understand the architecture of the system, it will give you the clarity what things you will be dealing with. Okay, what all technologies you will be dealing with, right? So here we will be dealing with a 3-tier web application where it will consist of front end, a back end, and a database, right? Now here we would be discussing about what all things are involved over here. Front end, here we would be dealing with Nginx and the basic static files such as HTML, CSS, and vanilla JavaScript. And post that, the backend, we would be dealing with Node.js, and the database, here we would be dealing with MongoDB, right? So those are the tech stack of the current application. Now the front end works on default port number 80, and the backend works on port number 5001, right? And here we would be using lightweight images. Now why we are considering lightweight images? Just to make sure that the image that are created with the Docker file that we will be writing, it is very lightweighted, so that whenever we are deploying it to any server, it will be very much quick, right? Because the lesser the size of image, the faster the deployment will be done, right? So that's the basic reason. So how would the flow look like? So basically the client will be accessing the application with the web browser. Now here he will be interacting with the front end page, right? And you already have seen the page look and feel. How does it looks like? So here he will be dealing with the front end, and basically all the API calls will be done via backend, and all the data will be stored into the MongoDB. So just in case if something goes wrong, if the backend goes down, we will be making use of Docker volume. So if something goes wrong, if things are not under our favor, we already have the data saved, and that is how we are going to persist the data, right, with the help of Docker volume. So just in case if backend goes down, we can just directly mount the volume to the next backend service, and our data won't get compromised, right? And here, in order to maintain project isolation, we would be making use of Docker networking, and that will make sure that our application is isolated with other projects, right? So that was all about the theory and understanding about the architecture of the system. And if you want to learn more about the application, and if you are curious where to get the code from, you can go to my GitHub profile and search for QuickByte. You will find the code for this entire project, and feel free to experiment, feel free to add more features into it. And if you raise PR, like I will definitely review and merge it if it add values, right? So yeah, if you want to learn more about this application, just go through the readme.md. Everything is explained over here. And yep, that was all about the system architecture. Now let's get straightforward and start with the project implementation. So here I will be making use of a fresh EC2 instance, so that we are not left out with. So I will click on launch instance, and here I will write quick byte app, and here I would be using the AMI of Ubuntu, and the machine type I will be making use of T3 small, because I want 2 CPU and 2 gigabits of memory. And then I will select the key pair Ubuntu local. If you want to create a new one, feel free to click on create new key pair and create a new key pair, right? Now we'll keep everything by default as is, and then I will click on launch instances. So after the instance is launched, the very first thing that we will be dealing with would be to install the Docker and Docker Compose, because here in this application we are going to write a fresh Docker file and we are going to write the fresh Compose file, so that you will understand what steps to proceed with and how do we actually write it. And one thing I would recommend you, so whenever you are writing the Docker file or whenever you are dealing with the Docker Compose, please use Visual Studio Code as a beginner, because it will give you the complete clarity where actually you are making the mistakes, right? And once you are comfortable with Visual Studio Code, then feel free to proceed with a Vim editor, because that is something that you would be using finally, right? So let's directly connect to our EC2 instance, and here I'll just click on connect and I will take the SSH. So here I will go to my terminal and I will take the SSH for the same, and I will click on yes. All right, so the SSH is done. Now let me clear the screen. Now the next thing that we would be doing is we need to install Docker into the system. So what we need to do is go to the official documentation of Docker, go to google.com, and here search for Docker install on Ubuntu. This would be the very first link that you have to search for, and here when you scroll down, you need to search for the installation commands for Docker, right? And here the first thing that you will find is run the following command to uninstall the conflicting package. Now since we created a bare new server, we don't need to run this. This is just for avoiding the conflicting packages, but since we didn't install anything, we won't be proceeding with it, right? And here we have the installation method. I'll directly copy the command and I will directly paste it. Now what actually this command does, it will update my system, it will install the necessary certificate, it will update my package repository, and finally it will install Docker into my system. So I'll paste it directly, and it will take some time based on the internet speed, and then finally the Docker will be installed into our system, right? So it was very straightforward installation that we have seen so far, and like this is something that you already have been doing from the starting of the video itself, right? Now why we are doing this from very much scratch, because we need to understand what issues can come when you are doing it for the very first time. That's the reason we are starting it from zero, right? So yeah, once the packages are installed, the next thing that we need to install is the Compose, right? So in order to install Docker Compose, scroll downwards, and here in the plugins, install the Docker packages, and it will allow you to install the Docker Compose plugin. So Control V and enter. Here it will ask, it will prompt you, do you want to continue, yes or no? Press yes and continue with the installation. So once this is done, the basic prerequisite for starting with this application is also completed, right? Now one more thing that we need to do is go to my GitHub profile and search for QuickByte and just clone this repository to get started with, right? So yeah, once this installation is done, we'll first verify whether the system is running or not. If not, we'll start the Docker service, and then finally we'll start with the installation. So yes, the installation is complete. Let me clear the screen and I will run docker -- version, and I am using version 29.4.1. okay, and it may vary whenever you are referring this video. And now let me first check the version, the status of Docker. So systemctl status Docker, and here it says the system is up and running. Okay, all right. Now the next thing that I want to do is I will clone my repository. So git clone followed by the repo name. So git clone once again, I will copy the URL once again, and then I will paste it over here. Okay, cloning is success. I will go inside the repository ls, and first thing that I will be doing is I will remove all the Docker file and all the Compose file. So we would be writing it from very much scratch, so it will give you the idea what order to proceed with, right? Let me clear the screen. And yeah, whenever you are dealing with Docker, there will be one error that you might face, that is the permission denied error. So I am deliberately not giving the permission because I want to show you the errors, what can happen during the runtime whenever you are doing it for the very first time. So when I do the ls here, is all the files that are currently present. Here I have an Nginx configuration file. Here I have a front end folder which consists of all the static files that the front end will be hosting. Here I have the backend file, backend folder where all the backend files are present. Here I have the architecture.html, so it is the architecture diagram which I just showed you. Here I have the readme.md file where all the instructions are written upfront, and here I have package log.json. Package JSON and package log.json specifically is used for installing the dependencies in Node. Right now, if I go to my repository, so you can just go through this documentation and it will give you a clear idea how does the application works, what all environment variables are required, and how to run the application locally, and how to run the application with the help of Compose. Right, and if you want to run it via Docker file, feel free to do the same because everything is documented over here. Right, so let us clear the screen. So what's the first thing that we would be dealing with? So the very first thing that we would be dealing with is to write the Docker file, right? And in the previous sections, you might have seen that whenever we were making use of Docker Compose, there were two build contexts that we were providing. First is the image, where it was pulling the image directly from Docker Hub, and second build context was the Docker file itself, right? So here we are going to try with our custom Docker file because this is my custom code and I understand the code better than anyone. So I will write Docker file based on my requirement, right? So what I will do, I will need two Docker file in this case. First is the Docker file for front end, second Docker file for the backend, and for MongoDB we would be utilizing the MongoDB image directly from the Docker Hub, right? So let me create a Docker file for front end. So Docker file and dot front end. So I will make use of Vim over here, and that will help me to write the Docker file for the same. Enter, and here let us start by writing the Docker file for the front end service. So when we are dealing with Docker file, the very first statement that we should write is the from, and which defines the base image. So here I will write from, and here we are dealing with Nginx, so I will write Nginx, and based on the architecture diagram we know that we are dealing with Nginx, so either you can use Nginx latest, but the issue with Nginx would be it will create an heavy image, but in order to avoid that we are going to make use of Alpine image, so Nginx Alpine. Now post that, what is the next thing that we want to do? Now as I mentioned earlier, all the front end files are stored in the front end directory, so I will need to copy all the front end files to the path where Nginx hosts the file. So I will copy the entire front end folder. So I will write front end. I will copy the entire front end directory to usr/share/nginx/html. So this will be the path where all the front end file will get copied. Next is I need to copy the Nginx configuration file, which is responsible for the default configuration that Nginx has been done. So I will copy the Nginx conf file. So nginx.conf space slash, and where do I copy it? I will copy it to that specific location where default configuration has been stored. So it's stored in /etc/nginx/conf.d/default.conf. Right now, once it is done, we know that the front end runs on port number 80, so we need to expose port number 80, and finally we are going to run the server. So how do we run the server? We are going to make use of CMD that will be responsible for starting the Nginx server. So I will make use of square brackets, and here I will run Nginx comma, make sure of a single space, then again inside the quotes mention -g space comma along with a single space, and then write daemon -off, DAEMON space off along with the semicolon, and then everything is done. Escape :WQ. And now when I run a cat on Docker file front end, here what we did, we made use of a very basic image of Nginx. We copied the entire front end directory to usr share nginx html. Then we copied the Nginx configuration, which is here. We copied it to etc default configuration, and finally we exposed the port number 80. And finally we started the container by running Nginx daemon off. Right, okay, so the front end file is ready. Let us try to build the Docker image out of this Docker file. So I will make use of docker build -t. Now let us name it as front end dot. But since here we are not using just docker file, we name the file as docker file dot frontend. We need to pass hyphen file hyphen f flag for specifying the absolute file and press enter. Now here what it says permission denied while trying to connect Docker API, and this was the error that I was speaking about earlier, right? So in order to resolve this, you need to just add your current user into the group of Docker, right? So just use user add hyphen ag docker and dollar user. Now it will actually take your current user, and in my case it is Ubuntu, right? When I press enter, it will say permission denied because I will need to run this command as a sudo user. So user add hyphen ag enter. Okay, my bad, it is not user add, it is user mod. So user is already created, we are just modifying it. So let me just correct the command, and this is user mod hyphen ag docker user, right? So it will add the current user into the group of Docker, and then we would be able to resolve that issue. I will need to go to my server, and this time I will need to just reboot the server, right? And this will give me all the permissions that are required to run the Docker application. So I will just reboot the instance, click on reboot. Click on reboot the instance, and then go to the server, clear the screen and wait for just 30 seconds, and then you can just take the SSH connection. All right, so once you are able to take the SSH of your instance, clear the screen, and this time I will again go back to the quickbyte repository which we cloned. If I do ls, I can show you we have the front end file, and now we will work with the next action of item, that is backend. So here we are going to create the Docker file for the backend service. So here I will write vim docker file dot backend, enter. So here again, if you are someone who is writing the Docker file for the very first time, or you need practice with, please use Visual Studio Code. It will give you the clarity, it will give you the emit, so that it would be easier for you and it won't be very much overwhelming for you for the very first time. Once you are done with Visual Studio Code, and once you have that confidence, then only you start with vim editor, right? Okay, so let's start with insert mode, and here I will define the base image for the backend. So I will be making use of node image over here. So node 18 Alpine. Why? Because I want to make the image very lightweighted. So Alpine, and then I will refine the working directory. So work dir space, and the working directory for this backend would be /usr/src/app, and then I will need to copy all the code of the backend to the place of the working directory. So copy backend slash to the working directory which we just created, enter. And before even that, we need to do one more thing, and that is we need to copy all the package JSON file to the working directory, and then we need to install all the dependencies through it by running npm install. So I will copy the package JSON file over here. So copy and that package JSON, let me first check where it is present. So cd backend, and when I do ls, cd backend, and when I do ls over here, I need to copy this package log JSON and package.json. All right, so I'll go back again, and I will just do on vim docker file backend, and here I need to copy all the file of package JSON to the working directory. So I will write copy package package star dot JSON, and I want to copy it to the working directory which we created. Control C and Control V, and here that package JSON file is stored in the backend directory. So I need to provide the complete path, and here it goes. So I am copying all the package JSON files, package JSON and package log JSONs to USR, SRC and app, and then we need to run the command, and that is nothing but npm install. Now, once npm install is done or dependencies are installed, then we are copying all the backend file to the working directory, and then we need to expose the container by the port number in which it is running, and backend is running on port number 5001. So I will write expose 5001, and finally we are going to start the node.js application. So here I will need to write the cmd command, and here I will just write npm comma a single space and followed by a start. Okay, so the docker file for the backend is also ready, escape colon wq, and let me just verify whether if there is any issue with the backend file or not. So docker build -t, and let me take it as backend, and the file name is dockerfile.backend, and it is present in the current place, that's why dot. So here, if there is no issue with the docker file, it will try to build the docker image for us, and it is actually starting to build the docker image for us, right? So once the docker images are ready, the next thing for us would be to verify whether the images are created successfully or not, right? So I will just correct the command, and here you can see the backend is also present. Let me just delete the image. So docker rmi -f, and I am going to make use of this command just in case if any redundant or dangling image is present. So I will just remove it. So docker images -q, enter. So I have deleted the backend image too. So right now, what all things do we have? We have the docker file for front end, we have the docker file for the backend, and now we are very much ready to prepare the compose file. Now you might be wondering, Shubham, okay, you said we would be creating the docker compose file. What about network? What about volume? Why we are not considering it? So basically, those are the things which we would be defining inside the compose file. So we don't even have to worry about it. So when you are using a docker compose file, you don't have to worry about networking, because docker compose file itself created a docker default network, which is of which consists of driver bridge. And secondly, we would be defining the volumes, which would be very much helpful for us whenever we are dealing with the database, right? So let's get started, and let's start by creating the docker compose file. All right, so let me just start by creating the docker file. I will write vim docker -compose .yaml or yml, enter. And here, now since you are dealing with docker compose, you are dealing with services, so you need to define the services. And what all services are we will be defining? It would be front end, it would be back end, and the database, right? So I will write services colon, enter. Now the very first thing that we would be doing is now instead of defining the service, we need to first define the volume, right? Because if the data is gone forever, we will be lost. So let's go by sequence. Let us first define the services, and then based on the use case and the discussion that we would be doing, we will be creating the volumes and network based on the necessity, right? So what all services we are dealing with? So we are dealing with MongoDB service. So MongoDB colon, enter. And the second service that we would be dealing with, so once the MongoDB is ready, we would be creating backend, enter. And after backend, what is the service that we would be dealing with? So it would be front end. So the sequence is like, once the database is ready, it should proceed with the backend, and once the backend is ready, it should allow the front end, right? So let's get started by defining the services for MongoDB. Now, when we are dealing with MongoDB, here we didn't wrote a specific Docker file for MongoDB, because we are going to use the official image from the Docker hub itself. So here, instead of the build context, so what is the build context over here? So here, build context is not a Docker file, it is the Docker image itself. So I will write image over here, and here I will define the image that I would be using. So here the name of the image would be Mongo, and if you want to write the tag, feel free to write the tag latest. And it is a best practice to write the tag, because it will give us the clarity what sort of version we are using. Right now we are going to make use of the latest version, but if you want to use a specific version of Mongo, do mention the version over here with the help of tag. Now let's move forward. Now once the image is created, after the image is ready, what's the next thing we do? We create a container, right? And we do give a name to that container. So let me give a name to this container. So I will write container underscore name. And what should be the name of this container? Now, since we are working with QuickByte application, let us name it as QuickByte DB. So QuickByte byte underscore db. So this would be the name of the container. Now the next thing is we need to do the port mapping. So ports colon enter with the dash and a single space and write the port number inside the quotes. And what's the port number that MongoDB runs on? It is 27017 colon 27017. Now here the host port is on the left hand side and the container port would be on the right hand side. Now once everything is done, we need to do one more thing. And in order to maintain the data, in order to persist the data, we need volumes, right? And that's the reason you need to create a volume first. So volumes will be following under the level of the service. Make sure of indentation. YAML is very strict about that. So I will write volumes. And what would be the name of the volume over here? So I will name it as MongoDB underscore data and along with the colon. So volumes is defined over here. Now let us define the MongoDB volume over here, and here we would be doing the volume mounting for the same, right? So here I will write volumes over here, volume colon, and here I need to write one dash space. Now what's the name of volume we created? We created MongoDB underscore date. It should be data. Let me just fix it. MongoDB data, yeah, now it's correct. And here we need to map it with slash data slash db inside the container. So now the MongoDB is ready. Let's start with the backend. Now when you are dealing with backend, here the build context is a Docker file, right? So instead of defining an image this time, here we will provide what is the build context for it. And here the build context is nothing but a Docker file, and that too not just Docker file, we renamed it to dockerfile.backend. Now how does compose will identify which file to pick up, right? If I do escape colon wq, here you can see we have two files, dockerfile.backend and dockerfile.frontend. How will Docker compose know which file to pick it up? So that is something that we are going to define over here. I will just go into insert mode. I will press enter, and here I will write build, and I will provide the context enter. And where is the Docker file present? So it is present in the root. That's why I am going to write dot enter. And then what is the name of the Docker file that we would be dealing with? So I will write Docker file colon space, and what's the name of Docker file? It is Docker file dot backend, right? And this is how you define the build context of a custom Docker file that you have written. So remember, when we were running the build command, we were explicitly mentioning -app option. So here that thing is been defined by Docker file itself, right? And here we define the build context. So Docker compose know which file to pick up for backend, right? Now once it is done, let us give the name of the container. So here it will fall to the build context section, and here I will write container underscore name. And what would be the name of container? Now the database is been given as quickbyte.db, so I will write the backend name as quickbyte underscore backend. Enter. Now what all ports we would be dealing with? Let me first check whether the, yeah, it is into the same indentation. Now let us check on what port it would be working on. It would be working on port number 5001. Let's do the port mapping this time. So here I will write ports colon enter along with the dash, and here I will write the port mapping. So host port 5001 with the container port 5001. Now here we are done with the port mapping, and now we need to do the environment variable mapping. Now where do I find the environment variable mapping? So basically you need to go to the repository, and here in the quickbyte repository itself, if you scroll down, I have mentioned the environment variables that we would be dealing with. So first is the port, and second is MongoDB URI, right? So let us define the environment variable. So environments enter along with a single dash inside the environments, and I will write Mongo underscore URI. And what is the Mongo URI over here? I will write Mongo colon / Mongo DB. That's the name of the DB along with the port number 27017 / foody fwdie hub hub. So this is the MongoDB URL, and now I will pass one more environment variable over here by passing one dash, and that is nothing but the port. And what's the port that we are working on? It is 5001, right? So let me just recheck the environment URI. So Mongo URI, it is Mongo colon MongoDB 27017 foodie hub, and the port is 5001. Right now, once it is done, the backend is ready. But on what condition the backend should be ready? It should first wait on the database to get ready, right? So here one condition also arises, that is it is dependent on MongoDB. So that is something we need to define over here, and I will write it depends underscore on basically the database. So I will write Mongo and now I will write MongoDB. So it states that it depends on MongoDB. So once the MongoDB is ready, it should run the command npm start, right? So for that, just below depends on, write command colon space npm start. So what it says basically, once your backend server everything is ready, it should first check, like whenever you are dealing with backend, it should first check whether MongoDB service is ready or not. And once it is ready, then proceed with backend and then run the command npm start. So this will make sure that npm service, the backend service is up and running. Now the backend is done, the database is done. Now let's move forward with the front end directly. So front end is again very much easy. Now again, when we are dealing with front end, the build context is again the same Docker file that we wrote for the front end file. It will be docker file dot front end. So I will write build colon enter, and here I need to define the build context. So context colon space, and since that Docker file is present in the current root, I will press dot enter. Now what's the name of Docker file? So I will write Docker file over here colon space, and here I will write the name of the Docker file. It is Docker file dot front end and front end. Now once it is done, we need to give the name to that container. So I will write the name of container by writing container underscore name colon space, and here I will write the name as QuickByte front end. Now we already know that our application works on port number 80. So here we need to do the port mapping. So I will write ports colon enter hyphen space, and here I will write host port 80 with the container port 80 enter. And now this front end service is dependent on backend. So that's the reason I will write depends underscore on, and the name of the backend service name I will write hyphen, and here I will write backend enter. So our front end service also ready. What it says, the build context is docker front end file, the name of the container will be QuickByte front end, the port that I would be using is port number 80, and it depends on backend. So you cannot you cannot up the front end service unless and until backend is ready, right? So I will run escape colon wq over here, and now let us try to build the image out of this. So before even that, I will first check whether my environment is clear or not, right? So docker images, and here there are no images, meaning we are good to proceed with it. So I will just write docker compose up, and I want to run this service into the background. That's why I will pass -d enter. Now here it says there is an issue, and here it says validating the compose file error, and there is an issue with the services.backend additional properties on environments. Oh, so here we made one mistake, and that is with environments, and I know what actually the issue is. So I will again do a vim on docker compose. It is not environments, it is just environment, MENT. Okay, escape colon wq, clear the screen. Now I will again run docker compose up -d enter. Now here it is actually working. It is trying to build a MongoDB. Now once MongoDB is ready, it will try to build the backend, and once the backend is ready, it will move forward with front end service. And that's the beauty of docker compose. And again, here we do not have to worry about the isolation, because here the default network will be created, and the network here that it created for us is QuickByte default, and the volume is again QuickByte MongoDB data, which we actually defined, right? If I run docker ps over here, docker ps, here you can see all the three containers are actually up and running. Now on port number 80, let us actually view our application. So I will go over here, I will go to instances, I will copy the public IP, and I will just write http:// followed by the public IP over here, and I will actually see my application over here. But there is again one catch. We will be able to access the application even if we are not able, even if we didn't even expose the ports, right? So we need to go to security rules first. Under security, go for the security rules, and here we would be defining the inbound rule. So I will click on edit, and here I need to define the port. So port number 80, and I will define port number for backend, that is 5001. I will write 0.0 decider blocks, and then finally click on save rules. Now, since the ports are defined, now I should be able to view my application. I will again write http:// followed by the public IP, and this time I should be able to access my application, right? So again, it should be the same, http:// and the port number, even if you don't specify, it will be the same. And here you can see the quick byte application is up over here. Now here I will just create a new user. I will write let's say Harsh, password, and I will select Harsh will be from Kanpur, okay, and I will just mark the password once again, and here it says the account created successfully. Now let us log in with Harsh user. So Harsh, and I will write the password, and here I am logged in with Harsh, and here it says discover the best food and drinks in Kanpur. And if you remember, in the drop down we selected Kanpur over here. So let us taste few foods from Kanpur. I will select butter chicken, I will make use of classic cheese, and then from Chinese, I will try some gobi Manchurian, and from sweets, I would love to have some gulab jamun. And then in the card, you can see I have all of these, and it costed me 70 rupees, right? And I will just click on checkout, and here my order is placed. Now, if I go to my order history, everything is present. Now, there is one more thing that we need to test. I will just log out from the application. Now, let's say if due to some reason I run Docker compose down, meaning all our services went down. So what will happen to the data, right? What will happen to the data like of the Harsh, right? We created Harsh user, that is a kind of data. The order which is placed by Harsh, that is again a kind of data. Now, since we mounted it to a volume, our data is safe, and that's the reason we have created the Docker volume in order to persist the data, right? So again, I will run Docker compose up -d, and we are going to up the service. And now I will again go to do a refresh, and I'm going to log in with Harsh once again, and I will write the same password which I used earlier. And here you can see I'm again able to log in, which means my data is safe. If I go to my orders, the history is still present, meaning my data is intact. So that was the power of Docker Compose. I believe this demonstration did give you the idea how does Docker Compose works, how to write Docker file, and how Docker Compose helps us in many ways, right? This was the final project that I wanted to showcase you that will help you to strengthen your knowledge with Docker file and Docker Compose, right? So yeah, that was all. And here, if you want to explore this application, if you want to add more features, feel free to go to this repo, raise one PR. I will definitely review it and merge it directly itself, right? Because right now you have all the knowledge that you require to get started with Docker, and you literally have done a very good job for it. Right now, the only thing that is left is just create the application, containerize it, and by doing multiple projects, it will give you the hands-on, it will give you the idea how does things work and what all real case errors you can face. Right, so that was all about this video. I believe that you have learned a lot from this series, and if you face any issue in future, just write down in the comments and I will definitely try to help you out. And if the issue is something which is recurring, I will definitely create a dedicated video for the same. Right, so yeah, that was all about this video. I will keep everything documented so that it would be easier for you to just take a reference over here. So yeah, that was all, and I will see you in the next one. Till then, keep learning, and thank you very much. And that brings us to the conclusion of this series, this video on Docker in one shot. We literally started from very much basics, and today here we are where we are able to containerize the application, where we are able to Dockerize the application. Why? Because our knowledge with Docker is sound now. We have that confidence where we can literally Dockerize any application now, right? So congratulations once again on completing the course, and as promised I will share you all the resources, all the cheat sheets, all the course material that we have used throughout the video. So yeah, congratulations once again on completing the course, and I will see you in the next one. Until then, keep learning, and I will see you in the next one. Adios.